Hey guys, welcome to this session by Great Learning. Data science is proving to be a pinnacle of computing in the modern world, right? Right from the time when these concepts were still a talk of, let's say, the only theoretical discussions, all the way to now practically using it in almost every aspect of our life, data science has come such a long way. Now, the future of data science stands very strong and portrays amazing trends as well. This ensures that that there is a creation of thousands and thousands of jobs across the globe every single year. But then, due to the ever increasing amount of data that we generate, and of course, even with the most powerful computer systems we have at our fingertips, there comes a situation where there are experts who are required in the field of data science, right? Since data science itself is a very vast field, it becomes very important that you all take a structured approach whenever you're learning the complex concepts that govern the entire domain here. Now guys, keeping all of this in mind, we here at Great Learning have come up with this comprehensively put together data science full course video to make sure that you guys can get started with this domain. Now, this structured tutorial consists of theoretical concepts, an ample number of examples, key insights, practical implementation using the Python programming language, and a lot more as well. So welcome to this video. My name is Anirudh and I'll be your instructor for this tutorial. Let's get started.
Now, before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you get access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains that we have, be it data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and a lot more absolutely free. Now, we have award-winning academicians and leading industry experts who design all of these courses. And the best part, you can also get a free certificate of completion when you enroll and complete all of these free courses. You will of course get access to all the presentations, be it the code notebooks, data sets, and the quizzes as well. So as of now, we have courses in English and Hindi. You can use these multilingual approach to make sure that you have the best learning experience possible in the language that you are comfortable with. So make sure you check out the description box of this video to get access to all of the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Now, coming to the course agenda of what we're going to discuss on this comprehensive full course tutorial for data science, we will begin by checking out an introduction to data science. So we're going to discuss a lot of things about data science. We're going to discuss the important concepts of statistics that are involved. Python for data science. Python is a beautiful programming language. It's very important for data science. We're going to be discussing that on this course in detail as well. We're going to be taking a look at and understanding what machine learning is, practically using all of these concepts, and even concepts of such as probability, database handling, exploratory data analysis, data visualization, deep learning, artificial intelligence, and a lot more. Now guys, we're going to be taking a theoretical approach alongside practical. So we're going to be checking theoretical concepts and we're going to be backing all of those by looking at code in Python, so that you get a complete and concise knowledge about what is the takeaway from all of these sessions, all of these modules in this particular video, right? And guys, one important thing, throughout this entire course, I will be giving you guys important pointers, so make sure you have a pen and paper handy. Now, whenever I give you these pointers throughout this particular course, make sure to note them down, because at a later date, you definitely will make a lot of sense of it. It's going to come to you and it's going to be of immense help. So that's very important important that you keep a note of that. Right, guys. Now, in fact, diving right into the first module of this full course of data science, we are going to start out with understanding the basics of data science, of in fact what data science is. So now these are the things that we're going to be covering in this particular module, which is the module 1, basics of data science. We're going to be understanding what data science is. We're going to look at why data science is required. We're going to take a look at the architecture of how data science itself is built and how it works. Now, once you understand how data science works, you will definitely want to look at the components that are used to build this particular domain, right? So we're going to check that out. And of course, at the end of this particular module, we are going to be discussing about how you can build a career in data science as well. So this is module 1 among many modules as you saw in the course agenda. So let us begin, guys. Now, to talk to you about what data science actually is, let me give you a beautiful example. Now, picture this or imagine this. Let us say you and your friends have gone on a vacation, maybe to Goa, maybe to Himachal Pradesh, or wherever it is around the world, right? So you and your 15 other friends decided to go. So of course, you have a lot of fun. You click a lot of pictures, you click a lot of selfies, you click a lot of group pictures and all of that. And now you want to upload it to social media. Now, what's the first thing you do after uploading it to social media, right? You want to tag your friends and, if you've clicked, let's say 10 pictures in total, which has 15 friends each, that is what? 150 times you have to go and tag each friend, right? So total tags you'll be doing is 150. Now imagine going and seeing, finding each person's face, clicking on it, seeing their ID, searching for them, tagging them and doing this 150 times. It does not make sense, right? But one thing you might have noticed on popular social media sites such as Facebook is that as soon as you put out a video, it will automatically start tagging people for you. It will automatically recognize that, the person is present. Now that is because of a concept we call as face recognition. And guess what? Face recognition is a very important part of data science as well. So at the end of it, when Facebook automatically tags your friend, data science is at play. Now this is a very nice example which I thought I wanted to include. Now, I have another important example here, guys. When you think about weather prediction right now, what is the easiest way that you guys can predict the weather today? Maybe you'll do a quick Google search. Maybe you'll ask your Google Assistant, you'll ask Siri, you'll ask Alexa. So, hey Alexa, what's the weather like today or tomorrow, right? It is that convenient. All you have to say is one statement and you will have the answer to it. But let us go back maybe 20 years or 50 years or 100 years back in the day. The way that they used to predict the weather is to actually go outside, look at the clouds, look at the current weather and then see if the next weather is anticipatable or not. Now when I say that, if there are dark looking clouds, very black clouds, there's a good chance it might rain, there might be a hailstorm or it might snow. If it is clear and sunny, there's a good chance it might not rain, correct? This is how it was done then. Now we have entire meteorological departments that are set up everywhere across the globe to make sure that weather can be tracked accurately in the future as well, right? To say the current weather is easy. All you have to do is look up at the sky. But to tell you what the weather is like next month, next year, at that point of time, that month, that date, that time, right? That takes, a lot of skills, of course. And next, it takes a lot of hunting around, a lot of research, a lot of analysis. This analysis, this research, this entire world is powered by data science. Now, predicting the weather is something nice. I absolutely love it because if I am headed out, I definitely would want to know if I have to take an umbrella. If I'm planning a vacation somewhere, I have to know what clothes do I pack. Do I pack winter clothes? Do I pack my rain cover and all of that things, right? That's fun. Here is another important aspect of data science that I am impressed by thoroughly. It is in emergency services. Now, for all of you guys who stay on the coastal cities or the coastal places anywhere around the world, you know that the coastal places are sometimes prone to the forces of nature, right? A tsunami can be extremely devastating across the world. Now, when I say tsunami, I have goosebumps out here because it is a force of nature which, no humans can stand against and win, right? When Mother Nature decides to just go ahead and punch in all that water from the oceans to the coast, it is devastation. Now, thankfully, we have multiple systems in place where we have sensors which will detect as soon as there is an earthquake and start an alert and all of that. But with the help of data science, now the entire process is automatically done. So what happens is that as soon as there is an underwater earthquake, which is the primary cause for tsunamis, is detected, there is, instead of waiting for a human being to sound an alarm, it automatically gets sounded on the coast, so that way people can evacuate and get to safety. Now, ladies and gentlemen, we are talking about a matter of life and death here, right? So data science is being used for not just this critical application, but hundreds of other critical applications as well. An example such as face recognition is beautiful to look at, very convenient, but if you know that it is extremely powerful in saving lives around the world, right? Especially now more than ever in the world of healthcare, data science is a key important player, right? So we are living among the COVID-19 pandemic at the time of recording this particular video. One important thing you have to know is that even before World Health Organization declared that there was a pandemic or a novel coronavirus at hand, there was a company who used an artificial intelligence model, a machine learning model, and they actually detected a rise in the number of cases in Wuhan, China, right? Pneumonia cases. They could pick up that there was something unusual going on there, and with that they said, hey, something fishy is going on here. The pneumonia cases have never been this high, so something is wrong. And they were the first people. An artificial intelligence model, a data science powered model, was the first in the entire world to say that there can be a pandemic. That is how powerful this domain is, ladies and gentlemen. So with that, I am sure you will have a question saying, okay, so all of this is amazing. What is data science? Well, to tell you what data science is, let me break it down in the most simplest way possible. Data science is a study where we actually try to make use of raw data and convert it into useful information. Now, whenever you think of the word raw data, you might be confused saying, okay, so how do you define data as raw and processed, right? I'll give you an analogy. What is your favorite food, right? For example, if my favorite food is French fries, now French fries, well, the potatoes has to be cut and then they have to be fried and then we can eat it. I cannot eat a potato raw and call it French fries, right? It has to be processed. In data science, we do a similar process to data. We take it, we process it, and at the end of that process, we will have an usable entity, which is called information, guys. So never confuse this particular thing. Never confuse data and information. Data can consist of things which you might use and which you might not use. Information is an important entity where majority of whatever is there in that bucket is everything that is useful for you. That's why it's called information, right? Now, let me give you more examples to talk about what data science is. When you think about the month of maybe November, December and January, right? This is the time when people are gearing up and getting ready for Christmas. They're getting ready to celebrate New Year. Everyone is excited and all of that, right? So what do? They go on to buy cakes, they buy toys, they buy sweaters. I mean, I absolutely love Christmas sweaters, right? I find it amazing. It's very comfortable and all of that. So I myself bought so many things such as chocolates, gifts and whatnot during the New Year's, during Christmas as well. Now, if you were a shop owner who was selling all of these things, how would you know how much of stock you should have, right? Now, maybe last year, 100 people walked into your store and bought something. Maybe they bought chocolates from you. This year, let's say if you just buy another 100 chocolates to sell, what if 1,000 people show up? What if 150 people, 200 people show up? You are going to lose the business of all those other people, right? Think about it. So, as a business owner, it is important for you that you know how many customers can walk into your shop. Guess what? With the help of data science, you can actually analyze all the past data from previous years and come up with a conclusion saying, hey, I can predict that this year and next year or the year after that, I will have these many customers who will come in. Now, based on that, if you make purchases yourself, you can sell it out, make a profit, have a nice New Year's Eve or whatever it is, right? Think about it. I just gave you 2 or 3 examples of data science now. If you're watching this, and I'm sure you're watching this on a video viewing platform such as YouTube, right? When you're watching this on YouTube, Vimeo, or wherever it is, all of these tools that in fact you're using to watch this particular video, they are powered by data science as well, right? So we live in a world where data science is literally everywhere around us. The most simplest task of you opening a calendar, opening your calculator on your phone, or whatever it is, involves so much on the back end to analyze and assess whatever it is that you do, right? So that's the most important thing. Now, I am sure you guys will be very curious. If you have clicked on this full course video, I am sure that you are very much interested to learn data science, and of course I'm going to do everything in my power to give you all the knowledge there is to know about data science in this particular full course video. But you have to understand this, a very very important point even before you learn data science, is that having a career in this, right? If you get a job in the domain of data science, it is extremely rewarding. Now, data science is actually not a new concept. Before, people thought data science is okay, it's just one of the computer science concepts, it's one of the information technology or IT concept, right? Now, guess what? Over the last couple of years, it has been so powerful that people are saying that it is one of the most trending computer science careers of all time. They are not saying that it's one of the most trending IT career, even bigger than that. They're saying it's the most trending computer science career at all. How beautiful is that, right? So having a career in data science is extremely promising. It is highly rewarding, and believe it or not, it is always in demand. People, individuals, startup companies, established MNCs, all of these guys require data scientists or some form of data science in one way or another when you look at it, right? If you just spend 10 or 15 minutes of your time thinking about where or what problem a company is trying to solve, you can use the concept of data science there. You just have to think, you have to understand the approach of it, and then you can hone in on the domain and eventually work on that, right? So the takeaway from this slide is that if you have a career in data science, if you're very serious, if you sit through this entire session and understand data science into its depths that I'm going to be teaching you all, it is going to be very rewarding for you all in terms of knowledge, ladies and gentlemen. Of course, if you have a career in it, well, it's going to be a beautiful one, because I myself am involved in data science for I don't know how many years now, and it's been an absolutely beautiful ride. Right. Now, talking about why data science is required, right? Again, let me take you back into the past. Let me take you to 1969, July 20th. This was the day humans first landed on the moon. Did you know certain facts about this particular computer which helped humans land on the moon in 1969? The entire computer was guided by a processor which is only 2 megahertz in clock. The processors in your phone right now are 1,000 times faster, or even 10,000 times faster than this. We have computers which are millions and millions of times faster than this, right? And guess the amount of RAM that was involved in taking humans from the Earth to the moon. It was 0.004 MB. It was not even 1 MB of RAM that the entire computer was using, right? So that's an important thing you should know. Today's computers have my computer itself has somewhere around 64 gigabytes of RAM. It's almost running a 5 gigahertz clock on its processor. That's literally a million times faster than the entire computer that landed people on Mars. So the computing power we have today is amazing. And here is why data science is very important. We generate so much amounts of data today. It's amazing, right? What is the world population, guys? The world population, roughly is somewhere around 7.6 billion people, right? 7.6 billion. Did you know that we send somewhere around 310 billion emails every single day? 310 billion, right? So that is so many times more than the entire world population itself. If that amused you, read the next couple of lines. We generate 26 lakh terabytes worth of data every single day. Now, what is the total amount of storage you have on your laptop, your computer, your phone? It can be somewhere around 64 GB, 500 GB, 1 terabyte, 2 terabyte, 4 terabytes, right? Imagine storing 26 lakh terabytes every single day. That is the entire amount of data that the world generates for every 24 hours. When the sun goes up until the sun goes down once, this is the amount of data we're generating. So with the amount of computing power we have and the amount of data we have at hand, if we bring these two together, the amount of insight we can take away from this computing power and this much data is the reason why data science is so popular right now. With data and processing power, you can not only tell where you went wrong in the past, but you can predict what happens in the future. That is the power of data science, ladies and gentlemen. So, with this, I am very sure that you guys are curious to understand, well, how does data science work? What is the architecture? What is the backend? What makes data science work, right? Now, that is exactly what we are going to discuss here. Now, when I say data science architecture, there is a life cycle which is in play here. There are 5 important steps which makes data science what it is, right? Now, we're going to discuss all of these. It goes from left to right, as you can see on your screen right now with the arrows. Firstly, we have data acquisition. Afterwards, we have data pre-processing. Next, we have machine learning. After that, we have data visualization. And the last step is driving key insights, right? Let us go on to check each of them individually now. When I say data acquisition, what do I mean? Data acquisition is one of these terms which means that I have to bring in data and I have to, acquire data, right? So when you're working in an organization, bringing in data is very important. Now, yes, that is important, but it is not only one place that you'll be bringing in the data. You can have your data stored in the office server. It can be in a cloud computing platform. It can be stored, somewhere else on an offshore server. It can be, data from competitors, data from your Instagram. It can be data from social media. It can be data from a pen drive, a hard disk, whatever it is, you get the point, right? So the first step in data science is to bring in data. Only when you have the data, you can work with it, right? So knowing that you can use these varieties of places to bring in data and store it and work with it is step 1. Now, data is a very important entity, right? So many times data is private. Your privacy is the most important concern for many companies across the globe today, because yes, there are many things that you do not want a lot of people to know. So whenever data is brought in, it should only be accessed by the people who are authorized to access it and not everyone. Guess what? In step 1, data can be stored in a way where only an authenticated person can access it. So that is very important as well. But then to go on to do this in step number 1, you are going to require knowledge of how you can work with databases, because databases are what we use to store the data in step 1. Now, this is the end of step 1. Step 1, you have basically brought in data from multiple sources and you have stored it in one place. After this, you are going to work on cleaning the data, which is step number 2. Now, why do you have to clean the data? At the start of this module, I mentioned that data is a raw entity. It consists of things which are useful to us and useless to us. So whatever is useless, we have to remove it out. We cannot say, okay, anyway, I don't use it, let's keep it. No. If you do that, what happens is, in the next step, which is machine learning, right? Machine learning algorithms learn based on the data we feed to it. If we are feeding wrong, incorrect, and nonsensical data to it, it is going to be highly inaccurate. If you provide the wrong data to a machine learning algorithm, and let's say you're trying to detect the picture of a cat and a picture of a dog, it will see a cat and say it's a dog. It will see a dog and say it's a cat, and it's going to say that accurately. it is doing it incorrect because the data it sees is incorrect. To make sure things like this do not happen, data has to be cleaned. There are many ways of processing the data and cleaning the data. In the next couple of modules, we are going to be discussing all of this practically as well. So make sure you stick around to watch the entire duration of this course, because it is going to immensely help you understand the entire world of data science, right? Anyway, coming back, step number 1 was talking about bringing in data. Step number 2 spoke about how you can clean the data and keep it nice and ready for step number 3, which is machine learning. Now, machine learning is an amazing application of data science, because here we train machines, we teach machines to do certain jobs so many times quicker than us human beings and so much more efficiently, right? So what happens in machine learning is that we use algorithms, we use structured set of steps to actually go on to process the data and teach a machine of what it should do with that data. Once a machine learning algorithm knows what it has to do with the data, it is going to learn without the help of a human being. After that, it's going to be called as a machine learning model. Now, a machine learning model is going to be only accurate if your data is accurate, hence step number 2, right? So, if your data is correct, your machine learning algorithm is going to be beautifully accurate and work fine in most of the cases. If your data is not clean, it is not going to work fine, guys. That's a very important point that you have to note. One important thing that we always get asked is, how important is machine learning for data science? I can tell you this is that it is the most important, it is the most vital application that we have for data science today. Now, wherever you look at data science job, there is a good chance that machine learning might be asked there in a majority of cases. That is because the entire world right now is using machine learning in one way or another, right? So guys, you really should know the value of machine learning, and you have to understand that machine learning is like a cherry on the cake. The cake is data science. Machine learning itself, winds it up really nicely is my point here. So step number 3 after cleaning your data is feeding it into a machine learning algorithm, training the machine learning algorithm to work, and later we come to step number 4. Step number 4, we are talking about data visualization. Now, before we talk about step 4, let us talk about step 3 a little. At the end of your machine learning model, it is going to give you a textual output. It's going to say, hey, I detected this XYZ percentage of accuracy in this model or whatever it is. It's going to give you an output which you can understand if you know machine learning, or that you have some sort of technical knowledge there. What if you have to convey this result to a non-technical person? What if you have to convey this result to maybe a board member, a director, a non-technical person, an MBA graduate, anyone in your company? Well, this is where data visualization comes into the picture. With data visualization, we convert numbers into beautiful looking graphs and dashboards. With this graph, not just one graph, it can be a series of graphs, hundreds of graphs. With these graphs, it becomes very simple to convey a point, because what would you do, guys? You tell me. If you had an Excel sheet which has like 500,000, 5 lakh entries and 2 beautiful graphs which is going to tell you everything you need to know, would you read through, all this, I would say, junk, because you would not understand anything in a complex data, with that amount of data, especially on an Excel sheet? Or would you look at 2 or 3 beautiful looking graphs and understand what it means? I am sure you said the second option, right? Exactly my point. There is in fact a very nice fact if you did not know. The human brain can understand images 3,000 times faster than text. 3,000 times faster. Now, when you can convey something 3,000 times faster, why would you want to do it slower, guys? Think about it, right? So it is very important that you take an output which is only understandable by a small number of people and make sure that it can be understood by everyone, right? This is an art. You're trying to tell a story with the data that you have. You're trying to solve a problem by using art in the form of graphs and dashboards, right? That's a very important thing. Now, step number 4 is important, but guess what? You're going to use this result. You're going to use the result from step number 4 to go into step number 5, which is deriving key insights. Now, When I spoke to you about why data science is required, I spoke about how data science is, used to solve problems across the globe, right? Every company who using data science in one way or another are using it to solve a problem or multiple problems. The end solution will usually be an insight that you derive, an approach which will get you closer to the solution or take you to the solution itself, right? That is step number 5 here. Using these visualization, you can understand so many different things. You can understand why the company went wrong with maybe something in the past, or you want to predict the future. You can do all of that as well. Now, I just told you 2 cases. There are many more cases. You can find out all the gaps that are existent in the processes that you already have. Fix those gaps and make your company more efficient. You can look at KPIs, which stands for key performance indicators. Analyze who's doing what job. Are they doing it effectively? Is the process correct? Is the process efficient? Can it be done better? All of these questions can be answered very beautifully with the help of data science. So next, let us talk about the components of data science, right? Now you know how data science works. Now you know the architecture of data science. But there are these components which will make data science work, right? Think of data science like a car. Now you know what the car does, but do you know what are the components that are used to build the car? That is exactly what we're going to check out now. Now there are 4 important components of data science in my opinion that you definitely should know about. These 4 components are the data set, a programming language, a user interface, and the problem. Now I'm going to walk you through what each of these mean. Firstly, the component number 1 we're going to discuss is the data set. Look at the name of the video you're watching right now. Data science. Data literally is the first name in the entire concept, in the entire domain, right? So data is the most important thing in data science. Data sets are these things where we store, collect, and process data in an efficient way, which we can use in step number 2, which was pre-processing the data, right? And at this point of time, you really should know that data sets are the most important aspects of data science in a way where it is so much more important to data science than you might have thought of before. The quality of data, the quantity of data is going to directly impact the performance of maybe a machine learning algorithm, maybe an artificial intelligence model, and all of these, right? So it becomes very, very important that you understand how one can go on to finish all those steps without missing an individual step, guys. It's very important. So this is component number 1, having the data for data science. The second component is the most important one, is the programming languages that you're going to use in data science. Now we get a lot of questions asking, I am not good at programming languages. Do I need programming languages for data science? Can I do data science without programming? All of these questions, right? I have one answer for all these questions. You require programming languages compulsorily for the world of data science. In one way or another, you're going to be using a programming language in either a small form, long form, whatever it is, right? Because you can look at data and you can understand. Now you have been trained right from your childhood to look at a cat and say it's a cat, and look at a dog and say it's a dog. Your computer only understands zeros and ones. It might seem to be the most intelligent thing there, which is going to choose songs for you, it is going to recommend videos for you, it's going to be your personal assistant. Everything is fine. But at the end of the day, your machine at its most core level is just zeros and ones. That's it. Now, for you to communicate, you cannot communicate with your computers in zeros and ones. It's going to be very, very, it's just not possible, right? At the end of the day, it is, not efficient to go on to do that. To talk to your machine and to make sure your machine understands data, you have to use a programming language. The most popular programming languages we have in this particular domain is Python and R programming languages. Now I am sure if you've clicked on this video, you might already know that Python is a top programming language in today's world. If you're asking why, again, we're going to discuss Python, completely in another module in the upcoming sections here. But you have to understand at this point of time that Python is such an easy to use programming language. It is used in not only data science but multiple different domains out there. It is very easy to use, it is very powerful, it is very efficient, it helps you solve a lot of problems. That is the reason of why Python became the number one programming language, right? Now I've put in another programming language there, it's called as R programming language. R programming language is also a really nice programming language to use, but it is very popular in the domain of data analysis. Now, if you're looking towards data analysis, you usually start out by learning Python and then learn R, because R is completely built for data analysis itself. Right? Now, since you're looking at data science, I would suggest sticking to Python, learning Python, understanding Python, because it is the requirement for you guys to go through and understand data science entirely. So, if you were to ask me, or if anyone asks me how important is a programming language for data science, I am going to say that it is 9 out of 10 important. It is a must have in my opinion. Do not worry if at this point of time that you might not have worked with the programming language, you're not good at a programming language, maybe you tried it in the past and you realized it's not for you. If you learn a programming language in a creative way, if you learn a programming language in a way where it is interesting to you, the number of things you can do is going to amuse you thoroughly. Because I have come across so many people in my life who have learned programming languages and they did not like it because they couldn't do it well. But they started learning it differently. They started keeping a structured way of learning a programming language, and now they are master programmers in their own domain. And I'm confident that every one of you guys who are watching this video, right, every single one of you, you can become good at, you can become good at definitely learning a programming language and using it in the domain of data science, guys. Because when you're looking at the concepts of data science, for example, machine learning, a programming language is a compulsory requirement for you to communicate with your machine as well. Right. Coming to component number 3. Component number 3, we talk about a development environment. Now, what do I mean by a development environment? Now, you already know that you need Python. You have to learn Python as a programming language. The next thing is you have to type in Python to your computer and make it understand. So you need an environment where you can work with Python, right? That is called as an IDE, an integrated development environment. Now there are many integrated environments for Python. You can use PyCharm, you can use the Python command line itself. You have Google Colab, you have Jupyter Notebook. So you have so many different ways that you can write Python code. One important thing that you always have to understand is that using a user interface is very much advantageous. Why? Because here, once you use a user interface, you writing the program becomes easier. Now, these days, multiple user interfaces, I'm not sure if you know this, will guess what code you are about to type and eventually type it out for you automatically. So your amount of typing the code is drastically down because the user interface itself guesses what you're typing and just puts it out for you. How convenient is that, right? Think about another important point of what happens when you're programming. When you're programming, there is a good chance that, every now and then you have an error, you have a warning and all of that. I'm sure if you have ever done programming in your life, you would have seen an error or a warning, right? With the help of a good user interface, it can actually help you solve, debug and understand the error better in a way where you do not have to spend a good amount of time with it. A good integrated development environment and a user interface will guide you in a way where you know how to solve the error. That is how important, a user interface is. So the advantage is that you become super efficient. You will have time to concentrate on the logic, time to solve the problem rather than breaking your head about syntax, about how complicated a programming language can be. All of that is gone. Programming now is very easy if you use a good integrated development environment. Again, we're going to check out all of these practically in the upcoming modules as well. With this, we come to the fourth component, which is the last component in my opinion in data science, which is the problem itself. Now, when I say a problem is the component, why do I say this is because without a problem, can you have a solution? First of all, you have to realize that there is a problem and then work on solving that problem. So it is a component without which you cannot solve it, correct? So understanding that there is a problem that exists is the first step of solving the problem itself. In the case of data science, the huge advantage here is that it will make you think in so many different ways. You will be thinking out of the box. Now let me give you an analogy. Think about your favorite ice cream shop near your house if you eat ice cream. Is there only one route that you can take to that particular ice cream shop? Don't you think you can go through like unlimited number of roads to get there? It sounds meaningless, but if the ice cream store is 3 roads away, you can go 1,000 kilometers away and then take another route and come to that same ice cream shop. That is an inefficient way of doing it, of course, but an efficient way of knowing is that what is the 3 or 4 quickest ways you can reach the ice cream shop. This approach of you thinking in multiple different ways is going to be one of these reasons which will help you solve problems in data science, guys. So when you are effective at solving problems, eventually you get amazing at the entire domain of data science itself. So this is the fourth important component. Now, to talk about a career in data science, you have to understand so many important things here. First of all, I told you that having a career in data science is highly rewarding. It is one among the top 10 jobs to have right now, especially even though the pandemic is here, so many different things are so different right now. Data science is still a very, very strong domain. So to have a career in data science, you will have a curiosity saying, so who is a data scientist? Who is this person who works with data science, right? Now, let me tell you this. A data scientist is a person who is like a 4-in-1 person, right? So this person has to be a mathematician, this person has to be a trend spotter, this person has to be a programmer, this person also has to be a business manager. Now let's walk through each of these things. Mathematics. Maths and statistics are very, very, very important for the world of data science because these are like the foundations of the entire domain. If you do not understand mathematics, it becomes very difficult to become an expert in this domain. Of course, you can learn just the theory, by heart it or something, and then go to one certain level. But then if your foundation is not strong at that level, as soon as you keep building, what will happen? Eventually it will come crashing down. To avoid that, you have to be strong in mathematics because mathematics are what powers so many concepts here in data science, guys. So having mathematics in your arsenal is very important as a data scientist. The second thing is that this person has to be a trend spotter. Now, there are so many different trends which keep happening around the world. One important thing that is still amusing to me is all these years back, if you guys remember, there was a spinny little toy called as a fidget spinner which became super popular, right? Everyone in the entire world, kids, people in 20 to 30 years old, even 70-year-olds wanted a fidget spinner to play around with. Guess what? There was a trend portrayed saying that it might become a very popular toy because it is fun to play around with. And that is exactly what happened. So a data scientist needs to have the skill saying, okay, so I am looking at this concept. This concept is going to be trending in the future, right? That's one way of thinking. The second way of thinking is that, okay, so my competitor company is using this tool. He or she is using this technique. If I use this, there is a good chance that, I can use my arsenal of skills and create a trend myself, either finding a trend or creating a trend. That skill is needed for a data scientist, guys. And the third most important thing is that a data scientist needs to be a programmer. Now, programming, as I've been mentioning from the start of this module, is an important thing. Now, these three things, being a mathematician, being a trend spotter, being a programmer, you can definitely solve a problem in data science. Why do you have to be a business manager? Business is so different from data science, right? Guess what? The first three will help you solve the problem. the last one, the business manager role, will definitely help you solve the problem in time. Now your company can tell you, hey, this is the problem, I want to solve it in 10 days. You can solve the problem maybe in 25 days, but you have a limit now, 10 days, right? So the 10-day limit where you have to adjust yourself to work and provide the goal, that is where the business side of things come. To match the business requirement, you have to have that knowledge as well. So it's very, very vital that a data scientist is also a business manager to a certain level, which is definitely required if you're an individual. No matter where you are, you're in a startup company, small company, you're in a multinational corporation, wherever it is still the same, guys. Right now you know who a data scientist is, but did you know this about the data science career after the pandemic ends? Now, if you go back to March 2020, right, the month March of 2020, a lot of people were panicking immensely about the pandemic. Thousands and thousands of people lost their job because there was a recession which was coming just because the entire world was locked in because of the COVID-19 pandemic, right? Guess what happened to the world of data science then? It showed so much resilience, it showed so much power that maybe 0.01% of the data scientists were laid off in the entire world. That is how powerful it is, right? There is always a constant requirement for new data scientists, right? Companies want more and more and more data scientists. Why would they fire the ones they have when they want more of it, right? It doesn't make sense. So since the demand is so high, with the pandemic, people said it's going to be a recession, people are going to lose their jobs. Of course, people lost their jobs, but the domain of data science showed so much power that now it is concrete that this is a domain that you definitely should look towards as well. Because machine learning, artificial intelligence, deep learning, these are the concepts that everyone around the world are trying to see if they can use to increase something in their business, make their lives more comfortable, sell a product better, whatever it is, guys. So if you're wondering about what happens to data science after the COVID-19 pandemic ends, the trends just are like this. It is just an up and up and up graph, which is definitely amazing. And that now you know that it is trending, I highly suggest you spend a good amount of time becoming a master in this domain, because it is hugely advantageous. If you have a career that is so much fun to work with, it is highly paying, you're going to enjoy your job, there is good amount of job security, you will play a huge role in solving the world's problems. The advantages are so many, guys, right? Now you will have a question saying, okay, so the entire world or most of the world is working from home now, how does that work? All these big companies say, until everyone is vaccinated, everyone is going to work from home, and people are okay with that. For example, the video that I am recording right now, I am doing it from home. It's amazing. It is possible to even use data science itself to track what the employees are doing. That is how amazing this particular domain is, guys. But there is nothing that says to be a data scientist you have to be in the company, you have to be in the office. Most of the time that is not the case. Since this domain shows so much amount of growth, so it is so stable that regardless of where you are in the world, whatever time zone you're sitting in, you can use it to solve problems in your company, if your company allows it, of course, and eventually solve the problems, right? So it is possible. If you are a person who's watching this particular video, and if you're a fresher or a person with less than 3 or 4 years of experience, and if you're wondering about what the future looks like for you, you are in for a treat. Because first of all, thousands of job postings are put up every single day for data science. Every 7 out of 10 job postings that are put out asks for freshers, people with 1 year experience, 2 year experience, 3 year experience, and 4 years of experience. This does not happen in a lot of different domains, because every other domain you look at, they're like, we want someone with 5 years of experience, we want someone with 10 years of experience and all of that. Here is a chance where 7 out of 10 of you all, freshers and people with less amount of experience have the chance to get a job in this domain, right? That is not possible, in my opinion, in a lot of other domains. Of course, there are certain domains, but not as strong as this. So you are, in for a treat if you're you're expecting an amazing career in data science, because it definitely is like that. Now, guys, if you are talking about the designations that one can have in the case of data science, right? Um, a data scientist's role is something we discussed, but that is not the only designation that powers the entire world of data science. There are multiple designations: a data analyst's role, a business analyst's role, a business intelligence analyst's role, a data engineer's role, and I can name maybe 5 or 6 other designations which you can have if you are working at a, in the domain of data science itself. But the 4 you see on your screen are the top 4 designations of this particular domain. Now, a data analyst is involved in churning through a lot of data, giving out insights, analyzing the data in depth to see again what happens in the future, what went wrong in the past, where are we in the current standing. So many things that a data analyst can do. A business analyst can also look at the business side of things, assess maybe why the sales are so low this month, what is the amount of sales we might do in the next month. So all these business related things a business analyst can take care. A data engineer can take care of all the data that is coming into his or her company. Right now, we've already seen that we generate somewhere around 26 lakh terabytes of data every single day. But of course, not one company uses all 26 lakhs every single day. But a data engineer's role is to create a pipeline where you can store the data in databases, use it in the next step very efficiently. That is one of the main jobs of a data engineer. Now, a BI analyst, BI stands for business intelligence. Right now, think about the name, business intelligence. So this analyst, this person uses amazing tools we have, such as Tableau, Microsoft Power BI. There are so many different business intelligence tools that this person uses to eventually create beautiful looking visualizations, dashboards, charts, reports, so many things, and provide a solution to a problem via these kind of visualizations, guys. That is what a BI analyst does as well. So if you are a person who's looking towards a job in data science, and if you think that a data scientist role is the only role in data science, the answer is no. You have many roles, but these are the most popular offerings in my opinion. So I hope I was clear with these concepts, guys. Next up, we will be moving to module number 2. Alright, ladies and gentlemen, welcome to module 2 in this data science full course video. Now, in module 2, we are going to be discussing a lot of things very important into the world of data science in the concepts of statistics. Now, in module number 1, we had already covered how important statistics is, but to reiterate, here are some of the things you should know. But then before we actually get into that, I want to tell you guys all the takeaways are for this particular module, right? So module number 2 will consist of an introduction to what statistics is, why it is required, and a lot of other things which is needed for data science. After which we're going to understand the various types of data collection that we can go about doing if we are working with statistics, and then we're going to be talking about the various types of statistical analysis that one can go on to do it. And of course, there are very important metrics and measures in statistics that is going to help you a lot in your data science career. So we are going to discuss all of that on this module as well. Right, guys. Now, coming to the introduction to statistics. Now, what is statistics? What is the meaning of it? What is the use of it, right? See, statistics is basically like proving a fact. Now, if I just say that, that I have 10 apples in front of me, and if I don't show you any proof to it, it can be true or false, but there is no way for you to find it out, right? But if I say, hey, here are 10 apples in front of me, and maybe I show you a video of it, I have proof, I have data to back up what I say. That is statistic, right? So statistics is like a way of how one can go on to not only just provide adequate proof to the fact, but also, find a way of how you can keep things measurable if your data is numerical. But of course, data can sometimes not be numerical as well. We're going to check that out, in the introductory part of this module, right? Now, when we're thinking about statistics itself as a concept for data science, one thing, ladies and gentlemen, that you have to know at this point in time is that statistics is a must. You definitely need statistics if you're very serious about having a career in data science, because without statistics, let me tell you, it will become very difficult for you to understand certain concepts of, you will not understand why things work the way they do right now. If you do not know that, once you go to the intermediary levels, then it becomes so difficult that you cannot continue ahead unless you actually go back to the basics and understand it. Now, to avoid all of that, keeping all of this in mind, I have put down statistics as module number 2, which is very important, right? Now, let us actually talk directly about the career aspect of data science for 1 second here, because whenever you're thinking about applying for a data scientist role, 90% or 95% of all of the job postings are going to ask for knowledge on statistics, and of course they're going to ask a little bit about mathematics as well. Now, statistics is a concept which is powered by mathematics. That is very important. So if you do not have statistics, and if statistics is a very, very important requirement in a job profile, well, you might not clear the requirement, right? That can be your make it or break it with your career in data science. So make sure you're working on statistics, guys. Now, why do we use statistics for data science? The primary thing here is that we're going to be using statistics as a concept where we will be using all of our data, analyzing this data and getting new insight out of it. Now, when I say analyzing, of course, we're going to use concepts such as machine learning, deep learning, and whatever there is. But to go on to check the working of the process of analytics, there is statistics involved there, right? So it's a core concept. It's a foundational concept upon which other concepts are built upon. So you definitely need to have knowledge upon that. Now, machine learning is of course one of the modules we're going to be covering detail, in the next couple of modules here. But you have to understand that the entire world of machine learning, of how algorithms work or how machines learn, right? It is completely based upon statistics as a core concept. When you bring in statistics, when you bring in data, when you bring in computation power, club all of these things, the product you get is a machine learning model. But to get to the product without statistics, you cannot go there, right? It's still going to be a raw form. Now, that is a very, very, very important thing, ladies and gentlemen, that you should know at this point of time. Now, as I've mentioned, it's not only machine learning, it's not only deep learning. If you are very serious about your career in data science, statistics is one of these concepts that is not only looked at when you're applying for a job, but even, let's say there was a job description which maybe did not ask for statistics, and they you were enrolled into the company, you start working. Guess what? After you start the work, there is a good chance that you will have to come across a concept which works based on statistics, where you might stumble upon, where the company might have not trained you, your engineering program, whatever it is that you did education wise might not have covered. Then it's going to be a real big issue. So to avoid all of that, I highly suggest you all consider statistics, right? Now, one important thing about statistics is this concept which is powered entirely by data, like everything else in this particular domain of data science, correct? Now, in data, there's many different types of data. Now, when I ask you what are the types of data, there's a good chance you're going to say, data can be an image, data can be video, data can be music, data can be text, data can be this, that, all of that, right? Fantastic answers, all of those are correct. But when we are talking about statistics terms, data is actually categorized into just two different things. We have categorical data and we have numerical data. Now guys, take a second to actually go on to pause the video and see if you can find out what categorical data means from the image that you see on your screen right now. Numerical data, I think, will make sense to a lot of you all, right? Numerical, it means numbers. We're going to be dealing with numbers in that aspect of data. But when I say categorical, when I say category, what does it literally mean, right? Try to see if you can find that out. But of course, I'm going to tell you what it means right now. But for now, understand that data as one entity gets divided into two things, categorical data and numerical data, right? To talk about categorical data, it is this kind of a data that mostly deals with textual data. Now, text is very different from numerical data, right? 1 plus 1 is 2. This plus that is what? You cannot say that, right? By what I mean, I'm asking you a question. So handling numbers is very, very, very different of how one can handle textual data. Just like how you're processing whatever I am saying right now is very different from how you would maybe do a mathematical problem or solve it, right? Think about it. In the case of categorical data, since I'm saying it's mostly textual data, there is a wide variety of data that you can put out with text, right? So there has to be some further division in this tree of data which simplifies of how we have categorized all the text in the world to be in a structured way, in a way where it is like an umbrella format. 1 divides into 2, 2 divides into 4 and all of that, right? Now data divides into categorical and numerical. Categorical divides into 3 types of data, which is ordered data, nominal data, and of course we have binary data. Now, to talk about ordered data, whenever I say order, it means that there is a certain rule that follows these kinds of textual numbers, right? Think about priority, think about rankings and all of that. Now, to give you an example of a priority, maybe you guys are in college, your lecturer is going to say, hey, this assignment is on priority. This is the first priority. This is the second priority. This is the third priority. Or even if they don't say numbers, they're going to say, hey, put this on priority, right? Deliver it on priority. That's a measure, that's an order. They're telling you, follow 1, 2, 3, follow this particular order to get the job done. That the data there itself has order. 1, 2, 3 is also an order. Now, whenever someone wins a car race, now I am a huge fan of Formula 1. Of course, if you guys are fans of Formula 1 or MotoGP or any other forms of racing sport, head to the comment section and let me know. But yeah, whenever there's any race that happens, a competition, prizes are given based on the top first person, second person who was a runner-up and the third winner, right? Now this is called as a podium. A podium consists of the top 3 people, the winner, the runner-up and the third person in the list. That is an order, right? The order of how people finish the race, that is ordered data. Now, if you're talking about nominal data can be everything that I am saying right now. There is no particular sense of order. Of course, there is a tiny sense of order when you look at my English, when you listen to my grammar, the way I communicate, there is an order there. But there is no order such as 1, 2, 3. There is no order that says I have to speak these words in this particular order. There is no script here, right? That is what nominal data means. Now guys, take a second to see if you can think about any other example that might come into your head right now, which is nominal in nature. Now, everything that does not have an order, which is not a number, which cannot be categorized as 1 and 0, is considered to be nominal data. That is how simple and vast nominal data is, right? I hope you got the point there. Now, let's talk about the third type of categorical data. The third type of categorical data is a very important one. It is binary data. Now, I am not sure if you know this or not. Again, I've already mentioned this in module number 1. Your computer is probably the most intelligent processing thing apart from a human or any other organism that is sitting in front of you right now. You may be watching this on a mobile. You may be watching this on an iPad, your computer, your laptop, your television. Anything digital, right? Any digital item out there in the world understands only 2 things, 0 and 1. Literally, that's it. You might say, hey, no, I have Alexa, I have Siri, I have, all of these personal assistants which are amazingly intelligent and all of that. Correct. Again, when you break down Alexa into its most simple form, no matter what concept you're talking about, right? When you go on to break all of these down into its simplest components, they definitely work on the basis of zeros and ones. So that is one of these concepts, right? Now, if you have to talk about the binary approach in nature itself, think about an approach where you have only 2 outcomes. For example, day and night. true and false, 0 and 1. The things that only have two outcomes can be considered binary in nature, right? So this is one of the very, very important aspects of categorical data that you as a person who is looking towards a career in data science and statistics should know. Now, categorical data is fine. We talked about ordered data, we talked about nominal data which does not have order, we spoke about binary data which is textual data which has two different meanings, day and night, left and right, up and bottom, all of these things, right? Now, let's talk about numerical data. When the talk is about numerical data, it is very easy to say that, hey, everything around me is a number. Well, you are right to one certain extent, but in the case of data science, if you go on to have that kind of a generalizations, things will not work here. So, in numerical data, right, data which are numbers, 1, 2, 3, 4, 5, -1, -1.3, all of these things, right, even imaginary numbers, right? Now, the concept of imaginary numbers is fascinating. You will never see an imaginary number in your real life. That's the reason they call it imaginary numbers. Now, you have one apple in a tree. You will never see the square root of -1 apples in a tree, or you will never see 3 plus 5 apples in a tree, right? It's a complex number. It's an imaginary number. All of these things will not work. Now, you have to consider all of these things whenever you're working with data science, right? So there are two different types of numerical data which always takes center stage when we discuss about this. It is discrete data and it is continuous data. Now, when I say discrete and continuous, can you actually pick up, what I'm trying to say here? Because with discrete, what happens is that the data if you have 3 data points, maybe 1, 10 and 20, there might not be a way of how you're looking towards a continuous path of 1, 10 and 20, right? Between 1 and 10, there are 9 other numbers. Between 10 and 20, there are 9 other numbers. Now, when in that particular case, data is not continuously growing. It is discrete. It is random. It is, I want to say hodgepodge, but at the end of the day, it actually isn't, right? Now, when you give it a thought like this, I have one number which is -10,000. I have another number which is 1 lakh, and maybe I have another number 0.001. Think about this. This is discrete data. It does not have a particular specific order that it has to go on to, work with. So a very good example of discrete data can be the number of days or the days itself in a calendar. Monday, Tuesday, Wednesday, all of these things, right? It goes all the way to 31st and again circles back to 1 and starts. We don't have 32, we don't have 33. Even though the order goes on, we split back and round back, right? That is discrete data. Now, if we are talking about continuous data, think about what the word continuous means for a second. Continuous literally talks about how you can go on to track something, track a number from its beginning till the end. That is the reason, I have an image on your right which shows the age of a person, right? Now, when a person is born, as soon as they're born, they are 1 day old, and probably at the last day of your life, they may be 70, 80, 90, 100 years, of course, whatever it is, right? So, during these times, one very good example of a continuous variable is the height of a person. Now, a newborn baby will not have the same height as a fully grown adult, maybe at the age of 24 or 25 years old, right? Think about it. How a baby goes, it's tiny, grows, and eventually maybe the guy or girl becomes 6 feet tall, 5 feet tall, whatever it is, right? So it's a continuous process. And maybe as age sets in, the height might drop a little. All of that is there, but it's an order. It is ascending 90% of the time, right? That is continuous data. Now, with this, I hope you have a complete clarity about what discrete data is and what continuous data is. Discrete data does not have an order. It is just random. It can, you can compulsorily map an order if you want to real badly, but in the sense of context, you will not be able to do it. That is why it's called discrete data. In continuous data, that is not the case. The main context itself talks about how data is connecting from one point to another. Right. Now, one important thing that you have to understand when we're talking about statistics is in data science, especially, right? Data science step number one, as we have discussed in module one, is all about bringing in the data to your organization, collecting data, right? Data sometimes is readily available, but there are certain cases where data might not be readily available as well. So there you have to collect it from a variety of sources. Maybe it's on your local storage, maybe it's on your competitors website, maybe it's on a cloud platform, wherever it is, right? So you have to collect it to process it. Now, when you are thinking towards all of this, handling data is important, yes, but before even handling the data, you have to collect it and store it, right? Now, if you think it's very easy to, just grab in data, put it in a database, store it, well, you are wrong, because it is a very, very complex concept which is broken down into so many simple things, as as I'll show you right here. So, we have already discussed about one nature of data is that it can be very, very complex, right? Data is one of these things which, I already told you we are generating somewhere around 26 lakh terabytes of data a day. So, how much amount of data do we use for data science? What amount of data do we proceed and make use of, make sense of for our application? It is a number which is not concrete all the time. So to even collect data and to start using it, your data, right, once you collect this entire data, it is called as a population. Now there is a reason why they call the world's population is 7.5 billion. So population is literally a term given to the entire thing in consideration for that context, right? Now I have given an example. Take a look at your screen, take a look at the presentation right now. What is it that you see on the left? Of course, there's population and there's something called as sample set. Now with population, what I'm trying to say here is this is like the entire collection of leaves and flowers, right? This is a total thing. On the right, sample set consists of only 2 flowers which are present on the left, right, from the entire population. Now what is sample set? Sample set basically talks about being a part, picking up 1 or 2 or 10 or 1,000 little parts of your entire population for analysis. Now, coming to data analysis, I know that you already know it as a vital part of data science by now, but not all the time we are going to use an entire population of data to go on to process something. We break that data down, we consider tinier bite-sized chunks, and we call those bite-sized chunks which are a part of the bigger population as sample set. Sample set is nothing but a simple collection which is already present in the population, but we only consider that and not everything else. Now, as you can see, there are 2 flowers which I've put in. Again, those flowers are also present in the population, but everything else is not. That is what makes a sample set, right? You have to understand that. That's a very, very important thing. Now, you might ask a question saying, okay, so why did you pick up only those 2 flowers? Why not the other leaves, the other beautiful looking flowers? Good question. So how can you pick up one sample from multiple different concepts, from multiple different data, right? This can be done in 2 ways. We have something called as random sampling and we have clustering. Random sampling is what I did previously. I just saw the population, I randomly picked 2, there was no thought which went into it, I picked it, I put it to the right, I called it sample set. That is the random way of doing it. Instead of showing you 2, I could have shown 9 out of 10 and called it a sample set. That would have worked. Yes, even a majority of the population data can be called as a sample set. This is one way, randomly picking anything I want in any order I want in any fashion I want. The second thing is clustering. Clustering is not random. It actually has an order to how you can pick it. Now, let me quickly go back to the previous slide here. You can see, take a look at the population. You can see certain leaves and you can see certain flowers here, right? Flowers are there and leaves are there. Random sampling, I told you, we just pick up random things. Now, if the talk is about clustering, with clustering, what I do is I follow a principle, I follow a rule to pick it up. Now I'm going to say, hey, I want to pick up all the leaves and I separately want to pick up all of the flowers. So I put all the leaves on my left side, I put all the flowers on my right side. So did you see what I did there? Flowers are clustered on the left, so it's a cluster of flowers, it's a cluster of leaves. It is separated based on an order, based on a principle, based on a rule. So this is how samples are actually picked up in real world. Either you do it completely randomly or you pick it up in an ordered fashion and then group it. And of course, grouping it is not the only way. Instead of clustering, you can actually have it, let's say all the images were flowers and you just wanted flowers. Well, you can pick 9 out of 10 flowers, 5 out of 10 flowers and still call it a flower, right? There is no clustering, there is no order. But if you want to order, you can do it. Yellow color flowers, red color flowers, blue color flowers, all that can be done as well. Again, one thing can lead to another, that can lead to another in the concepts of statistics. That is why I am trying to break it down into such a simple fashion that all of you guys understand this. Now, with that, I am sure you have been clear about how sample sets work, how we go on to pick the data and all of that. So using all of these data, we perform statistical analysis. Statistical analysis is the middle step in between input and output, or problem and solution, right? So there are different types of statistical analysis that you should know about if you're considering data science. What are these? There are many different ways of statistical analysis. Let me tell you that right now. But to go on to give you a complete picture, which is exactly what I'm going to do right now, first you have to understand the two most popular ways of how one can go on to perform analysis. Now, the two important methods of how one can go on to perform analysis is qualitative analysis and quantitative analysis. Qualitative analysis, quantitative analysis, right? Now, if you look at the example on your screen right now, can you figure out something? Can you understand what qualitative data means? Because what you see on your screens are pens, pencils, and a lot of other stationery, right? On the left, if we are talking about qualitative analysis talks about the data having a categorical output. In categorical output, the output is not a number. So what is the example? What are you seeing on the left when you see those pens? You're seeing a blue color pen, you're seeing a black color pen, you're seeing a dark blue, you're seeing a green color pen. Maybe the ink color varies, maybe the pen itself varies. There are two pens which are golden in color, two pens which are silver in color, right? If you are looking for that kind of an output, you will be looking towards qualitative analysis. If you're looking towards another output where you want to measure the number of pens I have put in on your screen right now, that is where you definitely would be looking at quantitative, because here we have a quantity, here we have something measurable, here we have something which we can go on to analyze, right? It is an important thing. Now let us talk about all these in detail, but then before we do that, you have to understand two other ways there are how one can perform analysis. It is inferential statistics and it is descriptive statistics. Now, can you again figure out something with the name inference and descriptive? Inference talks about of how you can infer something if you have already known something, right? Now, I'm going to give you an example, do not worry. When you're talking about descriptive statistics, description. Now, when, this video itself has a text description in the description box. When we're saying description, we are trying to describe something. We're trying to put out a detail in depth, right? That is descriptive statistics. Inferential statistics is going to talk about of how, why one might get to that result. Descriptive statistics talks about all the details of how a person went into that result. Now, let me explain with an example here. Inferential statistics, right? Again, as I told you, in the case of statistical concepts, in majority of these cases, we are not going to consider the population. We are going to take a sample out of it, which will be the sample space or the sample set, right? Sample space and sample set literally mean the same thing. Now, we're going to use that to create some inferences or make some inferences. Now, Take a look at the example on your screen. I have written 18 sedans, 4 SUVs and 3 convertible cars. What is the inference as soon as you see it? Well, here is an example of an inference. If I ask a question saying, okay, so which is the highest type of car, in numbers that are present there? You will of course say sedans, because there are 18 sedans in consideration, right? Which is the highest number of cars present there? Sedans. Which is the lowest number of types of cars which is present there? Convertible cars, which is 3, right? Are you getting it? The inference is you giving out an answer for the data which you have at hand. That is inferential statistics. Now, if you're talking about another concept which is very, very important in the case of inferential statistics, of how you can get to an answer by using data, there is a very, very, very important concept, ladies and gentlemen, in statistics. It is called as hypothesis testing. What is hypothesis? Hypothesis is like when you get to the proof of a solution, when you do not know, remember the first example that I told you about how you can have fact, but if you prove it with data, it becomes information. Hypothesis is when you cannot prove something yet, but you just lay out a foundation saying it might be the case, a guess, a very calculated guess, right? That is hypothesis. Now, what is hypothesis testing? Hypothesis testing talks about how, your analysis or the result of your analysis can either be working in your favor or it can be working against what you thought. Now, the concept of gravity is known by all of you all, right? Now, if I take a piece of paper and if I drop it, it is going to fall. Now, if I put a hypothesis there saying, no, the paper is going to float in mid-air, the hypothesis is wrong because gravity will act on it, right? I just dropped it, the paper dropped. The hypothesis there is wrong. Now, if my hypothesis was something saying that, I have a paper here, gravity is a force that is going to act on it, the paper will drop as soon as I leave it. Correct. The paper actually dropped. That is the difference between a hypothesis which failed versus a hypothesis which is true. Now, let us actually take a numerical example. Let us get into a little bit of probability. Of course, we're going to have another module discussing probability into its depth. But for now, here is an example. Let us consider a very, very, very simple situation. I'm going to break it down in the most simplest fashion that I can. Let us say that there are 8 people who walked into an interview at a particular company. Now, whatever is your favorite company, you can use that for your story, right? Now, if the company says, hey, we are only hiring 1 person right now, it doesn't mean that 1 person has to show up for the interview. 8 people can come in, 800 people can come in, correct? Now, what is the probability of a person being picked out of these 8 people, right? There is only 1 job. There are 8 people applying to it. So it becomes 1 divided by 8. So the probability of 1 among those 8 people getting a job is only 12.5%, correct? Or 0.125. Now, what is the probability of, the same person, who thought that they're going to get picked, who will now not get picked? It is a very simple thing. Probability works between 0 and 1. If the probability of 1 person getting picked is 0.125, the probability of the same person not getting picked is 1 minus that 1. It is the difference from the total, because difference from the total is going to give everyone else or the probability of the same person who will not get picked. So the answer is 87.5, right? Now, if you're wondering about why I said 12.5% and 87.5%, think about percentage. When I say percentage, data is from 0 to 100, correct? If the person getting picked is 12.5%, what is 100 minus 12.5? 87.5? Well, there's your answer, right? Now, if this person gets selected for first round, let us say person A got selected for the first round, what is the probability that this one person might not get selected, into the second round? It is simple. What is the probability of the person, not getting selected? 7 by 8 or 0.875? The second round is going to be the same amount of filtering, right? So just multiply it twice. 7 divided by 8 into 7 divided by 8, or 0.875 into 0.875 is going to give you 0.765. Now what does that answer mean? It means that there is a 76.5% chance that the person who got selected in the first round might not clear to the second round if everyone else cleared the first round as well. Right. Now, to give you a concept of hypothesis testing in the case of how you'll practically use it, well, here it is. When we speak about hypothesis testing, we speak about two things. One is the null hypothesis and the other one is the alternate hypothesis. Now, in the case of null hypothesis, it is going to be a statement that you are going to make. It is going to be an assumption, right? You're going to assume something and try to prove if it is correct or wrong. In the case of null hypothesis, if your result is the same as your original assumption, that statement itself is called as null hypothesis. Now, let's say we are trying to find out if gravity exists or not. My assumption is that as soon as I drop this piece of paper, it is going to fall because gravity will pull it down. My assumption is paper falling down and my result is paper falling down, right? Well, guess what? My hypothesis is now true. Null hypothesis became true. It means whatever I assumed was correct. Whatever is the result matched whatever I assumed, right? Perfect. Now, think about alternate hypothesis. Alternate hypothesis talks about a situation where your original hypothesis or your original statement contradicts. Your result is the complete opposite of what you assumed. Now, if I assumed that a paper will fall as soon as I drop, and if gravity did not exist, now think that we are maybe in the International Space Station or in space. If I leave the paper here and take my hand away, it is going to remain there, right? Because there is no gravity there. But if I try to say the same thing on Earth, if I say here, hey, I'm going to leave the paper here, I'm going to remove my hand, the paper is going to float in midair. Well, the result is paper falling. Me assuming that the paper is going to stay there doesn't absolutely make sense. So that is an alternate version of the null hypothesis, right? That's why it's called as alternate. But whenever you're going to hypothesize something, whenever you're going to assume something, when you know the result or when you're working towards the result, there are two things that can change your assumption rapidly, or there are two things which is going to hurt your analysis when you assume something. It is randomness and biasing. The concept of randomness is very, very important. Now, there are so many things that you can look around and say, hey, that's so random. If you look into the depths of it, things cannot be random everywhere because you can find some certain order if necessary there, right? Of course, when you look at it on the plain scale or on a wholesale scale, you're going to say, yes, it is random. When you start looking into the depth of it, you will find an order, or you might find an order. If you find that order and if you still call the data random, well, it is not random anymore because there is a certain order. You can use a rule or a principle to get that same data back in that order, right? That defeats the principle of randomness. Alternate hypothesis, that's what I'm trying to tell here. And the other thing is biasing. Biasing is one of, in randomness itself, we have a concept called as random bias. Random bias literally means that your data is not random enough to be called random. It's a bias. It is directed to one side. It is not in the midpoint of yes or no, true or false, in a way where it does not affect. It is not true, it is not false. That is biasing. Biasing is when your data is skewed either to the left, to the right, to one decision, to the other decision, wherever it is. Once your data starts misbehaving like this, the result that you drive out of this data again is not accurate. That is hypothesis testing, guys. Right. Now, we spoke about inferential statistics. Now is the time to talk about descriptive statistics. Alright, so when I've said descriptive statistics, what I actually mean is the fact that you can describe the data, right? I already told you this. Let us take the same example we discussed for inferential statistics. 18 sedans, 4 SUVs, 3 convertible cars. If you have to describe that example, how would you do it? You're going to say, hey, there are 4 sedans which are maybe blue in color, red in color. Then you have, 5 cars that are actually a sports model. You can have a comfort and a luxury convertible car, or you can have a sporty car which flies to 300 kilometers per hour or something like that, right? You're describing the car here. One tiny description that I've already put in is the type of car. Now, a sedan is a car which has 4 doors and it looks very different when you look at an SUV or a hatchback. A convertible car can open the roof while other cars cannot. Something like that. There is a certain amount of description there, but you can find even more descriptions on it. That is what is descriptive statistics, right? Describing the data, getting more of what you have, about the data. That is important, guys. That is descriptive statistics. Now, there are certain measures, there are certain very, very important measures in the concepts of statistics that you have to know about. I am sure you might have heard of whatever it is that you're seeing on your screen right now, measures of central tendency, right? I bet that you might have, learnt about this in your school, in your college, or wherever it is, or at least you know the concept of it, even though you might not know the name. So what do I mean when I say measures of central tendency? Well, measures of central tendency, again, is a measure. It's a numerical value. It's a way of how you can describe things. In this case, of course, we're describing data. There are 3 different measures in the case of measures of central tendency. They are mean, median, and mode. Hey, I said it right. You might have heard about this, and I hope, again, you might have heard of it again. If you've heard of mean, median, and mode, head to the comment section and just put down a quick yes and what you think about the concept as well, right? Now, what is mean? What is median? What is mode? Mean is one of these names which is given to a mathematical concept where we try to find the average of all the numbers that we have at hand. How do you find the average, right? We're going to look at that, don't worry. When I talk about median talks about if you have an ordered amount of data, what is the middle element in that ordered data? Again, I'm saying ordered data because it is compulsory for the data to be ordered, and you finding a middle element there, because if there is no order, your middle element is random. It does not make sense. That is not the median. If your data is in either an ascending order or descending orders, that is when you pick up the middle element, and that is when it is called median. Otherwise, absolutely no. Right, that is the median. When we talk about mode, mode is a very, very nice application which is used a lot. It's a great measure of central tendency because here we talk about the frequency of occurrence of elements. How many times can an element occur, right? Again, I'm going to give you all examples about mean, median, mode, and all of that. So let's get started with mean. Mean, as I said, is how one can go on to find the average of numbers, right? Take a look at your screen right now. How many numbers do you see right from 150 all the way to, all the way to 91, right? You see 10 numbers, right? These 10 numbers, can you find an order there? I don't think so, right? Because I randomly put out whatever number that came into my head when I was creating this. Now, if you are one of these persons who has to find the average of all of these numbers, well, how do you find the average? You take all the numbers, you add up all the numbers, and you divide it by the total number of numbers that you have, right? In this case, we have 10 numbers in total, so your denominator is 10. In the numerator, every single number we have to add all of it to find one common average. Now, in this particular case, if I do 150 plus 100 all the way until 91, if I add all of that divided by 10, it is going to give me a number 238.6. So the mean of this data is 238.6. That is how simple and straightforward mean is. Now let's take a look at median. One important pointer I gave you about the median is that data has to be ordered. If your data is not ordered, it is not possible, right? Again, take a look at the original, whatever we discussed with the mean. I have the same data here, 150, 100 all the way to 91. It is not in order, so I have rearranged it in the case of ascending order, 25, 36, 54. It's the same numbers as you see on the original data, but now I have arranged it, right? So if I have to find the median, it means it's the middle element of something, right? Now, if you have odd number of elements, 1, 2, 3, 4, 5. What is the middle number? 3, right? Because you have 1 and 2 on the left, 4 and 5 on the right. Middle 3 stands right exactly in the middle. That is if you have an odd number. Now if I have 1, 2, 3, 4, and if I say what is the middle number, the middle number is not 2, the middle number is not 3, it is in between 2 and 3, right? Now, in the case of an odd number, as you can see on the third chart that is shown on your screen, I've just removed one element and ordered it again in ascending order. The middle element is 100, so the median in that case is 100. Look at the middle now. I have of course rearranged it. The number of elements are still 10 here, but now since there are even number of elements, the average of the middle two numbers are considered. So if I want the median of this particular data, which consists of even numbers, it is 100 plus 150 divided by 2. So basically the average of 100 and 150 is the median in that particular case. So the answer is going to be 150 plus 100 is what? 250. 250 divided by 2 is how much? 125, right? That is the the median of the value that you see there. Perfect. I hope median was clear. Now let's take a look at the mode. Mode discusses about how numbers tend to repeat and how many times an element is particularly present, right? Take a look at your data right now. I have everything from 150, 100, 200. The data is not ordered. But can you find the element which is most repeated, which is repeated most number of times? Of course, it's 150, right? Because you can see 150 3 times in that data. This is, a mode. If 150 was given only 2 times and if all the other elements were unique, again 150 would have been the mode. What if every single number you see on your screen is unique? How would you say one number is the most occurring number there? It does not make sense, right? Correct. If there are no repeated numbers in a list, the mode does not exist. If there is a number which is repeated more than once, the highest number of times a number gets repeated, that becomes the mode. But if there are no numbers and everything is unique, there is no mode, guys. That is a very important point that you should know. So I hope mean, median and mode, the measures of central tendency were clear to you. Now we are going to look at more measures. This time we're going to check out a very important concept which is called as the measures of variability. Now when I say variability, when I say how things vary from each other, an apple varies from an orange, right? We're trying to, in the case of data, we're trying to see how data varies from each other. Now, two amounts of data, or let's say I have an image of a car, I have an image of a bike. You can say both of these are images, but when you look into the depth of it, you can say that they are different, right? So in the case of numbers, that is the same. The value of 1 is different from the value of 2. The value of 2 is very different from the value of -2, 0 of course, right? Now, to showcase the entire range of data, to explain the range of data and to have a measure on it, we have measures of variability. Here, you have 3 measures. We have the range, we have the variance, and we have the standard deviation. Let's look at the range now. When I say range, it is a very simple thing. Range basically is defined as the difference between the largest number and the smallest number in an ordered or an unordered list. So as you look at your screen right now, it is unordered. It is fine. Just find the highest number, just find the lowest number, highest number minus lowest number, that is your range. One measure of variability done, right? The highest number is 900, the lowest number is 25, 900 minus 25, the range is 875. I hope the range was clear. It is always the same, ordered, unordered, whatever it is. If your data has if your data has numbers, pick the highest, pick the lowest. Even if it is negative number, it works, right? But negative numbers are not usually considered because in the case of data science, every practical application will have positive numbers. Now, if I say how many mobile phones were sold in this month, nobody says I sold -5 mobile phones, right? No. They say I have sold 5 mobile phones. To get to that 5, you can have a range of units that you might have sold. That is range. Coming to the next measure is variance. Now, variance and standard deviation are beautiful applications because here Variance talks about how data is related to the average of all the data that is present. Now, it is the same data that we've been considering from the start of this particular measure section. 150, 100 all the way to 91. We calculated the mean. The mean came out to be 238.6. So how do you calculate the variance? Variance, again, as I told you, it describes the data as how much of a spread is there to the data when you compare to the mean. So to calculate the variance, all you have to do is you have to find the result of how you can square the difference between the mean. So to find variance, it is simple. Have the data, find the mean value. Now subtract all your individual elements from this mean value. You're gonna have 10 more numbers or 9 more numbers. Square all of that out. You're gonna have a product, right? Once you have a chart which is square of the difference between the mean and the existing element, take the average of it. That becomes your variance. Now, let me repeat that. First of all, have the data at hand, calculate the mean. Find the difference between the mean and each of those data. Even if you get negative numbers, it is okay. That is why we are squaring the number. The square of a negative number is always positive, right? So first step, find the mean. Second step, find the difference between mean and the elements that are there. Square all of these numbers, you will have more set of numbers. Take the average of all of those numbers, that becomes the average of the result that is obtained becomes the variance, guys. In this case, the variance is 67,321.84. I hope that was clear. Now, coming to standard deviation. Standard deviation is one of these measures which is again dependent on the variance itself. Here we are not trying to talk about the range of data, but we're trying to see how far away is the data spread out itself. So remember how we squared it in variance? Here all we have to do is take a square root of variance and we come to the standard deviation. Now, in this particular case, the square root of 67,321.84 is 259.46. 259 is the numerical measure of the data spread when you compare. The average spread of data across the entire data set is 259. That is why it's called as deviation. How much is your data deviating from its other comparison points and from the mean? That is standard deviation, guys. So first you have the data, you calculate the mean, you calculate the variance, take a square root of the variance, you are done with standard deviation, and with that you are done with measures of variability as well, right? Next, let us talk about measures of relationships. Now, when I say measures of relationships, we are talking about how a piece of data is related to another piece of data, right? The interdependency in between data, that is what we call as measures of relationships. There are two numerical measures of how you can find the relationship in between data. It is done in the case of covariation or covariance, and correlation, or as it's called commonly as to find the relation in between data. Of course, to simplify it and to categorize it out, it's called covariance and correlation. What is covariance? Covariance talks about how a piece of data varies from the other, right? It is literally the variance between two pieces of data, or of course it doesn't have to be two always, it can be more than two as well. That literally is covariance. Now, to give you an example of what covariance means, now if the data is moving in the same direction, the covariance is positive. If you consider two cars and if there is a race in between these two cars, the cars will be going in the same direction. So the variation is positive there. But what if one car decides, hey, I'm going to stop the race and I'm going to go in the opposite direction? That becomes a negative covariation, because there the data itself is moving in the opposite direction of the primary car, right? That is a simple example of covariance. But if there is a race and both of the cars like literally are standing, they're not at all moving, who wins the race? No, right? There is no relation. There is no who comes first, who comes second, none of that. So in that particular case, here the covariance is 0. If the covariance is positive, cars are moving in the same direction, data is moving in the same direction. If the covariance is negative, cars are moving in the opposite direction, and there is literally a change in data in the complete opposite direction. That is covariance, guys. Now, to talk about correlation. Correlation talks about again how data is related to each other, right? To have a measure here, we usually consider correlation in between -1 and +1. Now, if the values are closer to -1, it means that the data is there is no relationship in between two pieces of data. Now, if I say, here is an apple tree which gave me 5 apples this month, here is another apple tree which gave me 100 apples in a month, what is the relation? One apple tree can be sitting in Kashmir, another apple tree can be sitting somewhere in South India, right? There is no relationship that you can say. So in that case, if the number is closer to 0, it means no relation. If the number is closer to -1, -0.1, it means there is a weak relationship, right? But if the correlation is 1.9, 0.8, it means there is a strong relationship between the tree that's sitting in Kashmir and the tree that is sitting in Bangalore. Maybe you've used this exact same soil, and now you want to find out why the tree there is giving you 5 apples, why the tree here is giving you 100 apples, right? That is the measure of correlation, guys. Now, again, there are more measures of metrics that you definitely have to know in the case of statistics. We are going to talk about a very, very, very important measure. It is the measure of accuracy. In the case of measures of accuracy, there are 4 metrics. There are 4 numbers which denote how you can find if the data is accurate or not, if your finding is accurate or not, if your analysis is accurate or not. Right now, you might have heard of some of these things. The 4 measures of accuracy are true positive, false positive, true negative, and false negative. Now, beware. In many cases, they are not called by their full names. They are only called as TP, FP, TN, and FN. So, when someone says FN, it means false negative. When someone says TP, it means true positive. In the case of, in the context of statistics. Right. So, let us check out what each of these mean by giving you a very nice story, by telling you a story about dinosaurs. Now, I absolutely love dinosaurs. They are such majestic creatures who roamed the earth of one point of time. Of course, I'm a little sad that, there are no dinosaurs anymore that we can see. Of course, there's descendants of dinosaurs, reptiles and everything else, but there is no T-Rex as you see from the Jurassic Park movies around you, right? That makes me sad a little. Anyway, coming back to the story. Let us go back when dinosaurs were actually a real thing. When dinosaurs roamed the earth, there were humans also, right? Now, let us say there was a village. Near the village, there is a situation where a dinosaur might come and attack or might not come and attack. Let us discuss measures of accuracy using this particular story. Let me give you 4 different cases. Here are 4 situations. First situation, there is an actual dinosaur. The farmer is farming in his farm. He looks up, he sees the dinosaur. He goes back to the village. He alerts everyone, and everyone in the village run to safety. No one is dead. That is one situation. There is an actual dinosaur. Farmer sees the dinosaur. Farmer alerts the village, and the farmer is correct. He saw the dinosaur. He knows he saw the dinosaur. He goes and reports it back. Look at the top right. There's another situation. There is no dinosaur at all, but the farmer alerts the village saying, hey, I saw a dinosaur. He might have seen a tree or something in the dark, which he thinks was a dinosaur, which there is no dinosaur there. He says, hey, no, I saw a dinosaur, let's run away. So the entire village runs away. In this case, the situation is that there wasn't a dinosaur. Farmer thinks he saw a dinosaur. He's convinced. He tells everyone in the village runs away. The farmer is wrong. That is one case. Look at the bottom left one. There is an actual dinosaur. The dinosaur is nicely camouflaged and hidden. The farmer does not see the dinosaur, so he's happily doing his work. He comes back to the village and he says, hey, I didn't see any dinosaurs today. The dinosaur is going to come eat everyone in the village. Everyone is dead. Again, the dinosaur wins. The farmer is wrong, right? That is a case we do not want to have. There is another case. Look at the bottom right one. There is no dinosaur at all. And the farmer says, hey, no, there wasn't any dinosaur, sorry, I didn't see anything. He comes back to the village, everything is fine, because first of all, there is no dinosaur. He doesn't see one because there isn't one to see. He is right, so the village is saved, right? Guess what I told you right now? These are the 4 measures of accuracy. Now, let me bring you into the context of what's happening around the world, right? The coronavirus, the COVID-19 pandemic that we are living through right now, of course, at the time of recording this video. Let me tell you the cases of measures of accuracy in the case of coronavirus. But here were the 4 measures of accuracy: true positive, false positive, true negative, and true positive, right? Can you find out which was which? Take a second, pause the video and try to see if you can note it down. Well, I hope you took a second to note that down, because here are the answers. What you saw on the top left was a true positive case. There was a dinosaur, farmer saw, farmer alerted, everyone is safe. It is true. The outcome was correct. Take a look at the right side. It is false positive. False positive means that there was no dinosaur. The farmer simply started shouting, he saw a dinosaur, everyone ran away. That's a false positive. Look at the bottom left. False negative. In the case of false negative, there was an actual dinosaur. The farmer says, hey, there was no dinosaur, everyone chill out. The dinosaur came and ate everyone, right? Boo. Right, that's the case. That is false negative. No one likes false negative. Take a look at true negative. True negative is a very happy case, because here there was no dinosaur at all. The farmer never saw anything. He was happily farming. He took out his apple, he ate his apple, he went home and he slept. In that case, again, there was no dinosaur to alert. The village is completely safe. The outcome is the safety of the village, but the farmer has to play the key role here to see if there is danger coming or not. Now that you know what is true positive, false negative, and true negative, let me tell you this in the case of coronavirus pandemic. What is true positive? Someone has coronavirus, COVID-19 symptoms, they get tested and the result comes out to be positive, right? If someone is feeling very ill, they cannot breathe, they go get tested, they say, hey, sorry, you're COVID-19 positive, come in for treatment, quarantine yourself. That is correct. The person actually had the virus, test came out to be true. That is a true positive case. Think about false positive now. False positive is when maybe the person drowned in, maybe the person drenched in rain, maybe went for a swim or something, or went without a sweater in the morning. The person is cold, coughing a little now. He goes to a test. He does not have the virus, but the test says, hey, sorry, you have the virus. That is false positive. Even though he or she might not have the virus, in this case, of course, he does not have the virus at all. The test comes out to be positive. So the test is wrong. There is an error. That is a false positive situation. Talk about false negative. False negative in the context of COVID-19 is the worst thing ever. So let's say a person has all the COVID-19 symptoms. The person does not get tested. The person says, hey, I don't have any symptoms, and he or she is spreading the virus to everyone, right? Not a good thing. Even the case where the person actually has symptoms, gets tested, but the result comes out to be negative, even though the person has COVID-19, that can be considered as false negative as well. Think about true negative. True negative is when the person does not have COVID-19, simply goes to get tested just for the safety of others. Nowadays, I think when you have to fly out to another state or a country, you have to compulsorily get tested for the COVID-19 pandemic. So the person gets tested, he or she is alright, no virus, no symptoms. The test says, hey, you're negative, congratulations, you can fly. That is true negative. Right, so I hope this dinosaur story and the COVID-19 story gave you a complete clarity of the measures of accuracy that are existed. Now, guys, take a piece of paper. Now, I'm going to do it in front of you. Note down what true positive is. Note down what false positive is. Note down what false negative is. And note down what true negative is as well, because it is going to help you a lot. Now, see, me as a mentor is maintaining a sheet where I have some things that important pointers I want to convey to you. So you as a learner should definitely do this as well. Right? Now, Using these four measures of accuracy, these four concepts, we derive four other numbers which eventually form to be the measures of accuracy, which is sensitivity, specificity, precision, and F1 score. So what is sensitivity, specificity, precision, F1 score, and how is it dependent to true positive, true negative, all of the things we just learned, right? Well, let's take a look at this. Here's the situation for you. If you were again going back to offices, the times when everyone went to office, there was no pandemic and all of that. If there was a random free health camp or check or something, people were testing for diabetes and all of that. If you're testing someone for diabetes, there can only be two outcomes. One, the person is diabetic, and of course the person is non-diabetic. Of course there are other medical outcomes saying it's type 1 diabetes, type 2 diabetes, type 3, all of that. But in this case, what is the final outcome when you ask a question, is this person diabetic? Yes or no, right? Think about all the four practical cases I gave you right now. True positive, true negative, the entire dinosaur example and the COVID-19 example, right? Using those, now we're going to see how we can go on to, find a pattern and understand. In the case of, this is another example, the diabetic example that I'm giving you. The person, let's talk about true positive again. The person thinks he or she has diabetes. The person gets tested. The result comes out to be true. Person is diabetic. In the case of true negative, the person predicts saying, hey, I do not have diabetic, and the person actually is healthy and fine. Again, fine, right? The person does not have diabetics, goes to get tested. The test comes negative. The person is happy. False positive when the person does not have diabetes, yet the person goes for a test and says, sorry, you have diabetes, start taking this medication. Now that's a very, very dangerous thing, right? Taking medication for a condition which does not exist. The result came out from an error of measurement, error, whatever it is, right? That's a very wrong thing. False negative is even more horrible. The person has diabetes in real life. The person is diabetic. Doctor says, sorry, you are not diabetic. Congratulations, you are not diabetic. The person has diabetes. Doctor says you do not have diabetes. In that case, again, the person actually has diabetes, but the doctor is saying you do not have. Again, all of these are hypothetical situations, guys. All of these are for educational and representational purposes only. Do not consider any of these in the real world scenario. I'm just giving you all of these to make you understand these concepts, right? So that is how you consider these four measures of accuracy. Now, one question I always get asked whenever I am teaching these concepts is, okay, Anirudh, how do I remember the measures of accuracy easily? I have a trick for you guys. If something ever starts with true positive, true negative, it means the original prediction was correct. It means that, the prediction that there was a dinosaur, the prediction that there was COVID-19, the prediction that there was, diabetes, if the prediction was correct, it will start with a true. True positive and true negative talks about having a prediction and then contradicting the output, right? Think about false. If anything starts with false, it means your prediction itself was accurate. If a person has diabetes and doctor says you do not have diabetes, that is false positive. If a person has diabetes in real life, doctor says no, congratulations, you don't have diabetes. What case is this? Again, I just repeated another form of it, right? If you're taking medication for a condition that does not exist, that is false negative, right? I hope you understood this. If it starts with true, your prediction is correct. If it starts with false, your prediction is inaccurate or incorrect, guys. That is a trick to remember. Now, remember how we spoke about four different things: sensitivity, specificity, F1 score, and all of that. Let us discuss each of these metrics now. Guys, make sure you have a pen and paper right now, because you have to note down certain important formulas here. To find sensitivity, you're going to use the values of, whatever we found out, true positive or false negative and all of that. So, sensitivity has another name. It's a measure, of course. It's also called as recall. So when someone says find the recall or find the sensitivity, it is exactly the same thing, right? In the case of sensitivity, how correctly are you trying to predict if people have diabetes or not? How accurately are you trying to see? I use the word accurately. Measures of accuracy accurately are you trying to find if a person has diabetes, right? That is sensitivity. Sensitivity has a formula. It is a simple thing. True positive divided by true positive plus false negative gives you the answer of sensitivity. It's a number, it's a metric. Next, let's talk about specificity. Specificity is another measure of how you can try to find the analysis of people who are negative. The prediction was negative and they are not diabetic in real life as well. Again, this is a correct prediction. Prediction where you're trying to be specific, where you're trying to find out how correct, how accurate were you in finding out the people who are not diabetic and compare that to the people you tested and assumed at the start, right? That is specificity. Specificity is found out by this calculation: true negative divided by true negative plus false positive. Take a note of the formula, guys. Let me quickly go back. Here is sensitivity: true positive divided by true positive plus false negative. That is sensitivity. Talking about specificity, it's true negative divided by true negative plus false positive. Next, the third metric is going to talk about precision. Precision, as the name suggests, it asks a question like this: how many people are actually diabetic? Not you putting out error in your test, not you randomly saying the person has diabetes even though he or she does not, or saying he does not have diabetes when they actually do. No. How accurately are you trying to, how precisely can you say if the people are actually diabetic? That can be found out by this formula: true positive divided by true positive plus false positive. Guys, take a note of it. Next, the fourth measure talks about the F1 score. F1 score directly does not talk about true positive, false positive, but the previous outputs as well. F1 score is found out by taking the average of precision and recall. Recall is something we checked out at the start. What is the other name of recall? Well, you tell me now, guys. Come on. Right. So, F1 score calculation is very simple. Take the recall value, multiply it with precision value. Take the recall value, add it with precision value. So divide this multiplied value divided by the added value, multiply that entire score by 2 and you get the F1 score. Recall into precision divided by recall plus precision, whole thing multiplied by 2, that will give you the F1 score. That is the fourth metric, guys. Now I understand that it might be difficult for you to sort of, concentrate, learn and just look at the theory and say, oh, I got it. So I have the practical aspect of it as well. But before we practically calculate values, you will have a question saying, okay, you taught me 4 metrics. How do I know which one to pick? Very, very good question, because you will pick precision when you want to be extra sure of all the true positive cases that are out there. The person has COVID-19, got tested, the report came out to be positive, person is safe in quarantine. You will pick precision if you want to find out everything there is to know about true positive. You will pick specificity when you want to avoid false positive and when you want to avoid false alarms, right? So you will pick specificity when you want to, avoid all these false alarms in a case where the person might not have COVID-19, but the test comes out to be positive. That's a false case, right? You will pick specificity when you want to avoid all of these things. It's a measure of how you can avoid all of these things. Next, recall. Recall talks about a situation if, let's say, your false negative values, right? What is a false negative value? You think about it now. Pause this video, think about false negative. You got it? Okay. So you will pick recall if your false negative values are over the roof. If you're simply just pushing out false negative values in real world. I told you false negative is very, very harmful, right? You're giving diabetic tablet to a person who does not have diabetes, which eventually is going to hurt their body. You want to find out why this is happening. All of these false negative cases happen in real life. Yes, they do happen. Not in the case of diabetes maybe, but any other situation that you can think of, right? To find this out, you're going to use a metric, and that metric itself is recall, ladies and gentlemen. So I hope now you're clear about when to use what. Again, take a note of this slide. Now, there is a concept called as confusion matrix. Confusion matrix in data science is very important because it's like a matrix with 4 values. The 4 values is everything that you already learned right now: true positive, false negative, and true negative. So when you create a matrix, it has to have an axis. So on the top you see all the actual values, on the left you just map what is predicted. If your prediction is correct with the actual, it becomes true positive. If your predicted value is different from the actual values, it can become either false positive or false negative, right? That is what is indicated. The matrix is in that order. There is an order to it. True positive on the top left, false positive on the top right, false negative on the top bottom left, and true negative on the bottom right, guys. So to talk about confusion matrix, what is true positive? You predicted correct and it was true. It is true positive. You predicted something negative. You predicted the opposite thing and that is also true. Correct. You do not have COVID-19. You go get tested. It comes out negative. Happy. That is true negative. Then you have false positive. False positive was you say, hey, it is positive, but the result turned out to be no. That is false positive. False negative is when your prediction itself is negative and the result is also negative. It is false. It says your initial prediction itself is correct, giving the diabetic tablet to a non-diabetic person. That is false negative, right? So this is a confusion matrix that you have to know of how it works on the predicted values versus the actual value scale. So I hope all of you guys are clear with this. Now, let us calculate the metrics. I have some sample values on your screen right now. So I hope you guys took a note about where the true positive values are, false positive values are, and all that, right? To do this, I have to quickly get my calculator out as well. Of course, I can do it manually too, but with a calculator, it is quicker. Now, let me find my pen. Let me note it down. First thing is recall. Recall is sensitivity. What is the formula? Now, to help you out, I have the formula on the left side, but make sure you remember it. True positive divided by true positive plus false negative. Now, what is the true positive value here? It is 80. What is the false negative value here? The false negative value is 8. So, the denominator becomes 88. What is true positive? 80. So, 80 divided by 88 gives you 0.90. So the value of sensitivity is 0.90. Simple, right? Let's take the next one. Specificity talks about how you can use true negative divided by true negative plus false positive. True negative is how much? 56, right? True negative plus false positive. How much is false positive values? In this case, false positive is 2. So the denominator becomes 58. What is true negative? True negative value is 56. So what is 56 divided by 58? Right? The answer is 0.96. So specificity is 0.96. Sensitivity was 0.9. Specificity was 0.96. Next, let's take a look at precision. Precision talks about how you can use TP divided by TP plus FP. TP itself is 80. 80 divided by 80 plus false positive is 2. So what is 80 divided by 82? The answer is 0.975, right? See, the answers we're getting are very different. First we got 0.9, next we got 0.96, now we have 0.97. Guys, you have to calculate all of this manually to remember it. Then we have a very important metric again, as I told you, which is the F1 score. F1 score talks about recall, precision, and how you can find out using all of those things. So let me quickly go back. Precision value is the last one that you found out. Recall value is the first one that you found out, right? So 0.9 into 0.97. So it is 0.873, the first part of it. Now divide that by adding recall and precision. So that's 0.9 plus 0.97, right? So it's 1.87. So what is 0.873 divided by 1.87 answer? It is 0.046. Now, here's an important thing you will forget. There is a 2 which you have to multiply, right? So multiply this entire thing with 2. The answer is 0.093. 0.093 is the F1 score, ladies and gentlemen. Now, I wanted to do all of this on screen, but if I just show you that, there's a good chance you will just look at it. Now that I did it manually, I want you guys to go on to do it as well, right? I hope you did it. If you haven't, please take 10 seconds to calculate all of this. This will help you a lot in the next couple of steps. Now, coming to the last section of module number 2, we have a ton of questions where people ask, where can I learn more about data science online, guys? The first thing that I want to guide you guys about learning data science online is there is a ton of content. There is content everywhere. There's millions of blogs, millions of videos, millions of articles you can read, which can get confusing. Have a structured way of learning, because if you do not have a structured way, you can learn to a certain extent, then you will get confused, you will not know where to go, you will eventually drop it. It's literally like taking you and putting you in the middle of a forest and asking you find your way back. You might do it. There can be some people in the audience who have the skill to do it, but in the majority of people, right? If I put you in a country where you cannot speak the language, to talk to people is very difficult. That is exactly what happens here as well. Make sure to take it in a structured way. If you learn a language in a structured way, you can, at the end of the day, if I take you and put you in Japan right now, if you know Japanese because you learned it in a nice and easy way, you can converse in Japanese, right? Same point here. The next thing, make sure you're talking to experts. For example, if you're watching this particular session, right, I am a subject matter expert in so many things: data science, Python, artificial intelligence, deep learning, and all these concepts. So talk to a subject matter expert. Now, Great Learning channel is full of subject matter experts and people who can give you a wealth of knowledge, right? So make full use out of it. So for more free content on data science, right, you have 3 places. One, Great Learning Academy. Make sure you check out Great Learning Academy, because this is a place where you have access to 200 plus courses. You can enroll for free, learn for free, get a certificate of completion for free as well, ladies and gentlemen, for free. Great Learning Academy, everything is free no matter where you are in your career, in school, in college, finished college, looking for further education, further learning. Great Learning Academy is the place to be. The next thing is Great Learning YouTube channel. If you haven't subscribed to the Great Learning YouTube channel, hit that subscribe button right now, because we put out videos day in and day out, and all of these are taught by experts. It will help you immensely. You will be notified as soon as we put out the video. And of course, for all the people who love reading, we have Great Learning blogs as well. If you like reading blogs, and if you are a person who wants to read blogs rather than watch videos, make sure you check out Great Learning blogs as well. So these 3 are the places where you can get free content from Great Learning, guys. And of course, if you are very, very serious about your career, make sure to take a look at the specialization and post-graduation offerings. Of course, these are paid offerings, but you will be handheld and you will be taken right from a beginner all the way to becoming a thorough expert in data science. We have multiple post-graduation offerings, MTech offerings, masters in science offerings, and other online certification program courses offerings as well. So make sure you check it out. Now, all of these courses are done in collaboration with some of the most prestigious universities, Ivy League schools in the world, right? Texas McCombs, Great Lakes, PS University, Northwestern University, Stanford. All of these are in collaboration with Great Learning as well. So if you're very serious about it, make sure to check them out. Right, guys, this brings us to the end of module number 2. I hope you're clear with statistics. Again, if you are not clear with any of these concepts, scroll back in the video, watch those concepts, and then move on, because it is very vital in the further steps of the video as well. Right, guys, I'll see you in module number 3. Alright guys, now this is module number 3, where we're going to be discussing a lot about Python for data science. Now, ladies and gentlemen, as I've been mentioning in the first 2 modules, it is very, very important that you first of all require the knowledge of programming. Now, the knowledge of programming can be obtained through many ways using multiple languages. But in the case of data science, right, one very important thing that we've seen a lot, the trends developed for the last 10 years, 15 years or so, showcase that Python was the most preferred programming language for this domain. Now, data science itself is a huge domain, as you already know, but using Python simplifies the domain in such a nice way that you can work beautifully, guys. Now, this module, we're going to discuss a lot of things. So what are these? First of all, we have to look at why do you have to learn Python. Now, I just gave you one reasons, but there are hundreds of reasons of why Python is required for data science. We're going to discuss all of that, and then we're going to check out all the skills that are needed from your side if you are looking to get started with Python as a programming language. Now, after this, there are multiple libraries which are extremely popular for data science, right? We have 5 or 6 libraries that we're going to discuss to a good amount of details. So make sure you're taking a note of all of these libraries, because these are very important, going ahead in the next couple of modules as well. We're going to be discussing it again, 2 very important libraries. We're going to take a look at coding with them. We're going to take a complete practical approach, right from a couple of basic codes in Python all the way to checking out code walkthrough in terms of 2 libraries such as NumPy and Pandas. Now, NumPy and Pandas are these libraries in Python that form to be the heart of data science, because in data science, data is key. Now, to make good use of data, to import it, work with it, transform with it, and all of this, you require these libraries, be it data manipulation, be it numerical computations, all of these, right? So we're going to check that out in detail. So make sure you're paying good amount of attention for this module, guys. Right. Now, to begin with, did you know these facts? The first fact is that, of course, Python is the world's most popular programming language, but did you know that it is considered as the #1 programming language in today's world? #1, right? Now, there are many programming languages. There is C, there is C++, there is Java, there is R. You can name so many different programming languages out there. And these programming languages are not a new thing. These have been around for 40, 50 or somewhere around 60 years as well, the older programming languages which led to these languages, right? Now, these programming languages have been developed in such a way from these past decades that now it is at a point where even the most person who is not initiated into the world of computer science can pick up a programming language, can learn and become an expert in it as well. Now, coming to the points here, did you know that Python is extensively used in all of these popular streaming sites, be it Amazon Prime, be it Netflix, be it Spotify for music, be it YouTube as well. Now, you're watching this either on YouTube or any other video platform out there. There is a good chance that there is Python code running in the back end right now to make sure that you watch this video as well. How cool is that? And Python, when you think about Python and you say Python for a non-developer or a person who has nothing to do with computer science, the first thing they're going to think is the snake, right? There is a snake which is called Python as well. Of course, it's a venomous snake. I have had the opportunity to work with and closely analyze how these reptiles work, especially these venomous ones. But my point here is that the name Python for the programming language did not come from the snake. It came from a TV show called as Monty's Python Circus. Now, Guido van Rossum is the founder, is the creator of Python. He loved that TV show, so he wanted to give a tribute to it. Hence, he named his own programming language as Python. So it is named from a TV show and not the snake. The third point, it's that it is very popular for data science. If you're applying for a data science role, be it a data analyst role, no matter where you are in the data science ecosystem, right, the basic requirement in a job description is going to be a programming language, and 99 out of 100 of them have a good chance of asking Python as a requirement. So it is vital that no matter what you do in this domain, you take a look at Python as well. And also, this fact should not come as a surprise to you, because Python is used by thousands and thousands of companies out there. Now, it is not just individuals who use Python, not just startup companies, but even the biggest of the biggest multinational corporations make use of Python, not just to solve one problem or to take a look at a client's work on all of it. They use Python on a daily basis, right? So the development aspect of Python as a language itself and it being used for a solution is amazingly perspective, especially when you're taking a look at the future. And of course, if you're skilled with Python and if you're looking at a data scientist's role, the requirements is always pouring in. I've discussed this in detail in module number 1, where I told you about how the demands are created for the roles in the world of data science, and how people are struggling to find experts who fill into the role of data scientists, right? So some of these jobs do not ask for a lot of experience, but they are very, very high paying jobs. So if you have the right skills, right, you definitely can apply for all of these jobs, ladies and gentlemen. Now, to move on to the next section. The next section talks about why you even should learn Python. Pause this video, take a quick second to understand, to analyze yourself about why you think Python is so much required for data science, right? Now, I've been telling you that it's popular, it's a requirement, all of these things are fine, but can you think of any other reasons, which would make you want to start up with Python and learn the language, right? Let us discuss that now. First of all, whenever you're looking at learning a programming language, you're going to be thinking towards using it, right? When you're working on using a programming language, or when you're looking at having a career where you'll be using a programming language such as Python, you have to see what the companies are using. Did you know that Python is one of the most searched programming language in multiple search engines, multiple platforms across the globe? It means that individuals, learners, companies, hiring managers, all of these people are searching for Python. So there is a constant digging going on for Python, where people are required constantly, guys. Even though you may look around, you'll have friends, colleagues, or your family members who are good at Python. They say, hey, the world has a lot of Python developers. That is a very wrong statement to say, because yes, the world has a lot of Python developers, but guess what? The world needs way more than what it has right now. So it becomes very important that you understand that the trend chart is constantly rising, and if you are there to fill that trend chart, the salary expectations that you can have will definitely be met, guys. Right. Looking at the second point now. The second point is the general interest over, the language by all the people, right? Now, when you take a look at the screen right now, right from 2004 all the way till 2020 and a little bit into 2021, there is a very steep rise, especially I think somewhere around 2013 or 2014. All the way, and the number of searches, the people showing interest, the people developing projects using Python to provide solutions, right? So these numbers have not just shot up in a nice slow fashion, but as you can see on your graph, it has shot up exponentially, right? As I've been telling you, it is extremely vital that you invest your time now more than ever in programming languages. Now, all of these, whatever I'm saying, are not facts, right? These are proven by data. So this is valuable information which is proven by data, as you can see on your screen right now. So it becomes very, very, very important that you put in a good amount of time for this, guys. Now, let us say, as I told you, data science is a field which is like a huge umbrella. It's an ocean's worth of technology on its own. It has multiple different domains under it, even though the popular ones are just AI, ML, and all these, right? There's a million things that you can do with data science, and people are doing it now. With Python, right, this extends even further into multiple different domains. Now, think about web development, think about big data, game development, user experience development, data science. If you're just thinking about, yeah, Python works for all of this, your thought is perfect, because yes, Python has amazing support for all of these. When you're looking at web development, right, there's many libraries, Django being the most popular one. So if you're a person who's into web development, who likes writing websites, who wants to provide solutions via web apps, whatever it is, Python has a library that will help you do it. Next, big data. When you're thinking about big data, right, just give it a thought. We generate 26 lakh terabytes of data every single day to handle all of these, to store all of these, and have a simple way to communicate to your machine that's saying, hey, here's all the data, use it to learn or something like that, right? It's going to take a lot of skills. It's going to take so many concepts. It's going to take so many technologies. You have divided computing in these days. You're going to use the computational power of multiple systems anywhere across the globe, right then and there at every instance, parallelly, right? Parallel computing, distributed computing. Python supports all of this beautifully, guys. So now more than ever, we are handling a good amount of, good chunk of data in the case of Python. Next up is game development, right? Now, all of us, for entertainment sakes, we definitely have our own ways to, went out, just chill out and play games, right? Me personally, I love playing one or two games, maybe on the weekends or whenever I do get, free time. So, the important thing here you have to realize is that even in the field of game development, there are libraries such as Pygame and others which will help you build games completely from scratch, again by making use of Python syntax, right? Python syntax has become so popular because it is easy to use. Since it is easy to use, people have realized you can use it in all the domains out there, and hence the stretch towards other domains too. Right? Next up is UI UX development. UI stands for user interface, UX stands for user experience development. Now, whenever think about a website, think about an Android application, think about whatever it is when you're doing when you're working with a computer or your mobile phone, right? There is a user interface. There is a place where you can click, there's a place where you can type, there's a place where you can chat with people. All of these things are giving you these are interfaces through which you can work easily, right? Your computer, as I mentioned in module 2 as well, is one of these things that only understands zeros and ones at its most core level. No matter how intelligent is it, no matter how fast it can process things, at the end of the day, zeros and ones are all that it understands. So you cannot expect to show zeros and ones and expect an audience to understand that. That is going to be highly, highly inconvenient, right? So to develop a good user interface means you'll be driving a good experience, right? Think about going on your favorite e-commerce site to buy something. Nowadays, all the e-commerce sites make it as simple as possible for you to buy, right? Let's say you want to buy shoes. You just go to the product page. There's a direct button which says buy now. It is going to add to your cart automatically. It is going to log you in automatically. It's going to take you to a page where you're going to be putting your payment details, right? Just one click. That is how convenient it is. But if that was an activity that would take you 5 minutes, that you have to go through 10 different pages to eventually get to a place where you place the order, that is inconvenient. That is not good user experience, right? People will drop off. They will lose interest before they cross 10 or 15 pages to place an order for one item. Now that's important. And you can develop a good user interface by making use of Python as well, right? And lastly, of course, data science. As I've been mentioning, data science is a field which involves data analysis. It involves data engineering. It involves business intelligence analysis and all of these. Now, wherever Python is not directly used, there's a very good chance the code in which the software is written in, right? There Python has something to do. That is, that is an important aspect of Python's usage. Primarily, our concern in data science is to start using Python, where we're typing in Python code and working with it. Sometimes you'll have to use tools and technologies which are built using Python itself. So that's a point which I thought you guys definitely should know about. The next important thing you have to understand about Python is that this is a programming language that is built to scale. Now, when I say built to scale, I'll give you a simple analogy. Let's say you are a chocolate shop, you're a shop who's selling chocolates. So now you have the capability of the machines and the workforce to sell maybe 100 chocolates a day. What if tomorrow you get an order which says, I want 1 lakh chocolates starting every day, right? So you going from just producing a small number of chocolates to a huge number will be impossible. This was kept in mind when Python was being developed. What if the data goes from a very small chunk into being huge in a rapid amount of time? Python was built thinking this in mind, saying if that happens, we are going to handle it. That makes Python beautiful, guys. And there's many different points that we're going to discuss here as well. Now, the first point says Python is an interpreted language. Now, in the case of an interpreted language, there's two ways of how your computer can understand what you have written in terms of code. It is by compiling it and it is by interpreting it. In compilation, what happens is that the program, whatever you have written code, it has to run through, the compiler has to run through the entire thing to see if it has no errors and all of that. Then it is going to execute. It is not line by line, it is the entire program at once. But with Python, since it's an interpreted language, the execution happens line by line instead of the entire thing at once. There are numerous advantages to this. First of all, if there is an error at one point of in the process of compilation, if there's an error, the program does not compile, it does not run at all. In the case of an interpreted language like Python, what happens is that, let's say there's an error on line number 10, everything until 1 to 9 will execute perfectly fine, and it is going to say, hey, there's an error at 10, please fix it. That is an advantage in so many different cases. Instead of having your entire program crash down, you will just have one line error, you can fix it. Of course, there's a good chance the one line error can turn into another 10 line error as well, but at least until that line occurs, everything is executing fine. So in terms of building your code, in terms of maintaining your code, in terms of debugging your code, Python is providing so many advantages that you have to know if you're looking towards data science seriously, guys. And of course, the second point is that it's easy to learn. Now, you might have read it everywhere saying Python is a language which is easy to learn, but why is it easy to learn? How is it easier to learn? First of all, the syntax, right? Whenever you write the actual program, the code that you write, it is in a high level programming language kind of an aspect. In a way, what I mean by high level code is that it is written in understandable English code. Now, if you've ever worked with programming languages such as C++, to input something from the user and to display a message on the screen, you have to use functions such as cin, cout and all of this. Now, for a person who just knows English and not programming language, if you ask them, hey, what is cin or what is cout? They'll be like, I don't know, right? Guess what? In the case of Python, it's very straightforward. To input, you have a function called input. To output, you have a function called print. When you say print, put something in a bracket, done. Your message is gone out. Again, we're going to check this out practically. But this is what makes the language easier to learn, guys. Of course, next we have to take a look at how it is built for dynamism. Now, in many different cases, it so happens that especially in web development, right? Static websites, dynamic websites and all of that, you do not have to reload the entire website, the entire web page if you're performing small operations. There, dynamically, all of these can be handled, and instead of having a complete refresh, only whatever is that tiny aspect that needs to be refreshed can be done. That's a dynamic approach to solving a problem. Now, a website can be a very small sized, efficiently built website, but if you're having a solution with Python to rebuild the entire thing just because you changed something, well, that's going to be highly inconvenient, especially if it's a production situation. In that case, right, if it's meant for dynamism, if it's built keeping this in mind, saying if someone changes one small thing, it's okay, let us build it quicker, let us rebuild it quicker. There, Python gives you the advantage. And the next thing, of course, the most most popular reason why Python has become this huge phenomenon is that it is open source. It is beautiful. It has taken years together to write Python, and it is a language which is again helping solve millions of problems across the world. Now, it is open source. It is completely free to use. If you have the knowledge to work with Python, guess what? You can start with it without paying one buck to the people who have developed Python, right? That is the advantage of open source. Most of the libraries, 99% of all the libraries are again open source. So you can do a lot of things with Python, and that is the advantage here, ladies and gentlemen. Now, the next thing is, first of all, you already know the header here. Python is it's a very popular choice in today's world of programming. Did you know why? First of all, Python has a huge library when it comes to solving your problem. Now, when I say library, what do I mean? See, let's say you have a problem that you want to solve and it will take you maybe around 200 lines of code to solve it. If you have a library like how you have thousands in Python, a library is going to help you shorten your code exponentially in a way where maybe 200 lines of code can be solved in under 20 or maybe in under 30 lines. Where is 200? Where is 20 lines, right? 10%. Of course, it's an analogy which will not work in all the cases, but that is how it is. If we have a common saying as Python developers, if you have a problem that requires to be solved using Python, there is a 99% probability that Python will offer you a library to use in a way where it is going to simplify your task by 99%. It's a beautiful saying we have in the Python community, and of course, I agree to all of that as well. The next thing when I said community is that Python is this programming language that is used by millions of developers across the globe. It's not just hundreds, it's not in the thousands, it's in the millions. Now, people are using Python because, first of all, they realize it's a powerful language. Secondly, they understand the value that it adds to their, requirement, right? It is not only how Python can solve problems, it is how simple and how easily can Python solve problems as well. So that is an important thing here, guys. And of course, when you're taking a look at easy to read syntax, I already told you it's a high level programming language which eventually makes it easier for people, coders and people who are not initiated into the world of programming as well, to understand what we're talking about here, right? Next thing, it's a strongly typed language. Now, when I say Python is a strongly typed programming language, one thing you have to understand is that Python is intelligent enough to look at the data and say, okay, I understand this data. In a weakly typed programming language like maybe C, don't mean that weak is weak, strong is strong, literally. It is a term which is given here. In C programming language, you have to specify the data type of the data that you are going to use. Right now, you're going to say int A, B, C, int X, Y, Z. So int says you're telling the compiler this is an integer. Python, you don't have to do that. You just have to say A, B, C, and Python understands, hey, okay, so A is an integer, B is a string, C is a character. It has the capability to know what you have given in, and sometimes it has the capability to convert it into what it thinks is right or what you want as the output as well. That is a huge advantage in Python. Being strongly typed, it saves a lot of time with syntax. Secondly, when you're using multiple data points, it makes it very easier to work with as well. Right. Now, to talk about some of the most important skills that you are going to need if you're looking to learn Python seriously, here are some of them. The first thing, the first important requirement is that you need to have a data oriented approach in life. This is a skill, guys. Looking at data, knowing that you want to find something more that exists in the data, being a person who has a passion to unravel things in data, right? It is a passion, first of all, but if you have the right skill to do it, you can do it in a short amount of time compared to everyone else. That's an important. Your way of thinking and looking towards data, in the case of data science, especially, right? You taking a look at it, you finding out how you can, let's say there's a problem, there's multiple ways on how you can solve the problem, right? So having that thought is important. The second thing is out of the box thinking. Now, as I told you, one problem will never have just one solution in many of the cases, right? One problem can have 3 different solutions, 100 different solutions. But to get to that, you have to think. Python is one such programming language where this skill is very much necessary, of how you can think out of the box to provide a solution, right? Of course, again, there are going to be many libraries, many things that will help you do that. But eventually you have to build yourself in a way where you start thinking out of the box, ladies and gentlemen. It's very, very important. The third thing is the important skills that you are going to have, especially with Python, is logic building skills. Now, in my opinion, with other programming languages, what happens is that you will spend a good amount of time understanding the syntax, learning the syntax, finding out faults and all of these things. But with Python, since the syntax becomes very easy, you will have a lot of time to think about the solution itself, to think about the logic of the solution. Now, when the requirement says, hey, here's a complex problem that I want you to solve, Now that Python offers you an easy to read syntax, you can put a good amount of time for working out a good logic there, right? But then to do that, you need a thinking. You need how can you work, from this point to this point and build logic from there, right? So logic building skills are very, very, very important here. And the next thing, the fourth important thing here is that, let's say, as I told you, the chocolate example, when I was giving you a scaling up situation, right? You have 10 entries of data right now. Next, you're going to be faced with 1 lakh entries. Can your Python program handle all of these? Can you handle all of these, right? Now, data storage is not as easy as 2 or 3 clicks in Python. You have to write a good amount of code to make sure that you bring in data, right? So for that, not only to bring in data, but to make sure your data can cater to a big solution, to a bigger audience base or whatever it is, you have to have the ability to look into the future and say, okay, so today I have 10 data entries. What if I bring in 1 lakh data entries? That is how, you have to work on your thinking skills, guys. The next important thing that we are going to discuss here on Python for data science is you actually getting started with Python. Python is a easy to use programming language. Again, we're going to discuss all of these practically as well, but to know that, you can have a lot of impact with a lot less code is an important aspect, guys. So let's get started with Python. Right. So whenever you're thinking about learning Python, right, the first thing you have to do is start with the basics, start with the fundamentals. If you do not know how the language works, later when you're trying to implement complex stuff with the programming language, you will not know why things work the way they do. To answer those questions in later stages, your foundations are very, very important. Understand how the syntax works, understand how the flow in your program works, understand all the basic operations that you have to know in case if you're looking towards career in specific domains. In our case, it's going to be data science. Of course, we're going to discuss all of that. But if your foundations are not strong and you just, take an easy approach at the starting stages and eventually become a data scientist, when you are solving problems, right, it's like a building. If your foundation is not correct, it's going to crumble down, it's going to fall down. But if you have a very, very strong foundation, no matter how much you scale up vertically, it is going to hold, right? Exactly the same case. Start with the syntax, understand the language, find out how it works, and then move on, guys. Because the next step is to take a look at multiple domains, right? Now, data science is a domain. In this domain, there are multiple subdomains itself, right? Data analysis, data ingestion, pre-processing, visualization. There's so many places where you can use Python to solve in the case of data science. Find what is your favorite thing to do, hone in on that, practice working with that, see if you can focus completely on it to work on maybe 1 or 2 projects. See, just to make sure that you're putting your good amount of time and effort into that domain, because once you do, once you become an expert in that subdomain, right, there's a very good chance, and if not, there's 100% chance in the case of data science that you will find a job in that subdomain which asks for Python as well. This does not happen in a lot of other domains like cloud computing and whatnot, but here in the case of data science, it is possible, ladies and gentlemen. Right. Next, taking a look at working with data, right? See, now you will know Python syntax, you will know the basics of it, you will know what domain that you want to work in and all of that. The next thing you'll be looking at is how Python itself understands data, how you can make Python understand data. Now, it is not just data is always unstructured. There is a concept called as data structures, which you might already know of, how we can process data in a structured way, as the name itself suggests, right? There's many different techniques we use, there's many different containers we use to store data and work with it. So since data science deals with data, of course, you are going to require the knowledge of understanding the data structures in Python. There is mutable data types, there's immutable data types, list, dictionary, a lot of other things that you're going to be working with as well. So to know what data structures exist and know how you can fit your data into those data structures is very vital. So this is an important point. Make sure to take a note of this. And once you understand all the data, the next thing you'll be looking at is, of course, venturing into other domains in data science itself to see if you can use your skills to solve problems there as well. To do it, I highly suggest you talk to people who are experts in Python for data science. For example, I am a subject matter expert when it comes to data science, when it comes to Python, when it comes to working with all the concepts of AI and all of that. So once when you're watching this video of mine, you are having a communication, you are having conversation with me in a way where you get to learn a lot, right? So learn new things. Once you start exploring, you go out of your comfort zone in programming. That is very, very, very important for you to learn new things, because if you go on to spend time to do that, it brings out other things. It brings out more out of the box thinking skills. It brings out efficient ways of working. It brings out 10 other ways you can solve the problem and all of these guys. That's very, very important there. Next up is, whenever you're thinking about learning a programming language, look at programming challenges. Now there's many websites where you can use quizzes for programming languages. You can have competitions. All these can be free or paid. Kaggle is a beautiful site where you can solve a lot of problems, again, in data science using Python. So make sure you're pushing yourself. Once you start learning, right, look to see it is not just continuous theoretical learning, it is your practical implementation to see what you have learned as well. So when you push yourself with these challenges, you will come to know where you stand, what concepts you know right, what concepts you do not know right, and all of these. There are many, many fun ways to learn, and one of the most fun ways, at least for me, when I started out learning a programming language all those decades ago, is by picking up a challenge, guys. And after taking a look at programming challenges, you will come to a point in time where you will want to see how easily can you solve problems in Python, right? This is where you look at libraries, as I previously mentioned. Libraries help you solve your problems quicker, and in Python there are many, many libraries that you can make use of. We're going to discuss all of these, especially with regards to data science. Right now you see two libraries, two packages on your screen right now: NumPy and Pandas. NumPy is a very, very popular, again, both of these are open source, mind you. NumPy is a very popular library or a package which is used in Python for numerical computation. Now, when you have a lot of data that you have to work with, sometimes you have to create multidimensional arrays, store it, and work with it. For that, you're going to be using NumPy. Right now, when you're taking a look at data manipulation, when you're taking a look at a structured way of storing data that you might have ingested, you use Pandas. Pandas support using series, using data frames, and all of these concepts where it is not only data storage that you'll be looking at, but you'll be looking at data manipulation, which is very, very vital. As you're going to see, we're going to check out NumPy and Pandas in detail here as well. So it's vital that you know these two packages. After that, right now, when I ask you this question, what is the most popular application of data science? 90% of you, I am sure, will say artificial intelligence or machine learning or all of these, right? Now, the packages you see on your screen are meant for that. TensorFlow, PyTorch, Scikit-learn are meant for machine learning, deep learning, and AI related stuff as well. TensorFlow is a beautiful package you're going to be using for deep learning. PyTorch, again, TensorFlow came out, cut the word PyTorch. Again, TensorFlow came out from the people who work at Google as well, so it's Google's brainchild. PyTorch came from the Torch framework, which again people at Facebook developed, and then of course you have Scikit-learn. Scikit-learn will be the first library you're going to learn if you're taking a look at machine learning. Again, in the upcoming modules, we're going to be discussing machine learning as well, so we are going to be looking at and using Scikit-learn. So make sure you familiarize yourself with all of these packages that exist. And once you have ingested the data, once you have worked with it using AI, machine learning, whatever it is, the next thing in the process of data science, if you can think about module number one, is that I said that it is very vital that you perform data visualizations, right? For data visualization, in the case of Python, there's multiple packages, but two of the most popular ones are matplotlib and seaborn. Seaborn is a library which is actually built on top of matplotlib to increase its functionality. You have Plotly, you have other packages for data visualization which has come in from the world of R programming language as well, ggplot and whatnot, which you can use here as well now. So at this point of time, it is vital that you know that you have to use data visualization, and that Python offers beautiful packages for you to do so easily as well, right? Now guys, okay, now hold it at this slide. Now guys, since we have discussed all of these theoretically, I want to convey 4 or 5 code snippets, very simple snippets for you guys by practically taking a look at Python. So for this particular usage, for this full course video, we are going to be using the Google Colab Jupyter Notebook. So it's basically part of the Google ecosystem, the part of Google Cloud Platform, where you can run and execute Python code easily wherever you are. You can do it on your phone, on your laptop. It is very powerful. They offer a good amount of storage and RAM usage, GPU usage, which is very important for artificial intelligence, as we're going to discuss in one of these modules. They do it for free. So, installing Python is a good way to work with it as well. You can install Python, you can install an IDE such as PyCharm and work locally with Python. But I prefer having Python in a remote fashion where it is accessible, where it is portable, that I can sit and solve problems. Sometimes it so happens that maybe I am traveling in a public transport where I think of an idea, I get an immediate solution. So I just open up my phone, I start writing Python code, and I can execute it with the click of a button. That is how simple it is to work with Google Colab. So to reach Google Colab, all you have to do is go to collab.research.google.com, or just go to Google, just type Colab, COLAB, and it will bring you to this. To work with it, it is very simple. You have to just create a code block and write the code, hit the play button on your left, and it is done. No installing Python, no working with environment variables, no problem saying, hey, I have 32-bit Windows, I have Windows 7, it's not installing fine, it's not working fine, I'm getting errors, package errors, or no, nothing. It is very simple. One click, you're ready to use Python. That is how simple it is, guys. So let us check out some of the basic syntax in Python. Let me quickly zoom in here so you have a complete picture of the syntax, right? So the first code snippet is, I have to tell you, is if you are very serious about becoming a data scientist, or if you're working towards becoming a Python developer as well, use comments in your code. Comments are these snippets which do not execute, but which are there for your reference, which are there for you to understand what is going on, right? You can use comments in multiple different ways. You can have single line comments, you can have multi-line comments. It doesn't matter because it doesn't get executed. Now, as you can see, a comment in Python is put out. The syntax is to basically use the hash mark first, and whatever you write after hash in that line will not be executed because it becomes a comment. Right now, this is a comment. Everything you see in green is a comment. The next line also, hello dear learners, of course, hello to all of you all, right? So this is a comment as well. But these lines that you see, right, apart from this one, is actual executable code. Now this is also a comment, right? Now what are we doing here in the basic syntax? We have a variable x, we are putting 3 into it. After that, we are saying x is equal to x into 3. What is the value of x? 3. What is 3 multiplied by 3? 9. So this x, the x here, will have the value 9 stored into it. So print x is just us telling, hey, give me the output of what you have stored here, right? So as soon as I go on to run this, it is going to give me an output called 9. Pretty simple and straightforward, right? And here you can see a multi-line comment. It is just my English that I have split it into multiple lines by using a hashtag. As soon as you put a hashtag, everything to the right of it becomes a comment regardless of it, guys. So the takeaway is, use comments, use them a lot, because if you're writing complex programs, it becomes vital that you know what's going on as well, right? So the next thing we're going to check out is variables in Python. There are a lot of rules of how you can use variables, how you can name variables, right? In the case of Python, you can start the name of a variable by making use of a character, by making use of a letter or an underscore. Everything else is not possible. You cannot make use of numbers at the start, but of course you can have numbers later in the variable usage. Start of it is not possible. Then you have something called as keywords, restricted keywords that you are not allowed allowed to use as the name of a variable, because those keywords themselves have a meaning of their own. They are reserved keywords, so you cannot use them here as well. Now, in the case here, I have a variable called number of laptops. It says 3. I have another variable. Now, this is a number, right? Next, I have a character or a string input. Owner name Anirudh Rao. Of course, my name is Anirudh Rao. That's me. And then what I'm doing is I'm just trying to print it with a sentence saying Anirudh Rao has 3 laptops, right? Number of laptops equal to 3. The laptop owner's name is Anirudh Rao. As you can see, I have put out certain important comments here as well. As I told you, underscores are, you can use it everywhere else. You can begin with it, but you cannot begin with a number. Variable names are all case sensitive, guys. Now, small a and capital A are two different variables. There are two different variables you have to know. So Python is a case sensitive programming language. Next up, to look at some of the basic arithmetic operations that you can do. I have two variables, a equal to 10, b equal to 6. You're doing the basic addition, subtraction, multiplication, division. We're going to discuss the last two, but the first 4 should be very straightforward, right? 10 plus 6 is 16, 10 minus 6 is 4, 10 into 6, 10 multiplied with 6 of course is 60, 10 divided by 6 is going to give you an output which is not a whole number, right? Because 6 does not fit into 10. But if a was 12, 12 by 6 is 2, so that works. Next, you have modulus. Modulus is an operation where you are trying to instead of getting the divider, the output to be the divider, here you're going to get the remainder of the output, right? Now, remember how you did division in school. You put 10, you put 6. 6 doesn't go 2 times because it's 12, but 6 goes into 10 one time. So you just put 1. The remainder is now 4, because for 10 you have to subtract 4 from it to make sure it is completely divisible, right? So to get the remainder, you use modulus. Exponentiation is a very nice thing to use, because you will just be raising the power of a with b. So 10 power 6, 10 raised to 6, 10 square, 10 cube, 10 power 6. That is exactly what exponentiation is, and you just use 2 asterisks to get there. Now, as soon as I execute this, pretty simple output. 10 plus 6 is 16, 10 minus 6 is 4, 10 60, then you have 1.6, which is 10 divided by 6. Then, as I told you, the remainder is 4, right? And then 10 power 6, as you can see on your screen, is 10 lakhs. So this is very simple addition, subtraction operation in Python. Next, we are going to take a look at logical operators. Now, logical operators talk about logic, yes or no, true or false, all of those things. So again, I have two variables here, a equal to 5, b equal to 8. There are 3 important logical operators in Python that you have to know about: and, or, and, not. And is this logical variable where you have 2 things. If all of these are true on the left side and everything is true on the right side, the operations, then only it will give you a true output. If one of these is incorrect, or if one of these is false, everything is going to be false. That is and. Next, you have or. With or, either one, this or that can be true. With not, whatever you have given, it is the literal exact opposite of it. Now you're going to see what I mean. See, we have used an AND operation here. I've been saying a greater than 3 and a less than 7. So I'm asking Python, hey, is a greater than 3 and is a less than 7? How much is a? A is 5. Is 5 greater than 3? Yes, the answer is yes. So this becomes true. And is a less than 7? Yes, because a is 5. This becomes true. True and true is true. So this will give you an output saying it is true. The next thing is or. Here both the condition need not be true. Just one, if it is true, is fine. Is a greater than 6? No, the answer is no, because a is equal to 5. But is b greater than 7? Again, the answer is no, because b is 8, right? So that is how or works. Again, I'm going to execute it and show you the output. Next, now think about the NOT gate, right? NOT gate just reverses everything out there. Think about the statement just a greater than 3 now. A is 5. Is 5 greater than 3? The answer is yes, right? If you put a NOT on it, it's going to become no. So NOT is literally the inverse logic gate, that as we call it. So as you can see, this returns a true, this returns a false. But for this, if I have to make it return true as well, I can just say is b greater than 7. B is 8, right? So b is greater than 7 here. Now that becomes true. See, as simple as that. And lastly, guys, user input, right? As I told you, in the case of C++, you have to use complex syntax to input something, output something. In the case of Python, I have a variable called city, and I'm taking an input and I'm asking a question, where do you live? And I'm printing an answer saying, hey, whatever I type in, that's going to be the output. Now, where do you guys live? Head to the comment section, let me know. I stay in Bengaluru, India, right? So I hit enter and it is going to say the city you live in is Bengaluru, which is in India, right? Now these are some of the basic code snippets which I thought you definitely should know and get a feel for before diving into the depths of NumPy and Panda, guys. So that's exactly what we are going to check out next. NumPy and Pandas, two of the most important libraries for the usage in data science. So let's get started with NumPy and Pandas. See, NumPy is this package, as I've already mentioned, which is used to process arrays, matrices, and all of these. So whenever you have to work with an object-oriented programming language like Python, it becomes important that you know that everything that exists is treated as an object, right? Here, array, multidimensional arrays, matrices, all of these are commonly used to work with it as an array processing package. One of the top ones is NumPy, what we are going to use. Next, you have Pandas. Pandas is used for data manipulation, right? Think about data preparation, think about modeling the data to prepare for usage, actually using it, performing analysis, using their data and all of that, right? So Pandas is used for that. Numerical computation on NumPy side, data manipulation on the Pandas side, right? Now, Pandas has certain data structures that you have to know about. Pandas has supports two important data structures. It's the series and the data frame. Whenever you're working with one-dimensional data, 1D data, just one row, one column worth of data, you're going to be using a data structure in Pandas called as series. And whenever you're working with multi-dimensional data, two-dimensional data, you're going to be using an entity, a data structure called as data frames. Both of these are very popular. We're going to check out all of these as well. So you might have a question saying, okay, so how do we create data frames? Data frames are created by making use of a data structure in Python called as lists and of course dictionaries as well. Now, as I told you, a prerequisite is definitely for you to understand and know Python before you can begin your data science career, guys. So we're going to take a completely practical approach to understand NumPy and Pandas, and we're going to walk through multiple different things which are important because see, NumPy and Pandas in themselves are huge libraries which we can cover for hours and hours and hours together, and we are not going to be done with it. But the point here is to make sure you are geared up and ready for data science. So we're going to take a look at some of the operations, some of the important things practically that you are going to require for data science, right? Now, the first thing is, first of all, you have to create this shape. You have to create an array that you're working with, right? So how can you create a one-dimensional array and a two-dimensional array by making use of NumPy, right? Again, we're going to execute all of these practically, but before we do that, I want to run through all of these theoretically so you know what we are going to look at as well, right? Now, num1d is basically a one-dimensional array which is lists. It consists of 1, 2, 3, 4, 5 elements. Next, you have a two-dimensional list here, 1, 2, 3, 4, 5 being the first dimension and the second dimension being hello learners. As you can see, there's a slight mix and match here between numbers and string data. It is possible, it is supported. My point to put it there is to tell you guys that it is possible. Next thing is we are going to use the .array function. .array function is used in NumPy to take all the data, the list data that you have and convert it into an array. np.array of num1d will make sure that num1d is now an array. Again, similarly for the two-dimensional array as well. So this is a very simple way of how you can go on to create one and two-dimensional arrays by making use of NumPy. How easy is this syntax, guys? It's just 4 lines and your array is ready. The next thing, since you'll be working with a lot of matrices, there are certain tricky things that you have to know that you might come across with, or you have to solve a problem using a tricky approach as well. Now, there are multiple functions in NumPy, and one nice function that I have found a lot of usage for is the I function. What the I function does is that it will print a matrix, right? Now, if you have a 3 cross 3 matrix, you can have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, if you want a matrix with just 1 across all the diagonals and 0 everywhere, you don't have to manually sit and plot these 3 cross 3 matrix positions. If you use an I function, all the diagonal elements will automatically become 1, everything else will become 0. So we use a function called .i. np.i of 4 will create a 4 cross 4 matrix, and it's going to just print 1 across the diagonals and 0 everywhere else as well. So this is an important function that you should know about. The next thing, when we spoke about statistics, here's an important thing that I told you, that randomness is the key thing, right? So when you have data, not only when you're bringing in data, when you're storing it, when you're working with it, sometimes biasing can happen and your data's randomness can be lost. So to again jumble it, to make sure things are random and you have everything geared up for probability, well, you will have to mix up your data in a data structure as well. So we're going to do just that here. We're going to be printing random numbers using numpy in a named range, right? So we have a function for it. It's called as the randint function. So np.random.randint0 is going to print us random numbers from 0 all the way to 99, and it's going to put out in a nice structure. Now I'm going to tell you what that 10 means. If you know what that 10 means, head to the comment section and put it on now. When we practically check it out, you yourself will understand, because if I tell you everything right now, there's no fun and mystery when we're checking it out practically, right? All right, so this is how you can print random functions. This is how you can print random numbers using the randint function, random integer function. Next, a very important thing that we are going to be using a lot is sometimes the last position in an array. Now, if your array is 10 elements, picking the first one, second one, third one is easy because we can index everything. Picking the last one, you do not have to first find out what is the length, index that length, pick it out. No. If your index is 0, you're picking up the first position. If your index is 1, you're picking up the second position. If your index is -1, it literally means go to the last, pick me the last element. So the -1 index always stores the data of the last element in the case of Python. Now, as you can see, I have an array here. I have 4 names: Anirudh, Ramesh, Joe, Cynthia. Now, if I have to index the last element, all I have to do, now all of these is stored in the variable names. So all I have to do is names of -1. -1 is the index position that's going to bring out the output Cynthia in this case, because Cynthia is the last element, right? So this is how you can print the last element in an array. Next, we have to take a look at how we can print a certain index element in not just a single dimensional array, but in a multi-dimensional array as well, right? Now, I can ask you a question saying, okay, guys, take a piece of paper, write a 3 cross 3 matrix here. Print me an element. Print me the third element present in the second row in a 3-dimensional array. In that case, you will look at it and you will circle whatever is the answer and you will do it. But for Python to do it, first of all, you have to tell what the array is. That's what we have done. 5, 8, 3, 3, 1, 2, 5, 7, 8 is the 3-dimensional array that we just created, stored it into an element called numbers. Next, we're going to be taking a look at a specific index, right? Now we want a 2-dimensional index because here we're trying to print the third element of the second row. To get to the second row, index is number 1, 0 and 1. To get to the third element, the index is going to be 2. So 0, 1, 2. Hence, numbers of 1:2 is going to give us the third element present in the second row in a 3-dimensional array. Now, what is the third element in the second row? The answer is 2, right? So 2 is going to be the output which is going to be printed. Again, we're going to check this out practically. Next, in many cases, what happens is that sometimes you will have to insert elements into an array, and once you start punching in all these elements into an array, you realize that it is not in the dimension, in the shape that you want it. So you will have to insert stuff into it and you have to reshape it in a way of how you're going to use it further, right? That is where the reshape function comes into picture in the case of making use of numpy. np.arange is going to give you the range of numbers from 1 to 25, so it's going to have numbers 1 to 25 in this particular case. Dot reshape is me telling Python, hey, use numbers from 1 to 25, but make sure you're giving me a 5 cross 5 matrix and nothing else, right? That is how simple it is. 2 lines of code where we are trying to get Python to insert numbers 1 to 25 and reshape it and give it back to us by printing the output. How simple and convenient this is, right? Next, sometimes it so happens that it's not only just you printing in numbers, changing shapes and all of that, but you would have already put in some data in your in your data. This usually happens whenever you're working with any ends, not a number, right? Now when I ask you what is your age, you're going to say my age is 25, my age is 30, my age is 45. You're not going to say my age is O positive. You're not going to say my age is orange, right? No. But in data sets, this will happen. Sometimes data by errors, by other things can remain nonsensical and meaningless. To replace those nonsensical and meaningless things by a common element, maybe 0, maybe 1, maybe -1, you have to use a simple way. You don't, now if your CSV file, if your dataset file is like what, 10,000 rows and columns worth of data, you cannot find each and every one of these and replace it manually. In the case of Python, 3 lines, you can actually do it in 2 lines of code. Take a look at your screen right now. np.array, I have an array which has the elements between 0 and 25, 0 and 15. I am going to try to replace all the even numbers here with 10, right? Now, how do you find the logic if a number is even or not? What is the characteristic that makes a number even? If a number is even, it is completely divisible by 2, right? Now, once it's completely divisible by 2, the remainder is going to be what? Remainder is going to be 0. So if you take a number divided by 2 and the remainder is 0 at the end, it means it's an even number. So replace all of these things with whatever number you want. Numbers, as you can see here, numbers modulus 2 equal to 0 is where we are checking if it's an even number. If it is an even number, remove the even number out of that and put 10 in the place of all the even numbers and print it out. Simple enough, right? Perfect. The next thing we're going to take a look at, which is a very, very important concept, is how you can go on to convert a one-dimensional array into a two-dimensional array. This is done by making use of the reshape function, which is present in NumPy. Again, we're going to have numpy.arange. Arange is going to print us numbers from 0 to 10. We're going to print it out, and then it is going to print us out in a one-dimensional form. We're going to reshape it into 2 dimensions. So dot reshape of 2 of -1. Again, I'm going to tell you what -1 means when we check it out practically, but if you know at this point of time what 2, -1 means, head to the comment sections and let me know. So this is in a simple way 3 lines of code of how one can go on to convert a one-dimensional array into a two-dimensional array very easily, guys. The next thing that we are going to discuss is how we can go on to print elements from 2 NumPy arrays. Now I have an array 1, a NumPy array, another array, NumPy array 2. So how can I print whatever is common in between all of these, right? We have a function for that. This function is called as intersect 1D because it's a one-dimensional array. Take a look at the array X on your screen. We have 10, 6, 30, 45. Take a look at the array Y on your screen. You have 36, 85, 10, 2, 7, 30. What are the common elements here? Is 10 repeated? Yes, so 10 will be printed. Is 6 repeated? No, it's not going to be printed. 30 repeated? Yes, 30 is here, it's going to be printed. Is 45 present in both? The answer is no. So 10, what are 10, 30 are the 2 numbers that's common, and it's going to be printed out by using the intersect 1D function, right? Pretty simple and straightforward. Next, if you have to print a custom range of values that are present in an array. Now you have an array, I want numbers just from 3 to 6 to be printed by making use of a logical operation, right? First of all, I'm going to have arange. Arange is going to give me all the numbers, and then I'm going to run a logical function saying, hey, have only the numbers that are greater than 3 and less than or equal to 6. Of course, greater than equal to 3 and less than or equal to 6. It will remove all the other elements. It's going to only have 3, 4, 5 and 6, right? Pretty simple, pretty straightforward. Again, 2 lines of code. When we check this out practically, you are going to understand all of these better, guys. Next, coming to pandas. Now, pandas is a place, as I told you, if you're working with one-dimensional data, you're going to be using series. If you're working with more than one-dimensional data, if you're working with 2 dimensions, 3 dimensions, more than multi-dimensional, basically, you're going to be working with data frames. In this case, we're trying to create a series using the dictionaries data structures in Python. So here is a sample dictionary. for the people who do not know dictionaries, dictionaries usually have a key and an index system. So there's a key and there's a value associated with that particular key. That is what makes a dictionary a very nice data structure to use. In this case, again, I have a sample dictionary. Of course, dictionaries are all denoted by curly braces or flower brackets. After that, we are creating a series, pd.series of just our dictionary. So our dictionary gets converted into a series, and I'm just printing the series by making use of the function dot series function and printing it, right? Again, 2 lines of code, a lot that you are doing with just 2 lines of code. The next thing we're going to take a look at is how you can assign a name to an index, right? Now, in many cases, it might happen such that an index will not always be a number, right? I'll give you an example. Think about a person and age of a person. You have a sheet which contains the name of all the persons, all the people, and age of those people. You do not have any other index, so you have to index it based on the name of these people. Instead of saying 1, 2, 3, 4 for the names, you can have the name itself as the index. That is exactly what we're trying to do here. Look at this. I am passing a list of numbers 1 to 9 and creating a series out of it. And after which I have a function called .name, series.name, that I am using to make sure that, the name that I'm giving, the index that I'm giving is not a number, but it's a character, right? Now, when I see numbers in single quotes, this is not a number. This is not 1, 2, 3, 4, 5. This is a character. This is a word that we are going to use, right? So as soon as we do series.head, it's going to print us the index of it. Again, we're going to check this out practically. The next thing that we're going to do is we're going to print all the unique elements into series, right? Now with NumPy, we saw how you can bring in and print all the common elements. Here we're going to see if we can print unique elements out here. Now as you can see, I have one series here, 1, 2, 3, 4, 6. The next second series I have 5, 6, 7 and 8. So what I'm trying to do is I'm trying to find the elements that are present in just one but not the other. So I'm trying to find the elements that are present in the second series and not the first series, right? Now what are the elements that are present in second and not the first? You take a second, you let me know. You look at 1, 2, 3, 4, 6. You look at 5, 6, 7 and 8. So what is present in number 2 that's not present in number 1, right? That is exactly what we are trying to discuss here as well, guys. And next thing is, sometimes it so happens that you will have to take a NumPy array and convert it into a pandas data frame to work with it. This is a very, very, very important application which you should know, guys. So first of all, we're going to create a random data. Again, data is from 1 to 19. We're gonna arrange all of that data. It is going to be completely random. We're going to create a series out of it. Once we have a series out of it, we're going to reshape the series to whatever our data frame requires. Now, a series is one-dimensional data. What we want is a two-dimensional data. As you can see, I have the reshape function. I'm saying 5, 5. I want a 5 cross 5 two-dimensional entity here, right? Two-dimensional array. So as soon as we go on to have a NumPy array gets converted into series. Series gets broken down into a multi-dimensional data frame, a pandas data frame with how many lines? 2 lines of code. You can actually do all of this in 1 line of code as well, but then to give you a simple clarity, I have used 3 lines of code. Right, guys, now that we saw all of these theoretically, it is time that we head to Google Colab and check all of these out practically as well. So again, it's going to be everything that we just discussed, right? So the first thing we discussed is how we can create one-dimensional and two-dimensional arrays. We have a list of numbers 1, 2, 3, 4, 5. np.array is what we use to first of all create an array and print it. So as soon as I go on to run this, all we're trying to do is create a one-dimensional array from a list, right? Pretty simple, pretty straightforward. The next thing is, this is one-dimensional array. Now we're going to check out two-dimensional array, right? So we have 2 lists, 1, 2, 3, 4, 5, 6 and hello learners. Now, as soon as again, we're going to be using the same thing, np.array of numbers. As soon as I go on to run this, this is the two-dimensional array that's giving. It's basically giving us a deprecation warning. It does not matter. It's just a small change in the syntax. It works without it as well. But you can see the output that it is a list of 2 dimensions, right? Perfect. Next is the I function. The I function, as I told you, will print 1 across the dimensionals and 0 everywhere else. This is 3. It is going to give us a 3 cross 3. Now let me change it to 4. If I change this to 4, it's going to give us a 4 cross 4 matrix with 1 across the diagonal elements you can see here. and 0 everywhere else. Pretty simple, right? Next, as I told you, we're going to print numbers from 0 to 100 but not including 100 by printing it 10 times. You remember I told you what this 10 means? You guys probably thought that we're going to print numbers from 0 to 100 saying we're going to print 100 numbers, right? No. The first two parameters discusses the range. 0 to 100 means 0 to 99. And I'm saying use these random numbers. You have this range. Now use it 10 times to print me 10 numbers. That's exactly what we have done here. Next thing, to print the last element of the array, what index do we use? We use index -1, right? So as soon as I go on to print it, it's going to give me an output Cynthia, right? Perfect. But what if you have to reverse the entire array, right? To reverse the entire array, all I have to do is use colon -1, and as soon as I go on to print it, this is not going to be the last element of the array. Ignore the text here. It's going to be the entire reversed array. If I remove the double colon, now it is going to be just the last element of the array. Pretty simple, right? Next, as I told you, sometimes you have to print common elements. Sometimes you have to print elements from specific positions. Now, as you can see, right, so I have to print the third element of the second row. To go on to do it, this is the second row, the third element is 2. As soon as I run it, it gets printed because we are indexing 1. 1 talks about this is 0, this is 1. Now, once we are at 1, we have to find the third position. So it is 0, 1, 2, and we are printing it 2. Simple, right? Next, we're going to be using a 5x5 array where we're going to be reshaping it and inserting elements from 1 to 25. As you can see, every time I go on to click on this, it'll just do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 25. Now, if I had used the random function, it would have jumbled all the elements that are present there too. Next up, we're going to be replacing all the even numbers in an array. Remember, we had an array from 0 to 10, 0 to 15. Every time I find an even number, I want that number removed and replaced with 10. Just a simple code click here, and as you can see, 0, 1, 2, 3, 4, 5 became 10, 1, 10, 2, 10, 3, 10, 5, 10, 7, 10, 9, 10, 11. So whatever even numbers existed, they are all gone and replaced with 10. Now, if you want to replace it with 11, you can do it. Pretty simple. See? Done. Next up, you have to convert a one-dimensional array to a two-dimensional array. I told you we're going to be using a range of 10. We're going to print the numbers first and then reshape it into a two-dimensional array. As you can see, a one-dimensional array with the range of elements from 0 to 10, where of course it's going to give us 0 to 9, is this. It's going to give us 10 elements, right? A range of 10 is going to give you 0 to 9. And once we go on to reshape it, what are we trying to do? We are reshaping it into 2 dimensions. As you can see, 0, 1, 2, 3, 4 becomes 1 dimension, and the other dimension becomes 5, 6, 7, 8, 9. Perfect. Next up, as I told you, sometimes you have to print the common elements that are present in two arrays as well. As I told you, 10, 6, 30, 45, 2. We already saw this. Intersect 1D is the function that we're going to use. So 2 is present in both, that's printed. 10 is present in both, that is printed. 30 is present in both, that is printed. Everything else is ignored. Pretty simple. Next up, you have to print a common range of numbers that are present in an array, right? Now, np.arange is going to give us, first of all, numbers from 0 to 9. Here, I'm trying to using this, I'm just trying to print out 3, 4, 5, 6. I'm telling Python, hey, whatever is greater than equal to 3, print it. Whatever is less than equal to 6, print it. You can throw away everything else. So, it's giving us an array 3, 4, 5, 6. Right. Next up is to go on to create a sample series using dictionary. Of course, again, I've just imported NumPy and pandas here. We have a sample dictionary. The sample dictionary gets converted into pd.series. That's a function we're going to use to create the series. As soon as I run this, as you can see, this dictionary got converted into a series in using pandas. Pretty simple. The next thing, as I told you, sometimes you will have to assign names to indexes rather than numbers. So as soon as I go on to run this, we're going to be using the .name function to create a numbered, to create a named range as well. So in this case, every element you see, right, 1, 2, 3, 4, 5 here. Of course, we're only printing the first 5. The number actually went on to became. Now, when you look at it says name equal to numbers, right? The index for this entire series, right? The index for the positions actually is said to be this particular character, this particular string here, right? Simple. Next, we're going to be printing the elements that are present only in one series, right? A unique series rather than the other one. Now, let me go on to execute this to tell you what we're trying to print here. Now, here we're trying to print the elements that are only common to one of these series and not present in the other, right? Now, there are so many elements that are omitted. 5 is not here, 6 is not here, 7 is not here, 8 is not here, right? Why is that? Whatever element is only present in one series, right? Now, we've used a very nice operator here called as tilde. Tilde is the key that you would find on your keyboard, which is above the tab key. So tilde basically reverses that and gives us the output, right? So first series, whatever is in the second series and not in the first series, just give us the output, is exactly what we are trying to say. Next, we convert a NumPy array into a pandas data frame as we checked out last. Now we're going to be using a random function, as you already saw. We're going to be creating a series here from data, which is the range of data is 1 to 29. We are going to have 25 elements of all of these and convert that into a data frame, right? So this is the data. Now you can ignore 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 because those are the index positions. Everything from 11 here, 11 to 12 here and 12 to 24, right? This elements, right? Now we have a 5 cross 5 matrix here. Why is it 5 cross 5? Because we have used 25 elements only. But even if you used more, you can reshape it and say, no, I only want 5 into 5. 5 into 5 is 25, right? So I only want a 5 cross 5 matrix, so I want the output, guys. So this wraps up this particular module, guys. We checked out the basic syntax in Python. We worked with NumPy. We worked with all the important aspects of using NumPy and pandas and aligning all of these practically for the use of data science as well, guys. So this brings you to the end of this module. I'll see you on the next one. So guys, now we are going to take a look at module number 4 on this data science full course video, which is machine learning. As you might already know it, right? Machine learning is one of the most popular applications there is of the entire world of data science. When that becomes the case, it is vital that you know everything there is to know about machine learning. So in this session, we are going to check out a lot about the same. First of all, we're going to check out why you require machine learning, and after you understand why you require machine learning, we're going to take a look at the types of machine learning algorithms that are out there. What is the actual process of how machine learning works? Once you understand this process, we're going to check out the usage of Python for machine learning, and we're going to check out the top 5 machine learning algorithms that you must know as a person who's proficient, who's an expert in the field of machine learning and data science, right? And of course, at the end of it, we're not going to be just checking out theory of these concepts. As always, we're going to make sure we balance this theory with enough amount of practicals. I'm going to have a code walkthrough session where we're going to check out every single individual element practically, as I've explained to you theoretically, and we can proceed with the best way that you guys can understand these concepts, right, guys? Now, first of all, as I just mentioned, right, machine learning is one of these concepts which form to be the most important aspect of data science that there is. When you think about how you can get to artificial intelligence, right, artificial intelligence and data science go hand in hand because AI is the biggest application of data science there is. But to get from data science to AI, you require machine learning in the middle. That is why it is the most important stepping stone that adds so much value, right? So what are we doing with machine learning? With machine learning, the goal is very simple. So we make sure that, we get the machines to understand data on its own, to learn on its own, and eventually give us a solution without us having to intervene during this entire process. Now, it is very, very easy to say that, hey, machines are very intelligent. They understand a lot of things. But as I've been mentioning in the previous modules, your machine can only understand zeros and ones at its most functional level. Everything apart from that is just added for our convenience of how we can communicate with the machine better, right? So if you show a picture of a cat or a dog to your machine, there is a very good chance it will not understand anything unless it is trained or unless it is told that, hey, what you're seeing is a picture of a cat, what you're seeing is a picture of a dog, right? So what is the goal if it is naive at this level? Well, the goal is to make sure that our task in many cases can be simplified to its most easiest way possible by getting the machine to do work for us, right? So making the machine think like us, making the machine think like human beings is the primary goal here. Now again, if you've been wondering about where the machine learning data comes from, where it learns, again there are numerous data sets to singleton problems, customized problems. There's so many ways where you can collect data, as I've been already telling you since module number 1. You can collect data from multiple places and then have work on it, right? So here in the case of machine learning as well, the same thing applies. Data comes from a variety of places, it gets stored, and eventually then a solution is derived based upon the data at hand, and after it goes through an algorithm and all of that. So the first question you really should ask yourself is, why is machine learning required in the first place? Why is it the biggest thing in today's world, right? First of all, you have to understand that there's hundreds and hundreds of reasons. We can have a discussion hours together just talking about the advantages of machine learning. But to give you a clear and a concise picture of what you can expect, well, here are some of the important pointers. First of all, the most important thing is that it will help reduce production cost to a very big extent, right? Now, it is not only just production cost, it is everything right from production till delivery of of a product to the customer, right? Machine learning can sit in all of these different phases of product manufacturing and delivery in a way where you thought it was not possible before, right? From material procurement, right from actually processing it, quality control to delivery, supply chain analysis. You can do everything when it comes to production here. The next reason why it became really popular is that you already know we generate a huge amount of data every day, right? With machine learning, the advantage here is that you can process all of these very easily, in a simple fashion where you do not have to break your head to go through a lot of data, right? That's the advantage. The next thing is individuals, startups, multinational corporation, whoever you are at the end of the day, you can derive some key insights about your business in a very clear and a concise way if you go on to make use of machine learning. It simplifies your tasks not only in a way where it tells you that you've gone wrong here based on the past data, but it can also use past data and present data and give you a forecast into the future. It can tell you, hey, down the line, your company can sell these many products. It is forecasted that you can sell all of these products. So imagine, probably a couple of years before, maybe 20-30 years before, if someone told you can use your computer to predict the future, they would still treat it as a joke, right? Now it's not so much of a joke. Data is the new oil. It is packed. It's a treasure. You can use it to derive all of these insights, and it's a beautiful thing to do it as well. Again, we're going to see all of these practically in this module. The fourth point is what I just mentioned, right? You can find out hidden trends that are present in data. Now, let's say data, think of data as maybe a bowl of rice, right? If you just look at a bowl of rice, you really cannot make any sense out of it. But let's say that there is little snippets of gold hidden inside this bowl of rice. So if you put your hand, dump in, if you churn through the rice, and if you put in your hand, do the hard work, and then you can pick up these tiny figments of gold which was not visible to the naked eye, right? This is exactly how data is. It's like playing treasure hunt with the data. You will know that there is something at the end of the tunnel, but to get to that you have to work. That work takes extreme amount of processing, and that is why we require machine learning. So I hope I was clear with why you guys should definitely look at learning machine learning, right? Now, the next thing after you understand why machine learning is that you have to look at the different types of machine learning. Because if you do not understand the fundamental concept of how machine learning is divided, it becomes very difficult later down the line. So guys, there are three different types of machine learning of how a machine itself learns in this domain. It is supervised learning, it is unsupervised learning, and it is reinforcement learning. Now these three learning methodologies, right, they work in very different ways. Each has its own application, each has further subdivisions and a lot of things, but these are extremely important. These are foundational for everything that we are going to do go ahead with this in this module. So make sure you're putting an ample amount of concentration for these slides, guys. Right, the first one that we are going to check out is supervised learning. Now think away from data science, think away from machine learning for a second here. When someone says supervised learning, or that you are learning with some supervision, what's the first thing that comes into your mind? Because for me, it's probably a child who is studying for an examination and there's a parent who is supervising and making sure that the child is not playing games but is actually studying. Supervision, right? Keeping a control. Now in the case of machine learning, things work similarly to the analogy that I just mentioned to you. Here, however, it is not the machine itself governing. It is the data which is governing. It is the governing entity in a way where the machine itself knows what data it is seeing. It is not literally being supervised, but it understands the data as if it were supervised. That's the difference here, guys. So you have three images on your screen right now. Let me use those examples to explain supervised learning for you. You have the image of a flower, you have some dumbbells, and you have a car here. Now, you as a human being is probably taught from a very young age to see not one, not 100, but 1,000 pictures of flowers to say it's a flower, right? You will not see a flower and call it an aeroplane. You know that is wrong. You have been trained over the years again and again and again. You see a picture of a dumbbell, right? There's a good chance it can be slightly confusing because you might have never used a dumbbell, or if you have, it is very easy to spot it, right? Now car is definitely a popular thing that you've seen, you've known. You would have seen thousands of cars in your lifetime, hundreds of colors, hundreds of models, all of these. So as soon as you look at the picture that I've put in here, there's a good chance that you can say, hey, it's an orange color, it's this brand, it's a coupe, it has this brand sport wheels, it comes with this engine. You can actually go on to tell the model just by looking at that image. But if you show the image to a computer, no, it will not understand any of these, right? You have to be very clear about that. So to bridge this gap of us telling the machine what it is seeing, right, the advantage of supervised learning is we give the labels for the data. If the data is the image of a flower, we give a label. We tell, hey computer, here is the image of a flower. We specifically mention that it's a flower and then give the image to the machine learning algorithm. So at the end of the day, the machine learning algorithm already knows what it is seeing. So it uses that to learn and later predict other images which might be of the case. Now this is just one example of supervised learning that I'm giving to you. But having these labels below that says this is a car, this is a dumbbell, this is a flower, right? That is very important for supervised learning. Now, with unsupervised learning, you don't do this. I'm going to explain that in a second. But before that, here's another important concept that you definitely should know about when it comes to supervised learning. See, supervised learning is a very simple form of how we can have an input. How can we apply a function on the input to eventually transform and arrive at a solution, right? So if your input variable, as we call it, is considered as x, applying a function on it becomes f of x. If you assign this to another variable y is equal to f of x is what we get. This is the foundation of supervised learning. We are trying to map the output as a function of the input, right? So we have the input, you're doing some transformation on the input which eventually takes you to the output, right? So whenever there is a common discussion, y is equal to f of x, now you know what y is equal to f of x means. You have an input, you apply a transformation, you apply functions on it, you do a lot of things to the input to take it from its raw form to a processed form, and the processed form itself is considered as y, which is the output variable in this particular case, guys. So this is a very important thing about supervised learning that you should know about. But then, did you know that supervised learning is further branched into two things called as regression and classification? Now, first of all, machine learning is divided into three things: supervised learning, unsupervised learning, and reinforcement learning, right? Now, supervised learning branches into two, where it's called as regression on one side, classification on the other. Now, if you've been wondering about what regression means, again, regression is a concept which I have already discussed previously, where you take in data from the past and you try to predict what might happen in the future. Or let's say you take data from the past and you understand why we are at this point in time today, right? We're going to be discussing a regression use case practically as well, so make sure you stick around till the end of this module. So regression is a very simple concept. Again, we're going to discuss it with an example. But if you're looking at classification, right? Classification is a simple concept which you've already used. Regression is something which you might have used in a casual conversation, but classification is something which you have done. Let me give you an example. If I give you, a ripe apple versus an unripe apple, or let's say I give you 3 apples or 2 oranges, I mix it and I give it to you. I say, hey, based on the shape of the apple, based on the shape of the fruit, why don't you split it out and classify it differently? Well, an orange is a round fruit, right? So you just take it and you move it to another place. On the left, you keep an apple. The apple has a very unique shape, right? So you put it on the left. Now, if I said, hey, why don't you classify it now based on the type of fruit? Now, there might be a case where there's a defect in the apple and it is now round, right? There are certain chances that it is almost round, you can get confused. But if I say, classify it based on the fruit only, you will know no matter what size or shape the apple is, push it to the left. No matter what size or shape the orange is, push it to the right. That is a simple way of classification here. Now, let us take a look at supervised learning. Supervised learning is one of these methodologies which is a direct contrast to, unsupervised learning is one of these, types of learning which is a direct contrast to supervised learning. Here, the entire goal of the machine learning algorithm is not us telling what the data is, but it figuring it out on its own. So the entire usage of unsupervised learning is based upon how the machine learning algorithm itself can find some sort of hidden structure or pattern that is present in the data without us specifically telling it, right? Now, take a look at the same 3 images I have on your screen. Flowers, dumbbell, and car. But this time I have not labeled it, right? That is done on purpose because here in unsupervised learning, you do not label the data. You just give it an input variable and let the machine learning algorithm figure out on its own. Now, there is a very, very good chance that now there's a question in your mind saying, okay, so if you're not helping the machine, is unsupervised learning a complex procedure compared to supervised learning? In many cases, the answer is yes, because here, it is not just cross-referencing what it has learned to what it already knows, but here it has to first of all learn in a very different way and then work on cross-referencing. So it definitely takes a good amount of computing time, computing power, and of course the way the machine learns, the way it uses algorithms to already know that it only has the input to get to the output and find a structure is very, very different compared to supervised learning. So I hope I was clear in that point, right? Now, if you're looking at grouping, another very important thing that you have to know in unsupervised learning is that there's 2 groupings just like how we had for supervised learning. But here, instead of regression and classification like how we had in supervised learning, in unsupervised learning, we have clustering and association. Now, clustering is a fantastic example which again you would have used in your real life anyway. If I give you 3 erasers, 2 pencils and 5 pens and say, can you group all of these things separately and keep it into 2 or 3 piles? Can you or can you not do it? You can do it in a very simple way because you know what a pen looks like, you know what an eraser looks like, you know what a pencil looks like, and you know how to club it and group it and keep it separately, right? Does the machine know this? No. But if you train it, can it understand this? Absolutely yes. That is the entire point of using unsupervised learning, right? So that is a simple example of clustering. Now let us take a look at a simple example of association. Again, association is something which you have used but you might not know you have used. Maybe you're on the Amazon's website, maybe you're buying your favorite thing, maybe you just bought a new mobile phone. Now as soon as you buy a new mobile phone, as soon as you add it to the cart, there's an option below which says people who have bought this mobile phone also bought this. It may be a screen guard, it may be a case, it may be an earphone, whatever accessory, right? So it is recommending something to you. It is saying, hey, people bought this. No, people who bought this also bought this. So it is trying to map something. People who buy this phone have a good chance of buying the protective case for it, tempered glass for it, all of these things, right? That is association. Here's another example. Every time you finish watching a TV show on maybe Netflix or Amazon Prime, at the end of it, there is a good chance it recommends a very similar TV show for you. Now, if you watched a horror movie, the next recommendation is going to be a horror movie or a thriller or something like that. If you watched a comedy, a situational comedy, sitcom or anything like that, after you finish an episode or after you finish the TV show itself, the next one it's going to recommend to you is something similar, because here, Amazon, Netflix and all, they're trying to understand what your preferences are, what you like watching, and eventually customizing their platform so your viewing experience is amazing, right? That is association. If you've been wondering, association is used not only in these 2-3 cases but almost everywhere that you can think of. Everywhere where there's customization, where there is a goal to make sure that customer retention is high, will use association, and even in fact a concept of clustering very popularly as well. So it becomes very, very vital that you understand that unsupervised learning is among the most popular algorithms or the types of learning there are in today's world. Right, now that we checked out supervised learning and unsupervised learning, let's get to the third type of machine learning. Here we're going to take a look at reinforcement learning. Now, reinforcement learning is a very, very fun algorithm because, again, here's an analogy in real life to simplify what it means. Okay, so how many of you guys have either pet cats or pet dogs at home? It works better with dogs and less with cats because I personally am a owner of both, so I know that it just works amazingly well with dogs. Right, here's the example. Have you ever had your dog trained professionally? Right now, a simple training, it usually starts out with sit, stand, give me a handshake, all of those instructions to your dog, right? Now, your dog does this. Your dog is trained in a way where if it gives a handshake, it gets a tiny reward. It gets a biscuit. It gets a treat, right? So your intention here is to get the dog to give you a handshake. The dog's intention is to train itself in a way where if it gives a handshake, it gets a treat. It gets a nice thing to eat, right? Your happiness lies in getting the handshake. The dog's happiness lies in getting the biscuit. It's two different things. But at the end of the day, your purpose of getting a handshake is being solved, right? So that's the thing. With cats, I've seen that if you ask a cat for a handshake, they just meow and run away and they don't care absolutely. Or I don't know, just is it my cats or something like that? But that's the most common thing that I have seen, right? So there's a reward which is waiting at the end of learning. Now, if the dog does not give a handshake, and if you say, hey, give me a handshake, and you extend, you try, but it runs away, it is not getting the treat. It is missing a treat. It is intelligent enough to understand that it has to work towards something, be it a handshake, be it sit, stand, roll over, whatever it is, to get that treat while it is being trained, right? Exactly the same thing here in machine learning as well. When a machine learning algorithm learns, here we are trying to make sure that it is learning based on its own feedback. It will use its feedback in a way where either it has to work towards the rewards. In case, if it is learning right, it will be given a reward every position of the way. If it is going away from the solution, if it is doing something which does not add value to the solution, it is punished or it is penalized. Of course, guys, this is just an example with machine learning. There is no penalization or there is no punishment with real pet dogs. It was just an analogy, so that's an important thing you have to note, right? In machine learning algorithm, the penalty or the reward is just mathematical numbers. It's +1, -1, all of these things which will eventually not hurt anything, right? So keep it at that. What happens here is exactly that. If it's going towards the goal, it is given a quick reward and it knows that it has to maximize the number of rewards it gets. If it is learning something which is not useful to the reward, it gets to the goal, it gets penalized and the rewards keep coming down. So the goal is to maximize the number of rewards, and it does this by looking at its previous steps, previous learnings, previous iterations. So that is how reinforcement learning works. It's a really fun way to work with machine learning. I absolutely love working with reinforcement learning. But again, in the most simplest way, it is okay to implement for a simple solution. But if you have very complex solutions where you have to use reinforcement learning, the implementation does become tough, guys. So that's one thing you should know about. Right, so next up, we're gonna check out how a machine learning model actually goes on to learn. What is the procedure that a machine learning model uses to learn, right? Now guys, you see a term that I'm using here, machine learning model. It is very different from a machine learning algorithm. See, once you have the data, you create an algorithm. You use this algorithm along with the data to get your result, right? But after it has seen the data, after it has learned and trained, it is no longer called as a machine learning algorithm. It is called as a machine learning model. So whenever someone says model training, model has trained, they never say algorithm has trained. Algorithm will be used for training. That's it. So after something gets trained, it is called as model, guys. Make sure you keep this in mind. Right. So how does a machine learning model learn? First of all, for a machine learning model to learn, it requires data, right? Again, I'm going to give you a real life analogy here, but let us talk about machine learning aspect first. You have certain data, one chunk of data that which you're going to use for this particular solution. You're going to split it into two actually. One batch is called as the training data. The other batch is called as the testing data. Training data is everything that you push to the machine learning algorithm so that it learns, so that it uses it to understand what is going on. Next, to verify if the machine has learned anything or not, you are going to use another set of data which the machine has never seen before to eventually go on to see if it has learned something, if it can do things in the correct way or not. So training data is used to train, testing data is used to verify if it has learned or not. So usually in the common usage, data is split into 70% of training data, 30% of testing data, or 80% of training data, 20% of testing. There's a very good balance here in a way where majority of the data gets to the training, because more the data, the machine can train better. And of course, you can get away with a small amount of testing data to verify if it has learned something or not. But then again, this depends on the type of solution, the type of algorithm, the type of learning that eventually has gone into usage, right? So it's not always the case where, if you just use 70% of training data and 30% of testing data, that you will get the correct solution. This is open to experimentation. Sometimes you'll use 70 on the same data set. If you go on to use 80-85% of training data, it will give you an exponentially better solution, because it might have learned something new in that aspect of data which you hadn't given it before, right? So it's very important. Now coming to the analogy, this is literally like how you would write an examination in school or college, right? First of all, you would have been given a textbook or any other study material where you're going to use it to learn nicely, and after that there's going to be an examination where people are trying to evaluate, they're trying to verify if you've learned something or not. Well, training data, testing data, exactly the same thing, right? Now I hope you have complete picture on the data side of things. But to talk about the entire life cycle of machine learning, right? Well, here it is. Whenever you are solving any problem, be it a real life problem, a hypothetical problem, whatever it is, what is the first thing? The first thing you have to understand is that there is a problem that you have which you know machine learning can be used to solve it. The next thing is you understand the problem itself in a way where your thoughts are aligned towards using the domain to solve the problem, right? So once you understand the problem statement, once you understand the business problem completely, then the second step is, okay, so now I understand the problem. Next, I need data to go on to teach my machine learning algorithm and use it to train, right? That is exactly what goes on here as well. After you understand the problem, you start data acquiring, you start gathering data from multiple different places. Data can be stored on your server, on your cloud computing platform, it can be on your pen drive, it can be social media data, it can be competitor data. There is no end to bringing in data from any different source of choice, right? So it's very vital that you understand that you can bring in data from multiple ways and eventually use it. Now, the third thing which we already discussed in the module number 1 is data cleaning, right? I have been mentioning so much that data cleaning is very important. If you do not clean your data, if you feed incorrect data, your machine learning algorithm is going to learn things wrong. If I show it a picture of a cat, but if my data that I've given it says it's a dog, your machine learning algorithm is going to say, hey, it's a dog. Well, you, as soon as you look at the image, you're like, okay, that's not a dog, that's a cat. Because you know, right? You've been taught right from your childhood. Your machine learning algorithm, that's not the case. If the data is incorrect, it will definitely lead to a very inaccurate result, which is going to be a huge waste of time. So it's very vital that data is cleaned. Now, once data is cleaned, you can actually hunt into the data even before applying machine learning algorithms to get, a good amount of insight. It's called as EDA or exploratory data analysis. Exploratory data analysis is very popular because, again, no matter where you can think of it, right? See, you have data which can give you so much insights. If you're exploring into it and picking out insights out of it, that is literally nothing but exploratory data analysis. Again, it's completely a domain of its own. It's a module of its own. We're going to be discussing it in detail. But for now, you have to understand this, right? You can get a chunk of information, right, without even performing any machine learning operations. But once you go on to have this basic analysis done, you want to delve deeper into teaching your machine learning. That is when you will bring in a machine learning algorithm. We already saw the 3 types of learning. What were they? Supervised learning, unsupervised learning, reinforcement learning. So you're going to use one algorithm or one or more algorithm with this particular type, whatever you think is the right for the solution, and eventually you're going to apply the machine learning algorithm on the data. It is eventually going to train and it's ready to be verified. You fit the data, you verify if the machine learning algorithm has learned anything or not. That is the step where I'm saying predict your model accuracy. To see if it's accurate or not, first of all, you have to find what's the correct thing, and eventually what you predicted would be right. So once you mix and analyze the differences that exist between what you predicted versus what actually is the reality, you will get an accuracy difference. That accuracy difference will eventually tell you how well your model has learned or not. You can repeat step 2 to step 3 again. You can repeat the entire process to make sure your data is better, it is cleaned better, you're using a different test train split. You can do a lot of different things until you get to the last step, right? So once you experiment, you will have different models which will use different sets of accuracy to learn. So you will have this idea. After which, right, the last thing that you will do is deploy the model. When I say deploy the model, it means that I have the solution for the problem ready, and now I'm putting it out there so that I can actually and eventually solve that problem, right? That's the process of model deployment. Maybe it is going on a server where you're trying to implement ML on your website, as I told you, right, Amazon, Netflix. So when they code it in the background, they've done until predict your model accuracy step. After that, as soon as they put it on their website, as soon as things go live, that is when they have deployed it. That is when it is actually working to provide a solution, right? So that is something that you should know about. Right, so guys, this is the entire architecture of how a machine learning model learns and works. I hope I was completely clear on this aspect. Next, the important thing that you already knew about from the last module that we checked out is Python is the most important programming language we have whenever we are working towards machine learning, right? It is very vital that you, of course, you can use multiple different languages for machine learning, but you have to find the simplest and the easiest way to do it so you don't break your head about complex syntax, but rather use your time effectively to eventually drive a good solution, right? That is where Python comes into the main picture. Python is a very powerful programming, as we have discussed already. It is the most popular language out there, but for machine learning, it is the number 1 language. It is always preferred no matter what. Why? Because it gives you a high level syntax where you can again spend time on logic rather than the syntax itself. It's very easy to work with, and personally, if you ask me, the biggest reason why it's popular is, now when you think about machine learning, if you've never looked at machine learning code, there's a good chance you might think, okay, so if I have to teach my machine, train it and get it one step closer to artificial intelligence, it might take a huge amount of code. Guess what? With Python, that's not the case. A tiny amount of code that you write can have a huge impact, as I'm going to show you practically now. It's a very important thing, right? So you don't have to write 100 lines of code to see a tiny output. You write that tiny line of code to see a huge output. That is the power of which Python adds to this field of machine learning, guys. So that's an important thing. And of course, working with Python is amazing. You have multiple ways. You can install Python from the Python website. You install it via Anaconda. You can have an ID, an integrated development environment like PyCharm, or you can use a very simple Jupyter notebook on the Google Cloud platform called as Google Collaboratory. Again, all of these are free to use. So eventually at the end of the day, working with it, setting it up and starting to use is easy, as we have already discussed in the previous modules, right? Here are some of the important libraries which you're going to require for machine learning as well. First of all, to store data, to array processing data, manipulate it, and eventually work with complex numerical computations and data manipulation operations, you require NumPy and Pandas. NumPy and Pandas we covered in the last module to a good amount of depth to show you all the operations which you're going to require, right? Again, we're going to use all of these now as well. But then one important library that is very, very important for machine learning is scikit-learn. Scikit-learn is a beautiful library which is meant for machine learning, which is built so that machine learning can be worked around with in a very, very easy fashion, right, guys? So after these three libraries, again comes data visualization libraries. You have Seaborn, you have Matplotlib. We're going to discuss all of these in the data visualization module in depth again, right? Now, whenever you're taking a look at the traditional way of how one can go on to program versus how a machine learning algorithm learns, there is a huge difference which you may or may not know. So when you compare traditional programming, how does it differ with machine learning, right? Here is it. Here it is. It's a very, very important difference. Look at the left of your screen right now. I've put in traditional programming, right? In the case of traditional programming, what usually happens is you have data and you have a program. Your program uses the data, it's a compiler, whatever it is, and eventually gives you a simple output to work with, right? You have input, you have the computer program, input goes into the program, eventually what you get is an output at the end of the day. With machine learning, that is not the case. You have data and your machine learning algorithm already knows what the output is. It will know where it has to get to. It's not like there is no light at the end of the tunnel here. It already knows that, hey, using this data, I have to get to this output. So how can I get from this data to this output is how machine learning works. The entire process of it learning to go from understanding the data to get to the output is where it's called as a machine learning model, right? So every time we talk about machine learning, it can be very confusing, saying, hey, you have an input, you have a program, you get to the output. No, with machine learning you already have the output and the data in the previous stage itself, and the process is what is it's what we are after basically when we look on to this domain as well, guys. So this is a very, very important difference which you should know about if you're looking towards learning machine learning, no matter what level, basic level, intermediate level or advanced level. This is a foundational concept which you guys should know about, right? Now that we looked at a lot of things, it is high time we check it out all practically, right? So here are some of the machine learning algorithms which will add a ton of value to not only your career but to your entire learning in the field of data science as well. Of course, all the algorithms that I'm about to discuss right now are the most popular ones out there. They are the trending ones for this particular year. People who are hiring, right? Companies who are hiring right now for machine learning jobs or data science jobs will ask in the job description saying, you may or may not know one or two algorithms, but all the algorithms that I'm about to discuss usually are in that list which says it's a compulsory requirement for you to understand. So when the recruiters themselves say that you require these many machine learning algorithms, the knowledge of it, well, it becomes vital that we cover it and teach it for you, right? So here are some of the algorithms that we're going to be discussing, guys. First of all, there are many different algorithms that you can look towards and work with. There's linear regression, logistic regression, again, regression, right? We already discussed this as supervised learning. You have the naive Bayes algorithm, you have the KNN algorithm, you have SVMs, support vector machines, you have random forests, and you have many different types of algorithms, which eventually has its own way, uses its own protocols, uses its own way of learning to eventually get to the result. But to simplify things down and not pick up all complex data sets, let us work one by one into the top machine learning algorithms that you have to learn, guys. We're gonna keep it very simple. We're gonna take a look at simple data sets. I'm gonna explain what each line of code means so that you completely understand, right? So first of all, we have a linear regression here. Again, what is regression? To roll back on the same concept we checked out, we are trying to model an input variable by applying a function on it and eventually calling it an output, right? An output is a function of the independent input variable. So when I say input variable, when I say independent variable, it means the same thing. When I apply a function on the independent variable, it becomes a dependent variable on the outside, and that is your eventual y is equal to f of x. Y is the dependent variable, x becomes the independent variable, right? So there's another question which I'm usually asked a lot when I talk about linear regression, no matter where I go, is why is it so popular? Why do I have to know machine learning if I'm if I'm looking towards machine learning or if I'm looking towards data science as well? Well, the first thing that I can tell you, it is extremely popular because it will give you this cause-effect relationship which the real world requires a lot, right? Now, to simplify things, just let's look up at the sky right now if you're sitting outside or something, or maybe just look outside right now. How is the weather? If I ask you a question, what will you do? Right? You look up at the sky, you look at if there are clouds, if it's not cloudy and all of that. If there are black color clouds and you know that there are possibilities of rain, you might get a hailstorm, you might get snow and all of these things, right? If there are a good amount of clouds, right? Of course, weather changes rapidly. That's not the point here. The cause of the rain is what? Clouds. But what is the eventual effect? The effect is rain, right? Clouds cause rain. The effect is rain, the clouds is the cause, right? So that relationship, I just gave you one example. You can think of hundreds and hundreds of examples like this. So this is eventually what is used in today's world as well. That's why it is very, very popular. So what we are going to do is we're going to head to Google Colab. We're going to practically check out how we can implement a simple linear regression model by using a very popular data set. It is the Boston housing data set, right? Now, with this data set, what we're trying to do is, this consists of all the details of the houses in a locality in Boston. We're trying to see if our machine learning algorithm can predict the prices of the houses based on a multivariable assessment going on. It's called multivariate analysis. We're going to use multiple variables to see eventually to train our machine learning algorithm saying, hey, do you know why the prices are like this and how accurately can you detect these prices? That is the question we are going to get an answer for right now. Alright guys, we are now here at Google Colab. As I told you, Google Colab, we have used this in the previous module. It's a free Jupyter notebook hosted on the Google Cloud platform. You can just type in your Python code, hit the play button and you're done. You do not have to install a lot of these popular libraries that we're going to be working with, right? So again, the first step is to make sure we import all of these all the data sets that we're going to be using for algorithms. Of course, you can do it step by step, but to simplify everything, let me quickly go on to import all of these. There's a simple upload button here. With the upload button, all I have to go on to do is just put in our data sets that we're going to be using. It will upload it one by one, and so that we don't have to do it every single time here, right? Again, let the circles finish. It means that it is uploading. Alright, perfect. So all of my data is now uploaded. Let me zoom in on my screen to the max where you can see all the data, right? Now guys, with linear regression or any algorithm that we're going to use, the first step is what? We're going to be importing all the libraries that we have to use, right? Look on your screen. We are importing NumPy, we are importing Pandas, we are importing sklearn. NumPy and Pandas, I told you it's going to be very important for machine learning. We are using it right now. Scikit-learn or sklearn as it's called is a very important library for machine learning, right? So after importing the libraries, the next step is to import the data set so that we have a workable data set that we can work with, right? So here, as you can see, pd.read_csv means pandas, where we're trying to read a CSV file, calling it the housing.csv, where all the data of the Boston housing data set is present. Let me go on to hit play, and it prints us a lot of the row and column values that are present, right? It's printing us 5. Let's see if we can print 10. Now, boss1.head, boss1 is of course a variable that we just created. Head is a method. If you do not pass any parameters to it, it's going to only output 5. Now in the bracket, if I put 10 and if I hit execute, it's going to give me the first 10 rows worth of data, right? Now there's so many different things here that are talking about the prices of the house, the crime rate that's present, right? What is the age of the house? So whenever you're trying to find the value of a house, what will you look at? How convenient it is from the nearest supermarkets? How old is the house? What's the tax ratio? How many floors does the house have? What is the area footage? You look at a lot of different things, right? So all of these are, each of these columns that you see here are eventually individual attributes that contribute to the price of a house as well, right? Even crime rate is a very important thing that you will look at whenever you're buying a house. You'll see if the area or locality is shady or not. If it is shady, maybe the house is worth a lot less, correct? So that's an important thing here. So all we are trying to do at this point is to import the data set, import the libraries, print the first 10 for your reference, right? The next step after importing the data is to clean the data. Now to clean the data in this particular data set, all of what we require is numbers, right? For example, look at the age column. If I ask you what your age is, will you say my age is orange, my age is apple? No, that's a nonsensical answer to a question, right? If I ask you your age, I am 100% certain that the answer you're supposed to give me is a number. Now, sometimes it so happens that in the data set, right, it will not be a number, it will be something else, something meaningless. You have to remove all of those, because if you do not, your machine learning algorithm is going to use those nonsensical data entities to learn everything wrong, as I mentioned, right? So the next step we're going to be using a function called as isNA. Is basically a function which says, is it a number? We're going to be basically using this method to see if we have any characters where we have to have numbers, right? NaN stands for not a number. We are trying to find values which are not numbers, in the sense they are characters, string and all of that, right? Thankfully, this is a data set which is already pre-processed and cleaned. So no matter which column you take a look at, all the values are 0. It is saying that, hey, everything here is a number. There is no character or there is no data which can throw your machine learning algorithm off. This is a good thing. The data is clean. It is already pre-processed. The next step of the way is to make sure we can clean the data. The next step of the way is a very simple one, where we actually try to split the data, as I mentioned, right? We're going to split it into training and testing. That is exactly what we are doing with these 3 or 4 lines of code. But here, I've mentioned that, I want to split it 70% of training, which means that 30% of the data is going to go for testing. How do you know? What do you see on your screen that says it has to be 70% for training, right? Look at this variable which I use for test train split methodology. It says test size is equal to 0.3. Now, when it says test size is equal to 0.3, I am telling it, hey, what I want to use for testing later is 30% of the data. 0.3 means 30. So what is the remaining? If you have 30, it's 70, right? That becomes training. What if I put testing data as 20.2? If it is 0.2 or 20%, it means 80% of the data is being gone for training purposes, right? Now, if this is 0.5, it means 50% of the data for training, 50% of the data for testing, right? However, I have found the sweet spot to be somewhere around 70% for training for this data set. So let's check out what goes on. The next thing we're going to do is, since we are checking out linear regression, right? LR equal to linear regression and LR fit equal to X train and Y train. So we are trying to model the data in a way where it uses, So what we're trying to do here is we're trying to model, get the model to understand the data that we have been checking out in terms of the training data. Now, if you were a person who thought you required 100 lines of code to train a machine learning algorithm, you have 3 important lines where the machine learning algorithm actually does the learning process, right? The model fitting, when you say fitting the model, it means to actually use the data to learn. And later you're going to be predicting it based on the testing values which I mentioned. As you can look at it, the parameter we send for predictions is also the testing data set rather than the training data set, right? If you just send the training data set again, what happens is that it already has seen that data. It will tell you 100% accuracy because it knows everything that it is seeing. machine. If I give you a textbook and if I ask you, hey, write an examination based on this, where there are direct answers in the textbook, you do not have to spend a lot of time to learn it. It doesn't make sense. You can get 100 out of 100, right? But if I give you something else where you have to use your processing power to do it, that is exactly what we're trying to do. So with these 3 or 4 lines of code, our linear regression algorithm has learned everything it has to learn. Next, we have to see if it has learned or not. That is where we use error rates to actually go on to see if it has learned something. Now there's an error rate called as MSE, or mean squared error, which is again a concept of its own, which we are going to use to predict if the machine learning algorithm has learned anything or not. So let's see what error we get here, right? So it will be somewhere around 5-ish. Okay, yeah. The error that we see for using linear regression is 5.54. Now, if you are wondering about what this number means, hold this number in your thought for a second, because we're going to use the same data set for another algorithm. That way you will understand what happens if you use the exact same data but 2 different machine learning algorithms, right? Which one learns more accurately? Again, we're going to be checking this data set out in the next machine learning algorithm that we will discuss. Of course, not the exact next one. We're going to be checking out the third one. But now, moving to the second machine learning algorithm that we're going to be checking out is naive Bayes algorithm. Naive Bayes algorithm is a very, very popular algorithm that is, again, not just popular just because how it works, but rather the usefulness of naive Bayes as well, guys. Now, naive Bayes is an algorithm which works based on the Bayes theorem. Now, Bayes theorem is completely based upon the concepts of conditional probability, right? Conditional probability talks about the probability of one event occurring if another event has already occurred, right? P of event 1 occurring given that P of E2 has already occurred. That is Bayes theorem. So naive Bayes uses the concepts of conditional probability to work. It is again a type of supervised learning, just like how linear regression was. And here it is called naive because there is no codependency in between these attributes. So each attribute does not use itself or use the other one to get to the output. So since you don't have the dependency, it's more like a loner entity which sort of learns to which sort of tends to not learn efficiently. But it's not efficiency, but it's the way it learns. That's why it's called as naive in real life, guys. Again, it's a funny way to name it, but yeah, it does work. And now, it is very, very popular for 2 important things: is social media marketing and product management. So whenever you have a supply chain analytics problem, or whenever you're trying to market something on social media, you want to analyze the impact of your marketing, right? Naive Bayes is very, very, very popular in those cases. Again, there's many types of naive Bayes algorithms that we're going to be checking out. There's the multinomial naive Bayes, there's Bernoulli's, there's Gaussian. We're going to pick up one of these to make sure that you understand naive Bayes in detail. Of course, to do that, we are going to be using the social network data set, guys. So let's quickly get back to our Google Colab. Let me minimize linear regression and check out machine learning with naive Bayes algorithm, right? Perfect. Again, guys, what is the first step whenever we go on to work with anything? We import all the libraries, NumPy, Pandas, and scikit-learn, right? As soon as I click play, all of the libraries are done. The next thing is we're going to be importing the data set. In this data set, right, the salary data that we're going to be working with now, I have already pre-processed into training data and testing data separately myself. So I do not want the machine learning algorithm to again split it. Of course, I can manually define and get it to read and input 2 files. Salary data underscore train is the training data set. Salary data underscore test is the testing data set, right? So as soon as I go to hit play, let us check out what the data set itself is. So here there are a lot of different columns of how the data is working with, right? So whenever you're looking at salary data, we're trying to see what adds the most value to the salary, right? The working class of the person, the age of the person, education, marital status, occupation, relationship, the race, the sex, the capital gain that they're holding. Does that have an impact on having a high salary? So what makes, what value, what attribute here adds a lot of value value to eventually having a high salary is what we're going to check out, right? So as you can see, we're trying to check out all the education that the person has and the eventual salary that the person might have. What is the salary range that they're getting? Which country are they native of? How many hours per week they work? So all these data we're going to be using to teach the machine learning algorithm, right? So to go on to use naive bias, the next thing we're going to be using is a concept called as a label encoder. Now, all of these values that you see, right? Relationship, not in family, husband, white, male, female, married, spouse. All of these are what type of data? Categorical type of data, right? But to make sure our machine will not understand husband, wife and all of that unless you teach it, right? To simplify all of these things, we're going to convert every single categorical variable we have into a numerical data, and just to do that we're going to use something called as a label encoder. That's the entire process. All we're trying to do is convert categorical data into numerical data here. Once that is done, all of these get encoded into a numerical data format. It becomes variables of its own. Then we actually go on to assign it testing phases and training phases. That is literally what we're doing. 13th column is the last column for salary, right? So we're trying to add these encoded variables and assign them, saying, hey, what is your impact on the salary, right? As I told you, there's 3 types of naive bias classifiers that we're going to be that we actually have, which you can use depending on your application. Here we're using Gaussian naive bias. Gaussian naive bias is mostly used for continuous data, right? Now the data is continuous here. Salary is a continuous thing which will change based on your experience, right? The first salary which you might have got after graduation is very different from the salary you have after 10 years of experience. It's a continuous graph that rises up and up. So if the data is continuous like this, you're going to be using Gaussian naive bias. But if your data is, let's say, binary data, if you want answers such as yes or no, true or false, up and down, all of these answers, which there are only 2 possibilities, binary outcomes, you're going to be using the Bernoulli's naive bias classifiers. And there's another one which is called as multinomial naive bias. Multinomial naive bias is extremely popular for text classification, speech recognition, all of these things. We're not doing any sort of speech recognition here, nor are we having a binary outcome, right? Hence the reason we're going to be using Gaussian naive bias. Now, as you can see, as soon as I ran one line of code, model fitting is actually done. The next thing all I have to do is predict by passing it the testing data to see if it has learned something or not. And since that is done in 2 lines of code, the next thing I'm going to go on to do is print a confusion matrix. Guys, a confusion matrix is a very important concept which we already checked out in statistics, right? True positive, true negative, false positive. All of these values, as you can see on your screen, the most concerning numbers will be the true positive values and the false negative values. These has to be the highest because at the end of the day, if these are the highest, it means your model has learned really well. We do not want false positives or we do not want false negatives, because these are sort of the values which your machine predicted wrong based on all the values out there, right? Now, if you do not understand confusion matrix, again, I have an accuracy metric here at the bottom which says, hey, I have an 80% accuracy rate of detecting things correctly and making sure it matches up to what we predicted at the start as well. So for every 100 elements of data it sees, it can predict 79 or 80 of it perfectly. That is what our machine learning algorithm is trying to say to us, guys, right? That was naive bias. Next, we're going to take a look at the KNN algorithm. KNN algorithm has a full form. It's an abbreviation. It stands for K nearest neighbor algorithm, right? Now, let me give you an example to explain what KNN algorithm means or how it works. Let's say you want to visit your friend's place, who stays nearby to you. Is there only one road ever that you can take to get to your friend's place? There's a good chance that you can take very inefficient routes to eventually get to his house. You can take one route, 2 route, another crossroad, whatever it is, right? If your friend stays in the next street, the most inefficient way to go to his house is probably fly to America and fly back and directly go to his house, right? That's a possibility. It is stupid, it is meaningless, I understand, but it is a probability still, right? You cannot say it's stupid in the case of machine learning because it does not understand that it is stupid. You have to teach it that, correct? So here what we're trying to do is we have certain data. As soon as we put new data there, we try to index it based upon whatever data points are nearby to it, and from then we map an association saying, okay, so it is closest to this data. It may be the same data or similar data as well, right? So again, that's a very important thing. KNN algorithms are a type of lazy learners. It means they do not really take a lot of time to execute. They do not want a lot of computing power to go on to learn and execute as well. But then to go on to practically check it out, first let me give you a theoretical example to make sure you understand these things properly, right? Now, what we're going to actually do is we're going to try to predict if the person is a male or a female based on their height and weight. Now, it's usually a common survey or a statistic saying that, male or guys weigh more and they are usually taller than the female population. Of course, it might not be the case in every single country or every single place, but the usual statistic is somewhere like this, right? Guys are taller and they are heavier in the build, because that's how human bodies eventually work. In that particular case, can we predict if we just have height or weight of a person to see if they are male or female? Well, here are some of the things. I have heights of, these many people, 7 people. I have weights of 7 different people. And eventually I have the gender also, that if you have this height and weight, that person is a male. Now this is accurate data. This is the data that I've collected from 7 or 8 different people. Now if I have to teach my machine learning algorithm using KNN, saying can it predict if it's a male or a female, here's a graph. This graph is very simple. You remember seeing this chart, right? This chart with just its height and weight in the x and y axis. We have just put the data out there. As you can see, we had 7 data points, right? 3 of the data points are female, as you can see in the pink rectangle, in the pink triangles. Then 4 male data we had based on the green circles you see on your screen right now. As soon as you look at it, you can sort of say that height and weight of the females are slightly less compared to the height and of course the weight of the male population in this example, right? Now, what I will do is, there are 7 people here. I'm going to add another 8th person. I'm not going to tell if it's a male or a female. I just know that this person has a height of 190 centimeters and a weight of 100 kilos. If I put it and map it in the graph, the blue color rectangle you see right now is where that person will be put if the weight and height are matched with what everything else is put, right? Again, you as a person can look at this graph and say, okay, this new person added here is very similar to the guy's weight and height, so that he might be a guy, right? If it was somewhere here, you would say that there's a good chance it's a girl. But for our machine learning algorithm to do it, we have the value of k. K is us saying that, use the 3 nearest neighbors to map a pathway to the new person who was added. If k is equal to 3, as you can see, these 3 green dots are the nearest neighbors to this particular rectangle, to the new data, right? So if k is equal to 3 and if all 3 are pointing to the same guy and all the 3 closest points are guys, your machine learning algorithm can say, hey, I have a 90%, 95% accuracy of saying that the new person you added is a guy. That is how it learns, right? Now let's put k equal to 5. If we put k equal to 5, we are finding out the 5 nearest neighbors, right? 4 of them are guys, 1 is a female here. Now, 4 of them are guys, but 1 is a female. Can it still say it's a female? No, right? Why? Because the majority of the neighbors are still male population, right? So that is how we accurately say, hey, the data we have here, the new person you added is a male, right? Now, if you've been seeing I took k equal to 3, I took k equal to 5, both are odd numbers. Why did I only pick odd numbers? Well, you can use even numbers also, but the general way of working in the KNN algorithm is that if you pick the k value as an odd number, the number of neighbors that you have to track and index, you will use it as an odd number if you only have 2 classes in comparison, right? Here we only have 2 classes, male and female. That's it, right? We're only considering these 2 populations for this example. So since it is only 2 classes, it is vital that we go on to use this value, which is, an odd number, guys, right? The next thing we're going to check out is, again, as I told you, right, we're going to be checking the same Boston data housing data set. With linear regression, we got an error rate of somewhere around 5.4 or 5.5. But what is the error rate we're going to get if we use KNN algorithm, right? So let me quickly minimize the naive Bayes algorithm and let me open up KNN algorithm. Perfect. So again, this code is the exact same thing that we checked out while we were working out with linear regression. All we try to do is import the data set, import the data, import the libraries, print out the first 5. Next, we're going to be removing all the NaN values. As I told you, the data is already clean. Again, this was the exact same thing that we checked out. We're going to be splitting the data into 70-30. We checked out the exact piece of code. But the next thing is what we didn't check out is where we are trying to load the KNN model and use it, right? These 4 or 3 lines of code that you see is where we're actually going to use the KNN algorithm, right? So again, 3 lines of code. But if you see in the bracket here, I put a parameter 3 for KNN regressor, right? This is me telling the machine learning algorithm, hey, use k equal to 3, right? As I showed you to, as soon as I run this again, it's going to use the training data to learn, it's going to use the testing data to see if it has learned and all of that. 3 lines of code. Now, the next thing is, how do I know for sure that for the Boston housing data set that k equal to 3 is the most accurate value? K equal to 10 may give me better solutions, right? To make sure that I'm tuning all of these values and tweaking it to get my model to learn accurately, I'm going to do hyperparameter training. I'm going to do hyperparameter tuning. In hyperparameter tuning, what happens here is that I just print, since it's a small data set, I can just get the machine learning algorithm to work for multiple k values, which is exactly what I've done here. I have got the k value from 1 to 49 to see where the k value is, the error is the lowest, right? So k equal to 3 is what I said will be the lowest. It's 7.01. But hey, check out k equal to 4. K equal to 4 has an even lower error rate. So what it's trying to tell me is, for this data set, for the Boston housing data set with this algorithm, you will get the most accurate output. You will get a lesser error rate if you use k equal to 4. I wouldn't know this until I did it, right? Hence the eventual purpose of mapping out all the k values out here, guys. And of course, the last step is for us to always print the mean squared error. In this case, the mean squared error is 7.014 for k equal to 3, correct? It was 5.5 for linear regression. For the exact same data set, it is 7.01 here. What does that mean? It means that our machine learning algorithm for that particular Boston housing data learned better in the case of linear regression rather than using KNN on that data set, right? Now, once you use multiple algorithms, this is the clarity that you get, which is a beautiful thing. So, right, guys, next up, we're going to check out support vector machines. Support vector machines are very complex entities in the world of machine learning, because here the way that they learn itself is very, very different. They use multiple unknown parameters, and they use a technique which is called as a black box techniques, because there are so many unknown parameters, so many things going on in the background that it uses to learn, right? But then there are certain basic things that it has to work with, is linear data and non-linear data. So in the case of non-linear data, since it is very difficult to train, it actually separates this data by making use of something called as kernel tricks. And all of these parameters which eventually come after kernel tricking is usually tested and tuned by making use of kernel functions. Now there are multiple kernels that we can use, as the polynomial kernel and the RBF kernel, the radius basis function kernel. Each kernel has its own way of working, right? So what happens with the polynomial kernel is that with the polynomial kernel, the data gets transformed into a higher dimension and eventually it works into its non-linear classes. But with the case of radial basis function, the RBF kernel, here we have a parameter called as gamma, and we continuously tune this parameter rather than changing any dimensions, which eventually gets us to our results. That is how we're going to be using SVM, guys. So until we keep scaling these gamma values, RBF will go on to give us different outputs, and we find the best one and we usually hold it there, right? Now, coming to the advantages of SVMs, the most important thing is that it is very, very flexible to work with a variety of data, be it unstructured data, structured data, semi-structured data, whatever it is, right? Unstructured data is images, music, videos and all of that. Structured data is everything that we checked out, right? A nice CSV file with rows and columns worth of data. Semi-structured data, there's again multiple types of data based on the usage as well. So one advantage with SVMs you have to understand is that overfitting is not present, or it's very less here compared to all of the other models out there. So overfitting is a situation where your machine learning algorithm is learning so deeply with so much focus that it starts picking up noise in the data rather than useful stuff. So using its noise, it will not learn anything at the end of the day which is accurate, right? The data is going to be completely inaccurate because it hunted so deep into the data, it found noise rather than useful information. That is overfitting. In the case of SVMs, overfitting is less. But to talk about the disadvantage of SVM as well, one thing is that the training time will be a lot more if your data is huge. All the data sets we've been using now are very tiny figments of data, so it's working beautifully well. There are some cases where your machine learning algorithm can train for hours together, if not days together as well, if you use SVMs, right? The reason why SVMs are popular today is because they have a huge impact in the world of healthcare and in the world of banking sectors and in the case of banking sectors as well, guys. So it's a very popular thing. Let's actually check it out practically now. Let me just minimize KNN. Perfect. Let me open up SVM. And what's the first step in SVM or any algorithm? I can zoom in a little more. Perfect. Is to import all the libraries, importing NumPy, importing pandas. Now here I have another library called matplotlib. Matplotlib is used for data visualization to create beautiful looking graphs, right? Done. The next thing is to import the data set. Here we're going to be using the social network advertisement data set. So what we're trying to do is, if you advertise something, right? If you're advertising a pen or a pencil, and you know the salary of the people who may or may not buy the product, right? What is the probability that a person will buy the product if their salary is somewhere around that, right? So using salary to see if a person of this salary can afford your product or not. Now, if there's a very expensive car like a Ferrari or a Rolls Royce, there's a good chance the common man cannot be able to afford it, right? So advertising that to a common man might be considered as a waste of money as well. So to check that, to check if the person of this salary band can afford a product like that, is what we're going to try it out. But with this data set, as you can see, we have a user ID, we have the gender and age, estimated salary and purchase. Now, what are we concerned about? We are using the salary to see if a person purchased or not. So we do not require the age. We do not care about if a male bought it, female bought it, or whatever it is. So we can drop all of these columns: user ID, gender, age. I do not want. I just want salary and purchase, right? So I'm going to filter all of these columns out with just 2 lines of data. The next thing, again, we're going to be splitting the data. This time not 70-30, but 75-25. 75% goes for training, 25% goes for testing, right? As soon as I click this, that is exactly what I did. Now the data is split up. Next, we're going to be using a scalar called as the standard scalar for normal distribution. The normal distribution is a bell curve which will add meaning to the data so that we can plot it and derive some meaning out of it, right? So by using a standard scalar, all we're trying to do is we're trying to use the training data, map it and verify it against the testing data by using normal distribution. Again, distributions are a very important part of statistics, the concept which governs the world of data science, guys, right? Next, as I told you, there's polynomial kernel and there's RBF kernel. In this particular case, we're going to be making use of the RBF kernel, 3 lines of code. Your this thing model, the SVM has learnt it completely, and at the end of it, if you're trying to print the confusion matrix, again, confusion matrix, we discussed this in the last module: true positive, true negative, false negative, false positive, and false negative, right? So again, I didn't say it in order. There's an order of which the values goes on. You guys are supposed to tell me the order because we covered it in detail. The values I am concerned with are 64 and 29, that they're high. That's perfect. We have 4 and 3, which the model got incorrect, or it predicted in the wrong way, which is absolutely okay. Again, here is where the statistics come into the picture, right? You remember we calculated precision, recall, F1 score and all of that? Guess what? We calculate it here again. Of course, we're not doing it manually anymore. We have classification report which will give us all the details. So we have the precision value if the person bought the product, the recall value if the person bought the product or not. We have the precision, recall and F1 score if the person actually bought the value. 0 means the person didn't buy it. 1 means our prediction based on if the person actually bought it, right? Pretty simple when you look at it, but it's a beautiful concept of how support vector machines work. Right, guys. Next up, coming to the 5th algorithm, the last algorithm that we're going to be checking out in this module is the random forest algorithm. Random forest. When you say forest, what is the first thing that comes into your mind? It's a group of trees. It's a collection of trees, right? Here also it's a collection of trees, but not just trees. It is decision trees. Hence, once you have multiple decision trees, you just call it a forest. In this case, it's called as a random forest algorithm as well, right? One thing you have to know about these decision trees is that they have very high variance and very low bias. This is the exact opposite of what we need. We need low variance in our data and very high bias of learning, correct? To make sure that we solve this problem, we just group all of these trees and create a forest. That is how we solve this problem of decision trees having very high variance and very low bias. So what we do here is we take in data just like a real tree. A tree is going to have branches, it's going to have multiple branches, it's going to have leaves, right? So one important node will be our input. From there we create all our branches, and every single leaf at the end of the day, or the end nodes, are called as leaves. They will be the output in this case, guys. That's why the name random forest algorithm. So how do you go on to pick data when you're working with random forests, right? If you are considering two samples here that we've represented by two colors, the red and the blue color that you can see, we have multiple columns, right? In the concept that we have called bagging, we compulsorily pick data from all the columns out there to train the machine learning algorithm and to teach it. As you can see, all the pink ones, everything is picked, blue ones, all the columns are picked. But in the case of random forest, what happens is that we do not pick up all the columns. We just randomly pick up, a couple of columns to actually go on to build decision trees and eventually get our, model to learn, right? So that is exactly what we are going to check out here. The advantage of random forest algorithm is that it works amazingly well for classification problems and regression problems, which we already checked out. But if your data is not clean, and if you're a person who doesn't like to clean data, again, it's a very hectic task. Guess what? With random forest algorithm, sometimes if your data has missing values, random forest algorithm has the capability to automate it and fill it with zeros, ones, or whatever it is that it thinks will not hurt for learning. So it can automate itself, learn and fill in data wherever it is missing automatically too. But then one disadvantage of random forest here is that it will require a lot of computation power if you are looking to build very complex trees and forests, guys. So that's an important thing that you should know about, right? So let's quickly check it out practically now. So with random forest, again, the first step is pretty simple. Import the libraries, import the data set, print the first 5 elements of the data set, right? Now, let me actually go on to print 10 instead of the first 5 because I want to show you something here. Right, now that you see the data, I have 3 tabs here, 3 columns: position, level and salary, which I think is self-explanatory, right? A junior consultant is a level 2 employee who gets an average salary somewhere around 50,000 rupees. A CEO is a person who's a level 10 employee, the maximum level you can obtain, and he gets a salary of somewhere around 10 lakhs per annum, per month, whatever basis, right? We're not concerned about the duration of this particular salary. But look at the growth with the level. A person who's a business analyst is a level 1, junior consultant level 2, senior consultant level 3, manager 4, country manager 5, region manager 6, senior partner 8, 9, 10, right? So what I will try to predict is the average salary of a person who has the level of somewhere around 6 or 6.5 based on all these data. Again, to do this, I only require 2 columns, level and salary. I do not require position, right? So I'm just going to remove the position column, use only the level and the salary here. Here I'm going to be using 10 different trees. As I told you, a random forest is based upon multiple trees. Here I'm going to be using 10 different trees. N estimator is equal to 10 means that I want 10 trees to create one forest, right? As soon as I go on to click this, the model has actually learned the creation of the forest is done. So the next thing we're going to do is predict the salary of a person who has level greater than 6.5. So instead of just telling you that in a verbal way or to show it to you in a number, I want to show it to you in a graph. Now here is a very beautiful visualization, guys. What is as you can see, the salary, I have it on the y-axis, the position, I have it on the x-axis. The position we're trying to find is 6.5, so it might be somewhere here. Right now, if I go to the left of that point, the salary is somewhere around 0.2. Hey, the salary we were checking out was in the thousands. What is this 0.2? Look at the legend on the top. It says 1E6. 1E6 literally means multiply that number, whatever you get on your salary, by 10 lakhs. 0.2 into 10 lakhs is what? 2 lakhs? 2 lakhs for a person who has an average salary of 6.5. Let's take a look. See, for a person who has a salary between 6 and 7, the average salary can be considered as 2 lakhs as well. This is what a machine learning algorithm learned and predicted for us. So when you have a result in a graph like this, which is very nice to look at, it adds a lot of value to your learning, guys. So this was the top 5 machine learning algorithms that you have to learn. Again, to reiterate, with data science, there is so much content online out there. Do not be overwhelmed. Take it slow, take it easy, talk to subject matter experts. I am a subject matter expert in data science, as you might might have figured out by now, if you do not use a structured way of learning, right, you definitely will quit because things can get complex if you're learning. Now, keeping all of this in mind, we put out these tutorials to make sure you get the right amount of knowledge, guys. As I told you, there's so many places where you can learn free content, especially here at Great Learning Academy, where you have access to 200 plus courses, multiple different languages taught by multiple different subject matter experts. You can learn for free, enroll for free, get a certificate of completion absolutely free by not paying us 1 rupee as well. So that's an important place that you have to be, that you definitely should check out. Then we have Great Learning YouTube channel and Great Learning blogs, where again we put out a wealth of different content. So it is very vital that you subscribe to the Great Learning YouTube channel and hit that bell icon so that you're in touch with the channel, and blogs for all of you readers who absolutely love reading. Right, guys, then if you're very serious about your education, if you want to become a complete expert in this domain, to get a job, to switch your career, whatever it is, right, make sure you take a look at the specialization and post-graduation offerings we have here at Great Learning. We have multiple PG programs, MTech program, MS programs, certification offering programs, which is done in collaboration with some of the most prestigious universities and Ivy League schools, around the world. So you will have subject matter experts, professors from these renowned universities teaching you as well. Texas MECOM, Northwestern University, Stanford, Great Lakes, PES, multiple different universities as well. So if you want to be handheld right from being a beginner all the way to becoming a complete expert in a domain, make sure you spend some time. Head to the greatlearning.in website to check out our specialization and post-graduation offerings. Right, guys, on that note, you have reached the end of this module. I'll see you on the next one. So now, guys, we're going to check out module number 5, which is probability. Now, as I've been mentioning for a while now, the concepts of statistics, the concepts of probability govern the entire world of data science in many cases. So it is very vital that you understand probability. Right, guys, so what are we going to learn in this particular module, right? So in this module, we're going to have a quick introduction to understand what probability is. Once you know what probability is, there is a very nice concept called as factorial in mathematics, which you will be using a lot if you're solving problems using probability. So we're going to check out a lot about factorial, understand how to calculate it manually in Python, and a lot of other things as well. Of course, now when you're taking a look at probability, right, again, this is a concept where we're going to be using a lot of data. Now, to go on to use data, you have to understand, okay, so what types of data are supported in the use of probability? We're going to discuss all of that as well. And of course, as I've been mentioning in the previous modules, randomness is something which is very important in data science, because if things are not random, then there comes a concept called as biasing, where your data is skewed because your result is skewed because your data is not random. That is not what we want here. So we're going to be checking out a lot of things there is to know about how we can create random data, how we can create managed data, and all of that. Again, we checked out some of these things when we were working with NumPy and Pandas in the previous modules, but now again we have to revisit certain things in the perspective of probability. So guys, we're going to be checking out theory, and again we're going to be checking out code to complement the theory learning as well. And at the end of it, we're going to be checking out some of the important probability functions that you definitely should pick up on if you're looking to become very serious in this career in this fantastic field of data science. Right, guys, now that we understand what we're going to learn in this particular module, let us actually begin. Now, when I say probability, when someone says introduction to probability, what is it that you already know? See, I want you to take a second, pause the video, and reflect upon what you already know about probability. Now, probability is a concept that I can 100% say that you have used in your life in one way or another. It may be a very simple thing, right? Think about you going to your favorite restaurant, and then you're waiting for your friend. This person may have a history of not turning up on time. So you'll be like, okay, so he probably might not come. Probably, right? The term that again is talking about if the person will come or not. Him coming or not is considered as an event, right? So let us understand what probability is. But before that, we need to align probability to data science. Now, probability is one of the most important things whenever we are discussing about machine learning, so it is very vital that you understand it in its entirety, right? Because machine learning algorithms, mathematical functions, all of these statistical modeling aspects which govern how we can create good machine learning models, they are working by using the concepts of probability itself. So it's very vital that you understand these. Without having probability, I get this question a lot saying, hey, can we go ahead with data science without using probability or without learning probability on at all? My answer to this will be a straight no, because in multiple cases, if you do not know probability, you will not know, multiple things on the intermediate level, as we'll be checking out in the next couple of modules, data analysis and all of those places. If you are not down with probability, well, at that moment in time, it's going to get really tough. So wherever you are learning, you're going to stop it, you're going to pause it, you're going to eventually learn probability and get back there. So why do you want to do this back and forth circus, which is going to add a lot of confusion to your learning? So make sure you're checking out probability while you are learning data science in a structured manner as well. Right. Now, one last thing I have to mention about probability in the real world usage scenario is that, especially if you're a person who's looking for a job in data science or you want to have a career in data science, right? This is a concept which you will be tested on a lot if you go to a data science interview. Now, a lot of hiring managers love to quiz you and ask you certain questions about probability to, in fact, see if you are familiar with the domain, to see how well of a knowledgeable person you are when it comes to these important foundational concepts, guys. So that is the reasons why you definitely should be looking towards probability as well. Right, guys. Moving on, what exactly is probability? What is this concept that is this important in the world of data science? First of all, again, as I mentioned at the start of this module, it's a concept in mathematics. Here what we're trying to do is we're trying to understand, we're trying to see if we can mathematically put out a number saying, hey, this is the percentage of probability that a person might turn up to your favorite restaurant. You having a bet with your friend saying, hey, there is a 40% chance that this team might win today, there's a 30% chance that that team might win today, right? Again, all of these are hypothetical examples, but yeah, this exactly is where you would have used probability in your real life. So if there is a question that gets answered using probability, it is this question: how likely is an event, how likely will something occur or something happen? Now, when that is the question, you can put forth a lot of things there, right? So how likely is it that it's going to rain here in Bengaluru right now? What is the probability that it will rain tomorrow? What is the possibility that I buy a Ferrari in the near future, right? So all these questions, everything you can put a number onto all of these things. What is the probability that you guys will become billionaires, all of us, that is the thing. So whenever you have a question like that, you can have a mathematical answer to it. And you might have thought saying, hey, it is not mathematically possible for me to be the world's richest person. If you work for it, well, you definitely can do it. And whilst you're working for it, you can use mathematics to prove the probability of you going there as well. That's the amazing bit about mathematics. But then, guys, as I've been mentioning, there are two important things which you always have to be concerned about. It is randomness and it is outcomes. See, randomness is very, very important probability, because if your data is not random, the result that you get is as good as not doing the process of probability finding itself, because that is how important data is. Unless it is random, you will find a biased result, which is as good as it being almost useless, is something I can tell, because biased data tends to give you incorrect outputs if you're looking for an unbiased answer, right? Now, a simple example is that that the sun goes up at 6 a.m., the sun goes down at 6 p.m. in many countries around the world. So if I say, hey, what is the probability that the sun is down at 10 p.m., the answer is going to be like 100%, right? The sun is definitely, on the other side of the world, lighting that up. So when you ask questions like this, when you get the correct answer is right. Now, there will be situations saying, okay, so what's the probability of the sun going down at 6 p.m. if the earth is just standing still, right? See, sometimes nonsensical stuff like this will occur. Again, this is again based on your data. It is your job as a person. Again, I'm giving a reference to pre-processing here. So if you do not pre-process your data, sometimes junk information like this and things which are not random, things which are outliers, things which are erroneous in nature will affect your eventual data a lot, saying that, hey, no, the sun is high up in the sky at 8 p.m. at night. Right? It doesn't make sense. Sun, 8 p.m. night, no. Right? Of course, there are some places where the sun is still up in the sky at 8 p.m. But a general example of the proposition saying that, the sun goes up at 6 a.m., the sun goes down at 6 p.m. I hope you understood this concept of why randomness is so important here. Now, once you understand what probability is, there are certain key terms that we're going to be using a lot, so you have to know all of these things. The first key term is the population. Population, as the name itself suggests, talks about every item, talks about every single entity that we are considering whenever we are doing a study of something, right? Now, what is the probability of students coming and attending class, right? In that particular case, if I say what is the population here, population is going to be all the students who are enrolled in that class, batch, semester, whatever it is. Next, look at sample. In sample, it's going to be a subset of the entire population. If the entire population is 100 school kids, a sample can be 1 school kid, 2, 3, 4, 5, all the way until 99. Now, if you say, can 100 out of 100 kids also be considered as a sample? Well, yes, but then eventually you would rather be better off calling it as population than a sample, right? A sample is a part of it. Think about literally using the word sample in English, right? So when you have a lot of things, you take a little bit of it and it's a sample, right? The exact same thing here as well. So every time, in the example that I gave, the kids example, 1 to 99 is okay to be considered a sample. 100 can also be considered, but no, that is not the standard procedure sometimes that we follow. So it's very vital that you understand that it is a subset. It is not one entity lower than the entire thing always, but in many cases that is so. Right, now you know what population means, now you know what sample means. We have to understand what event means. See, now event is this thing that we are trying to measure. It is the outcome that we are trying to see the probability of. Now, if I say what is the probability that it will rain today, raining today, that aspect of it itself is the event, because I want the probability of the entire thing. I want the outcome that whatever is expected from our study, right? Again, if you take about the example that I just gave regarding students, the event is actually students attending school. Be it 10 students, 100 students, a million students. Students attending school is an event. That is the thing that they're doing and we're trying to measure. That is event, ladies and gentlemen, right? So I hope you're clear with population, sample and event. Let's move on. Next, there's a concept called as the probability line. A probability line will talk about, what is the probability of an event occurring, how can you measure it in sort of numerical tense, right? Well, first of all, we have to discuss the two binary things. I mean, of course, 2 is binary. Like an event occurring versus an event not occurring. If the event does not occur at all, well, if I have a very bright sun, right outside, as you can see probably on the camera right now, the probability of it raining is 0. It will not rain. It is impossible, right? But what if it is super cloudy? There's black clouds and all of that. Yes, 100% certain that it is going to rain eventually now or in another half an hour or in 1 hour, right? So that's the left extreme and the right extreme. Impossible for it to rain and 100% chance that it will rain. In the middle also there are certain certain metrics out here, right? First of all, we say there's a 50-50 chance that something might happen. If it's a cricket match, if it's a football match and all of that, we say, hey, there's a 50% chance that he or she might score a goal, hit a run or whatever that is, right? So that's in the middle. To the middle of to the left of the middle as well, we have a chance called as unlikely. Between 0 and 0.5 in the probability scale, we say, okay, it might happen. There are certain light clouds in the sky right now, so it might rain. It is not surely that it will rain, or not even 50% sure that it will rain, but 30%, 40% it will rain. That is what we call as unlikely. Next, you have a 3 by 4 chance or a 75% chance that it will rain. Of course, if the sky is getting darker, you see dark clouds far away which are coming in your direction, you will say, okay, yeah, it mostly might rain. I'm not 100% sure, but I'm majorly sure that it might rain, right? Or I'm 75% sure that it will rain. So it is impossible, unlikely, 50% chance, 3 by 4 or 75% chance, and then 100% certainty that an event will occur. This is the probability line, ladies and gentlemen, right? Now, let us actually go on to take an example to understand the concept of probability, right? There's a question here in the example format. There are 8 balls in a bag, 3 red colored balls, 1 blue colored ball, and 4 yellow ones. What is the probability that you will pick a red? Now imagine that there is a sack. The sack contains all of these 8 balls that we're trying to discuss. You put in your hand randomly and you pull out 1 or 2 balls. Now, what is the probability that among these 8 balls, the first one that you pull out is a red, right? You can of course pull out a red on the first try. You can pull out the blue that is there. You can pull out a yellow and all of these things, right? So you have to ask these questions to go on to solve it in a simple way. First of all, how many red balls do we have? We have 3 red balls. How many blue balls do we have? 1. How many yellow balls do we have? 4. Which probability are we trying to find? What colored ball do we have to pick? Red, right? So again, think back to the first question. How many red balls? 3. Now, once you know how many red balls that you have to pick, what is the probability of the event occurring? The answer to it is the total, probability of you picking the event versus and divided by the total occurrences of the complete event at hand as well. So in that particular case, here we have 3. The total number of balls we have is 8. So the answer is 3 by 8. So you will be picking 3 out of 8 balls is what is the total answer here. Now, if you go on to calculate 3 by 8, you will get a decimal number. This decimal number will have to lie in between 0 and 1 itself, no matter what. So that will be your answer. And if you multiply it with 100, that will give you the percentage probability of you picking a red ball in this case, right? Now, let me quickly open up my calculator and actually tell you the percentage of probability. Now, if I do 3 by 8, ladies and gentlemen, the answer is 0.375. I will multiply this with 100 to convert 0.375 into a percentage. The answer is 37.5. This means that there is a 37.5% chances that, 37.5 times out of 100, I put my hand, I pick up a red ball. That is the example and that is the explanation, guys. I hope I was clear with this. Of course, you can pause this video, put down other numbers for, just change around the colors, change around the number of balls, and then see if you can actually go on to, come at an answer. If you head to the comment section right now and if you just put down your probability question and a valid answer to you, to it, we'll be more than happy. So make sure you guys are practicing practically as well. The next concept we have to discuss is event independence. See, if you are considering 2 events, right, usually a cause and effect relationship, in the case there is a dependency in between 2 things. Think about the cloud example that I just gave. If it is very cloudy, there's a chance that it might rain. First of all, the clouds gathering together itself is an event, and later the effect of this cause is that it rains, right? Pretty simple there. But there is a dependency between the clouds coming around and the rain falling. If there is no clouds at all, well, the rain magically won't fall out of nowhere, correct? There is a dependency between rain and cloud. But there are certain events where there is absolutely no dependency at all. What is the probability that I pick 2 balls on my way to work, and what is the probability that while coming back I sign an autograph and I come back? Now, can you find dependency between me picking a ball versus me signing an autograph? The answer is absolutely no. There is no dependency at all. These are 2 different things which are not in the consideration of a single scope, right? Again, that is an independent event. If one event occurs and it does not disturb or affect the outcome of another event, then it is called as an independent event. First event can do whatever it wants, the second thing can do whatever it wants. But if the first thing has an influence on the second one, or if the second thing has the first influence on the first one, then it is dependent. Make sure that you understand this concept thoroughly. Now again, let me give you an example, right? So let's say there's a bag. Again, there are 4 balls here, and when you pick up 2 balls out of this bag, right? Now if there are 4 balls, this is not an independent event. Why? Because the first ball you pick will mean that that ball is less in the sack right now. So the second ball you're picking is dependent on the first ball, right? Let's say there are only 2 balls in a sack right now. One is blue, one is red. If you pick up a blue one, it means that red is left. So the red is dependent on the blue. If you pick up the red first, then the blue is dependent on the red, right? So either whatever you pick on the second one will somehow be dependent on the first one in this particular case, right? Again, when you think about a pack of cards, if you just pick up 5 different cards, it will affect all the remaining cards that are present there as well, right? So that is a very simple toned down example of what event independence is, right guys? Now, once you understand event independence and all of these things, the introduction to probability, everything we have discussed right now, you have to, give some good time into understanding this concept called as probability. Now guys, after you understand independent events, after you understand what probability is, why we require it, why it's used, and a lot of examples later, you have to understand this very, very important concept. It's called as factorial. Now, factorial is a term which you might have heard way back in school. You might have used it, you might have calculated it maybe in your pre-university, 10th grade, 11th grade and all of that, and then you just chucked it out the bin because you wouldn't require to use it later on, right? But let me tell you, this factorial is a very important concept for probability and for data science in whole as well. So what is probability? Well, probability is actually defined as the product of all the numbers, all the ordered numbers in a given range, right? In this particular case, when you say, can I have the factorial of numbers in between 52 and 55 as a single entity? The answer there is no. See, factorial starts from a valid range of ordered numbers. Now, if I say what is 5 factorial, it's a simple way to calculate it. It is 1 into 2 into 3 into 4 into 5, or the opposite will work as well, 5 into 4 into 3 into 2 into 1. The answer again there is 120, of course. And the definition and how factorial is denoted is by having a number and an exclamatory sign next to it. So if I say 10 exclamation, it means 10 factorial. And how do you calculate 10 factorial? 10 into 9 into 8 into 7, all the way until you reach 1. Now guys, on your screen right now, I have put out the value of 5 factorial and how you should find it. You guys take a second to find 8 factorial for me. Now 8 factorial is going to be a huge number, so let's both head to the calculator to do 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 will still have the exact same result because anything multiplied with 1 is 1. So what is the answer that you guys got? You were supposed to get 40,320. That is the answer to 8 factorial, right? So it's a very, very simple thing. All of these basic factorials you have to know. What is 2 factorial? 2 into 1 is 2. What is 3 factorial? 3 into 2 into 1 is 6, right? So what is 4 factorial? 4 into 3 into 2. What is 4 into 3 into 2? 24, right? So it is something similar to all of these things. You have to have a basic understanding of all of these. Now, well and good, you can calculate the factorial of anything. If I ask you the factorial of 5,000, you're going to do 5,000 into 4,999, 4,998. You're going to bring it all down to 1 and you will have a huge number. How do you calculate this in Python, right? If you have to manually calculate the factorial of 500, let's say even 100, it's a very huge task. So to make things simple for you, in Python, there is a function called as factorial. This function is available in the math module and it's a beautiful function to use. It is literally one line and it does wonders. So if we say print math.factorial of 6, the answer is just 720. You are just sending a parameter saying, hey, here's 6, find me the factorial of it. It will calculate it within a couple of milliseconds and you have it, right? So what is 6 factorial? 6 into 5 into 4 into 3 into 1. It is 720. Now a shortcut here, if you already know 5 factorial is 120, 120 into 6 is 720, right? So that is one thing that you guys can definitely use for as well. All right, next up, once we check out how we can work with, again, we're going to check that out all practically as well. So just I want to cover the theory first so that we are down, and then we can head to Google Colab to check out the theory. And then we can head to Google Colab to check out the practicals. Right, guys. So next up, we need to check out the types of data that govern the probability. Now, I have already discussed this in the previous module, but still, let us actually throw back and understand what are the types of data that exist, right? There's multiple types of data, which are of course present, but with probability you have to be careful. See, first of all, there's categorical data. Categorical data means there is, an answer which is either in the form of a sentence or a string, right? Now, if I ask you what is your eye color, you will not say my eye color is 41. You will say my eye color is blue, green, hazel, brown, black, all of those things, right? So those are not numbers, they are strings, they are characters, right? If I ask you what is your marital status, are you married, are you unmarried, are you divorced, all of these things, right? So those are not numbers again. These are categorical data. Then we have continuous data. See, in continuous data, what happens is it's a number which you can track and change and measure in a continuous fashion. For example, your weight. As you grow old and old, right, when you were probably a toddler, you weighed a lot less than what you weigh right now, right? And then it continuously and gradually went up and up and up. Even voltage is a continuous measure, right? If you've seen those AC and DC current curves, the voltage curve that you might have studied during school or college or anything, you realize that it's a continuous nice shape that goes on, right? That is continuous because you can map every single point of it and find a relationship between each of these points. That is continuous data. Now, for probability, we're going to be using discrete data. Discrete data is something which is not continuous in nature, of course, and this is another number, a metric that you can measure. For example, the number of children in your house. 5, 6, 3, 2, 1, whatever it is, right? You can measure it. This kind of a numerical measure, the discrete measure is very, very popular for the case of probability. So we're going to be considering a lot of discrete data moving on, because this is the primary type of data which we consider for the concept of statistics in many cases, of course. For statistics as well, we're going to be picking up categorical and continuous, but for probability, discrete data is what we're going to be using. Right. Next, we have to check out this concept called as data distribution. See, data distribution and understanding data distribution in probability happens in two ways. It's called as frequency distribution and it's called as probability distribution. First of all, when I say frequency, what is the meaning of it? The number of times an event will occur is called as frequency, ladies and gentlemen. So, if I am riding my cycle 4 or 5 times on my same street, the frequency of me crossing my street is 5. That's because I'm doing it continuously, right? That's the number of times I am doing an event of crossing my street. Whenever you might have heard of frequency, you might have heard of this term, this SI unit called as hertz. 60 hertz, 50 hertz. For all the gamers in the house will know 60 FPS, frames per second, 60 hertz, 120 hertz, 144 hertz, 250 hertz, and all of these, right? So that's a measure of how many times your screen is refreshing every single second, right? FPS means frames per second. Now that's a very simple concept to tell you about frequency. Next, we're going to check out frequency distribution. The concept is very simple. Frequency distribution is basically having a measure where we're trying to find out how often does an event occur. Now, first of all, we know I roam around the same street 5 times. How often am I, doing this? Once a day, twice a day, thrice a day, 5 times, 10 times a day. That is frequency distribution. How many times am I doing the same event again and again? It's a measure of that. That is frequency distribution. Next, we have probability distribution. See, probability distribution is a little different in a way where we're trying to see, hey, what is the probability that an event will occur? What is the probability that an event will happen or not at all? Now, the first thing, frequency distribution, it talks about how many times I roam around the street. Probability distribution talks about saying if I will ever roam around the street or not. That is the basic difference, guys. One is talking about how often an event occurs. The second one is talking about if the event will occur or not. If it does, well, what is the measure of it, or what is the probability of it? Simple, right? Beautiful. This is frequency distribution and probability distribution, guys. The next concept we have to check out in Python, in the concept of probability itself, is randomness. Now, as I've been telling you, randomness is very important, because at the end of the day, it has the complete capability to govern your entire output. It can majorly affect your output, and if your data is not random where it's supposed to be random, it is going to cause a lot of havoc, guys. That's a very important point you definitely should know. And as I've been telling, biasing is when your data is not random and you can map tiny relationships. Now, if you can find a relationship in between data, there's a good chance that the data is not random, because if it was random, as the basic definition of random itself stands, you cannot do anything with it. It is just there. You cannot find a relationship. That is what we want here as well, right? But if the data is not random, it means it can be skewed or biased. If the data is skewed or biased, it will mess with the output again. So what is your takeaway here? Make sure that whenever you're working on practical problems, whenever you have data at hand, that it is shuffled well, that you are aware that there is a sense of randomness at work always, because if your data is not random, your results are messed up, guys. I've been highlighting it for the third or the fourth time now, because it is literally that important, right? Now, when we go on to talk about Python, how can we assess randomness in Python? How can we calculate something which is random in nature in Python, right? First of all, let's ask this question. How can we pick a random string from a list, where we want to maybe, we have a population, we want to pick up a sample set or something like that. Now, this is easily done by having a module called as the random module. Python, again, right, it's being extremely convenient in giving us a module for everything that we want to do. Here again, to pick up data randomly, we have a module called as the random module. Here, as you can see, I just have 3 lines of code. One, we are importing the actual module. The second line is basically a list of all the places that I would love to tour around, and of course not right now during the pandemic, maybe after the pandemic ends. Australia, United Kingdom, USA, Amsterdam, Swiss Alps, Rome, Singapore. These are individual entities in a list, and this list is called as travel plans. Right now I have it in an order: Australia, UK, USA. From left to right there is an order, from right to left there is an order, correct? Now, if I print that statement saying choice of travel plans, it's basically jumbling up the output every time I execute that piece of code. Yes, if it just jumbles it once, and if it prints the same thing again and again, it's not random. Every time I run it, it has to change something there. Of course, there is a good chance that 2 out of 3 times, something might repeat from the last time. That's okay, right? But if I have the exact same thing, it's not random. No, every time I execute this piece of code, that choice function, in the random module is going to make sure that your output is completely shuffled every single time you execute it, right? Again, we're going to check out all of these practically as well. Now, let's say we want to create certain random data, and in this particular case, we're going to take the random data and we're going to have an output shape. We have already worked this out in the NumPy and Pandas module, but here, let's say we have some random data that we want to replace everything with another data, right? It's pretty simple. We can replace all the even numbers that are present with 10. This is another example that we checked out previously. We have the random function, rand_sample will eventually create the random values, fill it in a 4x4 array, and we're printing it. So it's literally using NumPy and having a one-liner output which will guide how we can create random data, right? Now, if you had a thought in your mind saying, do we have to write 20 lines of code to create some random data, add it to a list, or even reshape it as per our requirement? I hope this answers your question. So guys, before we check out probability functions in detail, here is a very important slide that I want you guys to check out, because at the end of the day, probability functions, of course, we're going to deal with it later, but for now, you have to create a probability function in Python itself, right? Now, this is not the probability types of probability functions, but this is an actual function, a user-defined function that we're going to check out, right? As you can see, there's a simple 2 or 3 lines of code. First of all, we're importing fractions. If you're working with fractions a lot, in the case of probability, we can import this this module. Next, what we're trying to do here is we're trying to find, we're defining a function called probability. What is the event at hand? What is the sample space? Then we're trying to find and return the fraction. We're trying to find the fraction of, in the numerator we have the length of event and sample, and of course in the denominator we have the length of just the sample, guys. So it's an important thing you will understand very much as soon as we go on to check all of this out practically. So let me quickly move on to Google Colab. Google Colab is again the Jupyter notebook that we've been using all this while. So let me quickly connect to the runtime. Let me zoom in so all of you guys can see, and we will check out some important concepts. Again, in the module of statistics, we checked out a lot of things, theoretically, but since you did not have an introduction to Python, then we're going to check out one or two things in Python as well. So guys, whenever you're concentrating on mean, median and mode in the concepts of statistics, right, in Python, it's very easy. You have a statistics module about how you can do all of these things. Statistics.mean, and if you pass a list, it's going to calculate the mean. The statistics of median, if you have data in an arranged way, it's going to give you the middle elements. Then you have the mode, the most number of times an element to get executed, right? Let me run this and see if this line runs or not. Yes, as you can see, the average, right, 1 plus 2 plus 3 plus 4 plus 5 plus 6 by 6 is 3.5. Then the median is the middle element, 3 plus 4 by 2. Then you have the mode is 6, right, 6 comma 6. Now I've put in a comment saying this line does not work. Why? Well, if I remove another extra 6, now the mode becomes, there are no repeated elements, right? Now you will have an error at the last line saying, hey, there are no two elements which are repeated. Everything is unique. That is the reason why, you will have it. Again, if I just add anything that I want, maybe I want another 1, right? If I put a 1 anywhere I want and I run it, the code will run absolutely fine. The mode will be 1 now. Perfect, right? Next up, calculating the standard deviation. Again, we have all of these values. These are all lists. To calculate the standard deviation, statistics.stdev is the function that you're going to use. The standard deviation here can be seen as 2.58. It shows the square of how the data moves around from the mean as well. Again, let me quickly zoom in a little more so that you guys can view it fine. So what if we can try to find the mean, or let's say the median of an empty element, right? Hello is an empty list. As soon as I go on to print it, it's going to give us a fancy error saying, hey, what are you trying to do? There's no input. What can I find the mean of, right? But if I just put in 1, 2, the answer should be 1.5 here. Perfect, right? But if you pass an empty data to it, it will not work. Now guys, coming to the factorial aspect of it, right? And I told you we're going to be checking out practically. First of all, you have to import the math module. Once the math module is done, we're going to take an input from the user and say, hey, enter the value of n for which you want the factorial answer. And then we're using the factorial function from the math module, math.factorial of integer n. This is basically the integer that the user is going to input, right? Now let's say we want 5 factorial. If I hit 5 and enter, the answer is 120. That's 5 factorial. Let me run it again. Now I want the answer of 8 factorial, which we already calculated manually, right? What is 8 factorial, ladies and gentlemen? As soon as I hit enter, it's going to give me 40,320, which again we calculate correctly. But what if there's a huge number that you want to find out the the value of? What is the factorial of 600? Well, look at the size of this number. I am scrolling. That is 600 factorial, ladies and gentlemen. That's how complex things can get. This is something that you wouldn't want to do on your calculator as well, right? Next up, we spoke about randomness, right? See, I told you that there's a module called random in Python that you can use. Again, we're using the choice function here, Australia, UK, USA, all of these things that we already spoke about. If I go on to run this, it's going to just pick up one random element and give it to me. If I run it again, it's going to give me another random element. I run it again, another random element. Again, another random, again, random, right? So every time I want to pick up a random sample from a population, I would use the choice function, which is present in the random module, right? Perfect. Next up, we're going to be working with random sample data with a customized reshaped output. So as soon as I go on to run this, it will throw in random data and it is going to fill it in for us in a 4x4 matrix. If I run it again, the data will not be the same. It's basically from a range of 0 to 1 and it can fill any value it wants from this range. Now let's say 4x4 matrix is way too much to look at, so I just want a 3x3 matrix. I just change the output shape and as you can see, it's giving me a 3x3 matrix output here, right? Pretty simple to deal with. It's again one line of code for the actual logic, one to import NumPy and one to print it. You can just do all of these things in just one single line, but to make sure you guys have clarity, I just split it down into 3 lines. The next thing, guys, before we head back to the presentation, we have to check is working with fractions, right? Now, this is something that we defined a probability function previously, but we just saw how we can import the fraction function, but here we'll check it out practically, right? Now, there's a module called as fractions. From fractions, we're going to be importing another submodule, function called as fractions, and we're going to be using f because we do not want to write fraction everywhere. So here, if you can see, it says f of 2, 5, f of 1, 4. So what we're trying to do is we're trying to say that, hey, this number is 2 by 5, this is 1 by 4, this is 8 by 3, this is 1 by 6. F of 8, 3 means 8 divided by 3, in this particular case, right? As soon as I go on to print it, we're trying to find the mean of 2 by 5, 1 by 4, 8 by 3, and 1 by 6. So it has to add all of these things, do a fractional addition, and eventually calculate it divided by the total number of elements. In this case it's 4, and give us an output, right? So you can see the entire output in terms of fraction is 209 by 240. Perfect, guys. Let's get back to our deck. Next, we're going to be checking out some examples so that you guys understand, the concepts of probability. Very, very popular examples, very important for you to understand. The first concept we're going to be checking out is how we can roll a die or dice as it's called, right? I'm sure whatever you're seeing on your screen, you've used this to play board games in your childhood, or maybe, when you were a kid, or in fact, even I know that, I've had a lot of college friends, a lot of juniors, sub-juniors, all of these people during the lockdown, they wanted to play this game called Ludo, again, which was apparently, it got very popular, right? So again, they roll a dice because, see, every time you roll a dice, you get a number between 1 to 6 if you just roll one die. And if you roll 2 dice, you get a number from 1 to 12, and it can be anything, right? It is random. It depends on how hard you shuffle and, you roll the die. So when we say a fair die, it means that every single face is just one number. 1, 2, 3, 4, 5, 6. That's a die, right? If you have an unfair die, it means that there can be 6 on 3 sides, and every time you roll, well, you can get a 6 way more than all the other things, right? So a fair die will have numbers between 1 to 6, guys. This is a very, very, very common problem which is used in making sure that you guys understand probability in a simple fashion. Right, now let us take an example of it. What is the probability of rolling an odd number on a fair die? Here we're talking about one die. See, we never told 2 dice, so our range is only 1 to 6, right? So, what is the population here? 1, 2, 3, 4, 5, 6. We have to get a number in that range and nothing else if we just roll one fair die, right? So our question says, what is the probability of us rolling an odd number? How many odd numbers are there in between 1 and 6, including 1 and 6? 1, 3, 5. There are 3 odd numbers, correct? But how many numbers do we have in total for our consideration? 6. So the probability of finding an odd number, rolling an odd number is 3 divided by 6, or 1 by 2, or 0.5. So every time every 2 times you roll, there's a good chance that one of these times you will occur and land on an odd number. How beautiful is that, right? The answer is exactly the same if you say how many, what is the probability of rolling an even number. How many even numbers are there between 1 and 6? 2, 4, 6. The answer again is 3 by 6. So the probability of landing an odd number and an even number is equal in the case of a fair die. Right. Now, how can we do all of this in Python, right? Now, as you can see, we discussed this previously as an aspect of having a function which does, take in an event, take in the total sample and finding a fraction for us. So this fraction will consist of a numerator value and a denominator value. The numerator value will be the length of the event and the sample space in total of what we're discussing, and the denominator will just be the sample space, right? So in this case, we have a data type and it's called die. Die has 1 2 3 4 5 6. Then we have another data type here. The name of it is odd. Odd numbers are 1 3 5. As soon as I pass it to the probability function saying, hey, here is odd comma die, here are the values of odd and die, it's going to give us a probability of how many odd numbers, what is the probability of picking up an odd number in a case of a die as well. Guys, we're going to check this out practically, but before we do that, there is another very popular example that you have to check out. It's called flipping a coin. Now, for all of you all who watch a lot of sports, cricket, badminton, football and all of these sports, usually starting there's a toss that happens. A toss happens while they flip a coin, and a coin has two sides. So, one of the people pick one side, and if it lands on their side, they win. Something like that, right? It is again random, but it only has two outcomes. In the case of a fair coin, it will have heads and tails or whatever it is, right? Both of the sides will not be the same or similar to each other. Now, this is a very, very popular problem if you're trying to understand what binary outcomes are. In the case of a binary outcome, it means heads or tails, ones or zeros, or there is a red color on one side, green color on the other. All of these things which are very different to each other, right? That's the binary outcome of it. As I mentioned, a fair coin means that it is completely unbiased. So if there are two different outcomes and if there are two total samples in consideration, what is the probability of getting heads? There's only one head you can get, and if your coin can land two times in two different ways, the answer is 1 by 2, right? You can get either a head or either a tail. You cannot get anything else. You cannot have half a coin, or you cannot have an uneven the coin standing like this instead of heads or tails, right? That can happen, but that is an invalid answer. That's an outlier that which we won't consider. In the mathematical aspect of things, it's just very simple: heads or tails, 0 or 1. Simple, guys. So there's only two outcomes in the case of having and flipping a fair coin. But here the next concept we're going to be checking out is a deck of cards. Now, a card deck is a concept which you definitely have to know about if you're looking towards probability, because here, right from the beginner problems all the way to the most extensive complex questions can be asked for you to find the probability, and it can get challenging, and there's a good chance that, if you're not prepared or if you do not know the concept of probability, that you can get things wrong as well, right? So let's take a pack of cards. A pack of cards, a fair pack of cards. You see how I'm using the word fair every time, because I'm making sure that, the deck is actually fair. So if you are picking up a pack of fair playing cards, there will be 52 cards in total. In these 52 cards, it is divided into 4 suits, as you can see on your screen right now. You have the hearts, you have the spade, you have the clubs, and you have the diamonds, right? Now, I've played a lot of blackjack and poker, so I do know these cards by heart. What are all the cards associated, right? So every time there's a suit is usually associated with a number. So all of these numbers, right, it goes from A all the way to J, K, Q, in the between there's 2, 3, 4, 5, 6, 7, 8, 9. So when you divide 52 by 4, right, what is the answer that you get? That is 26. 26 divided by 2 again is 13. So you have 13 diamond cards, 13 heart cards, 13 club cards, and 13 spade cards as well, right? So each of these cards gets a suit and a number as well. In our case of probability, right, in some games that you play with cards, you consider the joker card as well. Here the joker card is not at all valid because we do not use it. 52 cards are just 52 playing cards. The 53rd card, which is the joker, is not something that we are going to use. Let's take an example to understand this. Now if I say, what is the probability that I can pick a king or a queen from a deck? Now there are 52 cards in front of you. What is the probability that I pick a king or a queen card, right? To know this, first of all, you have to find out what are the total number of kings present and queens present. Each suit has a king and a queen. If there are 4 suits, it means that there are 4 kings and 4 queens, right? Now, I am saying what is the probability of picking up a queen or a king. So I can either pick this or that. So we have to consider both here, right? So there are 4 queens, there are 4 kings. So it means that my consideration is based upon 8 cards. Nice. What is the total number of cards? 52? The answer is 8 by 52, which is 2 by 13. Now again, if I go on to manually calculate 2 by 13 here, right? 2 divided by 13 is going to give us the answer 0.1538. If I multiply it with 100 because I want a percentage answer, it is 15.38%. So the probability of me picking up a queen or a king from a fair pack of playing cards is the answer, which is 15.38%. So for every 100 times you pick up, out of which there's a good chance that 15 of these will be a queen or a king card. Right, guys, now that you understand these deck of cards, you have to understand one important thing called as mutually exclusive events. This is a concept which is very, very important for you guys to know. Now, whenever we go on to say an event is mutually exclusive, it means that when one event occurs, the other will not occur. Let me take you back to the cloud example. If there are very dark clouds, there's a good chance I cannot see the sun, right? Of course, you will have small amount of light, but you cannot see the entire sun in its midday brightness. That is a mutually exclusive event. The cloud cover will make sure that the sun rays won't hit us here on the Earth's surface, right? So that's a mutually exclusive event. Even in a very simple coin flip example, so when you flip a fair coin, you will either get heads or tails. You cannot get both. You cannot flip a coin and say, hey, here is tails and here is also heads in the same flip. No, you can flip it twice and there's a good chance you can get heads and tails, tails and heads and all of that. But one flip will not give you both tails and heads. It will only give you one of those outcomes, right? So that's a mutually exclusive event. The occurrence of tails will totally bar and discard the occurrence of heads. At first, if you get a heads, it means that tails is absolutely out of the question because you just had a heads in your hand, correct? These are mutually exclusive events. And now guys, so all these things that we checked out, let us quickly run through a couple of pieces of code so you have the practical knowledge of how we can go on to work with all of these as well. Now let me just minimize the first section, open up the second section here. Perfect. Now as we already discussed, how can we go on to create a simple probability function? We have the probability, we have the event in discussion and sample. Totally as we go on to find the length of how many ever events we have in mind divided by the total sample space at hand will give us probability. Right? So as soon as I run this, our probability function is fixed. Next, I want to find out the probability of rolling an odd number on a fair die. A die consists of 1, 2, 3, 4, 5, 6 numbers. Then you have the odd numbers, which are 1, 3 and 5. So as soon as I go on to run this, it should say the answer is fraction of 1 by 2 or the answer is 0.5. Now if you want to find for even numbers also, it is possible, right? So what are the even numbers that are present? 2, 4 and 6. The answer will still remain the same. If I put this as even, what is the probability of finding even numbers here, right? As soon as I go on to run this, the answer is still going to be 1 by 2. Perfect. Right, ladies and gentlemen, next up we'll be checking out the coin flip example. First of all, we're going to import the library NumPy, which we already did. So what is the probability in a coin flip? No matter what, it is always going to be heads or tails. So the sample probability is 0.5. It's either this or that, 1 by 2, right? Perfect. Next up, we are going to, how many times do you want to flip the same coin again and again? In this case, let us do it 10 times or 10,000 times if you want it as well. So to go on to store all of these flip data, how many times we flip the data, we'll actually create an array, call it as flip data. We're going to give it a range from 0 to 10. So 0 to 9 is what the data that is going to be stored here. A range talks about that. Then we have a method. Here we are actually talking about a coin flip method where you're trying to pass the value of probability. defined coin flip of 0.5. 0.5 is our probability, right? So we're using a binomial distribution here because we know the answer is a binary outcome, 0 or 1, heads or tails, right? So as again, we're randomizing this and eventually we're giving out a result saying what is the probability of occurrence of that event. The next thing we have to check out is how many times the coin is flipped, right? So we already told that, hey, I want the coin to be flipped 10 times, but we have to here make sure the coin gets flipped 10 times. So we use a for loop to make sure that our flip data gets added one by one with the probability of us doing it. So simple 3 lines or 2 lines in the for loop logic is going to get that done for us. And lastly, as soon as I go on to print a result that says, hey, if it's a fair coin, the probability is 0.5. The number of tails that I got while flipping the coin 10 times is these many tails. Heads is denoted by 1, tails is denoted by 0. So if the coin was flipped 10 times, the number of heads given were 5, the number of tails we obtained were 5 as well. So how cool is this, right? So see, this is 4 lines, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. So whenever someone says, hey, implementing probability in Python is very difficult, do not listen to them. It all took just 12 lines for us to go on to, find the probability of flipping a coin. We checked out the probability of how one can go on to roll a die as well, right? Now, when you're thinking about the probability of understanding these card problems, things can get very, very complex real quick. That's the reason we just discussed 2 of them, right, guys? Now, next up, the last concept we are going to be checking out in this module is probability functions. Probability functions, there are 2 important types that you have to know. It is discrete probability function and continuous probability function. You already know what discrete means. You already know what continuous means, right? Pause the video quickly. Think about an example for discrete values. Think about an example for continuous values. Right, I hope you did that. Now, moving on, what is discrete probability functions? Well, first of all, you have to know that discrete probability functions and the other name it has, probability mass functions, PMF, is literally the same. Discrete probability functions and probability mass functions are the same, guys, because there's a reason it's called discrete. First of all, one, because there is no outcome in between each of these numerical values. The data is not continuous, hence the name discrete function, right? I'll give you 2 examples if you didn't think of any. What is the probability of you picking 1 book from 10 books out there, right? You cannot pick 2.5 books. You can say, hey, I picked 2.5 books where 1 book was broken in half. That is not a valid case that we are trying to discuss. What is the probability of picking a full book from a set of 10 books? 2 by 10, correct? 1 by 5, perfectly. But you cannot say I am picking 2.75 books from here. You probably can, but in this example, you cannot, right? Perfect. Next up is tossing a coin. As I told you, you cannot half toss a coin. You cannot expect to have both heads and tails in the example, in the outcome as well, right? So that's another discrete probability functions example. Now, there are 3 types of discrete probability functions. There's uniform distribution, there's Poisson's distribution, and there's binomial distribution. Binomial distribution is something which you already checked out. Binary data, flip data, 0, 1, heads, tails, true, false, all of these things. Poisson's distribution talks about the example where I gave you where, how can you count the number of books from a total amount of or a total sample of books, right? That is Poisson's distribution, a quick example of it. Next, you have uniform distribution. Uniform distribution talks about, what is the occurrence of an event where the probability might be the same, right? So you have multiple events where you can have the same probability. Think about rolling a die, right? So what is the probability of getting a 1? It is 1 by 6. What is the probability of getting a 2? 1 by 6. What is the probability of you rolling a 5 on a dice? 1 by 6, right? So this is where uniform distribution comes into the picture. Again, these concepts get very, very complex really quickly. But if you know these distributions, to a certain amount of expertise, it is good enough, guys. Right. Next, we're going to talk about the continuous probability functions. Continuous probability functions are also called as PDFs. Again, not the PDF that we use as a document here. It's called as the probability density function. Since the name says continuous probability function, the data and the outcome will vary on a numerical scale, on a continuous scale, right? Think about measuring the temperature in your room right now. Think about picking people based upon their height. Again, people grow from their infancy to old age in a way, right? They grow and maybe due to old age, the graph might come a little down, whatever that is. It's continuous in nature, right? So that is continuous probability function. Next, there are a couple of types of probability functions, continuous probability functions. You have the Gaussian distribution, you have the Weibull distribution, and you have the log normal distribution. Log normal distribution is the example that I've been quoting from a while right now, right? What is the probability, or what is the amount of rain that will occur? What is the amount of rainfall in an area? To calculate all of that, there's a type of distribution which is very popular for it. It's called as the log normal distribution. Next, you have the Weibull distribution. The Weibull distribution is very popular if your data is not random, it is skewed in one way or another. Then you have the Gaussian distribution. You'll be using Gaussian distribution for its famous bell curve, or the normal distribution curve that you might have seen. If your data pertains to that curve, you will be using the Gaussian distribution function as well, guys. Right, so with this, guys, you have come to the end of this particular module. I'll be seeing you on the next one. Make sure that until whatever you have learned in this particular module, all the examples that we checked out, throwing a fair die, flipping a coin, all these card examples that we checked out, we defined a probability function, we used all these probability tiny stuff that we calculated in Python as well. Make sure that you are taking a note of all of these. Again, as you can see that you're closer to the halfway point in this particular video, so it is very vital that you understand all these foundations, which are very, very important going ahead, guys. So make sure you always have a pen and paper. That's what I'm telling you, guys. For every module, have a pen and paper, note down all the important things that I'm telling you, and it will help you all immensely. So right, guys, see you in the next module. Alright, guys, so welcome to module number 6 on this data science full course, where we are going to check out database technologies. Now, ladies and gentlemen, this is a very important module with a good amount of theory that you have to know, because with data science, you're going to be working with a lot of data, as you might have seen in the previous modules. So it makes sense that you get an introduction and understanding about how one can go on to store data, how one can go on to work with it, manipulate it, delete it, and of course, find out what are the methodologies that are present for us to do it, right? Now, see, database technologies, again, are another dimension here, because at the end of the day, here is where a lot of things don't remain static. Now, what I mean by that is, today you work on a technology and you sleep. Tomorrow you wake up and you realize that that entire technology is superseded by something else, and you will have to learn that, scale yourself to that, and understand certain fundamental ways of how things work as well. Now, keeping that in mind, I wanted to teach you guys about this in module number 6, because it is very, very important for the modules up ahead as well. So right, guys, what are we going to learn in this particular module, which is database technologies? First of all, we'll get an introduction to what databases are, how they work, and why they work the way they do. Why should we go on to use databases for data science? And of course, at the end of the day, two important types of databases, which are the most foundational concepts. We are going to check that out. After which, we can take a quick introduction to understand SQL. Guys, if you know what SQL is, head to the comment section and let me know the abbreviation of it. Of course, we're going to discuss this. And then we are going to take a look at a couple of points of very, very important distinctions that exist between SQL and something called NoSQL. Guys, we're going to check out all of this to a fair bit of detail. Now, to talk about introduction to databases, just go back to your school days or college days, because in the curriculum that I was a part of, I keenly remember having this subject called as DBMS, or Database Management Systems, where we actually had to work with databases to store new data, to query it and bring out some data, manipulate it, delete it, so many different things. So, was this included in your curriculum, guys? Head to the comment section and let me know. If not, do not worry, we're going to check out what they are. But even before I tell you what databases are, can you quickly think about a definition in your mind right now, what you think a database would mean, right? Again, to reiterate on the same concept which we are trying to focus so much on here, is that data is the heart of data science. We are living in a world where we're generating a ton of data every single day, 22 lakh terabytes worth of data every single day, right? Now just imagine if you're in a position where you have to store all of this single-handedly, work with it, manipulate it, keep it ready for the next steps of the data analytics pipeline or whatever it is, right? Of course, you'll have a point saying, yes, of course, all of this data is not handled by one person. It's the entire globe. It can all be handled with the powerful amount of processing we have today. All fair points, but at the end of the day, what our primary requirement as data scientists is to make sure that our data is ready in the pipeline if I want my machine learning algorithm to access it. That is it at the end of the day. Right now, to store data in multiple different ways, all of that is a category, a part of what a data engineer does. And of course, a data engineer's role is vital in data science as well. But this is a problem which was thought to be a problem, but fortunately nowadays we know how to handle all of this, so we are good. There are many efficient ways of how one can store data, but of course we need people who are efficient in handling all of this efficient data, right? I hope you get my point there. So it becomes very vital that you as a person, as a data scientist or a data science professional, understands the importance of databases and knows how you can go on to work with all of it, guys. So to give you a better understanding of what a database would be, let me simplify it down. A database is basically a term we give when we want to store data in a structured manner. Now, a database can also be data stored in an unstructured manner, but if you do not have a structured way of accessing it, reviving the data that you have stored, or processing the data in the database itself, then it is not counted as a database, right? The entire point of, think about your book rack, think about your, probably your wardrobe or whatever it is, right? You arrange your clothes in a fashion. Maybe it's all the casual wear on one side, all the luxury stuff on the other side, the winter wear on one side, all of these things. You split it out. You categorize all of this data, right? Here again, that is how data is stored in a database, in categories, in simple forms, where each data is related to another. If you go back to your wardrobe example again, you might have a favorite pair of jeans that really go well with a shirt, right? Now, I am a fan of black colored shirts for some reason. I have designated jeans pants that go with it, right? So there is a linkage that I have in between those data, right? So in an actual database, that is actually what happens as well. If your data is related, again, we're going to check out all of these in the upcoming sessions, but at this moment in time, you have to know that even though data might be pushed or shoved into a database in an unorganized fashion, if and when required for you to pull out the data, it has to be accessible. And an important thing that you have to think about whenever you're thinking about databases, how secure is all of my data sitting at one place, right? Now, there's a good chance that your database is not a centralized repository where you just dump in all the data, bring it all together. But even if that is the case, you should have an immense amount of security procedures, firewalls, and whatnot to make sure that your data is safe, right? Of course, this is if you are looking towards a local environment where you have the database physically at office. But there are certain cases where, databases can be on the cloud as well. Now, when they are on the cloud, what usually happens is it is the headache of the cloud provider to make sure that your data is safe. Of course, he or she will be charging you a sufficient amount considering all of these things. But at the end of the day, your data is at the mercy of their hands, and you would trust your data with them based upon their repo, based upon how well they are. For example, there are big guys with whom you can trust your data, right? You have AWS, you have Azure, you have GCP, you have the IBM cloud and whatnot. So it becomes very vital that you understand databases are not only popular in local offerings, but even in cloud computing, especially cloud computing today, that at the time of the recording of this particular video, the majority of world is still working remotely due to the COVID-19 pandemic, right? So it becomes very vital that you know that point. Then moving on to the next thing is how one would go on to interact with a database, right? See, a database is a place where you store the data. Amazing. But what are the things that you want to do with the data? See, for example, you have to access the stored data, right? If you have a wardrobe, you don't just dump clothes in it, lock it up and throw the key outside. No, you have the key at hand. So whenever you want to access the data, it is possible. Next, the same example holds when you want to manipulate the data, right? Now, let's say there's an entry or there's something wrong with one or two aspects of data. Now, for example, if I ask you what is your blood group, you might say, hey, my blood group is O positive. But there so happens in many cases that your data is not up to the mark, or it is not cleaned, it is not pre-processed in a way where the blood group column might have a phone number randomly, right? A phone number for a blood group it doesn't make sense. Exactly my point here. So you have to have the capability to change once you have stored the data. It's not only this, sometimes you might have erroneous data, data which is extra, something which you would not need. So you will have to delete this, reprocess it, and use it based upon the situation. So then and there, you must have the capability to drop, that's a keyword here in databases, or delete, which basically sort of mean the same thing, to delete all the data. The next thing you'll be doing is having the capability to not just delete it and redo things again, but also replace the data which is already existing. So here in my case, if my blood group is my phone number, unfortunately, I have to, make sure that I replace my phone number with my particular blood group, right? That is an important thing. That capability you must have. Even though all of these seem quite basic, once you have data stored on one database, one server, or 100 servers, or in a cloud computing environment where your data is being stored on the other face of the earth or on the other side of the world, right? So you need to have access to all of these things. And look at the last point. I am talking about how one can go on to keep the data secure, right? Of course, there are, if you're looking towards these cloud computing solutions and whatnot, or general data centers, right? You might have seen videos of Google's data centers, Facebook data centers, and whatnot. There are armed guards who are making sure that there are like 10 or 15 layers worth of security before one can actually physically access the server or the hard drives which consist your data. Now, that is a very important thing, because if you cut off complete physical access, then the hackers or the miscreants who want to do something to your data can only try to break in via software, right? There again, there are very, very strong firewalls which are sitting to make sure that your data is completely usable only by authorized entities, and that misusing it is as minimal, if not, I wouldn't say it's 100% secure. There have been instances where, there have been data breaches and whatnot, but at the end of the day, it is majorly considered to be safe. So guys, these are some of the capabilities which databases, no matter what type of database they are, they should provide to you, because you will require all of these at the end of the day. Now, to align what we have just learned about databases with a data scientist's perspective, you as a data scientist must have these capabilities. First of all, you must work with an existing database. Now that sounds very silly when you think about it, like, okay, if I can work on a new database, I can work on an existing database, right? No. Sometimes the offerings, the solutions which are provided via databases are very much customized in a way where you will require the person to give you some sort of knowledge training on how the database was designed, why it was designed the way it was, and how you can go on to work with it effectively, right? This can be simplified, of course, if the person is in the same organization, you just go find out what's going on and all of that. But your capability to pick up data, to tie that database to your program and to make it work is an important requirement. The second thing, of course, is something which you should have. This is the capability to make sure you can create a database from scratch. Now you will know, here are my data points, here is what I require, here's my database. I just have to push all of them here, and not just randomly push it, to make sure it's stored in a structured way and that I can pull it out whenever I require it, right? That's another thing. The third point is to make sure that you already have a database. Now maybe you want to scale up, you want to change things around, you want to move different types of databases and all of that. Here is when you have to have the ability and the knowledge of how you can go on to customize an existing database, right? It might sound very simple, but to actually customize existing databases, you have to back everything up. You have to make sure that you're putting in new methodologies, new protocols. You have to test them out rigorously. You have to have a testing team sitting for that. Then you bring it to production. You use it. You have the verification team verifying if everything is alright. So it's an entire, life cycle on its own. But you need to know what happens at each of these points of the life cycle. It's a very important thing. Now, these first 3 points adds up to one simple point on the last one, which says handling databases can get challenging. It definitely can. Now, I have worked on a couple of data sets, on a couple of entities where I have to pull data from multiple points at the same time, or of course, even if it's a separate thing, things can get a little challenging in a way of how you connect your program or how you connect yourself to the database, how you pull the data, all the authentication details, creating the pipeline, making sure that the data flow rate is positive, right? There's a million things which can go wrong, but you as a person, a data scientist, now if you look at even job descriptions, right, they say you must have knowledge of SQL, they say you must have working knowledge of this Oracle database, a MySQL database, or whatever those things are, right, depending on the job. But if you analyze all of these data scientists job roles, there is a very good chance that they ask for that, and this is the reason for all of that, guys. So coming to this section of why we require databases, right? Now, if you have heard me very clearly in the last couple of slides, I definitely gave you some insights about why databases are very much required. We spoke about security, we spoke about access, we spoke about having data ready for a pipeline and everything, right? Here are some of the most important things which you might not know about database usage. Think about your data being used by someone else to make sure that you have a customized user experience. How cool is that, right? Everywhere you look at it, right now you're watching this on YouTube or any other video platform, your data is being used so that next when YouTube or any other streaming service can recommend videos like this for you, right? So your data is being used right now as you watch this video. Of course, it's okay, it's good, it's nothing bad, but you have to be aware of that, right? Let me give you a couple of examples. Think about Amazon. Amazon shows all these relevant products which, whenever you add a product to a cart. For example, if you're a person, who's just buying a gaming console on on Amazon, what happens is that as soon as you add it to the cart, it will say, hey, people who bought this gaming console also bought these game CDs or whatever, right? So it is trying to recommend something to you. It is again working on the basis of recommendation systems. We're going to check it out in another module down the line. But at the end of the day, now you have to realize that the data that you're providing to it is instantly being used to give something back to you again, right? To drive user experience out of it. That is a popular use of making organized and efficient usage of databases. That is Amazon. So think about Netflix. Right now, most of us, if not all of you all, definitely have tried Netflix, Amazon Prime, or any streaming service. In fact, YouTube can be considered as a sort of a streaming service as well. But at the end of the day, when you think about it, let's say you finish watching a TV show now, the next recommendation you get is on a similar genre. You might have watched a sitcom, you might have watched something related to documentaries or whatever it is. So as soon as you're done with it, Netflix itself will sort of put out a message saying, hey, do you want to watch this also, which might interest you? Well, how does it know what would interest you, right? It's a computer, it's a website, it's a application which understands zeros and ones at its most functional level. How is it doing this? Amazing thing, right? It's not only that, there is the Netflix algorithm is very, very complex in a way where maybe you have a favorite actor in mind, right? Now, Tom Cruise may be your favorite actor. Once you start watching Tom Cruise movies on Netflix, even if Tom Cruise is in a very minor role or he has done a cameo or something, those movies, the thumbnails itself will change and put Tom Cruise on the thumbnail and they will be shown to you. And, the platform wants to make sure that you watch it because it has Tom Cruise, right? Something like this is very, very, very powerful in a way. Of course, their goal is to make sure that there is customer retention, that people are watching the shows put on their platform, right? Their goal is being met, but your data data is in fact used to make sure that you can get hooked onto the platform. How cool is that? And then think about Spotify works in a similar way, but here again, when you think about all the songs that you would have downloaded and listened to, it will analyze your liking preferences, and it will check what you like, what you don't like, and it will start recommending things based upon that. But where is it getting all this data to recommend? How does it know what to recommend to you, and why is it recommending songs to you the way it is? All of these questions tie back somewhere down the line, down the ladder into a database, right? So that is the importance of why we require all of these. So if you're wondering about how all of this is done, there is two important steps that you have to know here. It is data collection and data analysis. A result of this becomes personalization. See, whenever you're watching any videos on Netflix, whenever you're watching videos on YouTube, you're browsing through your Instagram feed, you're going through Facebook, you're searching for a product on Google, whatever it is that you are doing on the internet, certain amount of data will be collected about you in a way where it is collected, it is stored, it is completely analyzed to make sure that you can drive, you can have a better user experience, that they can drive a better user experience for you. At the end of the day, whenever you use these social media apps, you feel a bit comfortable using them. Why? Because they feel personalized for you. It feels like it's meant for you. It is showing you things that you like. It is showing you things that it thinks that you absolutely love. So you keep scrolling down, that you're engaged with the platform itself, right? But to do this, there is two important things. One is the data analysis aspect of things, which is again a part of data science. The second thing is to make sure that there is certain data for the process of analysis or analytics, right? So that is an important concept which you must know, and it is not a simple game as it might sound. Hey, I have some data, why don't you analyze it and give me some sort of personalization? Okay, you're one people, but millions and millions, if not billions of people use these kinds of applications in a way. They almost use it every day. So to collect all those user information, to store it, to process it, and eventually give out a viable result from it, right? That takes some skill and challenges, and those skills from these database specialists, data analysts, and the people who drive these entire chains require knowledge on database, because without knowing where or how or when or where their data is stored, it sort of becomes impossible to access it when and where it's required, guys. So this is why we require databases. But at the end of the day, if you're breaking it down into its most simple concepts, you have to understand this. It is a very, very efficient data storage methodology. There's a lot of ways you can store data, right? Now, one simple thing that you might have seen is a compressed archived form of data, right? It's called RAR or .rar, .zip, zip, whatever it is, right? Now there are numerous ways of how you can in fact compress data and store it and uncompress it whenever you want as well. Storing 22 lakh terabytes every single day requires some challenge, right? It is either stored in a dense form, packed form, a loose form, whatever it is. But it has to be done that way, and you require knowledge to do all of that. Only then can it be called, or only then it qualifies to be called as an efficient data storage, right? That's important. And the next thing that you have to really know about is that the basic requirement of databases involve, it giving you the capability to write data and to read data whenever you require, right? That's an important thing. You typing in anything on Google Docs, Google Word, on Google Sheets, whatever it is literally you actually talking to a database. So there you are directly connected to a database, which gives you a tiny aspect of storage in it. You type in everything you want, you save it, you get out of there, and the next time you open it, it is still there, right? It is accessible in the right moment at the right time. There is good amount of data security in terms of all of these Google platforms which are offered to you in terms of Google Photos, Google Drive, Google Docs, Google Sheets, whatever it is, right? Those again are pointing to databases at the back end of it. You are just not directly given access or getting a look at the database, but you're getting a look at the user interface which talks to the the database. So that's an important thing. And it's not like you open Google Docs right now, you typed a document maybe last night, and that it takes 2 days to recover it for you. That would be absolutely meaningless, right? Now, as soon as you open it, it takes a fraction of milliseconds for it to hunt for that data wherever it is in the entire world, in the hundreds, if not thousands of data centers out there, pull it, bring it to your, into your internet connection, into your firewall, and to show you where it is. So this rapid access of data is very important, because once you even get a job and you're in a production environment where you're actually actively working and implementing a solution, this becomes a very important requirement there as well, guys. So this is one of the reasons why you are going to require databases as well. Now, after understanding why one would require databases, you definitely need the knowledge about the types of databases that exist. Now, how many types of databases do you think exist, ladies and gentlemen? Because databases can be classified into multiple different types, but the most important classification, the most functional basic classification happens in two types. We have the relational databases and we have the non-relational, or it's also called as the NoSQL databases. So whenever you see term like NoSQL or non-relational, think about it as the same mode of working, right? Now, when you say relational and when you say non-relational data, well, what is the first thing that comes into your mind? Don't think about databases, think about data. Relational data, right? It means data is related in one way or another. Now, what we mean by relational data is this. Data is actually stored in a very structured way, and each data point that gets stored is, it is organized, it is linked to each other, and there is a structured way of access and manipulation of data here. Now, if you are a person who's been wondering about, hey, have I ever used a relational database in your life? Even though directly you might not have, indirectly there's 100% chance that you have, because this type of database, right? It is one of the most popular offerings out there in the world right now, right? I mean, this is not a new concept. We have this for so many decades right now to store databases, work with all the languages which are meant for databases and all of these things. So anyway, coming back, in the case of relational databases, data gets stored in the form of tables. Now, when I say tables, think about your Excel workbook, right? There are certain rows, there are columns worth of data. Now, when I say data is linked, can I give you an example? Well, look at that. Name and age of students in a college, right? So let's say you have 50 classmates in your engineering, or you had 50 classmates in your engineering. You noted down their names and gave a column name as name. Then you put down age and you put the corresponding age of all of these people. Even if you put it down on a paper, it can be considered as a relational database, because if you're considering the 10th person, then you look at the 10th age and you realize, hey, this age is related to this person. Look at that. This age is related to that person, right? Now, from your school days, you have just thought to, read if it's on the same line. Of course, in an Excel sheet, it means the same thing. It is mapped to this. It is understood by all of that. But you skip this simple sense of that there is a relation in between that. You cannot find the 10th person age and say, hey, this is the age of the 100th person with the name on it, right? So it might be possible if your data is random, jumbled, or whatever it is. But in a usual case where data is related to one another, it is usually like this, in the form of rows, in the form of columns. This is a very, very popular form of database, and this was the database example that I spoke about in the start of this module, that you might have used it in your engineering, you might have used it sometime in the past, if you ever had it in your curriculum, guys. Now, for you to work with relational databases, there are certain open source and of course paid offerings as well. Two open source or free offerings that you can work with. I mean, these types of databases are PostgreSQL and of course you have MySQL. Now, I have had experience working with MySQL a lot, because first of all, it was free. Second of all, I was interested to find out about databases. The third thing is I had a curriculum. We had to work on projects. We had to solve real life situations and everything there. So understand that there are offerings where you do not have to pay money to use, but there are certain commercial offerings in terms of IBM IBM, Oracle, and all of these popular offerings which can in fact charge you for their usage as well. For example, IBM DB2 is a paid offering. It is not open source. So usually when someone think about databases, the first thing they'll think about is MySQL, and they think that the entire world of databases is free to use. Majority of it, yes, it is free to use, but if you look into the depths of it, it definitely portrays another picture out here, because of course, paid databases have their own advantages when you look at the free ones, the free offerings. But in many cases, these free offerings, or mostly these open source offerings themselves, are good enough to solve all of these different problems. Right now, that is the reason why this domain itself is popular. If you asked everyone to pay so that data can be stored in databases, well, people would not want to do it, or there would be only a niche audience who would want to do it. So in that case, that is one of the reasons, the popularity of databases as whole. Next up, we will be checking out non-relational databases, or it's also called as NoSQL databases. Again, we're going to check out what SQL is, but bear with me for 1 second here. The working of a relational database and the working of a NoSQL or NoSQL as it's called, right? SQL is called as SQL. So whenever you hear someone say SQL, don't want to say what it is. It is SQL, basically a simple and a nice way to say it out. So the working of this is very different in the case of relational and non-relational, because at the end of the day, here data is not stored or mapped based on relations, but they are stored based on the categories of data that are obtained and put into the databases here. Databases are stored in the case of key value pairs, where again, if you're looking at an example of a key value pair, think about the roll number or the university serial number of a student, along with the marks that they scored for one particular semester, 2 semesters, 3 semesters, all of those things, right? So you're using a key. A key is the university serial number or the roll number of a person, and then you're using this key to see what value is associated with this particular key, right? Of course, that key might not be a column at all there, but at the end of the day, you're using it to get to another thing. It's an indexing form that we use here, right? Now, ladies and gentlemen, in Python, there is a data type called as dictionaries, and if you've ever had the opportunity to work with dictionaries, right, there again, there are key value pairs which are used. The working of NoSQL databases are very similar, very familiar. Whenever you worked with these concepts of dictionaries, of course, there's lists, sets, dictionaries, tuples, and whatnot. So if you've had the experience of working with it, understand that the concept of key value pairs are similar, right? The next thing I want to talk to you about is certain important pointers that you have to have in your mind if you're learning about NoSQL databases. Now, the first thing you have to know about a NoSQL database is that all the keys, right, all the mapping elements that are present which store all these relations have to be unique. You cannot have one key point to two points of data. It does not work, because at the end of the day, there will be a lot of confusion saying, okay, if one is pointed to 2 and if I want to just access it using the key, which do I pick, right? So every single key element which is present in a NoSQL databases must be absolutely unique to each other. Only then can your data be worked upon efficiently, and whenever it is required, there is no confusion. There is literally no error situation which occurs where you will not know, the database will not know which to pick and give for you, right? So imagine the situation where one key opens every lock out there. The purpose of the lock is defeated. Similar analogy here as well, right? So keys have to be unique. The next thing is that if you remember in the case of relational databases, there data was stored in the form of a table, right? Data is stored in tables basically. Here data is actually stored as a document. It's a document file where the data is stored. Again, with SQL databases as well, you can perform removal of data, addition of data, manipulation of data, whatever operations you want to perform. Similarly, even in NoSQL databases, apart from how the relationships are mapped, Here as well, you have the complete authority, the complete freedom to add, manipulate, or delete elements from your database if that is the requirement. So these are some of the important pointers. Once you understand these important pointers, it becomes very vital that you know that there are certain very, very, very popular offerings out there in terms of NoSQL databases. Think about MongoDB, DynamoDB, Cassandra, HBase, and there's multiple other NoSQL databases. NoSQL is this domain which is definitely taking over all the legacy usages of SQL databases or relational databases as a whole. Now, if any of you are web developers or you've heard of web development terms, you might have heard of these development stacks called as MERN stacks, mean stacks, and all of that, right? So MERN, basically the M in MERN, MERN stands for MongoDB. Same for the mean stack as well, right? So at the end of the day, they're trying to say, hey, in web development, this is a very popular domain. And in data science, of course, the name itself has data. Again, to reiterate, it becomes a very vital thing, right? DynamoDB and Cassandra have been very popular in terms of today's usage, but mostly whenever someone goes on to learn NoSQL databases, it usually begins with them checking out MongoDB, right? MongoDB is very effective. It is easy to use. The way you work with the data will interest you and will pique your interest in a way where you would want to do it more. So that is the importance and the examples of NoSQL databases, right? Now, we've been talking about SQL databases, relational databases, NoSQL databases, and all of that. So what is SQL or SQL? SQL is one of the most important things you will have to know as a person working with databases, because this is an open source programming language. Again, it means it's free to use, which you will use to work with a database. Guys, do take a second and head to the comment section and let me know what you think is the full form of SQL, right? So, if you could not get the answer, SQL actually stands for Structured Query Language. So, you're trying to query the database. You are asking database certain questions and it is giving you answers. Hence, the name is called as a query language itself. If you're wondering about if SQL is a very new concept, how popular it is and whatnot, one thing extremely popular because it is used to work with relational databases or RDBMS systems, as it's called, Relational Database Management Systems, right? It is not a new thing. It has been around since the year 1974. Imagine the computing power that they had 2020, 2021, 2022, 2030, 2050. Imagine the computing power, right? Now you have to know, you will have a question saying, okay, why are we using something from 1974? Isn't there something better? It's a mixed thing. We're going to check out the differences between SQL and NoSQL, since NoSQL is a later concept which came about. But at the end of the day, SQL in its own terms has been refined over the years. Since it's open source, a lot of people have contributed to it to make it a better language than it eventually was. Now it is very popular. It is a prime requirement, right? Now, SQL is this language which you use to literally talk to the database, without which there is no user interface where you can sort of drag and drop. I mean, of course there is, but once your data sort of gets really complex, you do not have the liberty to check multiple rows, pull them out using that fashion. So it becomes vital that you know SQL and have it in your arsenal as a person who's looking towards data science, right? Now there may be questions saying, okay, so why should I even learn SQL? Why is it considered to be the most popular querying language when one can think about data science, right? First of all, my first point always has to be data security, ladies and gentlemen. The amount of advantages you get when you know your data is secure, the peace of mind, and it's not just peace of mind at the end of the day, that's how it is supposed to be, right? So once your language itself offers that kind of flexibility and freedom, why would you not want to pick it? That's reason number one. Reason number two, we're going to talk about how data is stored in a reliable way in an RDBMS, so that, at the end of the day, whenever you are asking the question saying, hey, I want this row from that column in this particular database, in this particular table. So when you ask for it, SQL will not randomly throw in another data or some erroneous, faulty, non-present, random junk value there and say, hey, here is your data. It will not do that. So it is a reliable way for you to store data effectively and pull it out. The third thing is that it is an easy to use syntax language. It is friendly in a way where it is sort of like using the English language. Of course, there are certain numerical terms and mathematical concepts, symbols such as star, the asterisk symbol, of course, and many other symbols which are put into place. But at the end of the day, if you know the basics of its foundations of it, understanding a simple query in SQL is not at all difficult. So this easy to use syntax, even on complex applications, makes life a lot simpler for a SQL developer, right? The next thing you have to know is how well it integrates with all the other scripting languages out there, right? Think about all the flavors of JavaScript. Think about all the usage with C++. So SQL databases are one of these databases that are very popular. Again, for another reason is that they work really well. You can write a query and have it executed in another scripting language, and the scripting language will understand that, hey, this is an SQL query, so let's connect with the database, pull the data out and give it to the person, right? You as a person who is implementing it in a programming language will be using a very similar concept of how you can pull the data into your program and work with it, right? Now, whenever your data requires whenever your program requires some data, it is not the case that someone sits and sends the data to you. Your program talks to another query language. It basically writes a query, sends the query out saying, this is what I want. The database is going to check if the person is authorized or not. If the person is authorized, it's going to push the data comes to your machine. That is how it is, right? So this integration, this hand holding, this handshaking procedure is very important. Next, when we talk about data redundancy, now, there are certain types of databases, even the most popular ones, where data redundancy becomes an advantage and a disadvantage. Now, why would you want to store one thing twice? One very important reason would be backup, right? What if one fails? Now, all of us have had data lost in one way or another. A memory card failed, a hard disk failed or something. If we have it backed up somewhere, nice. But if you do not have it backed up, you lost it sort of forever if your disk is unrecoverable or whatever it is, right? The data is gone. If this happens in a multinational corporation data, or in fact even an individual's data, sometimes it can hurt financially, sentimentally, whatever it is, right? So making sure that your data is secure enough in a storage place where not a lot of redundancy is required to keep it safe and to make sure that it doesn't mess up is something that an SQL related database can do really well. So these are some of the reasons of why you should pick SQL as well, guys. Now that you understand why SQL is so popular, why in fact it is so important, you will have a question saying, okay, now I know SQL, now I don't know SQL. How does these two compare, right? So whenever you're thinking about these, there are certain important points that we have to discuss. So let's check them out one by one. The first point that we have to look at is the nature of working, the basis of working, right? As I've been telling you guys for a while now, SQL databases work based on relations. They are relational databases where one data entity, a column, is mapped with the data present in the rows, and a row data can be accessed and mapped back into the column, something like that, right? In NoSQL databases, that does not happen. There is key value pairs, and the data in fact is stored in a very different way. So this basic difference is something you should be clear by now. Once point number one is understood, you will be checking at point number two. Point number two talks about scalability. Now, scalability is a very important aspect here because SQL databases can literally be built one on top of the other to increase a requirement. Right now, let's say you have database which can store 100 points of data. Now you have a requirement to store another 1,000. So you can literally lay it like bricks and go on and on and on and scale on the same architecture using the same hardware, the same principles of usage and all of that. That is the meaning of vertically scalable databases. databases. Then you have horizontally scalable databases. So instead of laying the bricks on top and top and top, you just lay it side by side and then connect these two to eventually get working, right? So these, when they are stacked separately, they become two different databases. Of course, you can have access to both of them at the same time at your fingertips, but scaling something vertically is way more convenient than scaling something horizontally. But there are certain situations where if you have to build a wall, you cannot just lay one row of bricks and say it's a wall. You have to scale it this direction as well, right? So because multiple points of data can come access into it, and for one database it can get overwhelming, it can get overloaded and all of that. So having horizontal scalability is equally important. So there is no clear winner. It is just that with point number 2, understanding that databases work differently is the key. Next up is the third point where we're discussing about data storage. Now with SQL databases, what usually happens is data gets stored in the form of tables as in rows and columns worth of data. What happens in the case of NoSQL databases? In NoSQL databases, data is stored by making use of documents, right? When I say documents, think literally about a doc file where you might have key value pairs indicated with a chart. A lot of JSON data is like this, right? So at the end of the day, the way data is stored itself is fundamentally different, since there are no relations that have to be mapped in a NoSQL database. I hope point number 3 was clear for all of you all. Then talking about point number 4. Point number 4 is talking about how data, what kind of data, if you have, which database would you prefer? If you have data with many rows and columns worth of data that you want to store, just like the student example that I gave, maybe you want to store the data of an entire university. Now, in that case, you would prefer storing it in an SQL database, right? Then when would you pick a NoSQL database? Well, you would pick a NoSQL database when your requirement is to store data. You're good with key value pairs. You know that your data can be stored, or it is in the form of JSON itself. So if your data is in the form of JSON, at the end of the day, you can easily scale it up and store it in a database. Or even when you know your output document has to be stored in the form of a document, right? So again, that was a confusing term. If you want your data to be stored as a document, it is possible natively by making use of NoSQL databases, ladies and gentlemen. So after this, what usually is a common thing that I get asked even after pointing out differences is that, okay, so now I know the differences also, which do I pick and how do I know what to pick? Here are some of the most important pointers. Guys, this is the most important slide in our discussion between SQL versus NoSQL, and make sure to take it down. The first thing is, if you have a requirement to make sure, let's say your data has to be available the second you access it, right? Think about Google Photos, Google Docs and all of that. And you want your data to work every time. It has to be safe. It doesn't have to mess up and all of that. So if availability and data consistency are your primary points of concern, you will definitely want to store one kind, or in fact, almost any kind of data in a relational database. But if you're on the other side of the requirement and you say, hey, I want my data to be partitioned in a way where I really do not care about this kind of the integrity that exists in between relationships of data, or if you are a person who says, hey, I want my data to be fault tolerant in a good way where if something happens to the data, I can recover it quickly, right? So in that particular case, if you're looking towards those aspects of things, you would be a person who would be investing and looking towards learning NoSQL databases, guys. Now, another question I get asked is, okay, I want to learn both. Can I do it? You definitely can do it. Usually there isn't a requirement for you guys to know both. My suggestion is to start out by understanding SQL databases. Working with relational databases is definitely something that is foundational, that's going to add value to your learning, even though you might later work towards NoSQL as well. As you might have seen in the differences right now, the fundamental ways of working of an SQL database and a NoSQL database is eventually very different. different. So learning one will not go waste about learning the other, because there are certain concepts which are shared, right? Of course, working is different, but having the knowledge of it definitely helps, is my point and your takeaway for this year. Start out with SQL. Down the line, if you want to scale up or if you want to move bases, you definitely can learn about NoSQL. You can work with it, get started with it, and again, there are multiple features that are offered in both of these databases. Let's say by mistake you delete something, there are features where you can start pulling back the data as soon as you delete it. If you delete it by mistake, if you added an entry by mistake, again you can remove it, you can delete the entire thing, create it from scratch. There's a million things which add convenience to you. It is not like, hey, I have a data point, I just stored some data, now by mistake I hit delete, it's gone forever. In some cases it might happen like that, but in 99% of the cases there are redundancies in place where even if you delete it, there you get a time frame, you get a period frame, you get a change frame in a way where you can pull back and use that data again, so it doesn't vanish forever and you lose all your hard work. That is an important thing that you guys should know. Right, guys, now coming to the section where we are talking about you guys learning data science online. Again, to reiterate, it becomes very, very important that you guys use a structured way to learn. Now, of course, keeping that in mind itself, we have put up this data science full course program. But ladies and gentlemen, it becomes so vital that if you do not get into the foundational aspect of things, if you do not take things in a structured way, it will get very difficult, right? Now, we are scratching the surface of the entire world of data science, and as and when you dive into the depths of it, when you actually use it in a production environment, if your foundations are not strong, you will then have to revisit it. Things can get confusing. You will not know how to integrate something that you just learned new with something that is existing. All this hodgepodge nonsense will happen. Avoid all of that. Use a structured way of learning and make sure you're talking to experts, right? By now, I am sure that you might know that I am a subject matter expert in Python, data science, AI, all of these different concepts which govern the world of, data science and the world of IT. So at the end of it, having, it is not just me that you have to talk about or any of the subject matter experts here at Great Learning. Talk to your friends, talk to your colleagues, talk to your seniors, talk to your faculty, whoever it is that you think know these concepts, right? It is always nice to get their view of understanding about a data science concept. Now, if you ask someone, hey, how does a neural network work? If you ask three different people who are from three different backgrounds, which they might have some clarity on the domain, they'll give you three different ways of what they think a neural network is. Use that and, sort of collectively make sure that you have one good answer of what a neural network means, right? It's like going to your favorite restaurant, enjoying your favorite pasta, but now you're moving to three other unknown restaurants, eating the pasta there. It may be good, may not be good, it may be right to your terms or not right, but it is vital that you try it, in fact, to know if it is better than your restaurant or whatnot, right? That is why talking to experts is very, very important, guys. And again, whenever you're looking at free content, on data science or any other domain for that matter, we have three different channels you can reach out to us. We have the Great Learning Academy where you guys can enroll into multiple courses for free. We have 200 plus courses at the time of recording of this video. It is taught by subject matter experts in multiple different languages where you can sign up for free, look at courses for free, enroll in them, learn them completely, and get a course certification or a certificate of completion for free as well, ladies and gentlemen. So that is something which is not only going to add a ton of value to your knowledge, but also add immense amounts of value to your resume in this extremely competitive world of data science as well. So make sure you're checking out Great Learning Academy and make sure you're subscribing to the Great Learning YouTube channel, because if you subscribe and hit that bell icon, right, as soon as we put out a video, you will be the first one who will get notified of it. And these videos, we know, add immense amounts of value to your life. So we want to make sure that you see it and learn it as soon as we put them out, right? So it becomes vital you subscribe. And then guys, for all the people who love reading, for example, I am a guy who loves watching YouTube videos as well, and of course I love reading too. So if you're a person who prefers reading, again, we have great learning blogs which you definitely can check out on all of these concepts. You have multiple blogs written by multiple subject matter experts in the domain of data science. Do check them out, get a head start, understand the concepts of data science that way as well. But at the end of the day, if you're looking for complete specialization, if you're looking for if you're looking towards becoming a complete expert, a thoroughly knowledgeable person on this domain who's also certified, I highly recommend you take a look at Great Learning's specialization and post-graduation offerings. These are made in collaboration with some of the most prestigious universities across the globe. We have multiple post-graduation programs, certification training programs. We have MTech offerings. We have MS, which is Masters of Science and Data Science, of course. Again, as you can see, these are done in collaboration with Texas, McCombs, Great Lakes, PS University, Northwestern, with more and more programs coming. So make sure you guys head to greatlearning.in to check them out as well, guys. Right, so at this moment, guys, you have reached the end of this module. I hope you all are clear with all the database stuff that we discussed. Practical implementation is one thing that is very important here again, but at the end of the day, to make sure that you guys are clear on the further concepts that we're going to discuss as well, it was vital for me to give you the theoretical knowledge out of it. Of course, if you head to Great Learning Academy, you have multiple courses on SQL. If you head to the Great Learning YouTube channel, you have complete tutorials for SQL with multiple use cases as well. So you definitely can check them out to make sure you pace yourself, to make sure that you have a complete understanding of this aspect of database handling. Right, guys, on that note, I'll see you on the next module. So guys, welcome to module number 7, which is exploratory data analysis. Now, as I've been mentioning over the last 6 modules, it becomes extremely vital that you understand what exploratory data analysis is. At the end of the day, just knowing the fact that you can get so much more information out of your data, which is not possible via the naked eye, is something that you guys definitely should be looking about. Now, a data scientist role also involves a lot of performing data analysis in a way where it has a huge impact on internal company data, external company data, business analytics data, and whatnot. So at the end of the day, having this kind of knowledge about business analytics, data analytics, and of course performing exploratory data analytics is something that will definitely add a lot of value to your learning as a data science expert, and of course to your knowledge base of how you can provide solutions using the same as well. So right, guys, what are we going to learn from module number 7? In module number 7, we are going to be taking a look at an introduction to understand what this concept of EDA or exploratory data analysis is. After which we are going to take a look and understand the various types of data analytics that are out there. There are multiple types of EDA that you have to know about. We're going to be checking out all of that. We're going to be taking a look at the immense number of advantages that are applicable, that are eventually the goal to get to EDA is to know that using EDA it is extremely advantageous, right? So that we're going to be discussing that, and at the end of it we're going to be practically taking a look at all of these in Python as well. Right, guys, so when I say exploratory data analysis, what is the first thing that comes into your mind? What is this train of thought that you are governed with, that you understand, right? Let me give you an example. Think of this particular situation, right? So there's a new TV show that has come out, maybe on Netflix, Amazon Prime, YouTube, Hotstar, wherever it is that you guys watch it. And that now it is super trending in a way where all of your friends are talking about it, right? We have multiple shows which did this in the past, saying, hey, friends would ask you saying, hey, did you watch that show? It is very trending and all of that. So now your friends are all talking about all of these. It is in the news, it's on the TV, it's on your Instagram, it's on Facebook. It is everywhere, right? So on the whole, right now, you do not know much about the TV show apart from that. It exists. What would you do? The first thing is, if you really are interested into it, if you can, actually have time to watch it and all of that, you will be curious to learn more about it, to understand more about it. So you might search on Google, watch a video on YouTube, all of these things, right? So what are you doing? You're exploring to understand what is the thing at hand here, right? Again, this is exactly how exploratory data analysis works as well. At the end of the day, you are more and more curious about what you can find in your data. So once you go ahead and sort of tap into that potential, the immense amount of potential that exists in your data, you would be very clear with how things unravel, how things wrap out, and give you so much more information than what you could pick up, right? So this is a very beautiful example just for that. So to come towards understanding what exploratory data analysis itself is, first of all, you must begin by looking at the data to understand what it is. Now, data can be understood in multiple different ways, on a low level, on a high level, on a mid-tier level, to see what it is that you're getting for your money, right? Here in the case of exploratory data analysis, we're trying to investigate, we're trying to look into the data, and we're trying to see, hey, is there anything that I can find when I look into this data, and eventually have a result which will add meaning to the entire exercise that we are doing. That is exploratory data analysis, right? Sometimes it is not, not all the times it is the case that you'll only be looking for trends and all of this in your data. Sometimes you'll be performing in-depth exploratory data analysis to find out if there are certain anomalies in your data. If your data is working fine, it is doing things the way it should. Is it the other way around? Are there errors in your data which is eventually hurting maybe machine learning or deep learning systems down the line? Or is there anything that is going wrong in your data that you can find out by performing some analysis on it, right? This is exploratory data analysis in one picture, guys. Next up, you really have to understand why exploratory data analysis is so important. It is the requirement of the hour and all of these things, right? There are multiple different points. We can talk about this for hours on end, but the first important point you really have to understand is that whenever you're taking a look at data to understand what conclusions you might arrive at, to take a look at data, to understand data means you're already trying to assess and analyze something, right? That is one important point. It will get you to your goal quicker. The second thing is, it is very easy to make assumptions with data saying, hey, all the rows in my data are fine. There are no errors and all of that. So if you want clarity about these assumptions that you make, if you want facts which back up everything that you say, and of course what your data shows at the end of the day, it becomes vital that you have a methodology to do it. Guess what? EDA is how you do all of that. The next thing, as I've mentioned, to spot new trends, to know that, hey, here is the product at hand. There is a good chance that down the line in the next 2 months, 3 months or 3 years, this product might be extremely trending. So we have to work on it, right? Now that summer is approaching, a lot of summer wear, light clothes, sweat absorbent clothes, and all of these will be on sale. So to know that if you are a person who's into selling all of these, you will be ramping up on your production scale, because you will have such a high demand for it, right? That is exactly my point on this particular topic. So it is not just with data, it is not just you stating out something, but your data is packed now with good amount of proof saying that, hey, this is what I say and I have backup and I have proof for all of that. So that is an important thing you have to know about when you're investing your time learning about exploratory data analytics. Okay, so all of this is amazing. Can we take a look at the types of exploratory data analysis? I'm sure by now your interests are high. You want to find out more about the domain. You want to start using it practically. We're going to start using it, don't worry, at the end of this module. Before all of that, there is various types of analysis which can be performed using exploratory data analysis. So it is vital that you know all of them. Three important types of exploratory data analysis that exist are univariate analysis, bivariate analysis, and multivariate analysis. Now, what happens with univariate analysis? Uni, as the name suggests, you will be analyzing only one particular variable. You will be using a good amount of data to analyze what is happening to that, that column worth of data, right? And then when you're taking a look at bivariate analysis, with bivariate analysis, as the name itself suggests, you'll be taking a look at two things. You'll be analyzing two variables at the same time to see what is the goal that you're trying to achieve. And then we have multivariate analysis. See, multivariate analysis talks about how you can go on to perform analysis based on more than two variables at a time. So it may be 3, maybe 4, maybe 5, maybe 10, right? So knowing that your result is based on just one column data, 2 columns of data, 10 columns of data, and the results you get out of it is astonishing compared to knowing that, hey, only one row of data can have so much impact, right? That is why it is very important. Now quickly take a second to see if you can think of an example for univariate and bivariate, right? For multivariate, I can give you a good example. If you're trying to teach a machine learning algorithm to see if it can predict if a person has diabetes or not. Diabetes is one of these medical conditions where it depends on a lot of different things. It depends on age, it depends on a factor of heredity, it depends on your blood sugar, it depends on your body mass index, it depends on if you're obese or not, it depends on your weight, it depends on your height. There are million different variables that can be used to assess and say that this person might be diabetic. For example, your sugar levels, your blood sugar levels can be super high, and that is when you realize that you might have diabetes. Maybe you have a wound which is not healing. That is one of the symptoms of diabetes as well, right? So there's many different things. That is a classic example of multivariate analysis. So you take a second to think about univariate and bivariate analysis. Right. I hope you all did that, because here are some really nice examples for the same. Multivariate analysis we already discussed. You'll be trying to see if diabetes can be predicted if you have insulin at hand, if you have the age of the person, the body mass index, and all of these things. Next, when you're taking a look at univariate analysis, back to one variable analysis. Here, if you want to understand how the person's age changes and maybe how the height changed based on the age, right? So when we were all babies, we weren't a lot tall, and as you grow years and years and years, you can go pretty tall, right? 6 feet, 6.5 feet, all of these are achievable. So this change of height is dependent on your age, right? So using one variable to see if the person how the height is changing of this person. So that's an important thing to know. And the next thing is bivariate analysis. See, with bivariate analysis, you're trying to understand variables based on two analytic criteria. For example, if you look at multiple sporting events that happen, right? For example, there's cricket, there's hockey, there is swimming, there's badminton, there's all of these sports. If you want to find out what the population prefers playing, right now, what the males prefer, what the females prefer playing or watching or whatever it is, you will realize that there is a difference between, there's a difference between what people like as well. To understand what they like, you have to take two variables into account and have one sport and say, hey, males usually like playing cricket, maybe females absolutely love playing hockey or badminton, whatever it is, right? That was just a hypothetical example, but that is the case. Next, if you're taking a look at your GRE score, right? Now, maybe with more and more experience, if you prepare for competitive examinations such as GRE and GMAT and all of these examinations, it could come to a point where, with more experience, you can do it better, right? So here again, your score is dependent on your previous performances, your score is dependent on how you learn, and your score is also dependent on your age. So there are two important criteria that you can pick up and perform bivariate analysis even in a multivariate analysis statement as well, guys. So these are some of the important examples of exploratory data analysis that you guys should know about. And once we talk about all of these examples, we come to a very important step where you have to understand this entity called as box plot. Box plot, again, we're going to discuss all of this in the data visualization module in a good amount of detail, but for now you have to understand that it is very, very important you know what box plot is, right? For example, if you have concentrated well on the probability module and of course the module number 2, which was statistics, there I have specifically mentioned that you have multiple ways of how you can split the data, work with the data and all of that. So a box plot is basically a measure. It is a representation of a measure, if I have to put it out accurately, right? Now, if you have a lot of data points and you want to, for example, if you calculate the metrics of, central tendency, it is mean, median and mode, right? If you look at your box plot right now, your box plot will look something like this, where Q1 median, Q3 min, max and outliers, all of these are individual values. Each circle you see is a data point, right? So if your data is broken down into its quartile ranges, there are again 4 quartiles which are calculated, right? So there's one quartile in between minimum and Q1, you have another one between Q1 and median, you have another one between median and Q3 and max. So we are dividing data into 4 different quarters and working with them, because we'll be taking a look at data as a percentile and all of that, right? So in this case, whatever data we had at hand, the minimum value was maybe 1, the Q1 value, the first quartile value was somewhere around 7, the median was 11 or 12, we had the third quartile value, the Q3, which is somewhere around 25, and then you had a max value in your data which said, hey, the maximum is 30, and then you have something called as outliers. These outliers are concepts which are deviating from the actual data. For example, if you can see that your minimum is 0, maximum is 30, you might have data which is like 100, 150, 200, which are very different compared to the majority of population of data, right? It may be -1, -10, -100 also if you're not expecting that. That is called as an outlier. It may be an anomaly, it may be an error, or it might be those 2 or 3 of the exponentially rare cases which might occur to give you that kind of a result. It is possible. So it is vital that you take a note of where and how all of these elements are represented on a box plot. You have the minimum element on the left hand side, you have the maximum element on the right side. But here you might have outliers on the left or the right also. But again, when you take a look at the divisions, there is a quartile between min and Q1, between Q1 and median and Q3 and max. So whatever is the values that fall there, it is a part of that quartile in data, ladies and gentlemen. So it's a very important thing that you understand this. And the next thing that we're taking a look at, as I've mentioned in the session takeaway for this particular module, is the advantages of EDA. There are numerous amount of advantages. I can just have a 1-hour session just to talk about the advantages of EDA, but I want to give you a good amount of highlights to tell you what they are, right? Now, advantages are many, but the most important reason why exploratory data analysis is even so popular is because of the fact that you can, look at data, understand that, hey, I want to use this data to get to this point. Can I do it or not? If the answer to that is yes, just start digging into the data, hunting for conclusions, looking for insights which your data can give you. A good example to this is maybe you are a person who sells chocolates and cakes and all of these, right? Usually during Christmas and New Year, this sells a lot. So in that particular case, what usually happens is, you will have to stock a lot of these items, right? You will have to, maybe in the month of November, if you sell 100 chocolates, in the month of December you might sell 1,000. So you have to have previous year's data. If you look at maybe 2019 or 2020's New Year data, there might have been 800 people, 850 people who have bought it, right? So in that case, that's not an outlier. You use that data to know, hey, the analysis result is that in the month of December, I am selling a lot more chocolates that I am actually producing, or whatever it is. So arriving at data-driven conclusion, it's not a guess, it's a conclusion, and it is proven by data, right? So that's an important thing you should know about. The second thing is that whenever you're taking a look at all of these things that you can do with exploratory data analysis, one thing which is usually extremely popular in today's world is that you'll be checking out for data anomalies and the consistency of data itself to know if your data is correct or not, to know if your data is doing what it is supposed to do and that it is not hurting any other pipeline down the line. It becomes very, very vital that you understand data anomalies, ladies and gentlemen. So that's that. And the third thing is feature engineering, right? So feature engineering is one of these concepts where you'll try to understand what feature can be used to obtain what result, or if you can explore into finding a feature in a way where, maybe there is another concept in the case of diabetes, right? There is another element that we are not looking at, which can have an impact on your eventual goal of a person being diabetic or not, right? To analyze that, there might be some other feature. We are considering blood sugar, body mass index, age, weight, all of these things, amazing. But it is not that is the entire thing, right? There might be something else, and that something else to find out is exactly what you're going to be taking a look at with feature engineering. So I hope you have concentrated on the second point, because the fourth point talks about something similar, which is data pre-processing and cleaning. Again, over the last couple of modules, you already know this. I have stressed how much is the importance of data pre-processing, data cleaning, and making sure that you feed the right amount of data to your process of how you would analyze data, or of course to a machine learning algorithm. You have to be extremely careful if you're giving the data to a machine learning algorithm to learn, because it can go wrong in so many different ways that I've mentioned in the last module, right? If you show a picture of a cat and a picture of a dog, if your computer is trained wrong, if your machine learning algorithm is trained wrong, it can interchange and see a picture of a cat and say, hey, that's a dog, and I'm sure. And it can see a cat and say again that, I'm a dog. So it doesn't make sense. And I gave you a very simple example, but in an actual productive environment, this can get, very, very, very difficult to handle. And people will not know what's going wrong, where it's going wrong. But at the end of the day, it usually comes down to the quality and the quantity of data too. So it's important. Next advantage here is that with exploratory data analysis, you can have the capability to handle these two concepts called as underfitting and overfitting. Now, underfitting is one of these concepts where your machine learning algorithm does not have enough access to data. It is not searching your data enough where it is getting some meaningful learning done. So it is just brushing through things. It is not understanding things in detail and all of that. That is underfitting. Overfitting is the exact opposite of it. It is when it completely starts looking into your depths of data. It is looking at noise rather than useful information. It is using this noise to learn, which at the end of the day will hurt its accuracy when it is overfitted, right? So handling underfitting and overfitting becomes extremely, extremely important, because if you do not do so, again, your data is messed up when you process it ahead, because not only will your values, the output values that you might get can be wrong, but it also comes down to a fact where your machine learning algorithms processing itself is going to take a lot more time. It's going to take a lot more time to learn, and eventually, even after it does that, the accuracy is not great. So it's not a win-win situation in any way possible. So it is very vital to handle underfitting and overfitting in any of these solutions, and EDA is doing a very, very good job at helping for that. Right, so guys, in the next section, we are going to be taking a look at, all the concepts of EDA in a practical fashion. Now that you already know all the basics, right, it will add a lot of value if you learn things practically, and I'm going to do my best to do the same. Now, what happens in the case of EDA is this, especially in this data set that we're taking, is a really, really fun data set to take out. So I hope that, we do have viewers here who are fans of cricket, right? Now, IPL is Indian Premier League, which takes place, on a yearly basis where, it is a very, very popular event here in India. It's a cricketing event, and there's a lot of insight which even the teams are very keen to take a look at the data to understand what was the bowler's performance, batsman's performance, who plays really well against which bowler, which batsman. There's a million things that these guys will be analyzing and looking at. They will have entire data analytics teams together who are sitting to analyze individual players. So that is how much how much complex sport has become these days. They try to predict things, they understand strategies, they try to get strategies from an AI related algorithm as well. There's so many different things that they're doing. So we are going to use this data set which has all the data regarding the Indian Premier League which has happened over the last couple of years. So there are certain questions which you can ask, right? See, exploratory data analysis is you exploring. For you to explore, you must ask some questions and get answers from your data, right? There are certain data set questions that you can ask. For example, saying, what is the size of the data set that I'm dealing with? Well, you can find that out in Python. Next, what is the type of data that we're trying to work with in this particular data set, right? There's numerous types of data which one is working with. Here in IPL data, again, I'm going to show you all of these things practically, but of course, it's not just IPL data that we're talking about here. It is you asking a question saying, what are the types of data I'm working with? Can I find it out and can I use it in the next couple of steps? The answer is yes, and you can find out the types as well, right? The next thing, dataset question, which is very important to ask is the data pre-processed, right? To find out data cleaning. Remember when we spoke about advantages, I told you that it helps in pre-processing as well. This is exactly what we're talking about here. These are all dataset related questions in a way where you can ask if the labels are correctly present to the data as well. For example, if you consider a player, if he is just a batsman and not a bowler at all, right? So in that case, if your data is correctly put him as a batsman rather than a bowler or any other thing, right? It might have put your captain as a coach or something like that. There will be something wrong with the data in many cases. So here is where you ask these questions to clear out that air. The next questions, the set of questions that you're going to be asking is statistical questions, right? In the case of statistical questions, you'll be asking so many things to your data saying, hey, so what are the values of central tendency? How is the quartile division of the chart? You remember I showed you the box plot which contained Q1 median, Q2 min, max, all of these values. The box plot itself is a representation of the quartile division. Your values will be shown. You can do that with the help of EDA. And then when you're taking a look at the third thing, right? The third thing talks about how important is it for you to understand the total count of all of the individual data elements that are present, knowing that you'll be using 10 rows worth of data, 10 columns worth of data to, at the end of the day, take your result and show that, hey, my result is backed up with this amount of data, right? That's a very important question that you are going to be exploring. So guys, without further ado, let me quickly jump in to Google Colab. Again, we have used Google Colab previously. However, let me zoom in so that it is better, visible on all of your screens. This should be perfect, I presume. So we're going to be taking a look at exploratory data analysis on the IPL data set. But before all of that, I have to upload, the data set. So let me quickly go on to upload the data set. As soon as I hit OK, if this orange circle vanishes, it means the data set is uploaded. Perfect. I can close that and we are here. Guys, the first important thing that you have to take a look at is, as you've already checked out in the case of machine learning and all the other modules, what is the first thing that we do whenever we are working with any program? We import all the libraries and the dependencies, right? So for this particular case, to perform exploratory data analysis here, we require pandas, first of all, to store the data as data frames. We require NumPy to make sure we're working with numerical computations using its data structures as well. And we're going to be using Matplotlib and Seaborn. These are two beautiful data visualization libraries, which I absolutely love working with. We're going to be checking out data visualization itself, ahead in the next modules. But then for now, you have to know that we are going to be using it, right? So as soon as I hit the play button, these libraries are all imported and ready. The next step after importing all your libraries is to bring in your data set to the working environment. In this case, the working environment is the IPL data set, which we have to bring into our Google Colab. So as soon as I go on to click this, we are using read_CSV method in pandas to take a look at our data set. Right now, let me quickly zoom out a little so that you can see the data better. Right, so I've basically printed the first 5 rows worth of data using data.head. I can print 10 as well. It's a pretty simple thing. All I have to do is pass 10 as a parameter to it, and instead of 5, I now have 10. Amazing, right? So the data that we have is something like this. There are identifications for the data rows. Eventually, then you're taking a look at all the various cities which where the games were actually played, where the matches were actually played. Then you're taking a look at the dates of when individual matches were played. Who are the two teams who played these matches, who won the toss, what was the decision after they won the toss, what was the result, was the match forfeited, was the match won, match lost, who was the winner, who won by how many runs. And there are so many things. Let me scroll to the right. You can find out by how many runs they won, how many wickets they won, who was man of the match or player of the match, where was this game played, which venue, who were the first umpires, second umpires, and third umpires as well, right? So this data set is beautiful to work with. It will give you a lot of insight when you're working with, ladies and gentlemen. So to move ahead, we have to next take a look at how big is our data set. I just printed 10 rows for you, right? So with data.shape, we will come to a realization that we're using 18 columns of data, and each of these columns have 756 rows of data. So overall, we have details about 756 IPL matches. We're going to be using that to analyze things, right? So guys, it's very important you know that this is not only data from one single IPL season, but this is data from multiple IPL seasons, right? So we're going to check out all those seasons as well. So when I go to click data.info, it will show you just all the details about this itself. Data.shape just gives you it in a concise way, but if you want more details about it, as I told you, we have 18 columns worth of data, 756 rows of data, and it will show you samples of what these data is as well. See, for example, some cases your umpire number 2 or umpire number 3 is NAN. NAN means not a number. It means that data is not present there. So you do not have the name of umpire number 3 for a particular match. And for our case, it is okay. But maybe if you're trying to analyze the performance of the umpire himself or herself, then in that case, it becomes tough, right? So it's very vital that you print out to realize this. Next, let me just print out all the columns that we are trying to use. ID, which season, IPL season, which city was it, what was the match hosted, what is the date, two teams which played, who won the toss, what was the decision, what was the result, so basically everything that I ran you through, right? So all the columns and the labels are very, very important stuff. Next thing when we talk about is finding out if there are any NAN values where there are not supposed to be, right? See, for example, seasons are all these year dates, right? IPL 2016, IPL 2017, 18, all of these things. So these are numbers. So there are no NAN values. Then city. City is not a number. You cannot say Bangalore is 1, Hyderabad is 2 and all of that. There you have to give a name. Bangalore is Bangalore. Next, Hyderabad is Hyderabad, right? So city name is will be a character. Then you take a look at a lot of things which are false, because all of these are number outputs, but wherever it says true, it is trying to give you a character output, right? Now the name of the team who won a cricket match will not be a number. It'll maybe be that, hey, this team won by that many runs or wickets, but which team won? The answer to that question is a character or a string, right? So that's the reason why this is true, and it is true for all the umpires, because all of these are just names of people, right? Even man of the match or player of the match. I hope this aspect of it is clear to you. The next thing we're going to take a look at is to describe the data in a standard way where we understand using statistical functions. So data.describe will eventually give you a lot of different things. First of all is the count of how many rows worth of data is there. We have 756 match data. What is the mean of all the IDs? You can find the mean of all the average win by runs in all 756 matches. You can find the standard deviation of how far the data deviates from the mean. You can find the minimum value, minimum number of matches played, minimum number of matches won by using runs. Maybe the team won, there was a draw, then there is no winners, right? Then you're taking a look here at min, 25, 50%, 75 percentile and max, right? So this is the interquartile range. It's called as the quartiles. Interquartile range is when you perform a calculation on it, but this is the quartile range that you're printing out. This data falls upon and in between that quartile. So that's an important thing that you are supposed to know about, right? So that's important. The next thing is we start asking questions on the data set, if you remember. And one important question that we're going to ask is how many matches were played in total with all the data set, which we already know this from because I showed you the data set previously. We are 756 matches worth of data out here, right? So that's something which you have to know. The next thing is we'll try to see how many seasons are we trying to analyze. Here all we're trying to do is we're finding the seasons columns, and since there is 756 matches, you can get 756 answers here saying IPL 2018, 19, 19, 19, 18, 17. So all of these things. So we're trying to use the unique method here to only print us all the unique data. So this data set consists of data right from IPL 2008 all the way till IPL 2019. Again, this may be accurate to what happened in real life, or this can be a hypothetical data set. We are going to assume that it happened in real life, so we can just have more fun with the data set, but that is how it should be as well. This is a hypothetical example of using the data set, guys. So the next question that we can ask with that particular data is which IPL team won by scoring the maximum amount of runs. So which team won a cricket match where they scored the maximum amount of runs, right? So as soon as ILOC is basically us using a filter we're trying to apply on the data where we're trying to find the max element that is present in that particular column. So as soon as I run this, it will tell us that hey, it was basically IPL 2017. The match was played in Delhi. Here's the date of the match. It was played in between Mumbai Indians and Delhi Daredevils. Delhi Daredevils won the toss. They wanted to field. The result was normal. It was just win or not win. Mumbai Indians won and they hit 146 runs, which eventually gave them the win, right? So maybe the other team could not chase that amount and they were bowled out or whatever it is, right? So these guys won by 146 runs in an advantage. You have man of the match, LMP Simmons. You have the venue. It was played in Feroz Shah Kotla, right? Feroz Shah Kotla, I think, is in Delhi. I don't watch much of cricket, but I hope that's the case. Look at this. One line of code, it is very simple line of code. All you're trying to do is find the maximum in a column and you have such beautiful insights to take a look at it, right? Next, the next question you're going to ask is, okay, so who won by, just taking down and destroying all the wickets? So which team won maximum that way, right? So this is again IPL 2017. The match took place in Rajkot between KKR and Gujarat Lions. KKR won the toss. They wanted to field and KKR eventually won the match because they bowled out every single one of Gujarat Lions' batsmen or something like that. Again, I do not know if this data is true or not, but as of what I can see with my data set, the question I asked, I have the answer right in front of me, right? So it was played in Saurashtra Cricket Association Stadium, which again is in Rajkot, I believe, right? Again, you have details about the umpires and all of that as well. They took 10 wickets, which is again the maximum number of wickets you can take to win. Right. The next question, we can go on to ask is which IPL team won by taking minimum wickets, where they might have not made the batsman out, but eventually their bowling was so good that they never let the opposition score runs, right? So this was a match in between Sunrisers Hyderabad and Royal Challengers Bangalore, SRH and RCB as they are called. RCB won the toss. They wanted to field and Sunrisers Hyderabad won this match. They won it by 35 runs. This is the minimum amount of this is the runs that they did, but the minimum amount of wickets that they took was 0. So even though no wickets fell, their bowling only gave RCB chance to hit 35 wickets or something like that, right? So this match was played in Hyderabad. It was played in Rajiv Gandhi International Stadium, Uppal, right? See how nice, how fantastically you're getting answers to your data here. That is what makes EDA so much fun. Next, when we are taking a look at which season consisted of the highest number of matches ever played from 2008 to 2019, here's a beautiful graph that we are trying to print for you and showcase the same, right? So we have data IPL 2008, 9, 10, 11, all the way until 16. We have 17 here on the left, 18 and 19. So as soon as I look at it, I wouldn't have to struggle anything at all. I can see that in the year 2013, the graph is at its highest, which means the maximum number of cricket matches were played in IPL 2013. It was somewhere around 75 matches or 80 matches around that, right? So it took me 1 second to look at that data and give you the output. Next, when we take a look at which is the most successful IPL team with the data that we have at hand here, again, all of this is based on the data. I do not know if this data is true to its real life form, right? So here it shows that, Mumbai Indians have been the team which has won all of these seasons. They have won maximum number of matches till now. If you take a look at 768 matches, if you ask a question saying, okay, so who won maximum, and can you arrange that in descending order, that is exactly what we've done. Below MI, you have CSK with Chennai Super Kings, you have KKR, RCB, Kings 11, Punjab, and all of these guys who have won smaller and smaller amount of matches compared to the number one person on this list, who is Mumbai Indians, right? Again, it took 2 lines of code. All we're trying to find is the count of the matches that they've ever won. Take a bar plot and arrange it in descending order, and it is literally it, right? So see how much fun is EDA to work with, guys. The next thing we're going to take a look at is a very interesting concept. This usually happens when you play cricket, or when I see the kids on my street play cricket as well. They think that if they win a toss, there is a huge advantage to win a match. It may or may not be the case based on the pitch, based on the stadium, or whatever it is, or I do not know, right? In that particular case, we have to see what is the probability that a match was won if the toss was won. Conditional probability, right? So let's take a look at that. So it so happened in 393 cases that when the toss was won, the match also was won. But in many cases where the toss was not won, or it was either, basically the match was not won even though the toss was won. That is what false says. True talks about how the match was won because of if the toss was won as well. So if I want to neatly print it, instead of just showing you this, if I print it nicely on a graph like this, if I plot it and say, hey, it is true in how many cases? It is true in 393 cases that the toss helped people win, or it is also true that in 363 of these matches that even though a person might not have won the toss, that they might have won the game or something like that, right? So that's an important thing you have to realize. Right, now basically with this line of code, all I'm trying to do is print more number of rows rather than just 1 or 2 rows. You're going to see what I mean by that. So we have to find out now is the highest number of wins per team per season, right? So as soon as I go on to run this, it will give me an output right from the first season, arranging it in a descending order, telling me who are the people who won those seasons, right? So see, in 2008, Rajasthan Royals won 13 matches, Punjab won 10, Chennai won 9. All of these in IPL 2009. Delhi won the maximum runs in 10. Mumbai Indians won 11. CSK won 12. KKR won 13. So you can see. So if I had not done this higher row width, it would just give me 2 or 3 rows and say it's done. Now I have access to the entirety of the data, and that is the thing that I've said here. I've said, hey, even if I have 10,000 rows of data, you please print it. Even though I have 400 columns of data, you please print it, right? That is exactly what I am doing here, and you can see who won maximum number of matches in that particular season of IPL. Right, guys. So the next thing that I am going to print is to find out what is the toss decision which happened over all of these years. What is the, see, tossing a coin in probability, as you checked out, is it has probability and randomness associated with it, right? So in the 700 and whatever times we tossed a coin, the umpire tossed a coin, 463 times people chose to field, and 293 times captains chose to bat first, right? So this shows that maybe if you field first, there is a good chance that you might win, you might analyze the opponent better or something like that, right? So that's an important concept. The next thing we're going to take a look at is who is the person who has won player of the match or man of the match in one matches, of course. So as of what I know in cricket, once you win a match, from the winning team, there is one person who is selected who becomes a man of the match. In basketball, it's usually called as MVP, or the most valued player for a season or something like that. But here again, take a look at it. Highest to lowest is what we are printing, right? Let me quickly scroll up since it's printed the entire thing. So Chris Gale, Christopher Henry Gale, I've been to a match where I've seen this person hit a 6 and, I sort of caught the ball. I mean, that's a different story. So here basically this person has hit, has a record of having 21 man of the matches award. Then you have AB de Villiers who has 20. Then you have RG Sharma who has 17, MS Dhoni with 17, Warner with 17. All of these data, again, I do not know if they're correct or not. But as per my data, as per the questions I'm asking, I am receiving beautiful answers, right? So that is what adds meaning to all of these data, guys, right? And the last thing that we're going to check out is to find out in which city were the maximum number of IPL matches ever played. So as soon as I want to hit this, all I'm trying to do is find out find out the count of individual cities, find the maximum of it, arrange it in descending order, and my answer is there, right? So there are 101 matches which took place in Mumbai, Kolkata, Delhi, Bangalore. So these top 5 places have been extremely popular from IPL 2008 all the way to IPL 2019, guys. So this is basically telling you that there is why are people preferring to play in Mumbai? Is it because of the matches? Is it because of how later down the line people started dropping off from the tables? Whatever it is, right? You can analyze 10 different things with one result such as this. This is the beauty of EDA, guys. So this is how we can go on to work with exploratory data analysis. It is a very simple IPL data set that we worked with, but when things get complex, you can go on to learn more and more and more, and it is so much fun that if you ask a question, you can look at your data and pick up an answer by processing something in that data, right? That is what makes EDA so much fun to work with. It is I'm trying to portray it in a way where it's fun to work with because you guys are getting started with it, but understand this, it is extremely powerful. It is used by individuals, MNCs, startups, thousands if not millions of companies across the globe. So it adds a lot of value to these companies, and that is the reason why they go on to use this, guys, right? So guys, with this, I hope exploratory data analysis was clear to you all. You have reached the end of this module. See you in the next one. So hey guys, welcome to module number 8. In module number 8, there is one important thing that we're going to check out, which is data visualization. Now, over these previous modules, I have told you the immense amount of importance that data visualization adds, right? In the entire field of data science, what usually happens is people do not get to understand certain complex data. To simplify it to a certain extent, we use this. So let's check out what all we have planned for you in this module, right? Now guys, I'm going to be covering the following things. I'm going to start out by giving you an introduction to what data visualization is, why it is required, and of course, it is vital that you know the top libraries in Python because you yourself, of course, we're going to check out all of these practically, but you yourself should know all of these at the end of this module, and it has to be at the back of your head because it adds an immense amount of value to your learning, right? Now, after we go on to check out these libraries, as I mentioned, the importance of them, the next thing that we're going to be discussing is the important visualizations that you have to consider. Now, when we just say data visualization, it is not a one solution catered to all problems, right? So there are various visualizations which we'll be using for various situations. We're going to check out all of that. I'm going to explain the working to you, and of course, everything that we check out right now, we're going to head to our playbook, our playroom, and eventually we're going to check it out all practically, and it is all very simple code, and I'm sure you guys will appreciate visualizations as much as I do. Right guys, let's get started right now, right? So introduction to data visualization. Ask yourself the first question here. Why do you think data visualization is even required? Next, we're going to talk about data science, right? See, why it is required is a section on its own, but as I've mentioned, the result of a data science output in be it any domain, machine learning, deep learning, or any kind of a subdomain in the case of data science as well, the result that you obtain will not be understood by a non-technical audience generally, right? You have a complex data set which has 10 lakh entries into it, or you have a result which only is understood by a person who knows Python, who knows machine learning, who knows deep learning and all of these, right? Now, when you're working in an office, do you think everyone around you is a machine learning expert or a deep learning expert? The answer is no, right? Sometimes you have to take the solution to a client who will not know deep learning, or you have to take it to your stakeholders, your managers, your board members, and explain to them in a way that they understand this complex data, right? So you as a person should have the capability to take something really complex textual data and convert it into beautiful looking visualizations, guys. And in fact, even, here are some really fun things that you should know. The first thing is human beings, right? As human beings, we can comprehend and understand an image 3,000 times faster than reading text. How amazing is this? Now, this is one of the primary reasons why the film industry took off rapidly, way back, centuries back. But at the same time, you definitely have to know, you definitely have to understand the meaning, the impact it has, right? If you can convey something 3000 times faster, why would you not want to do it? Makes sense, right? Exactly my point here. The second point is that, as I mentioned, your data, your output, or wherever it is that you have to explain, whatever point of execution, it will not be understood by a person who might not know machine learning or deep learning. In that case, it becomes your duty to make sure you convey the information in a way which they understand, right? This is where data visualization comes into, the most important sector of data science itself. It so happens that even in real life situations where maybe you're looking at a sales team and the sales team is getting some data from an artificial intelligence model or a machine learning model, if you just send the output as it is, there's a good chance sales guys are amazing at sales, but I'm not sure if they're really well versed with machine learning. So it is my job to make sure that my machine learning model or deep learning model is presenting an output that is understandable and comprehensible by the sales team, right? That is one example where even in real life, everywhere around you, it does happen. It is not only just this example, there is hundreds and hundreds of examples, right? So eventually, if we are coming to have a discussion about the definition itself, what data visualization is and all of that, you have to understand that this is a structured process that we use to take input as our textual data, numerical data, character data, string data, whatever it is. We take all of these data to see if we can create graphs out of it, which are not only aesthetical, right? So graphs can be very boring to look at, or they can be very amazing with all colors, points, markers, and all of that, right? It is not only the aesthetics aspect of a graph that we look at in data visualization, but also the functional aspect of it. How good does it look and how well does it work? These two questions you always have to keep in mind when you're working for a data visualization solution, right? So if you have one graph, it's one solution. It could be that one graph is enough to, gather all, compress all of this data and give one concise picture. Sometimes you would need more than one graph. If you require more than one graph, it is usually called as a report, where a report consists all of these graphs and there are descriptions of each of these graphs, what they mean, what is the takeaway from them, and all of that, right? So it becomes very vital that you know how to take these reports, and eventually sometimes you have to put it out on an online media, right? Sometimes you have to put it on a website, a web application, and whatnot. So it becomes key that you create a dashboard. Now a dashboard is basically a website where you can see all of these graphs, and sometimes in the case of business intelligence solutions like we discussed previously, right, if your data is changing, your graphs can be changing in real time as well. That is the beauty of data visualization, and especially in the world of neural networks and the world of deep learning, where you want to track what's happening to your own program or code, sometimes with the help of graphs, right, it is very, very vital. It helps a lot immensely to rather not see just volumes of data and rather see a good amount of graphs where you can understand everything without having to spend hours and hours breaking your head about it, right? This is the importance of data visualization. But does it end at that? Is it only 2 or 3 reasons why data visualization has been so popular? The answer to that is no, because at the end of the day, it will give you multiple things which you thought which was not possible from a graph. Now, as you look at a graph, you can say, oh, okay, so my data said this is what the output is, we are done. No. It helps to map cause-effect relationships, right? Now, I'll give you an example which we've already discussed previously, right? So how do you predict the weather? Previously, if you went back 300 years or 200 years, to predict the weather, you would have to go outside, look up at the sky. If it's dark, if it's black, if it's full of, clouds which are like really dark in color, it means that there might be rain, snow, hailstorm, or whatever it is. If there was a blue sky, very clear sky, it's a hot day, there's absolutely no cloud in the sky, it would not rain as much, right? So a cause and an effect relationship are built here. The cause is that the clouds it themselves will cause the rain becomes the effect. To see if it rains or not on a particular day, you can use this cause and effect relationship to derive another cause and effect relationship between day and rain instead of cloud and rain, and eventually you can build relationships like this, which will give you a lot of insight, a lot of depth, right? So just convoluted layer inside layer, and the amount of insight you get is amazing out of it. Right. The next thing we're talking about is feature engineering. See, sometimes when you go on to visualize graphs, you will realize at the end, looking at the graph, saying, "Oh, okay, so if these three, variables are pointing out in a multivariate analysis situation, they're having a good impact on my output variable. What about a fourth one? What about a fifth one?" So this kind of a feature engineering thought, looking at more than, more amount of features that can add in value to your program, which you thought might not be possible, will definitely become possible if you explore the usage of data visualization in that regard, right? So you might be asking, is that it? The answer is no, because take a look at the third point. It helps in finding and mapping and removing outliers in the data. Now, I've already spoken about pre-processing multiple times in this full course video, but it so happens in many cases that sometimes there are outliers which you cannot see in a huge data set even with pre-processing methodologies. So there you might have to plot all of those on a graph and then work on removing those, because there you can visually see it, where all of your data are one side, but you definitely have points on the outside. So those are the outliers, right? So you decide if it's an outlier or not and eventually push out those values. If you do not, it'll be detrimental to your machine learning model, which will eventually learn things wrong and give you a wrong output, right? I've discussed this already. Next, the fourth point. The fourth point makes sure that your data is understood by a non-technical audience. We just discussed this, and this is a very important point. I want to emphasize on all of this because I do get asked a lot saying, is it that important that you have to make everyone understand your data? Everyone is subjective, but a non-technical audience understanding your data is very important, because if the client himself was a deep learning expert, why do you think he would come to you for work, right? So that is one thing that you always have to keep in consideration, guys. Now, the thing that we have to understand, a very, very important aspect here, is that there are multiple, data visualization libraries out there in Python and of course in other programming languages like R as well. But since we are championing Python here, and of course the entire world is championing Python for data science, I want you guys to understand the top data visualization libraries that exist. And again, if you already know this, take a second, pause the video, note them down, or of course put them down in the comment section saying that you know all of these. It'll just add a lot of value to your learning, and it just makes learning fun, right? So that we know what you guys know as well. So make sure to do that. And then of course, when you're resuming the video, here are the top 3 data visualization libraries which are extremely important in Python, guys. Now you might ask a question saying, okay Anirudh, so is this the only 3 Python data visualization libraries out there? The answer to that is an absolute no, because with Python, since it's open source, even you can create a data visualization library on your own if you choose to. But these are what you see, right? Matplotlib, Seaborn, Plotly, all of these are sort of intertwined with each other in a way where it gives you the complete functionality which you would require in creating a good data visualization. Not just one graph. If you want 100 graphs, you can do it. If you want 100 different graphs with 100 different styles, and for it to be equally functional and understandable by a non-technical audience, it can be done with these 3 visualizations: Matplotlib, Seaborn, and Plotly. And across the world, if you look at trends, there are numerous reasons why each of these libraries are considered. They are the best at what they do. The developers have put in a lot of time and effort to make sure that when you use this library, it is easier for you, to do it. So eventually it adds a lot of value to your learning, guys. So let's quickly check out Matplotlib. Among Matplotlib, Seaborn, and Plotly, Matplotlib is considered to be the world's #1 data visualization library if you're using Python. So it works in a variety of situations. That's the beauty of it. Do you want to use it in Python script? When you're scripting manually, if you want to use it, perfect, it works. Are you using any sort of shell command interfaces where you want to, again, print certain graphs? It works there as well. Do you want to use Jupyter notebooks like how we've been doing for a while now? Of course, it does work in a Jupyter notebook. If it works in a script and a shell, there's a good chance it works in a notebook, right? So that is an important thing. This kind of a diversity, helps you learn it in an effective way. The next thing is that when you are thinking about the graphs, the different types, the different varieties of graphs and charts and whatnot that you can put out with Matplotlib, the collection is absolutely huge. The literal number of, graphs that you can put out, the types of graphs are amazing, and each of them are very good at a single purpose, right? So you open up your dimension to a wide variety of, requirements that you can cater to in a very simple fashion. And the third thing is that whenever you're talking about graphics, whenever you're talking about creating an image or anything of that sort, the first question a technical person is going to ask is, okay, so how much of memory and processing power am I going to require to do this, right? Printing textual information will take certain memory, no doubt about that, but printing an image, printing a graphical entity will take exponentially more. So in this case, though, depending on how well Matplotlib is designed currently, it is actually very, very efficient in terms of memory. It is very good for processing power, and even if you can get away by using Matplotlib on a low power computing machine, which again, it will work absolutely fine. It might take a second or two to execute, but at the end of the day, it will work. That is the advantage. You do not require a really fancy, expensive system to run these visualizations, right? And the next thing we're going to check out is Seaborn. Guess what? Seaborn is a library on its own, which is eventually built on top of Matplotlib. So it extends the functionality of Matplotlib if you require, a lot more functionality than what Matplotlib can offer natively, right? At the end of the day, Seaborn's primary reason for being another amazing graphic library here or a data visualization library here is that it can be used with a high-level interface whenever you're plotting any sort of statistical graphs and all of those sort. So doing this will make sure your job as a person in visualization becomes easy, and at the end of the day you have a good amount of time working on your logic or whatever it is, rather than breaking your head about data visualization, right? Okay, next, the second point. The second point talks about how Seaborn works amazingly well with data from NumPy and Pandas, right? Now, we've already discussed NumPy and Pandas to a good amount of detail using this data. Now, once you have NumPy and Pandas data, you cannot say, hey, my visualization library does not support that, so let's convert it into something else. All of that is not there here. As it is, whatever data is thrown out by NumPy and whatever is the data structures, series and data frames, whatever it is, with the Seaborn library, there's a good chance that you can directly use it without having to manipulate it a lot. This again saves time and efficiency, right? Of course, when you're taking a look at the third point talks about how you can plot certain functions over your data. You can work with your data set effectively. In many cases, using and learning with all of these data sets becomes easy if your library makes it even more simpler than a generic solution, right? So that is how Seaborn actually works. It simplifies an already simple solution to make sure that you guys can learn it all quickly and work with it effectively, right? Okay. Now, the third one that we're going to talk about is Plotly. Plotly is basically a web-based toolkit that is very, very popular, again in the case for data visualization. It has three very important points that you should know at this moment in time. The first point is that it provides amazing APIs to work with. This makes sure that you can tie in your program here, get the result out of it without having to break your head about interfacing these two entities, right? The Plotly library and whatever it is that you're trying to visualize. So the second thing here that you definitely have to think about is how there are supports given for 3D visualization and 3D plots. 3D visualization and 3D plots just take data visualization into a whole nother level. But until you get to a good amount of complexity, there's a good chance that you guys might not be using it. So eventually overwhelming yourself with a 3D visualization as of now is definitely not recommended. But what you should be knowing is that with Plotly, you definitely can do it. Even with Matplotlib and Seaborn to a certain extent, you can work with a couple of plots to make sure it looks like 3 dimensions or it has 3 dimensions itself. And in a concept called as contour plots are these entities which are notoriously difficult to map, but the results they give is very beautiful to look at and highly functional. Those can be used here as well. I just gave you one example. There are many things that Plotly can do better than Seaborn. There are many things that Seaborn can do better than Plotly and Matplotlib, and of course Matplotlib in its own nature can do multiple things better than all the other two as well. So that's an important thing, you guys should know as well. Right. Now, we are coming on to a section where we will be discussing the important visualizations that exist in the field of data science, right? There are hundreds of visualizations that you can put out if you're looking to the extreme depths of it. But out of those 100, 5 or 6 or maximum 10 of them are extremely popular in a way that you definitely have to know all of these guys. So I recommend you have a pen and paper ready so you can take down certain important points of all of these. And after we go on to discuss this, right, we definitely are going to check them out practically so that you know what we are dealing with as well. So theoretical learning plus practical learning is what we here at Great Learning stand for, and of course we're going to take it that way to make sure you guys can learn it in a simple fashion. Right. Now to talk about the important visualizations for data science, there are so many as I mentioned, but I want to discuss 6 important visualizations with you. So we have bar plots, we have the pie charts, we have histograms, box plots, scatter plots, and of course the strip plot as well. So these 6 are the ones that we're going to be checking out theoretically and practically, guys. Now, wait, let me actually go back before we discuss bar plots. Tell me if you have actually worked with any other visualization. It doesn't have to be in Python. There's a good chance that you might have used a pie chart in your school or college or sometime then, right? Histogram is very familiar for photographers because again, while editing it, that becomes a very important component. Box plots is used for statistics. We checked this out in the previous module. I want to revisit it again because it's important. Scatter plot and strip plots again give you a beautiful looking visualization, yet so much data with it as well. So guys, if you know any other visualization which you think are important, head to the comment section and do put it down there so we know again what you are looking towards as well. Right guys, now taking a look at bar plots, right? See, bar plots, as you can see on your screen on the right side right now, is what a bar plot looks like. It is a very beautifully aesthetically pleasing entity. You can select all the colors, you can work with multiple things, and it is mostly used in a case where we have to show that there are certain numerical changes whenever we compare it to categorical labels, right? See, a categorical label can be something such as height of a person when you're taking a look at age, right? You can put a student's name, for example, and map their particular age as well. Or consider the age of common students, like maybe just take the case of class 10 students, try to map the age of all of these, right? So there is a categorical element being that there are people from class 10 and the numerical value here is the age that you're going to map, right? It can be height, it can be age, it can be weight, it can be roll number, whatever it is that you want to do. Bar plots will definitely help you get there. Right now, even looking at a certain data like this, you can just say, hey, here's the height, weight and age of 3 different people. So using that, you definitely can show, the gray color is one person, yellow color is the other person, blue is another person. Of course, you can have 100 different persons if you choose to, but yes, that kind of a feature will make sure that instead of just looking at an Excel sheet with like 1,000 students with all the data of their age, height and weight and all of that, if you were to look at a graph like this, you can definitely pick it up rapidly and say, oh, okay, so this is the average height, this is the tallest person, who's the shortest person, who weighs the most, who weighs the least. If that is the kind of information that you're looking at, you definitely can get access to that with bar plots. Right. Next thing we're going to check out is pie charts. Pie charts are something I definitely remember learning in my school days way back, a couple of decades ago for sure, is that this is a kind of a thing that will show you there are certain divisions, right? An entire pie chart is consisting of 100% of the entity that we are in discussion. But when you take a look at a fraction of things that you have to discuss, pie charts are an amazing way to do it. Here again, we'll be comparing numerical values and categorical values and all of that. And see, for example, on your screen right now, you can see 3 numbers, 40, 40, 20. When you add all of that, you get to 100%, right? So that is showing the entire completion in one circle. But in those circles, each color shows a representation which has a categorical label given to it, right? Now, for example, think about a situation where 40% of the people like pizza, another 40% of the people like eating fries maybe as an evening snack or something, and then there were 20% of people who like to maybe get a fizzy drink or get a soda or something like that, right? When you think about evening snacks, now these are just random things that I just told you. It will apply to any different situation. If you want to think about pizza, now I'm hungry thinking about pizza, right? You can just say that there are three people and this is how much pizza each person ate. Two people ate 40% of pizza, and there was another person who ate 2 slices out of 10 or whatever it is, right? So you can find any sort of situations where you have to divide in fractions, and you can represent that easily in the case of a pie chart. That is the beauty of using a pie chart, guys. So after bar plot and pie chart, the next thing that we're going to check out is histograms. Histograms are extremely important in the case of data science because here, whenever we're trying to assess what a continuous group of variables are doing or values are doing, and we want to see their performance, their changes, or why, assess why they're changing the way they are, what is the result of these continuous variables changing, all of these, right? You can find out easily with the case of an histogram. When you're using an histogram, usually data is in a range 0 to 255, 1 to 300, minus 500 to plus 500. So this kind of a range makes sure that your histogram doesn't go out of bounds and that it works effectively, and the visualization that you get at the end of the day will add meaning rather than confuse you, right? That's an important thing. So talking about an example for an histogram, maybe think about how you can categorize people based on their age. Again, you can do it with a bar plot again, but at the end of the day, it's vital that you understand how you can do it with an histogram too, and knowing that you can do it is the first important point, guys. So you can think about any other example where you would want to map a continuous value. For example, if you want to map the changes of cost of fossil fuels, maybe the change in the price of petroleum, diesel, or whatever that is. Again, that's a popular usage of histogram that I have actually seen in petrol bunks near my place. They put up a chart to show that either the price went up, price went down, whatever that is, and all of these, right? So this is histogram. The next thing we're going to check out is box plot. Box plot is this very simple box with two lines that packs so much of an impact. It gives you a ton of information, which is, again, when you look at it as it is, you'll be like, okay, so what is it? But once you understand what a box plot means, like I've explained in the previous module, you definitely will know that it is just an expansive amount of wealth of information that you're going to get out of it, right? Now, as you can see, every single point here will talk about a data entity. For example, min talks about the minimum value you have in your data set, max talks about the maximum value, and of course you might have outliers on both sides of the data as well. It can go below the minimum, it can go above the maximum and whatnot. And then you have three important points: Q1, median, and Q3, right? So minimum to Q1 is the first quartile, Q1 to median is the second quartile, median to Q3 is the third quartile, and of course Q3 to the maximum value becomes the fourth quartile. And wherever you see this center, and of course all of these are not labeled all the time, there is numbers given in that particular case. In this, the minimum may be 1, the Q1 may be 5, median is somewhere around 11 or 12, Q3 can be somewhere around 25, maximum is 30. All these outliers can be 33, 34, 35, which you think make no sense with your data, right? So it's a simple thing, but once you understand it, you'll get to know everything: minimum, maximum, medium, the quartile range, and all of that. Once you have the min, max, Q1, median, and Q3, you can find out the interquartile range as well, and you can start reverse engineering statistics out of a chart as well. That's the beauty of box plot. So guys, it is vital that you know this. Next, we're going to talk about scatter plots. Now, scatter plots are very, very vital for machine learning. They're beautiful to look at. Just take a look at your screen right now, right? It is amazing that you can have and work with visualizations like this. It is usually very popular whenever you're taking a look at two numerical data points that you want to compare, side by side, or usually this becomes a result. A scatter plot is the result of what happens, when you plot a regressor line, right? Again, we've discussed linear regression in the case of the machine learning module. So once you plot what happens in the regression process, the eventual result is usually plotted very well and understood very well if it's done using a scatter plot, guys. That's the important aspect of things here. You might understand saying, okay, so can you give an example where what you see on the screen works? In that case, think about the number of clothes that you might wear based on the temperature around you, right? If it's 40 degrees, 50 degrees, you would be shirtless, you would be wearing very thin clothes, clothes that absorb moisture, your sweat and whatnot. And maybe if you're sitting on a mountain or if you're hiking in the Himalayan ranges, temperatures can hit minus 15, minus 20 and all of that, right? So there you'll be packed and stuffed with thermal wear, fleece jackets, outer jackets, and then, just you'll be stuffed to make sure your body can maintain temperature, right? If you want to plot both of those, that in the summer, these are the number of clothes I wear. In the winter, these are the number of clothes I wear. At the end of the day, it's a beautiful usage of a scatter plot as well, guys. So for the first important thing here, you're supposed to remember is that it's important for machine learning. The second thing is that it's aesthetic, beautiful, and really functional at the same time, right? The next thing we're going to take a look at is the strip plot. So strip plots are very, very similar to the usage of scatter plots. So what happens in the case of scatter plot is that we're going to be using two numerical coordinate labels, right? Temperature in winter, temperature in summer, and all of that. In the case of a strip plot, one of the values will be categorical in nature, while the other one is numerical in nature, guys. So when you're thinking about an example, think about maybe the amount of sales that happen on a particular day, right? Sometimes on a day, your sales might be amazing. On the next day, the sales might have dropped a little, and each dot you see there may be an individual sale, sale for a week, sale for a month, or whatever it is, right? So you can see total bill is what is given on the y-axis, day is given on the x-axis. So on this day, you just sold 10, 20, 30, 40, you sold a product maybe which are worth these amounts. Total bill was somewhere in the 40, total bill was 50. So each of these dots represent a single bill with the worth probably shown on the y-axis as well. Again, this is a very simple example. You can find numerous examples in the case of strip plot. It is used very popularly, and if you're a person who is looking towards data science, you definitely require knowledge on strip plot, guys. So I hope all the plots that we discussed theoretically until now, you guys are clear with them, because the next concept that we're going to look at is a little different from the graphs that we have taken a look at, right? So now all the graphs, let me just go back: strip plots, scatter plots, box plots, histograms, everything we've just looked at is a graph. The next one we're going to look at is sort of a graph as well. It's called correlation. Now, correlation is one of these beautiful things that will eventually, it's like a matrix, but it's a colorful visualization of a matrix that will give you the interdependency between two variables, right? Let me show you one important use cases. Here you can see pregnancies written, and again on the x-axis you have seen pregnancies written. So what is the relationship between pregnancies and pregnancies? It is literally equal, right? So it has to be the brightest color possible. It's the same case with all the other elements, hence the reason why you see these diagonal elements to be maximum correlation or white in color, because you cannot differentiate between two exactly same values and say they're different. In this case, it is not possible, right? And then if you're taking a look at the dependency of skin thickness and pregnancies, well, it does not relate a lot as is what we can obtain from our data, because at the end of the day, you can see that there is black here. Black means that there is 0.0% correlation, that this data does not relate to the other data and have an effect on the output as well, right? So this is a very simple thing. So we've already done multivariate analysis in the case by using diabetes prediction. Just think about the same thing here, and that kind of a correlation, it adds a lot of value. We explained it there as well, and I'm repeating it enough to make sure that you guys are clear with all of these concepts, guys. So I hope you understood all the plots that we've used. I made sure to take examples to help you guys understand all of them. There was a simple demo visualization there as well, and all of these is eventually theoretical learning to get you prepped for the practical session that we're going to check out, right? So guys, let me quickly head into Google Colab, and as always, the Google Colab is the Python Jupyter notebook that we're going to be using throughout this course. So I'm going to go there. We're going to check out all of these plots individually and practically, and see what are all the nitty-gritty things, the fine print that we have to understand to eventually use them effectively, guys. So let's quickly go to Google Colab and check them out. Right, guys, so we are in Google Colab. We're going to be checking out all the different plots that we just spoke about, but the one important thing that all of you guys have to know about is the order that we use to work with any sort of code in Python, right? So the first step is the most important step. We are importing Seaborn and we are importing Matplotlib, right? So as soon as I go on to run it, Seaborn is imported, Matplotlib is imported. Then we're going to take a look whenever we're plotting line plots, right? So we're going to take a look at the fMRI dataset. fMRI set is a part of Seaborn. It basically talks about the data whenever you go on to have an MRI scan. It's a very complex thing which cannot be understood by a lot of people. You have the subject, the ID given to the subject, at what time point was there, what event, in which part of the brain, the parietal region it was taken, what is the signal that was firing from a neuron, possibly in that particular region of your brain. So it's a very complex data set, but we can simplify it by taking a look at data visualization. Right now, these are the first 5 elements of what our data set looks like. We have labels such as subject. Subject is of course the person, time point of when it was measured, event is talking about either a stim, or again we have another one which you're going to check out. Then you have region, what region of the brain, and what is the signal that was obtained from that part of the brain when scanned as well, right? So let's quickly plot a line plot by making use of time point and signal column data. Now time point is one column data, signal is another column data. So on the x-axis, what I want is I want time point. On the y-axis, what I want is this signal, right? So signal value versus the time point. Now as soon as I go on to use sns.lineplot, where x is equal to time point, y is equal to signal, and data is coming from the fMRI data set, I'm just telling that, hey, on the x-axis put all the values of time plot, on the y-axis put all the values of signal, and eventually show me what the plot looks like. Now as soon as I run this, you can see that this is a beautiful visualization, right? On the left, you have signal. On the y-axis, 0 is there. You have -5. On the y-axis, you have the individual time points and all of these. So this adds, instead of looking at this and saying like, okay, so I cannot understand anything. If you take a look at this, there's a good chance you can figure out that, hey, the minimum value of the signal was maybe -0.07 or something. And then your maximum value touched somewhere around 0.15. This was the time point at which this particular part of the brain was doing this thing. So eventually, medical experts can understand this definitely better than me as a Python expert, but that is the case, right? Helping people understand things better. Now it is in blue color. There's a nice this thing running out on it, so it looks great even as it is if I were to understand this. But is there any way we can add more value into this? Well, of course, you can add a color to it as well. You can use a different color to go on to map it. Now, sns.lineplot, x is equal to time point, y is equal to signal, data equal to fMRI. This is exactly the same that we actually use, but here we are adding another thing called as hue is equal to event. So we are adding a hue from another aspect of data to understand what it looks like, right? So you have Q and you have a stim here. You have the data coming in from the time points. Again, on the y-axis you have signal. So you are seeing a differentiation of data where you have a hue called event, and this event data is also being published here, right? So the event says stim. So you can see the changes that happen between that time point and that aspect of signal as soon as you take a look at the data set. And all we added was hue equal to event, right? Everything else is literally the same thing that we checked out previously. Now, after adding the hue, after understanding time point, signal, all of that, so maybe you want to add some styling, maybe you want to change what the lines look like and all of that, you definitely can do it. As soon as I go on to hit play, you will eventually see that, for example, the Q visualization that we're seeing, instead of just being a solid line, it's now dashed or dotted lines, as you can see, right? So if you want this kind of a differentiation to help you understand it better, or if you want to look at it in a different way, or if that is a requirement where a legend value is different, this is something that you are going to use, guys. Now, building upon this, there are even more parameters that you can try to go on to use. In this case, see, we are not being shown how many data points have gone on to make this graph, right? It just looks very smooth, and sometimes maybe 1 or 2 points you can get 1, 2, 3, 4, 5, 6. If you look at where the line changes a little, there's a good chance there's a point there. But why to struggle so much? Let us have our markers show us how the data moves, right? Now if you can take a look at this, Look at that. These are the points. From one point to the other is how the eventual graph comes into being, right? Now with Q, again, there's a different style. There's X and dashes. In the case of stem, we have just circles and a solid line. So this is something that you definitely should know about when we are using line plot, guys. To go on to use line plot, SNS dot line plot, where SNS is basically what we imported from CBAR, right? It's a pretty simple way to go on to understand line plots. Now, the next thing is, let us check out bar plots. But then in bar plots, as you can see, I've been importing a data set here, a very nice Pokemon data set. So let me go on to actually import it. And okay, perfect. So I already have it imported, all the data sets that we're going to be using further on to showcase the various visualization. If you're wondering about why I didn't import fMRI is a data set which is already part of CBAR. So I didn't have to explicitly import it. But in this case, we are working on the Pokemon data set. Pokemon, I think, was an amazing TV show when we were all kids. I definitely remember coming back from school and running from school, in fact, sometimes, to make sure I get home in time to actually watch it and all of that. It was a beautiful part of our childhood. So let's take a look and use that data set to see if we can produce beautiful visualizations by making use of what? Bar plots, right? So the first step is, as always, you have to import whatever is the libraries that you're going to use. In this case, Matplotlib and Seaborn were already imported. Here I'm going to be using pandas. Why do I need pandas? Well, pandas is basically used to read the data set, right? So in this case, pandas has a function read_csv, which will help in bringing together and importing the data set. That is done. The next step we're going to be taking a look at is to print the first 5 rows of what our data looks like, right? Now, perfect. Look at this. Abilities of the Pokemon. There's an ability called as Blaze. There's an ability called Solar Power, Overgrow, Chlorophyll, of each of these. Of course, if you know what Pokemon we're talking about, head to the comment section and let me know. There are multiple types of attacks: Dragon's Attack, Electric Attacks, and Fairy Pokemon. You have Dark Pokemon, you have Bug Pokemon, and all of that, right? So against Fire Pokemon, Flying Pokemon, Water Pokemon, what is the value of strength that each of these different? So every single row worth of data you see is a Pokemon. Again, against Poison Pokemon, Psychic Pokemon, Steel, Water, Attack, all of that, right? So what is the happiness? How happy is your Pokemon? Now, if we watch the show, we do remember 1 or 2 Pokemon which is always unhappy. They're annoyed no matter what their owners or their trainers do, right? So that's an important thing you have to know. So there's a lot of things. What is the classification? Is it a Lizard Pokemon, Flame Pokemon, Seed? How many has it been captured? How good is its defense? How much of experience does it need to eventually evolve or go into another form of evolution, right? Evolution was something that we checked out. You have Bulbasaur, Ivysaur, Venusaur, you have Charmander, Charmeleon, all these different Pokemon, right? Again, these are just little. I've just printed out the first 5, but we have an entirely huge data set that we're talking about. What is the index in the Pokédex? Pokédex is this identification device that they use to identify a Pokemon, and all of that, right? Even what type of attacks they have, what is their weight, what is their generation that they're in, Charmander, Charmeleon, Bulbasaur, all of those things, right? Then you have if it's a legendary Pokemon or not. If it's 0, it means the Pokemon is not legendary. If it's 1, it means that yes, it is a legendary Pokemon, right? Now, to understand and ask, this is an addition to the data analytics module. You can consider it for sure, because here, if there's a question that says, okay, so what is the speed of the legendary Pokemon that we have to find out when you compare it to non-legendary Pokemon? Again, SNS that bar plot where x-axis we're talking about if it's legendary or not, y-axis is the average speed. Data is picking up from our Pokemon data set, and when you hit plot.show. So here you can see 2 bar plots, right? First of all, x-axis is talking about if this Pokemon is legendary or non-legendary and the speed. Now, as soon as I look at this, I can find out, okay, if it's a non-legendary Pokemon, its speed is somewhere around 60 kilometers per hour maybe, but if it's a legendary Pokemon, it is way higher. The average of all of these legendary Pokemons is way higher than what is available for the non-legendary Pokemon, right? It took me 2 seconds to find that out rather than look through 1,000 row data set. The next question we can ask is, okay, so instead of speed, can we check the weight? Do legendary Pokemons weigh heavier than non-legendary ones? The answer to that is an absolute yes, because as you can see, non-legendary Pokemon weigh comparatively very less, and legendary Pokemon are huge in their weight and size as well, right? So this is an amazing thing. Again, it took us 2 seconds. It's literally one line of code that is showing us and giving us so many insights, right? That is the beauty of data visualization. The next thing we can check out is, let's have the same thing. If X is legendary, Y is equal to speed that we previously discussed, data is coming from Pokemon. Here, like how we did with the line plots, we're going to add a hue here. Hue is based upon the generation when you're trying to compare. So you're trying to give a color to the various generation of Pokemon. So here that you can understand so many things. First of all, on the left, you have non-legendary Pokemons. In that, you can see if it's blue, if it's a first generation of Pokemon. If it's yellow, it's a second generation. Green, it's a third generation. So the evolution of Pokemon and their individual speed for their evolution is plotted as well. And the same goes for these legendary Pokemon as well. So there's level 1 legendary, level 2 legendary, level 3 legendary, right? So even when they evolve, you can find out the average speed at which they travel based upon their evolution. For some reason, evolutionary Pokemon, as they evolve more and more and more, their speed comes down a little. But yeah, see, again, you answered one more question even though you did not have to, or it just gave you an insight, a hidden insight, right? So that's the beauty of doing that. Now, we've been checking out all of these different colors, all of these different things. Can we use custom colors will be a different question that you're going to have. The answer is an absolute yes. Now, if I go on to plot the same speed and legendary graph, is legendary versus speed, this graph, but if I add a color element there and say, hey, a palette, it's called a palette here in the case of Seaborn. If I call it as VLAG or VLAG as it's called, is basically changing the colors into a more pink and a light blue, subtle colors that you're seeing on your screen right now. So again, this is aesthetic purposes, or maybe you're a person who wants to see it everything in red. If that is the case, put color equal to red, and at the end of the day, instead of having a palette with different colors, it's just going to put everything on red and show it to you if this is what you require as well. This again shows what all is the things that you can do in the case of bar plots, guys. So I hope you understood bar plots. It's a very simple thing, and since with the case of Pokemon dataset, I hope it became more and more understandable by you guys and more fun. Right. The next data set that we're going to check out, and of course the next type of plot that we're going to check out, is this scatter plot. In the case of scatter plots, a very amazing dataset to use to train all of you guys is the iris dataset. The iris dataset talks about the varieties of petals and the sepal length of a petal, three different types of flowers, and gives you a lot of data about all of that, right? So let me actually print the first 5 rows of it and show you. See, if it's a flower, you have Setosa, and in fact, let's print the first maybe 20 rows to see what it gives us, right? As soon as you run this, you can see okay, it's all Setosa, for example, right now, but there are 3 types of species of flowers that we're going to be discussing here. So 3 types of species that we're going to be discussing are Setosa, Virginica, and versicolor as well. Each of these types of flowers has its own width in terms of petal, the length, the width of the sepal, the length of the sepal, and how it differentiates from the petal itself, right? So a lot of details can be obtained from all of that. So guys, as soon as I go on to hit click, we're trying to map the sepal length and the petal length based on the data, right? As you can see, again, all the parameters are literally the same. X talks about mapping values on the x-axis, Y talks about mapping values on the y-axis. Data is from the IE's data sets. As soon as you use a plot to go on to do this, it is just telling you that the sepal length is this for this particular petal length. This can be actually divided into 3 different groups based on the 3 different types of flowers that the data set has. But having the capability to point out each and every single flower and say, hey, this is what its sepal length is and petal length is something amazing, right? Now, instead of me running through all of these manually trying to break my head with the data, I look at this and I know easily what the sepal length looks like and the petal length is like, right? Perfect. But now, as you can see, everything is just the same color. It gets confusing to know what these 3 types of flowers are, right? So let's actually map it based on species and give it a different color. As I told you, there are 3 different species. You have Setosa, you have versicolor, and you have Virginica. Now, as you can see, all the blue colors has a sepal length which is not very big. It is from somewhere around 6 centimeters or whatever it is. Petal length is again very, very small. So the petals are tiny as, very, very very tiny. And then your versicolor where, okay, the petal length is also really good, the sepal length is amazing. And then you have the biggest of the flowers in our discussion, which is Virginica. Virginica are huge in terms of its sepal length and huge in terms of its petal length as well, right? So all we did is we added hue on. What did we add the hue on? What column did we add the hue on? Basically species, right? As soon as you add the hue, it is going to give you a legend, and of course it's going to color all the individual data points so that you understand it better. Amazing. The next thing we're going to add is, let's say if you want to differentiate between each of these flowers, if you want to add a hue based on the petal length, right? Now, if you add a hue based on the petal length, it will help you differentiate and understand it better. All these light colored ones have a very small petal length as and when it grows and grows and grows. When the color becomes darker, it means at the end of the day that, your petal length is changing. And as soon as I look at it, if I look at all the light colored things, I can know, okay, so the petal length here is very low. And as soon as I look at the dark ones, I'm like, okay, the petal length is amazing. So if that is an effect that you want to achieve, it is literally one word. You have to add hue and you are done. Previously, we added hue based on the species. So we got 3 different species, so 3 different colors. If you add the hue on a petal length, it is not 3 different petal lengths that we're discussing. It is a continuous variable, right? So here it just changes it based on the saturation in the color to make us understand it better, guys. So this was, scatter plot. I hope you guys understand it. Until now, we checked out line plot, bar plot, and scatter plot, right? The next thing we're going to check out are histogram, or as they called as disk plots. So in this case, we're going to be considering a data set. It's called as the diamonds data set. Now, if you're wondering about what diamonds data set is, let me print the data set for you to show you what it means. Now, whenever you take a look at a diamond, right, diamond is usually cut and polished. It has a carat value given to it. It has a clarity index. It has a color given to it. It has the size, shape, the price, the depth of color that you can see, or how well things are magnified on the inside, how good is the cut, because eventually the diamond's biggest thing is its cut. If it's cut amazingly well, it will reflect light way better and all of that, right? So as you can see, each diamond, each row of value you see here is an individual diamond. It has a carat rating. How is the cut? Is it just ideal? Okay, is it premium? It is good. What is the color that it's giving? What is the clarity it has? Depth, the price, the XYZ axis values to showcase its size and all of that, right? So this is the diamonds data set we have. Now, let us just take one column here. Let us take the price column here and plot an histogram based on it. Again, the syntax is very similar. SNS.dispLot diamonds of price. If I print diamonds of price, the plot that you're going to see here is something like this, right? So you have a function here that is showing your value as well, and you're actually getting the density too. So this is basically giving you density. As you can see on the left side, you have density, where how dense is that material compared to the price, and you're getting a functional value to go towards that as well. But let's say we do not want the frequency, or let's say we only want to print the frequency rather than showcasing our density, right? So in that particular case, if I just put histogram equal to false, so this is a histogram and a bar plot that you can see on the previous screen, right? If I just want the frequency curve, guess what? I just have to say histogram equal to false. If histogram equal to true, it is printing both the histogram and the frequency curve for us. So in this particular case, we just want the frequency curve and not the histogram, so we put hist equal to false, and the effect is achieved, right? It looks beautiful. The price, density, you just have one nice curve that is showcasing you what the frequency curve looks like. Now it looks very nice. Why not add some color into it, right? So we add another variable here. We add another parameter called as color, and maybe let's color it in green right now instead of having a blue colored line. Again, if we just put here again, instead of color equal to green, along with that, if you put hist equal to false, you'll just get the frequency curve. But just to show you that it creates two different curves for the frequency chart and the bar plot and the histogram itself, I just showed you that. Maybe you don't want green, you want red. Perfect. You can have red as well. So there is a lot of support for colors. You can make it really, really beautiful to look at if that is what you want to as well, guys. So the next thing, we printed both histogram and frequency curve. We just printed the frequency curve. What if we only want the histogram and not the frequency curve, right? So in that case, you just have to put KDE equal to false. If you put the parameter KDE equal to false, here you will only have the histogram printed, but no, frequency curve that gets printed for you. So that is one important thing that you have to understand. And the next thing, right? In fact, even if you go to the next thing, let me show you what bins mean. Now, as you can see, this is one data. You have 2, 3, 4, 5, 6, 7. So every single trough that you see on the top, it is actually a line that goes, right? It goes like this into the x-axis. Now, in that particular case, these are individual elements that are called as bins. Now, maybe this is just printing us 100 different bins of data, which is eventually getting confusing. So I maybe only want 5 bins of data, right? So if I just put bins equal to 5, as you can see here, see how well this looks now. So instead of it breaking the data into so many things, 0 to 500, 500 to 1000, 1000 to 2000 and all that, here it is just taking, hey, 0 to 3000 is one bin. Let us just group all the data and print it, right? So you have 1, 2, 3, 4, 5. Just 5 bins, right? If you want 10 bins, of course you can do that as well. If I just change bins equal to 10 and if I hit play here, well, now you have 10 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, right? So this will give you a better clarity if you want to zoom in and zoom out to understand your data from a bird's eye view is something that's very important that you should know about, right? The next thing we're going to check out is how you can plot it on a vertical axis. Now, we have always been plotting a histogram on the horizontal axis, right? We have been starting from the bottom and going top, top, top. What if we want to start it from the side and go on to do it sideways, right? If you have to do it from the sideways, it is possible. There is another parameter that you're supposed to use. All the code that we have checked out until now is very, very similar. You just have to add another parameter called as vertical. Put vertical equal to true and it will give you a bar, it will give you a histogram which is again mapped on a different scale. As you can see now, it's instead of horizontal, everything is vertical, right? So vertical equal to true means that, hey, give me my histogram and put it out in the vertical way where I would want to see it like this for some reason, right? If you want to do it, you have the option to do it as well, guys. So this is a dist plot. This is a histogram. You saw how we can go on to print just an histogram, just a frequency curve, both of them at the same time, and a lot more things as well, right? The next thing we're going to check out is a box plot. Now, box plots are really, really fun to work with. For this, we're going to be taking a look at the customer churn data set. So what is the customer churn data set? Let's print it out and see for ourselves. Right. Now, customer churn dataset talks about if you are a person who is willing to buy or use a mobile service or a phone service based upon a lot of factors that talk about the company itself, right? For example, you have a customer, this customer is a female, he or she is not a senior citizen, they are a partner, are they dependents? No, they want one phone connection, they do not have services right now, they do not have phones right now, you're giving them internet, you're not giving them online security, are you giving them online backup, device protection, technical support, are you giving TV over the phone line, are you giving movies over the phone line, what is the contract like, is it 1 month that you have to pay every single month to month, or you just pay once for 1 year and this person has phone and internet and all of that, do you have to print a bill all the time, or can you go paperless to save the environment, what is the payment method, do you have to send an mail with the check in it, or can you just pay it online and be done with it, all of that, what are the monthly charges, total charges, and if the person eventually bought the data set or not, right? So all of these you can try to predict if a person bought or not by again performing multivariate analysis here. So let us actually go on to use boxplot to plot churn and tenure to see if a person bought something based on the tenure, right? Now, what I mean by this, as you can see, is that the maximum number of people who bought the product, yes, right? So they wanted a smaller tenure. Now, if you go to 3 people and ask them, hey, you have to pay one amount which will cover the entire year, they might not have the budget or the finances to go on to do so. That is literally what is being showed here as well. As you can see, the tenure, if it is a smaller tenure, then people are likely to pick it up. If it's a larger tenure, it means that people might not be comfortable because they might not trust you. You might be new into the area. You might be a person who's giving the phone or internet services which no one has used before, so they don't know the reviews and all of that. So these people decline just because the tenure is long as well. So the person who's looking at it on the back end can understand, okay, so our tenure is long, this is the reason people don't want it, maybe let us reduce the tenure and have them on board, right? I answered a very important question there. The next thing is, maybe let us check out based on the internet services and the monthly charges that they're quoting, right? So if it's a regular DSL internet that they're using, the internet charges monthly charges are maybe the average, the median charges are somewhere around $60, minimum is $25, maximum is somewhere around $98, Q1 is somewhere around $45, Q3 is somewhere around $65, right? You remember the box plot that I showed you? This is exactly what we're discussing. Now, to analyze it, maybe for the people who used fiber optic connection, they are paying a lot more in monthly charges because they're maybe getting a better speed, they're getting more download and upload, FUP, the fair usage policy and whatnot and all of that, right? But for the people who do not want to opt in for an internet, well, they are literally paying nothing, maybe just a little bit of charges just for the phone line, but nothing for the internet, right? So you can see from this saying that, okay, there are people who definitely are using both fiber and DSL and people who are not using as well. The people who using the fiber optic are paying a lot more. That's an amazing thing which we just found out by taking a look at that, right? The next thing that we're going to take a look at is how you can plot based on contract. So all we are trying to change is the x-axis, y-axis values here, guys. Now, there are people who prefer month to month contract here. Then there's another group of people who love a longer tenure, right? A 1 year contract is going to be a longer tenure, a lot of days. And then you have another tenure which says, okay, you have to pay for 2 years and you'll be happy. People are there. That is the point to show this particular graph. Month to month, there is a good amount of people. The average tenure is somewhere around 10. For the average tenure of 1 year contract, somewhere around 45. The average tenure for 2 years of worth of contract is somewhere around 60, right? So people are wanting and are willing to use either one of these to understand what is popular. You can see the median values usually change in those. Nothing is at the center all the time, right? Because that denotes the line. This important line in the middle denotes the median values, right? The next thing we can print is how we can change the line width, right? Now the width of this gray color line that you see, maybe it's too small for you, so let's brighten it up. If we just set a parameter called as line width equal to 5, 5 is basically taking it from 1, the default is 1. If you put it into 5, this is what it would look like. If you are a person who wants to look at it better and understand it in a higher depth of clarity, this is what you would look at, right? So previously it was like this, the line thickness was very thin, it was at 1. Now if I do this with line width equal to 5, it just becomes bigger to look at, right? The last thing that we're going to check out is how we can plot based on our customized ordering on the x-axis, right? Now, if you can see here, line width equal to 5, until here, everything is the same, the code that we just wrote. The next thing is order equal to 1 year, 2 year, month to month. Here is where I say, hey, I do not want you to randomly print me an order. On the left, I want 1 year contracts. On the middle, I want 2 year contracts. On the right, I want month to month contracts. And that is how I want you to pay. Or that is how I want you to plot a graph, right? As you can see, it is showing that all the 1 year contracts and the tenures are here. All the 2 year contracts are here. All the month to month contracts are here. If you want to change them around, all you have to do is just change the order here, and eventually you are given with that different order, right? Customizing your order on the x-axis, guys. So this is something which you can do with box plots. Box plots are amazing. They are really fun to work with, and all of these things that we just checked out, let me zoom out, right? Line plot, bar plot, scatter plot, histogram, or what's called as the disk plot, or even it's the other one that we checked out is the box plot, right? So all of these add a lot of value to your learning, ladies and gentlemen. I hope you were clear with all of these. If you're not, wherever you are stuck, make sure that you give a second, and instead of just copying whatever I just showed you here, explore on your own. Use different colors, use different palettes, use your own data set to map different XY variables to see if you can answer a question. As soon as you plot it, usually you will have a question in mind, right? That's how I did it in 2 or 3 times. I looked at the graph and I'm like, okay, so if the evolution is decreasing, as the Pokemons evolve, the weight is maybe decreasing or their height is decreasing, whatever it is, right? So I answered a question even without asking it. That is the advantage with data visualization, guys. So make sure you spend a good amount of time with data visualization. Right, now coming to the section where we discuss of how you can learn data science online, guys, it becomes extremely vital that you take it slow, keep it in a structured way. Do not be overwhelmed with all the content that you see. Now more than ever, it adds an immense amount of value for you guys to definitely take a look, talk to experts, visit the sessions, courses, everything built by experts. You're watching a session created by a Python expert, a data science expert as well. So at the end of the day, talking to us will make sure that you learn it in a better way. We keep all these things in mind when we create these kind of free courses for you guys to learn. At the end of of the day, you having structured learning is very important. If you do not, there's a good chance you might quit learning, because things can get complex later, as I've been mentioning, right? We keep all of these in mind to make sure you guys get the best learning experience possible, guys. Right. So coming to the section where we're discussing about free content on data science, you already know Great Learning Academy. We have the Great Learning YouTube channel. Make sure to subscribe to it, and we have Great Learning blogs for all the people who are willing to learn and use blogs to learn as well. With Great Learning Academy, the immense advantage is that you can enroll into courses for free, you can learn courses for free, and get a certificate of completion absolutely free as well. So you can, right when you land on the Great Learning Academy page, all the way till you exit where you have a certificate of completion, it is free, guys. In fact, let me actually go on to Great Learning Academy to show you guys what I am talking about, right? So you can reach Great Learning Academy simply by searching Great Learning Academy, of course. Click on the page, and once you do, you can see a lot of different content, right? We have 700,000 plus learners from 140 different countries. You have 1,000 plus hours of free learning content. You have 3 million plus monthly viewers we get on all of these sessions. For example, since we're discussing data science, we have 200 plus courses in total. In the case of data science, you can see you have multiple data science, multiple levels of learning, right? You have beginner courses, intermediate courses, advanced programs. These are in different languages as well. We have Python in Hindi, for example, if you want to learn that in Hindi. If you want to learn R programming, it is there. If you want to learn the basics of data science, right? Data science foundation, you can see it gives you 1.5 hours worth of content. You have a quiz as well. There are 11,000 learners who went through this. The skills that are covered are the analytics landscape, linear programming, hands-on exercises, and you have the entire details about the course as well. You have a complete syllabus that talks about it, and after completion, as I mentioned, since it is completely free, you get a certificate of completion given to you. This will add immense amount of value to your not only learning, your knowledge, but also to your resume, guys. So make sure you're checking out Great Learning Academy. We have multiple courses. If I just hit go back, if I'm just looking at all the data science courses we have, as you can see, I can just keep scrolling, and we have multiple different courses absolutely free. So make sure that you guys are checking them out, right, guys? With this, again, I have to mention all of these free learning materials will definitely give you an amazing head start, since we have put it out all in a very structured way to learn. But if you guys are very serious about your career, I highly suggest you to look towards the specialization and the post-graduation offerings we have here at Great Learning. We are tied up with numerous prestigious universities across the globe, be it Texas McComm School, Great Lakes, PES, Northwestern, Stanford, and other Ivy League schools as well. So we are tied up with some of the most prestigious universities where you can learn from the faculty, from the experts, expert professors in that particular college as well. So we have multiple post-graduation programs, certification training programs, MTech programs, MS programs, Masters of Science and whatnot. And for data science, it is not only just the 4 you see on your screen. We have a lot more. You can find all of these details on the Great Learning website, guys. On that note, you have come to the end of this module. I'll see you guys on the next module, which is again a very important discussion that we're going to have. Alright, guys, see you then. Alright, guys, welcome to module number 9. Now, as the name states, deep learning is such a fascinating concept that all of you guys should definitely know about if you are considering a career in data science. Now, even though deep learning forms to be, in the way of getting towards artificial intelligence, it is a destination that you have to get to before you have the product, which is at the end of the day achieving artificial intelligence, right? Being a goal of data science. To get there, you have to know this particular module, guys. There are so many things we are going to talk about in the case of deep learning. There's multiple things which you guys should know about. So let's get started with it. Let us understand this very important module of deep learning. But then, guys, if you already know what deep learning is, take a second, pause the video, head to the comment section right now and just type it out and let me know what you think about deep learning, right? We can have a conversation, of course, in the comment section. And if you have any questions at any point of time during this full course tutorial, make sure you're putting down your queries in the comments of this particular video. I'll be more than happy to answer them. Right, guys. Now, if you are curious about what are the particular takeaways, at least in this particular module as of now, we are going to be covering, an introduction to deep learning first. It becomes very vital that you know what we are trying to achieve with this domain, right? If you do not know what the goal is, then it doesn't make sense to even know why we have to use it. So I'm going to give you the goal first. I'm going to try to tell you what, we are going to achieve. Later, the curiosity is going to build saying, why do we require deep learning for this? Can't it be done using anything else? Or what are the practical applications of deep learning and all of that? As you can see, I am going to be answering all of that as well. And then, deep learning in its name itself sounds very, very similar to machine learning, right? Machine learning, deep learning and all of that, but you have to understand there is a good amount of difference that exists between these two concepts. Now again, I'm going to be talking about this in depth when we get to the session, but right now it is vital that you know that there is a difference that exists. It's a very important difference, and that you will get to know when you finish learning this module. Right, guys, the next thing we're going to take a look at after that is we're going to be checking out certain important deep learning use cases that we have around us that are revolutionizing the world as we speak of it. Now, as you can see, with every single module, we have taken an approach where we cover theory, where we cover practicals as well, and I'm giving you real life applications of it too, right? That real life applications should be, piquing your curiosity in a way that you would want to find out more applications. So when we come to that section, we're going to check that out. And lastly, in this particular module, we are going to be discussing the top libraries that are available for deep learning when you go on to make use of Python, which of course is what we are doing throughout this course. Right, guys. Now, without further ado, let us actually dive right into the introduction to deep learning to understand what it is. Again, if you know what it is, head to the comment section and do put out your views on there. We can have a conversation there as well. But to tell you about this domain itself, let us start with a quick did you know. Now, deep learning is such a fascinating concept that I was, many years ago when I started my career, and even before me starting my career when I was still studying, this concept came to be told to me by one of my professors, where I had to research about it and put out a thesis on deep learning. Now, in that particular case, I did a lot of research, and this domain was so fascinating that ever since way back during the college days till now, I have been hooked onto this domain. It's my favorite domain in the case of, in the case of data science, which of course, again, a lot of people agree with me. It's the gateway to artificial intelligence and all of that, right? So I'm sure you guys will appreciate this as much as me, right, guys? So the first point that we have to discuss is, this is a concept. Deep learning is a concept where I told you that we're going to get towards artificial intelligence, right? What I mean by that is actually that we're going to take machines, train them in a way where their thinking, their behavior, and the output that they give when we furnish it with an input is going to be very similar to what a human being would do. Now, to do that, it takes this kind of a human-like thinking approach which you have to impart to your machine. Now, me and everyone else who are watching this video, right, human beings, and of course all the algorithms and all the artificial intelligence models in the back end of the video platforms that you're watching this as well, you have to realize that as human beings, we have billions of neurons which are like supercomputers on their own, and there is a connected network in between all of these neurons which make us the being that we are, right? Our conscious is the experience that we are living in. Now, to take these power of billions and billions of neurons and to make your computer understand it, which at the end of the day your computer can only understand zeros and ones to its fundamental level, as I've been explaining, it is a very tough challenge. But these days, with the amount of data that we have, with the immense amount of algorithms and computing power, we can combine all of this together and make sure that our machines can behave as humanly as possible, right? So that is one thing you're supposed to know. The second thing is deep learning is used literally everywhere around you, even though you might, not be aware of it. If you're watching, a video on an online platform, there is a lot of AI related models working there. Are you using social media? I'm sure, all of you, if not most of you, would be using one form of social media or the other. Well, deep learning algorithms are at play there, even though you wouldn't recognize it at first. And then it is not only this, right? It is as simple as you looking at your mobile phone, asking the Google Assistant, asking Siri, asking Alexa, Cortana, whatever are the new personal assistants we have in today's world, right? You are literally talking to your computer and your computer is talking back to you in a human voice. How amazing is that, right? That is what deep learning is all about. The output of this, the applications of it, as you're going to see, we will discuss, is extremely trending right now. There was a time when people thought, hey, you know what, you cannot have your mobile talk to you or order a pizza for you as well automatically without you having to do anything. Now all of that are a piece of cake. It can be done very easily, right? So when people said it couldn't be done, all the way to now that, hey, it's not really a tough thing, it can be done easily, the world has grown a lot in terms of how we can repurpose deep learning for other use cases as well, guys. So it's an extremely trending concept, and if you are proficient in this, your foundation as a person who's looking to become an expert in data science will be strengthened a lot. So I suggest you pay a good amount of attention to understand deep learning. So with that, you should have a question saying, okay, what exactly is deep learning, right? Deep learning is one of these subsets of artificial intelligence. Now, artificial intelligence is an application of data science, right? It's a domain in which we use this subdomain or the subset to get us to a solution. Right now, in AI itself as a subdomain, inside it we have machine learning and deep learning. Now, machine learning is a simpler version of deep learning, but the differences don't end there. We are going to discuss about it because the working is extremely different in these both cases. But as of now, you have to understand that deep learning is a way that we train our machines so that they become sufficient, self-sufficient on their own in terms of learning and giving us a result which is almost human-like. Now, I cannot say 100% human-like, because if that was the case, then it would be very difficult for us to differentiate between a machine and a human being, right? We haven't gone to that extent yet, but we are getting really, really close to that point. Now, way back in the day, there was a test conducted called as the Turing test. It was named after the very famous mathematician Alan Turing, where he says that a machine can pass the Turing test if it can convince a person that the responses it gives is as human-like as possible. So the person on the other side of the test, if he or she cannot differentiate between the result given by a human being and the result furnished by an artificial intelligence algorithms, that is when that model or whatever is the entity in discussion has cleared the Turing test. Way back from the 60s until now, it has been an amazing feat that we are trying to get to teach machines to do it. It is not a new concept. It is not something that was born yesterday and that it is exploding right now. It is a very old concept, just that we did not have ample amount of computing performance to go on to process it then. But now that we do, it's going to be an amazing thing of how personally we can sit and teach the machines of how they can think on their own, how they can build logic on their own. We are logical beings, but the computers also have logic, yes and no, 1 and 0, multiple states, continuous values, discrete values. It is just that your computer does not understand and process emotions, nor does it have this complex network that is wired by itself, right? Of course, we are a product of evolution, and we are developing the computer to make sure that it can evolve into something better as well. So that's an important thing that you guys should know about. Now, deep learning is a name which comes from the fact that we actually use several layers of processing. Now, when we say deep, it means you have to go through a process, you have to go through multiple things to get to the depth of things, right? So your algorithm is going to touch the depths of what it can do, hence the name. Multiple layers on layers. It's called as a neural network. We're going to be discussing in depth about it in the next module as well, but for now you need to have an understanding of the domain itself. So this kind of a way of learning, where we use multiple layers of learning at the end of the day to give us a fantastic product which is very, very powerful and is amazing to use, right? That is deep learning on a whole, ladies and gentlemen. So as I've been mentioning right now, for a while, right? So it is an important thing you have to understand that we are trying to imitate human intelligence here. We humans are very, very, very intelligent compared to our computers right at this moment. Even though you might say, okay, there's the world's fastest supercomputer that can, compute things faster than a human being. I will agree to all of that. There was a time when, Shakuntala Devi, the person who was called as the fastest, the human computer, the human calculator, right? At the end of the day, we set new benchmarks which our machines themselves beat. Nowadays, of course, when you look at programming power and the processing of computers, it is definitely a lot more than what it was in the past, because even if you go back to the time when the humans landed on the moon, right, when NASA put humans on the moon, the processing power of the computer had somewhere around 0.001 MB of RAM. 0.001 MB. That's it. It's not even 1 megabyte. Today, the phone that I use, the laptop that I use, and of course, the machine that I use to work on, are powered with a maximum of somewhere around 64 gigabytes worth of random access memory RAM. 64 gigabytes. Right now, where is 0.001 MB and where is 64 gigabytes? Look at how much the world has progressed, right? Now is the right time to teach our machines and to make sure they understand everything there is to know about what makes us intelligent, right? Now, there are many things you have to consider when you are trying to get your machine to imitate human intelligence. First of all, it is our programming which goes on to teaching these machines, right? Now, usually a question comes into picture whenever we talk about deep learning and artificial intelligence is that can machines learn on their own, get more stronger than the humankind, and sort of attack us and all of that, like how it happens in these amazing movies that we have watched in the past, right? The thing is, as I told you, your deep learning model, your machine learning model, your artificial intelligence solution at this point of time is only as good as the programmer himself or herself. So at the end of the day, if you are amazing at your programming skills, it means that you are your program at the end of the day, or your model is working efficiently, so it cannot surpass your intelligence. Of course, there has been cases where cryptic texts have been passed through which we do not understand as humans, and we perceive it as something like, okay, so the machines are talking to themselves, something is going on. It can be a fact which can be debatable, but of course that's a different discussion. But for now, you have to understand that one particular thing, that your program is as good as you, right? One important place where we can get the machines to imitate human intelligence well is pattern recognition. Everything you look around you is a pattern, and that is what builds your conscious experience, right? Now, I am looking into my camera to sort of teach you guys on this. You are looking to your phone or your laptop or your TV or wherever it is that you are learning on. That is an experience, right? So there are certain patterns you know where to look at when you're learning. It's not like you're randomly staring at the wall and learning, right? You know what pattern you're supposed to know. You know what a square looks like. You know what a circle looks like, even to its most foundational level. That is the important thing here in discussion, ladies and gentlemen. And the fourth point, right? So in the case of deep learning itself, we take a little bit of machine learning, we complexify it. What is the word? We complicate it, and we apply so many different transformations to the existing machine learning solutions in a way where it becomes way, way, way more powerful than it already is, and that gives rise to and brings us one step closer to artificial intelligence, right? So using very complex machine learning concepts are an important thing here in deep learning as well, guys. So I hope this section was clear for all of you all. Now, let us actually talk about why we even require deep learning, right? Now, why we require deep learning is a question when asked to me, I can probably give you an answer hours and hours together to tell you why it is required. But, we can have a detailed discussion on the application of deep learning sometime else. But for now, to give you the highlights of all of these very, very important points, the first thing is we are generating an immense amount of data. You already know this, right? The world puts out somewhere around 26 lakh terabytes of data every single day. To handle this data, which is just adding on every single day, and to make sure that the data is available for further use and processing, we require more intelligence. See, manually, if you have to sift through maybe 10 lakh files which are full of data, physical files with papers in it, it becomes tough, right? You can take days, you can take weeks or months. A deep learning algorithm can do it like this, and maybe at the end of 5 or 10 minutes or maybe 1 hour, it has ran through 10 lakh documents and it knows what the documents are all about, right? Where is 10 minutes? Where is 1 month of hard work? That is an important thing you have to note. The second thing is that we are living in a world where autonomous systems are guiding us, right? Everything, from the most simple thing, you might have an AquaGuard or whatever is your water purification system, right? If you're wasting water, it usually shuts off the power supply, your camera, the CCTV system at your home, it can detect movement and it can take photos as and when people sort of move through, in case you have authorized it to do so. And planes have their own autopilot systems. Defense systems use a lot of drones and unmanned aerial vehicles, or UAVs as they are called, right? Things have become intelligent in a way where you really don't need as much human care, as much piloting, not only in the case of aircrafting but of course in other domains as well, to make sure that the job is done. There was a time when, of course, we're still living in that time where you have to drive your own car. But now we have come to a point, I'm sure all of you all watching this video already know that the systems we have, there are certain companies like Tesla, Google, and now even apparently Apple is developing a car, which I'm not sure of, is a fact that you should know that only thing that is stopping us to have complete autonomous driving is the law. Apart from that, the systems are here, they are ready to go on to do the driving for you. There was a time when cars would just back out of parking lots automatically for you, but now they can automatically take you from one destination to the other destination, do everything that you want to do. You can talk to your car. It is very, very intelligent these days, right? In this case, in the case of defense, for in the case of having robots to do a lot of tasks where human life is on the line, it's a very important thing. The third thing we have to discuss is how you can make use of large amounts of data to drive a good amount of information, right? Just the example that I gave you with the physical example of the files is exactly my point here, the third point. The fourth thing we have to discuss, which is very important, is how we can use iterative learning. Now, see, iterative learning is something that even we as human beings use. It is not a new thing for us. When you were in school, when you were in college, or even every day when you're learning something, right? Maybe you're learning to play badminton, or you're learning to code, or even you're watching this data science video to become, knowledgeable about the domain, right? If you just watch it once, yes, there's a good chance you can pick up all of the different things, but you can get more clarity if you do it 2 times, 3 times, right? You will not become a professional or an Olympic gold medalist the first time you probably play a sport. You have to give your time and effort to learn, to train, do the same thing again and again and again, that you remove all your mistakes and become efficient at what you do, right? That is iterative learning. Your computers also do the same thing. In the case of machine learning, again, in the case of deep learning, a common data set, your machine just runs through the data set, keeps learning. With every time it learns, there is some new insight that it picks up. It understands something new, something more than what it previously learned. Of course, in not in all the cases that it just keeps happening that if you train for an indefinite amount of time that your machines will keep learning. No, there goes until a point where it can learn new things. That is the key point in a discussion of why we require deep learning, guys. The next 3 points that we have to discuss talks about how immensely popular it is in all the domains, right? Self-driving cars, personal assistants, home security on your phones, social media, the TV shows that you watch, the music that you listen, the computers that you use, the search engines that take in the search entity element that you put on. Guys, again, as I told you, it is literally there everywhere. It is just that you have to find out. If you're ever confused about where deep learning is used in a certain domain that you think, quickly Google it out. If you're thinking about, hey, can deep learning work in finance departments? Can it work in the case of law? Can it work in the departments, or can it work in the domain of anything else which is not directly related to computer science, maybe arts, right? There is deep learning there. Trust me, there is. You just have to search and then you will find a ton of results, right? Now, the second point here, or the fifth point in discussion, a very important thing you have to understand is that we are a being where we want our lives to be more and more convenient, right? Now, we can also talk to our computers with zeros and ones, but we have to just type millions of zeros an hour or a day, which is not convenient for us to talk. So we want to use Windows, we want to use other operating systems like Mac OS, whatnot. It has to be as simple as possible. It has to be snappy. It has to make working fun for us, right? So we want convenience everywhere we go. Right now, I have a fan which is swirling some air in the room as well. So even that is convenience. We have a roof over our head, convenience. Nowadays, everything is talking about how you can make your phones convenient, right? There was a time in the past where if you held a brick and if you held a phone, it weighed the same thing. Nowadays, a phone is a pretty tiny thing which can fit at the palm of your hand. It can be a watch. Watches these days are millions, if not billions of times faster than the entire spacecraft that took humans to the moon, right? That's a fact. That is how amazing we have come through. So contributing to add more and more convenience to our lives is why people want to look towards these solutions, guys. It adds so much value for us, right? Now, deep learning is used in a lot of different places, which we are going to discuss in the applications section. But understand this, it is very, very popular for the usage of face recognition. As I told you, security assistance, parking assistance, and all of these are extensively used. Even though you might not be the person who is actively using all of these, but everywhere across the globe there's millions and millions of solutions which are powered by deep learning. That is what makes this domain fantastic to talk about. The next thing we're going to check out is the applications of deep learning. So guys, as we have discussed, there are numerous applications of deep learning, but let us check out some of the most popular ones. First one, which you might not know of, is real-time behavior analysis. Now, it is a fantastic thing to know about and understand if you're a person who is selling a product, right? Now, let's consider the case of fidget spinners, right? They became extremely popular. People who are young, people who are old, everyone wanted to play with a fidget spinner, and of course, I myself had one as well. To understand about if you are a person who was selling something like that, people will definitely talk about your product on social media, right? They're going to give you their views saying how good is it, how bad is it, if they liked it, did not like it, all of that. So there is a sentiment which goes into what they type, and computers today, your models in the domain of sentiment analysis, which can read a message and understand if the person is angry, happy, sad, all of these emotions which we understand, right? We can train a machine to understand them as well, cross-reference it with data that exists to see what your what your customers are talking about the product. Now, 3 guys might be happy about it, 4 guys might be really unhappy, they're suggesting changes and all of that. So you can use that feedback to positively have a difference on the life of your product, right? Maybe they're giving you important feedback which you can use to further develop your product, right? So this can happen even in real time, as and when people maybe take on to social media platforms like Twitter or something and they're putting their views on it. You can have a deep learning model here to analyze, assess everything in real time and to give you a score saying, are people generally happy with my product or are they sad? That is an important thing in terms of real-time behavior analysis. The second thing that we are going to discuss are symptom-based disease prediction, right? I am not sure if you know this, but medicine has really come a long way since the past, and now with the world of computing and medicine, it has come together in a way where doctors sitting on the other side of the world can monitor your parameters, they can suggest changes for you, and maybe look at your whatever symptoms that you might have, and then give you a medicine right from where they are across the world, right? Guess what? Of course, full credit goes to doctors because they are the experts in this domain, but computers are slowly catching up in a way where they can sort of look at symptoms, analyze what disease you might have, and eventually give you, a prediction saying, hey, this person might have this kind of a disease. It might be something very, very specific, very generic, like a common cold or a flu or whatever it is, right? So it has come a long way where I'm not saying that it will replace doctors, but it can assist doctors for sure to help provide a better solution. Right now, if there is something which helps the field of healthcare, I am very sure that the doctors are going to take a positive note about it. There will be time spent, millions of hours on research on it before it has been put to usage in a human life critical situation. But yes, it is possible. That is the important thing that you're supposed to know. The third thing is autonomous car functions, right? Now, I am a huge fan of this and I cannot wait for these autonomous cars to hit India, where, I definitely want to drive around in one of those in a way where, of course, even though it sounds very funny, like, how can you drive, and how can you sit confidently if your car is driving for you? But the technology that goes into it, the immense amount of processing and the way these cars learn to drive on their own, the autonomous aspect of it is something I absolutely love, right? You can check out multiple videos online of how cars can drive people around. It's already there in multiple different countries. These cars are there, they're on the road, they're already being used. Think about Tesla, right? Tesla is very popular for putting out these cars which come with a feature called as the autopilot. The autopilot can take you from one destination to another automatically. It can brake, it can turn, it can change lanes, it can do a lot of different things, right? Coming to the fourth point. The fourth point talks about data center security. As we discussed in a previous module, that if you are storing your data online or if it's in a database or wherever it is, there is always a risk that someone might have access to it, someone might misuse it, right? In the case, if you're storing your data with a reliable data professional, maybe think about Google's data centers, Amazon, Microsoft, all of these, their data centers are guarded in a way where, there is impossible access for you to go on to even touch the servers that are there which hold your data, completely barring you from physical access. First of all, is the first way to defend against any sort of miscreants or misuse of your data, right? That is an important thing. These 15, 16, 17, 20 layers worth of security that you have to clear to even go close to the server is all in a human way. But nowadays it is becoming autonomous to a fact that, we can have a computer do this job of screening a person, seeing if he or she has authorized access to have, that kind of a security clearance, move ahead and all of that. It is very intelligent, it is fail safe, and it is being developed in a way where it is doing a fantastic job in this domain. That is data center security. The next thing we're going to talk about is the server optimization itself, right? See, manually we have come up with methodologies of how we can store your data on a hard drive and in a server architecture. But nowadays we use deep learning algorithms to make sure it is effectively stored based upon their usage. Maybe there is some data which you're going to store which you might not touch for the next 6 or 8 months, and your deep learning algorithm already knows this. It has learned the fact that you might not touch that data, so it will store it in a place which would not require immediate access to it. It understands that it is on the back burner and all of that, but there can be some data which you need on a daily basis which can actively store on a faster hard drive or a SSD or whatever it is, right? So moving these data around based on your usage, I'm not talking about 1 MB, 2 MB, 1 terabyte. This is thousands and thousands of terabytes every day, right? So this deep learning algorithm will run through the data, understand what it is, understand how you're using it, and then store it in a way where if required immediate access, of course you'll get it, but it knows how to store it effectively. That is the important talk about server optimization. Considering we are putting out millions and millions of terabytes out every single month, it becomes very vital, guys, right? The next application is self-driving cars. As I told you, self-driving cars are already in use today, but to go on to teach a car to drive on its own, it has to have, first of all, a ton of sensors which it can use to get a sense of the environment around them, right? So we have a lot of senses. We can see, we can hear, we can smell, we can touch, we feel pain. All of these things are sensory things which tell our brain that, hey, there is an activity that is going on. But for a car to do all of this, for it to sense that someone is crossing the road, to know that it has to go in that, and it has to have some sort of image recognition to understand that it has to go on the road and not on the footpath, right? So there is a ton of sensors and processing which goes on in a very, very important way. As I told you, aircraft these days can be controlled from thousands and thousands of kilometers away. So there, a person sitting in his room can actually control an actual aircraft. This is usually very popular in the defense domain, but it is also trickling down to the commercial airspace domain as well. So in that particular case, again, another beautiful application, right? So in the entire automobile market, if you see that every day, it is not just Tesla, it is not just Google or Apple, it is just that everyone is looking towards coming one step closer to driving a better user experience, to giving you a sense that your car is more and more intelligent, right? Again, they're doing all of that by making use of deep learning itself. And if you look at cars these days, it will give you a personalized feel. As soon as you get into your car, you will realize that even though it is a commercially mass-produced car, that it feels very close to you. It understands you, it talks to you, it welcomes you, it sets your seat, your temperature, your steering height, everything, right? Maybe even your suspension preferences if you're a person who likes to drive really quick, of course safe at the same time, or if you're a person who likes a slow comfort drive, it can pick music automatically for you. It can turn the wipers on and headlights on depending on rain and outdoor lighting. Guys, the amount of personalization that can bring together a lifeless entity and give it this kind of a human emotion, that is an important thing you have to know here, guys. And the next thing, right, the last couple of applications we're going to discuss in deep learning talks about recommendation systems. Recommendation systems are absolutely amazing. I am a huge fan of this particular domain because we sort of use it almost every day, right? Think about Amazon. Let me give you an example. On Amazon, let's say there is a flash sale or whatever they keep doing where they're trying to sell products. You get a phone, you put it in your cart. Before you check out, there is usually a pop-up or something on the bottom side that says, hey, people who bought this phone also bought XYZ, maybe a tempered glass, maybe a case or something like that, which adds value to your original purchase, right? That recommendation, product recommendation, comes from the fact that the website or whatever it is that is displaying information on the Amazon's page is intelligent enough to understand that when people buy that item, a phone, they also buy a tempered glass or maybe a case, right? That is product recommendation. And you might think, okay, but I usually take one product, I buy it, I check out and I'm done. What is even the meaning or the validity of having a product purchase recommendation? You know that probably the co-founder of Amazon or Amazon itself as a business is grossing at number 1 or number 2 spot in the entire world, which is worth trillions of dollars, right? Now, Amazon themselves have said that 35% of their revenue that they sell on their website comes from product recommendation, guys. 35%, where a business is worth trillions. Of course, trillions, all the trillions are not on the Amazon sales thing, but think about it. It is still a huge number. 35% of a huge number is huge in itself, right? So it is adding a lot of value to, a lot of e-commerce sites. Amazon is just one name that I'm taking up here. Think about Walmart, think about Best Buy. Think about all of these guys who are trying to catch up and use as much computing power as they can to solve problems. That is the discussion here. The second thing is Netflix. Oh my god, Netflix uses a highly complex recommendation systems, which is making sure that you stay on their platform, you watch nice content, right? Just a few minutes back, I just told you about how personalization makes you feel nicer, right? Netflix is a platform where their goal is to make sure you watch more and more content. To do that, they go to extreme measures which are beautiful, at least for a person who's looking at it as a developer. Now, you might have a favorite actor, right? Maybe your favorite actor is Tom Cruise. Now, if you are a person who loves Tom Cruise, if you watched 1 or 2 movies of Tom Cruise on Netflix, It understands that you have a favorite. It knows, it has learned that this user watches a lot of Tom Cruise content. So what it does is, even if Tom Cruise is on another movie where he might be a supporting actor, he might have done a cameo, or he's just on the screen for a few seconds, the Netflix recommendation system is so intelligent that it can change the thumbnail of the entire picture, put Tom Cruise on it to make sure you click on it and watch it. That is how amazing it is. Changing these thumbnails based upon your favorite actors, making you want to click on it and watch it. That is intelligence, in my opinion, right? Of course, it's a good thing. It is giving you personalization. It wants to show you what you like, right? That's an amazing thing. The next thing is, maybe after you're done watching a movie or done watching a TV show, for a second you might have a crisis saying, okay, so this TV show is done, what do I do? But right the next second after the credits or the thing ends, it will start recommending you new TV shows and movies to watch right then. You might have watched a documentary, you might have watched a comedy TV show, whatever it is, right? Or a thriller movie or horror movie in that same domain itself, or using the same actors and the actresses. It will give you a recommendation which would make you want to watch the next thing as well. It is a brilliant thing, Netflix making use of deep learning, in my opinion. The third thing is Spotify. Of course, Spotify is one of these music streaming services which, again, I use a lot personally. So based upon the songs that you listen, it can automatically create a playlist for you, arrange them in the order of your liking based on how many times you've played it. Not only that, it will create playlists on its own, looking at the genres of music that you have listened to, what type of music, are they sad songs, happy songs, what emotions are evoked in you. It cannot be 100% accurate, right? So even a happy song can make me sad if that is the case, if it brings back a different memory, but it tries to a certain level to make sure that whatever it is that you're going through, your emotion, that there is a song that can be catered to it to soothe your emotions. That is a beautiful thing that these guys are doing as well. So be it Amazon, Netflix, Spotify, or millions of others who are using it, everyone every day is getting one step closer to making our computers and machines that much closer to us and giving us an amazing experience, right? Amazing. Now, in the next section, we are going to take a look at the prerequisites that are required for you guys to learn deep learning itself. So there's many prerequisites you're going to require for deep learning, but I'm going to give you the highlights of it and the importance of it. The first thing you're going to require is mathematics. The concepts of statistics, concepts of probability, concepts of calculus and linear algebra are extremely important. Mathematics govern these algorithms. These algorithms are used to teach the model. Data plus algorithms gives your model a purpose to use, and that model is used to solve a problem. You see that change that I just built right now? That is why you require mathematics. If you remove mathematics from it, your algorithms are no more intelligent. Your model does not understand what data it is seeing. At the end of the day, your goal is not being met at all. So what is the purpose, right? So mathematics is foundational for this learning, guys. The second thing you're going to require is programming. Of course, you might have seen, we have discussed a lot of things practically at this point of time. So programming is something which you are going to require. You require proficiency in Python or languages such as C, C++, R programming language if you're looking towards deep learning and data analysis and all of those. But yes, the point here being that you require a programming language. First of all, ladies and gentlemen, this is how you teach your machines. Your machines are as good as you and your program, right? So you effectively typing out the best logic, the most powerful logic, using the maximum amount of computing resources allocated is human intelligence, right? That is a point to be discussed here. The third thing is, today's world is very intelligent in a way where we use a lot of cloud computing technologies, right? Be it Amazon's web services, be it Microsoft Azure, Google Cloud Platform. We use a lot of different things. We have used GCP to a point where we have shown you all the demos on Google Colab, right? It's a free and an open source Jupyter notebook. Where do you think the processing power for that is coming from? It is coming from the Google Cloud Platform itself, right? So you have to know that you can use a lot of deep learning, develop systems right there, cater to custom audiences, provide customized solutions. even in the domain, you even using a computer which is probably sitting 10,000 kilometers away from you in a very well protected data centers, or Microsoft has gone on to put data centers even in the ocean as well, is what I've read. So yes, so you are talking to a computer which is underwater. How cool is that, right? So it's an important thing that you're supposed to know, and these three things form to be the most important knowledge, guys. If you have mathematics, you can understand the data yourself, you can drive statistical insights out of it, and your algorithms can use it to learn. If you know programming, you can develop and put out these algorithms in a way where it uses data to train and learn and understand something. After programming, if you have an output which is working really, really well, you can take it to the cloud computing platform and give it out to the world to actually solve the problem, right? You might be catering to a client who's sitting very far away or right next to you. It is possible to use the computing power, the resources, and whatever it is that you require to drive that solution. You might require maybe 150, 300 computers, very powerful computers to do it. You might not be able to afford buying all of these at once. Well, you do not have to buy them anymore. With cloud computing, you can just pay as you go, use as many computers as you want to drive that solution to see if it is worth. Maybe at the end of the day, you might actually buy it. But to get to that point, it is highly convenient, right? So if you buy 300 computers, it is not just you paying money, bringing it to your office and sitting. You have to cool them down adequately. Heat kills electronics. You have to maintain them. You have to make sure that all these softwares are upgraded. Everything. It's a huge headache to do things offline. And now that is the reason why people just prefer cloud, guys. That is among, I just gave you 5 or 10 reasons among probably hundreds of reasons of why people want to prefer cloud computing. So in the domain of data science as well, there is an amazing scope for that. So coming to a little bit of technicality of how the domain of deep learning itself works, right? How do you guys think deep learning works? Now, I've been giving you clues all until this point of time, but let me divulge it to you. The first thing is deep learning works based on iterative learning, guys. Iterative learning, as I've already mentioned, is how we humans learn as well. And the goal of deep learning is to make sure machines can learn like humans, right? So that is how we are teaching the machines as well. It sees a picture of a cat, it sees a picture of a dog, and if it's the first picture it sees and if it doesn't know what it's seeing, it'll be like, meh. The moment you start training it, showing it 100 if not 1,000 images of a cat and a dog and say, hey, all of these are cats, all of these are dogs, please learn it, and eventually you create a model that does it, at the end of it, it can say, oh, okay, so now I understand that this is not the only cat in the world that exists. Even if I see another image of a cat, I can understand it's a cat. If it sees another image of a dog, it knows it's a dog, right? Even in these motion sensor things that happen, maybe people, nowadays it's very common that due to the COVID-19 restrictions, you have to maintain a minimum distance between two people, right? 6 feet or whatever the distance is as per your country's guideline. There are machine learning models, and of course nowadays machine learning for image processing is slightly coming down because deep learning is way more powerful in that domain, where these deep learning models can assess if you have given that extra gap, if people are wearing the masks or not, right? The pandemic is not yet ended at the moment we are recording this particular video, so it becomes very vital to use technologies to make sure people are kept safe, right? So that is one thing. We make sure it trains and understands, and then it can provide beautiful solutions for us like this. The next thing is iterative learning is one part of it. The second part of it is hierarchical learning. It learns one thing, understands it completely. It uses that learning itself to build upon the next thing. It uses previous learning to go up and up and up. And at the end of the day, this kind of a hierarchical given with iterative learning methodologies makes it extremely intelligent and brings it pretty close to human level intelligence. That is our goal, and these are the things that are taking it there, right? That answers the question of how the domain works itself. One important thing is that in the case of deep learning, in 99% of the cases, the more the data the machine has access to, it keeps learning. It understands data better the more it does one thing again and again. So with every different level, it picks up new data. It knows something about the data than the previous iteration, guys. That is an important fact that you guys should know about. Let me give you an example to give you more clarity about how deep learning works, right? Think about this personal assistant, Alexa. Now, as soon as I say Alexa, of course, my phone wants to light up, and I have numerous products in my home which uses Alexa itself. So in that particular case, this is a personal assistant that can do everything. If I say, hey Alexa, turn the light on, it can turn the light on. If I say, hey Alexa, play this music, or turn on my home theater, whatever it is, it can keep everything ready. It can set the temperature on my air conditioner, open the door for me, and well, it can do a lot of different things. It can water my plants, right? There's so many things that I personally use this personal assistant Alexa for. So how does it learn? How does it understand? So we feed it with data. We say, hey, this is the requirement, this is what you're supposed to learn, and it knows a lot of different things. It knows the differentiation between when I'm speaking, it has to understand intonation, it has to understand that I am talking to that particular entity, it has to know inundations, right? For example, there might be certain commands that I give to Alexa which she'll follow only if I say it, not everyone else, right? She has to figure out that it is my voice that is coming, and once it figures out that it is my voice, the next thing it has to figure out is the content of my voice, right? All of that, if you just go on in depth and depth and depth, we can discuss so many things, but its basic nature of understanding our grammar, our vocabulary, of course it is not 100% there yet, and I'm sure the team at Alexa or any other personal assistant out there are developing to better their products, but the work is going on. It is intelligent enough in a way where it is fascinating to me at least, and I'm sure you guys can use some of these solutions yours itself. So having a common input, training on the current situation, and giving you a customized response based on this data and input is something that they are aiming for, and Alexa or Siri in fact is doing brilliantly as well, guys. So I absolutely love how deep learning works, and I hope with this now that you guys appreciate deep learning as much as me, right? So you go back to the second where I told you that we humans use billions of neurons to go on to learn things, and it's like a small tiny computer in itself. Well, in the case of deep learning itself, there's a domain called as neural networks where we use neurons as the foundational concept. A lot more detail about this is coming for you guys in the next module. But for now, you have to understand that just like how neurons work in your brain, where it stores certain information, it passes information to the other neuron, it processes it, multiple neurons work together to give a common output and all of that. We're getting our machines to do it for us in a very, very similar way as well. That's the beauty of deep learning, guys. So whenever you're assigned any sort of values into each of these neurons, that is when you have the capability to differentiate. Hey, there's neuron number 1, neuron number 2, neuron number 3, and all of that. So they get their own numbers. It's called weights and all of that. We're going to discuss this in detail in the next module, but for now you need to know we have the capability to discern and differentiate between one neuron and the other, guys. So there's multiple ways of how these neurons connect to other neurons around them, how they map things, right? So for example, if you're a person who's learning to play a musical instrument, for example, I am trained on playing the guitar, so my brain's neurons are wired up in a way where it knows how to play a guitar. Basically, since it knows how to play a guitar, I can play the guitar. That is how I hope that made sense for you guys, right? So these neurons connect to each other in a way where they have trained, they have learned, and they have retained that learning of me playing a guitar, right? So based on a lot of things called as transfer functions, node connections, activation functions, and all of these, we get our deep learning model to learn something and hold whatever it has learned in its memory as well. That's a very important thing that is governing the basis of deep learning, guys. So as I mentioned, activation function, right? Now see, whenever you're using multiple neurons, it is mostly the case that you have to find out if a neuron has to fire or not, or has to work or not in its terms. So if it has to do that, and if the data given to the neuron, the number that is assigned to it is a very large number, things can get a little confusing. So we use an activation function. An entity, what it does is it squishes down your value, this value which might be negative 1000 all the way to positive 10 million or whatever it is. It just squishes squishes all of this down to bring it to a range of -1 to 1 or 0 to 1. So in that particular case, if it's 0, it knows that the neuron might not fire. If it's 1, there is a 100% chance the neuron is firing, connecting to another neuron and passing some information to it, right? To see if the neuron has to pass these values or not in its foundational level, we require activation function, guys. So once the activation is done, once the neurons are activated and is passing some values, there is a weight which gets assigned to each of these nodes. Again, we're going to see how activation function works, how these weight works, how they come together to provide a solution in the neural network module. But for now, you need to know that there is an entity called as activation function, and this is how it works, and this is why it works as well, guys. So after understanding activation functions, as I told you, one neuron connects to the other, so data moves in one direction or the other, right? In the case of deep learning as well, that is true. Data can move in the forward or the backward direction in this kind of an entity called as a neural network. When the data moves in the forward direction, it is called as forward propagation. When the data moves from the output towards the input direction in the network, it's called as backward propagation. Each of these has a very, very fantastic meaning. Forward propagation talks about how you can calculate all of these weights first, make sure that your neuron knows what it is supposed to do if it comes to its usage and all of that. The backward propagation talks about what the neuron has learned. It tries to verify it, compare what it has learned with what the output is, if it has learned something and all of that. So forward propagation is like the neural network learning, and backward propagation is like giving the neural network an examination and saying, hey, what have you learned? Right? That is a very simplification of this concept of how deep learning works as well, guys. So with that, I hope you guys are clear, with how deep learning works on a functional level. The next thing that we are going to check out are the differences that exist between deep learning and machine learning. Now, as I mentioned at the start of this module, it becomes vital that you know the differences, even though these two domains sound very similar, deep learning, machine learning, and both of them are the subset of artificial intelligence. There are key differences here that you're supposed to know, guys. So here are some of the differences. We're going to compare each point and see how we can work with that, right? So the first point, the first criteria for our comparison is the data set size. Now, in the case of machine learning, you can get away with training a machine with a smaller amount of data, and you do not require a large amount of data. Of course, a large amount of data will help it learn better, but it is not a compulsory requirement. In the case of deep learning, that is not the case. It really might not work well unless you provide it with a huge amount of data, right? So more the data works better in deep learning. It is a compulsory requirement there, but for machine learning, that is not so. Why is the case? Well, this is a very important thing you're supposed to know, because at the end of the day, how deep learning works itself, right? These interconnected networks means it is very complex, and your data is being processed in a very different way than machine learning. So to give it information, to make sure it understands what it is learning, you require a lot of data. So this complexity of deep learning asks for a bigger data set compared to machine learning, guys. That's an important thing that you should know about. Talking about the second important point here, it is feature engineering. See, what happens in the case of feature engineering is we try to see what column of data has how much amount of impact on the output, right? So in the diabetes example, again, that I've mentioned, maybe two columns of data have a huge impact, like age and blood sugar and all of that. Maybe there is another criteria which we haven't looked at until now, right? Hereditary can be one of those criteria, whatever it is, right? To know that this new feature can have an impact on it, you have to first of all know the feature exists and use it to get to the output. Right? So in machine learning, we have to manually do this. We have to manually say, hey, here's a new column of data. Try to see what impact it has on the output. In the case of deep learning, it is intelligent enough to sort of figure this on its own. So it has the capability on multiple levels of complexity that it can, go on to learn things, understand things, create feature labels, use it to learn, and then provide an output. And all of this is done automatically, ladies and gentlemen. That is the magic of deep learning. And of course, with this, what happens is that, whenever you go on to teach the machine how things work, right, it becomes very easy because it sort of is very quick at learning. It will understand shape, it understands texture, it knows a lot of different features. As soon as it sees a circle, it will not say, hey, this is a square. It knows it is a circle, it knows it is a sphere, right? That is the important thing. Making your machine already intelligent so that you do not have to teach it again and again sort of is the point here. Your machine will know the basics and you just have to train it on advanced things. If I have to break it down to the most simple level, that is why this automatic feature engineering feature that brings us out, that is shining in the case of deep learning, is very important, guys. So the next thing, the next important point that we have to discuss about is the hardware dependencies. In the case of deep learning, of course, in today's world, since we already have sophisticated high-end hardware, deep learning for its process, for its complexity. Now, we are the most sophisticated beings out there. That is debatable, of course, but at least in my opinion, sort of, in our perceivable world right now, right, so we are very sophisticated, and nowadays computers are getting sophisticated, as we have discussed. So deep learning uses this kind of, there is a hard requirement of high powered computers and graphical processing units, GPUs as it's called, along with CPUs for it to learn and understand things. In the case of machine learning, even a complex machine learning algorithm can get away with low-end machines as well. So you do not require state-of-the-art stuff. You do not require the most fancy, most expensive computers to get your application created and done. Right? That can be a make it or break it things for a company who might not be able to afford a huge computer. Right? You have to understand that it is not the fault of the technology, because that is how deep learning works. We are trying to imitate the most intelligent being in our senses right now. So all the mathematical operation which goes on, very, very heavy matrix multiplication operations, high amount of computation rates, that goes on in deep learning is what asks it, saying, hey, to do this, I require high-end hardware and high-end computing technologies, right? So that is an important difference that you guys should know about. And then talking about the next thing is execution time. I think you would have guessed execution time by now, right? First of all, deep learning, whenever you're using it, it requires a lot of time to not only train, but also to give you an output based upon whatever it is learning in, and to furnish a usable output. In the case of deep learning, it might take a day, it might take 10 minutes, all the way until a week, a month for it to learn and give you a usable output at the end of the day. So what happens here is that I'm going to show you a demo at the end of the next module, the neural network module, where you will see that it takes a comprehensive amount of time to execute, right? We have already discussed machine learning in a previous module. Now you would have seen that as soon as I hit play, it takes 1 second, 2 seconds, boom, the output is ready. That is not the case when you're training a deep learning model, right? You're going to check that out practically in the next module. So it requires, of course, I'm not going to take weeks worth of time to make you guys wait and show you that. I'm going to take a demo which will probably take 10 minutes instead of 2 seconds to go on to do the same thing in the case of machine learning versus deep learning, right? That's the thing. So it is not just the large amount of data that adds to this kind of a large amount of time, but it's also the complexity, the way machines get trained. But I'm sure execution time is something that you guys would have already picked up on, right? Now, to give you an example, think about creating an application where, it takes pictures of people and sort of helps them find whatever clothing they like, right? So I just have a model in front of me. I take a picture of the model. So in the case of machine learning, you have to manually say, hey, this person is looking for a shirt. This person is looking for a hat. This person is looking for maybe shoes, a tie, a bow tie, whatever it is, right? So we have to create these features, and it has to be coded manually and say that is what we want. So learn based upon that. In the case of deep learning, you do not have to do all of that, so you can get it to understand features automatically, get things created automatically, and it will give you a feature at the end of the day saying, would you like a bow tie? Would you like a tie? Right? So it understands that is the requirement that is being asked of it. It learns based upon that and eventually gives you a result. This automatic way of feature extraction and feature generation is something which is, again, it is a constant amount of research that goes into doing it, but it is intelligent enough to give us the output at this moment in time, guys. Right, the next thing that we're going to discuss is the important use cases when it comes to deep learning. In the case of image classification, in the case of object identification and face recognition, wherever it is, right? Be it in a very simple usage of maybe Facebook's algorithm where you just put out a picture, it automatically tags your friend for you, all the way to knowing that, hey, this person might be who I thought that I saw maybe in some kind of an investigation, criminal proceedings, civil proceedings, whatever that is, right? So right from something which is very, very vital all the way to social media, which I don't think is an extremely vital part of everyone's life, is where these things are popular. Be it object identification, you show an apple to your computer, and if it sees it, things like Google Lens and all of these things understand what it is seeing. It knows it is seeing an apple. It can see if it's a ripe apple or if it's still a raw, unripe apple. Is it good to eat? If your apple looks maybe black or something, or if it's not edible, you can show your phone the apple and say, can I eat this? And it can be intelligent enough to tell you, hey, it is good for consumption, it is okay for consumption, and all of that. So guys, computer vision is a brilliant use case where you're making your computer see things and understand them right, hand in hand, right? Multiple airports across the world have used a concept right now with face recognition, where if you're trying to check into the airport to get your plane, to get to board the plane, there was a time when you had to show your passport. Of course, it is still there. You have to show your passport, you have to prove that you're there physically, and you have to go through a lot of procedures to get your plane. Nowadays, the check-in is in a way where you just go look into a camera, the machine on the other side matches your photo with the passport or something, or whatever details that it has. It understands that you have checked in into the airport and that you're waiting to board your plane and all of that, right? Of course, I just simplified that entire process to you, but that is how computer vision is very popular. Now, I've already talked about text and sequential data in the case of speech recognition, in the case of sentiment classification. It is very, very important. When I say Alexa, that when my voice is said, Alexa knows that it has to recognize what I'm saying, why I'm saying it, and all of that. Sentiment classification, I told you, if you're a product seller, you want to analyze the sentiment of your customers, right? In the case of DNA sequence analysis, if you do not know what sequence analysis is, I highly recommend you read it. It is fantastic. We have DNA in our body, right, and our being itself. So it's a very complex term to explain it to you guys, but it is very interesting that you guys check it out after this video as well. The fourth thing is video activity recognition, as I told you, to check if people are wearing masks or not, to make sure that there is minimum distance maintained, to see if someone is intruding at the middle of the night, right? So you cannot have a security system of human beings, maybe, have 10 human beings to guard one building. You can have 10 different cameras. And if this camera captures a motion where a human is walking or something, it can alert people saying, hey, during the time of night when people are not usually expected to whatever office or government building it is, that people are coming there, then it is intelligent enough to understand all of that, guys. Right, coming to the last section of this particular module, where we'll be discussing the top libraries for deep learning. We'll be taking a look at these libraries which are extremely popular for Python, guys. We have 6 amazing open source libraries which I absolutely love to work with. They are TensorFlow, we have Microsoft CNTK. CNTK stands for Cognitive Toolkit, so it's Microsoft's Cognitive Toolkit. We have Cafe, we have a lot of different things. We have Theano, we have Chainer, we have Keras, we have Deep Learning for J, and we have at least 20 amazing deep learning libraries out there, but these are the ones which get used a lot. So I thought it is worth to mention to you guys the top 6 open source libraries for deep learning, right? To talk about the first one, TensorFlow, right? Now, TensorFlow is amongst the world's most used framework for deep learning. It is the most popular in the case of natural language processing, speech recognition, image recognition, and all of these different things. It is a framework which comes with multiple libraries. It is very flexible to work with, and it also provides you tools that you require in the case of machine learning and deep learning to deploy your applications automatically, right? So to build and even handle deployment, TensorFlow offers multiple options to users. And TensorFlow is a framework in which the at the end of the day, the syntax that you use in Python itself is very easy, as we have been checking out. But even in the case of TensorFlow, that is the same thing as well. Here, using TensorFlow's syntax in Python is sort of very easy. Of course, you require some training to get started, but once you're trained, eventually you will know what your deep learning algorithm is trying to do, guys. That That is the point here. So TensorFlow is extremely popular. It is a brainchild of the people at Google. The next thing that we're going to check out is Microsoft's CNTK, or the Cognitive Toolkit. This is Microsoft's offering, of course. It is amazing. It works really, really well whenever we're doing any sort of image recognition or pattern recognition kind of applications. It works with two types of neural networks called as convolutional neural networks and recurrent neural networks. We're going to check out what these are to a good amount of detail on the next module. But for now, you need to know that CNTK supports both of them. And in this concept of deep learning, where things can get really complex even for the programmer, CNTK offers a way in which you can break down complex concepts into simple stuffs, into building blocks, tiny Lego blocks, work with it, and then build upon a complex solution, right? The pyramids of Egypt were not just one rock which was just placed there and people shaped it, right? They brought tiny rocks and eventually put one on top of the other, and then it became a pyramid. That is the approach that people at CNTK sort of take too, right? Then we have Caffe. Caffe is one of these amazing frameworks which will help you to scale up rapidly if that is your requirement. It is built keeping in mind that today you might have a deep learning solution which might, you might be catering to 10 applications. At the end of the day, if you want to build 100, if not thousands of applications, or have one application used by 1,000 customers to give them some sort of personalization, Caffe is the framework that you're supposed to use. It is used with Python in a modular way. It's an amazing user interface. You can work with it in Python, C, C++, and all of these, and it is very, very, very popular to work with one type of neural networks. It's called as the convolutional neural networks, or CNN as short, guys. So Caffe is meant, it's a tool, it's a framework that is built if you are looking towards to scale. Right, guys. The next thing that we're going to discuss is Chainer. Now, Chainer is again another amazing, it's a fantastic framework which is again built if you have dynamism in your head, right? So, not all the things in deep learning cases are static. It keeps learning, it keeps changing things, and you don't have to do the entire thing again, teach it again and again every day to make sure that it knows a new thing or it understands a new thing, right? It perceives a new thing. So in that case, with Chainer, to do all of these things, to make sure that it is a very dynamic, snappy framework to use, it uses a lot of what we call as auto differentiation APIs, and it uses approach using computational graphs. It uses define by run approach. All of these amazing concepts which you guys should learn about if you're very serious about a data science career, right? So you can build amazing neural networks here using high level APIs which are not very difficult to code with, but at the end of the day, a small amount of effort from your side will get you an output which is fantastic, guys. That is what Chainer is all about. Then Keras. Keras is again a very, very popular offering. It is it is basically a framework which runs on top of using TensorFlow as well. It's a tool which has the capability to run on top of TensorFlow and increase its capability. It works both on convolutional neural networks and recurrent neural networks. In the case of how Keras is built, Keras is actually built, the framework itself is built using Python. It works fantastically in the case of Theano, in the case of CNTK, and works really, really well with TensorFlow as well, guys. So if you're a company who is into rapid prototyping and experimentation, right? So maybe you have a concept right now and you don't have a lot of time to take it to a product where you have a short amount of time which you can invest to make sure you can take this prototype, right? So a prototype is this first thing that you create which eventually gets converted into a product. So if you want to rapidly do it, if you want the methodologies, the tools, the techniques which goes into rapid prototyping and experimenting a lot of different things, Keras is something you definitely should be looking at because it provides a very simple API to help you develop new things rapidly. And of course, if there are bugs on the way, which of course as a programmer you're going to see a lot of bugs, it will make sure that you can find out these bugs easily and solve them easily as well, guys. That is the magic of Keras. So right, guys, the next one we're going to check out is deep learning for J. Now we have been talking a lot about Python and all of that, right? So here is a deep learning module which is built upon using Java, guys. So deep learning for J 4J sounds, stands for Java. It is basically built using Java. It is meant to be used on the Java virtual machines. So it is again a very, very popular library. Again, all of these frameworks that we have discussed, all of them are open source as well. So even in the case of deep learning for J, it is an open source library. It supports the usage of multiple deep learning algorithms, which you can use for a variety of solutions to cater, for a variety of clients. And it works really, really well with all of these big data solutions like Hadoop, Scala, Spark, and all of these different things. It brings together this architecture of big data, binds it to deep learning, and makes sure that you can have a constant flow of data to work with, use distributed computing, and give out a solution which is very powerful, guys. So guys, with this you have come to the end of this particular module. I hope you guys took away a lot of information from this particular module. Deep learning is very, very important for you guys. In the next module we're going to be checking out neural networks. So neural networks again are a subtopic or a concept of deep learning itself, but that is again an ocean's worth of concepts on its own. You got introduction to neural networks here. We spoke about neurons, activation functions, and all of that, but yes, we have a separate module. We're going to be discussing it in detail and check it out practically as well, guys. So make sure you check out the next module as well. So guys, welcome to module number 10. In module number 10, we're going to be discussing the very important concept of neural networks, as I mentioned in module number 9, right? So deep learning and neural networks go hand in hand, because at the end of the day, most of the things that go on into the working of deep learning come from the foundational aspects and the functional core of neural networks itself, guys. So without further ado, we can actually begin to understand neural networks to a good amount of depth. Now guys, with module number 10, we are going to be covering these important points here. First of all, we need to take a look at the introduction to neural networks, understand it in a more intuitive way, understand why it is called the way it is, why it works the way it is, how it works and all of that, what is the mathematics that powers the concepts of neural networks and all of that. Once you're clear with this, once you understand the foundational aspects of things, we can take a look at the varieties of neural networks that exist. Once you get to know, hey, so these are the types of neural networks, you will have a complete understanding to hone in on, either 1, 2, or 3 or multiple types of neural networks that you would like to work on and eventually get started with it, right? So we're going to be using a popular application. I'm going to be demonstrating all of these practically as well whenever we're taking a look at the working of neural networks, or consider the practical implementation aspect as well, right? So as always, a good amount of theoretical knowledge backed by practical learning is something we've always standing by here at Great Learning, and I'm sure you guys saw that through this full course video. So guys, let us get started with module number 10. Now, whenever the talk is about the introduction to neural networks, right? So guys, everything that we have learned from module number 9, the deep learning aspects of things, why don't you head to the comment section and why don't you put down in the comment section what you think is a neural network, right? It can be a definition, it can be the way you understand neural network, it can be that you might have used it, heard it anywhere, right? So make sure you guys are doing that. Now, to actually talk about a neural network, right? A neural network for me personally is a very, very fascinating concept. At the end of the day, the goal, again, as I've mentioned in module number 9, is to get your machine to think like a human being. And with module number 9, we saw that that is not a simple task, right? So deep learning, first of all, it's machine learning, then comes deep learning. Deep learning consists of neural networks and many other concepts. And this takes us to be on a pathway of where we can go on to use these concepts to achieve artificial intelligence, right? Now, achieving artificial intelligence is one of the products that we look out for in this domain of data science, as I've told you. So it becomes very vital that you know how you can achieve it in the most intuitive, most fun way possible, right? So these concepts of neural networks are amazing to work with. The output they give you is very satisfactory, in my opinion. They give you a high amount of satisfaction at the end of the day. So the time you invest in trying to solve a problem with this, right, you will be very well rewarded at the end. That is what makes you want to learn more and more about these domains and get working with them, guys. Right. Anyway, coming back. Now that we're talking about artificial neural networks, one very important thing that you have to know is that this is a concept. Neural networks is a complete concept which is sort of a direct lift from how the human brain processes things, right? So we have millions of, if not billions and billions of neurons in our brain, and each of them act like a micro computer, mini computer on their own. So these computers are always in conjunction to create a network. That network is what we experience as reality, right? So reality is how we perceive things, and it's not like all of these computers work the same way. There are certain things which is common to our species which work the same way, but at the end of the day, when you look at the thought process of a human being, it can be very, very different from another person, right? And we have 7.5 billion people across the globe, so that is 7.5 billion people with billions of neurons each, right? So this is a web of the world's biggest computer network, is something that I can tell you now. Bringing actual computers into this is going to be something fun and interactive, right? So guys, whenever we take a look at this concept of how neurons talk to each other, right? So one neuron consists of certain data, and as soon as there is a requirement to pass this kind of a data to another one, it gets activated based on it. There is something called as activation that happens, where it sends a small voltage kind of a thing. That's how the whenever there's a brain scan or anything that happens, they realize that that part of the brain is active. So it sends its electrical signal, very mild electrical signal, and one neuron talks to the other, and that is how one part of your brain works whenever you're doing, for example, maybe a motor related activity. You're running, you're walking, you're thinking, you're happy, you're sad, whatever this is, right? So they know what part of the brain does what part of the thing. So even in our case of neural networks, what we do is we make sure that, of course, we will not have billions and billions of neurons here, depending on the application, of course, but we do have multiple neurons in a connected network, where we are going to make sure these neurons are connected to each other in a way. If information is supposed to be passed from one neuron to another, we have a way to say, hey, so this is the neuron that is sending the next neuron some data. Here's the data, who sent it, which neuron sent it, why it is sent can also be tracked if you're looking to backtrack into the neural network architecture. But the most important thing is that we have a verifiable mathematical and computer sciencey way of how we can track this and replicate the human behavior there, guys. So this is a quick introduction to what a neural network is. But when you think about the generic working of what it would look like, what is the mathematical aspect of things, why does a neuron want to pass an information, and all of these things, right? Well, a neuron, in our case, in a neural network, is an entity which consists of weights and inputs. So each neuron is assigned an input, and it is given a weight, and of course it has a bias value with it as well. Now these inputs and random weights get multiplied, and there's a bias value which is basically attached to this. So a multiplied version of your input along with random weights get added with a bias, and this is later pushed into the value. So this is the exact values that we try to push. Of course, in multiple places, most of these values will get edited, which again we're going to cover down the line as well. So whenever you say, hey, a neuron is to pass a value to the next neuron, there is something called as an activation function that it has to go through. So once it goes through an activation function, the model will realize if this neuron is going to add any sort of value to the next one or not in terms of learning, right? So for example, if you are running and your only goal is to run, sometimes you might want to sing, sometimes you might not want to, right? So if you want to sing, there is a neuron in your brain or multiple network of neurons which says, hey, let us sing and run, right? So here as well, so if there is one particular thing in the input or the data that you think is going to have an impact on the output, and the neural network is capable enough to, of course, learn that on its own, it is capable of feature mapping automatically. So in that case, it will turn that neuron on, connect it to the next one, and move on. The way we track, the way we assess and help the neural network train is based on these values of inputs, weights, biases, activation function, and all of these terms, guys. So again, we're going to be revisiting all of these concepts as we move ahead. But now to give you a clarity, so that whenever I'm mentioning these concepts ahead, that you have some clarity, right? Weights. So what are weights? Weights are these concepts where things get multiplied with the input for the neuron, and they get basically sent to the next stages of a neural network. Right now, in that case, you might be wondering, okay, so what is the point of having a weight? Why do we need weight? Right? Well, weights are these numbers, numerical measures which we use later down the line to see if if the model actually learnt anything or not. During the training period, these values get set randomly, and along with the input data, they get pushed forward. Once during this forward motion, the entire neural network learns, we trace back, we run the neural network in the reverse direction. This is a concept called as back propagation, where we try to compare our final value, what was supposed to be obtained, with the data of what the machine used during the training, right? So there again comes the concept of loss function. Loss function is again something we're going to discuss. But our goal is to make sure that the neural network's loss is very less. So when I say loss, what I'm trying to mean is the difference in the accuracy rate of the actual output we were supposed to receive versus what the neural network actually learned, right? So of course, when we're going through the concept of backpropagation, we revisit each of these weights. We change it based on what it learned on training, what was the predicted outcome, how far away it is based on the predictive outcome as well. Now this is a concept that will eventually add a lot of value, because with this we have a way to optimize, train the network better, and tune it out in a way where it gives us the most accurate value, right? That is why we require the important concept of weights. Now, once you understand what is weights, why we multiply it, what is the use later down the line, and now you should know that weights form to be a very, very, very important concept of it, right? Because without weights, it would become highly difficult to optimize your network, to train it in a way where things work, and it is backed by data and mathematics as well. So keeping that in mind, since we are taking a look at mathematics to a good amount of extent, it becomes rightly so that you guys are well versed with the mathematical calculations that happen in a neural network. Now again, be aware that there are hundreds if not thousands of calculations that happen. I have picked up some simple examples here to make sure that you guys are well versed with the concepts, right? So, first of all, let us actually take a simple example to begin working with, to begin understanding about how things work here. So guys, take a look at the example on your screen. We have two input variables, x1 and x2, where x1 has a value of 0.6, x2 has a value of 1.0 or 1. Now, as I told you, inputs get multiplied with weights, right? So we have weights. Let us take a weight 1 to be 0.5, weight 2 to be 0.8, and we have another value called as threshold. Threshold is 1.0. Now, what are all of these values? What are we doing with? x1, x2 forms to be the input variables. W1, W2 forms to be the weights, correct? Now, the mathematical aspect of things in a neural network happen in a way where the step one, where you have to transfer data into another neuron, you have to push data ahead, happens with the usage of a transfer function. Now, in the transfer function, as I mentioned, our input value gets multiplied with the weights, right? So x1 into w1, the answer of that gets added with x2 into w2. Now here we have 0.6 into 0.5 added with 1 into 0.8. So this gives us a product 0.3 plus 0.8, which eventually our transfer function's value right now stands at 1.1. Guys, all of the values that you see, x1, x2, w1, w2, threshold, I have put it on the right hand side to make sure that you guys are calculating this alongside as well. Take a note of the formulas that you see. Transfer function is a very important thing. That is how data gets passed on to the network, right? So that is a very important thing. Next guys, after you take a look at the transfer function, step number 2 is how we calculate and compare this output that we just got with the threshold value, guys. So the output that we have, if you remember from our transfer function calculation, is 1.1, correct? what is our threshold value? It is 1. So if we take a difference between 1.1 and 1, it gives us a value of 0.1, right? So this is how we are comparing our output with the threshold itself. But still, what is threshold, right? See, threshold comes into the picture when we talk about the activation function. If your output value, the value that you got, if it is greater than the threshold, right? In our case, output value is definitely by a huge margin greater than our threshold. So in that case, what happens is that the neuron itself gets activated. Right now, if we go back, as you can see, the output is 1.1. What is our threshold? Our threshold is 1. So we have a positive difference, right? Anything, when we compare this, if the output minus threshold is a positive number, it always means that your output is higher than the threshold number, right? So if the output is higher than the threshold function, the neuron gets activated then and there, guys. So this is the fancy concept of, the mathematical calculation in a neural network. I have tried to simplify it as much as possible so that all of you guys, especially beginners who are watching this video, can understand it in its full sense. Right. Now, what happens if your output is less than the threshold, right? If your output is less than the threshold, our comparison value in step number 2 will either be 0 or it's going to be a negative value for sure, right? If it is a negative value, we are trying to say, hey, no, your output is less than threshold. If your output is less than the upper threshold, right? So if this is the output, if it comes very close to threshold, this hand is the threshold, this hand is the output. If it comes very close to it, then you say, okay, let us still activate it, because at the end of the day, this hand is the threshold and this hand is the output, right? So if your output is less than the threshold, your neuron will not get activated. But once your output beats the threshold and it is higher than the threshold, then we say, hey, activate it, push the value next, because whatever you are contributing is going to affect the neural network. That is the simple way of how we can take a look at the mathematical calculations in a neural network, guys. Right. Now with that, you have to know the various types of neural networks that exist. Now there are multiple different types of neural networks, which again, trickles down to what is your requirement, how you want to use it. But at the end of the day, even though there is a long list of types of neural networks, there are certain very, very popular things. They have their own set of advantages and disadvantages, their own set of usage, their own set of working methodologies, which is very popular for certain specific applications as well. So keeping all of this in mind, let us discuss some of the most popular or the important types of neural networks that exist, right? As I told you, there are many, but here are some that we are going to discuss. You have, among the multiple types of neural networks, we have a perceptron. We're going to be discussing feed-forward networks, a multi-layer perceptron, convolutional neural networks, or it's also called as CNNs. Then we're going to talk about the radial basis function neural network. It's also called as the RBF neural network. And of course, then we have the recurrent neural network, which is very popularly called RNN. Now, if you might have done a little bit of research on your own, you might have heard the term thrown around everywhere: CNN, RNN, RBF kernel and all of that, right? So again, these all concepts are something that you're going to get a quick introduction to in this section of module number 10. Right. Without further ado, we can actually jump on to the first one to understand a perceptron. Now, perceptron is the most foundational concept of how a neuron works, because practically in all of its sense, it is the most simple neural models that one can go on to calculate, guys. Because at the working stage of it, at its initial basis of propagating values and becoming a network on its own, a perceptron itself is a simple unit in a neural network, right? So this simple unit, even though it sounds very simple, as you can see, we have two inputs and these two inputs converge into one output cell on the image that you see on your screen right now, right? Even though you just have two inputs and you have one output, do not be taken by the simplicity of things here, because even a perceptron is very well capable enough to detect features and give give you computations for that as well. So it accepts inputs, it accepts inputs and weights, and it uses an activation function. All of these concepts we already discussed, right? So it uses these values to push it to the next layer, and eventually, since there's only one layer with the perceptron, the weighted inputs and of course the activation function, depending on it, whatever value gets activated between 1, 2 or multiple neurons, it is just directly pushed to the output and say, hey, this is the output, here's how we have arrived, right? So guys, make sure you're taking a note of the image as well. If you have a pen and paper handy, it is always vital, because these are the functional concepts which will help you down the line in data science a lot. So guys, this is a perceptron. Now to talk about a certain advantage and disadvantage of using a perceptron, right? Now, whenever you're talking about the concepts of electronics in a way where, again, even with computers as well, right, the hardware functionality of it works on multiple logic gates, AND gate, OR gate, NOT gate, and all of these. So we're trying to use these logic gates to say, hey, if these inputs are passed, I want such and such output, right? So in the case of an AND gate, only if both the values are true or same, the output is given to you as a true. If one of these is false, then it's false. But in the case of an OR gate, that is not the case. One out of two values, if it is the opposite, if it is the same, it doesn't matter. If one, this or that is whatever that you require, yes, you will get the output. NOT gate is again a very fancy gate where no matter what you throw at it, it is going to give an inverse of the output. So if you give the NOT gate a logical input of 1, it's going to give you an output of 0. So it is used to invert the signal or invert the concept of whatever you sent into the input, right? So the advantage here with the perceptron is that you can implement all of these in a very, very simple fashion. But it also comes with a small disadvantage, is that whenever you're working with nonlinear functions and whenever you have nonlinear gates, such as the XOR gates, where you have to build applications based upon this, a perceptron will not work, because again, XOR gate comes with its own working, its own truth table, its own challenges to implement. So the concept of perceptron doesn't directly feed into the working of that, is the small disadvantage with the case of a perceptron, guys. Right. Next up, taking a look at the feed-forward neural networks. Feed-forward, what does it mean, and why does it, look a little bit more complicated than the perceptron, right? Of course, perceptron is a very simple entity. Here, it is no longer a simple entity. We have a network where, you can have multiple inputs, layers in the network, and of course it is passed through the output, right? But one very important thing that you have to know about whenever you're learning about feed-forward networks is this is a type of neural network that is extremely popular for face recognition applications, guys. So whenever you want to add filters onto your face, whenever you're using social media, whenever auto tagging is implemented by multiple social media out there, or you're trying to use any sort of computer vision and all of these concepts, right, it becomes very vital that you know what sort of a network is powered the concept in the backend. So a feed-forward network is something like this. Coming to the working of it, as the name itself suggests, a feed-forward network will only feed data in the forward direction. Remember how I told you previously that we even work the network in its backward direction in a concept called as backward propagation, where we try to minimize the loss. In this case, that is not possible because the data moves in only one direction, which is the forward direction, right? Of course, here, even though it is not a perceptron, it means you can have multiple layers out of it. So a multi-layer network is definitely something that is possible. But the working of a feed-forward network itself changes, very much from a conventional neural network, where here we do not require a back propagation itself because the weights are static in nature. Now, with back propagation, you keep changing weights in a way where you have to recompute, change the weights, bring the loss down, all of that. Here, if your weights itself are static, it means down the line the model sees these inputs and these static weights multiplied. So it literally doesn't have to use the concept of back propagation itself, because weights are not random, and even if they are at the first stage of it, they are static. It is one set of numbers that are used which moves ahead, right? So coming to talk about certain advantages of the feed-forward network, one thing is that whenever you're working on it, it is brilliant enough to give you a very good output, which doesn't require a lot of effort from your side. So it is very easy to implement. It is amazing to maintain and keep reusing for multiple solutions out there. To talk about the disadvantage of it, see, the concept of deep learning itself talks about how well versed can you get your machine to learn. If it learns it differently or wrong, it has to have the capability to relearn it, right? In the case of feed-forward network, relearning is the backward propagation aspect which we are not taking a look at. So in all of its sense, if your complete application is a requirement of an output based upon the concepts of deep learning, well, it certainly does not hold true because ability to relearn is sort of lost here, right? So this is feed-forward network. Next up, we're going to take a look at multi-layer perceptron. Now guys, perceptron is something that we checked out. What is a multi-layer perceptron? A multi-layer perceptron is basically a fully connected neural network where you have a certain set of layers called as the input layer, where all of these neurons are there which gets its values. On the most right hand side, as you can see, we have an output value. But between these input and output values, you have certain layers called as the hidden layers, right? So this hidden layer again consists of multiple neurons where each neuron has an effect on what the output is going to be like. So guys, since we already know the basic working of a perceptron, here it is the same thing. But again, here the data moves in the backward direction for the neural network to relearn itself, right? An advantage of a multi-layer perceptron is that the weights are automatically adjusted. It can self-adjust in a way depending on the result that is obtained at hand. So that makes it a huge advantage in the working of a multi-layer perceptron with these hidden layers, right? Now, based on the complexity of the solution that you're trying to obtain, you will have multiple hidden layers. It can be 1, 2, 3, it can be hundreds of hidden layers if your model can get that complex as well. So multi-layer perceptron is an extremely trending concept in the world of speech recognition, right? So whenever you're talking to a chatbot, for example, when you say, hey Siri, hey Alexa, when you're talking to these chatbots have to recognize everything in your speech. It has to know that it is you who's talking. It has to understand grammar, it has to understand phonetics, it has to understand so many different things, and it has to give you an output in real time, right? So a multi-layer perceptron is very fancy for these kinds of applications, guys. To talk about advantages and disadvantages, again, each of these neural networks come with their own set of advantages and disadvantages, as you've seen, right? In the case of a multi-layer perceptron, a huge advantage here is that no matter how complex your deep learning problem can get, even though implementation might be slightly tough, you can use it and work with a multi-layer perceptron to eventually get to your goal. That is the advantage. The disadvantage whenever you're talking about a multi-layer perceptron is that execution times are a little bit slow, because what happens is that things here are very complex to implement, right? With the hidden layers, your neurons are interconnected. It is fully connected in a way where one neuron's interaction can completely trickle down until the output layer. So execution becomes a little slow due to the complex nature of the working itself, guys. So this is a multi-layer perceptron. Now, once you've understood about a multi-layer perceptron, we come to a very, very nice type of neural network, which again, probably a lot of the people in the world use today. It's called as a convolutional neural network. Now, convolutional neural network is extremely popular whenever anything talks about image processing. This was a type of neural network which was built to handle image processing, guys. So imagine it is purpose built for that. So of course it is going to be really good at doing things the way it does, right? So here what happens is that whenever you pass an image into a neural network, it gets converted into an array of pixels. These array of pixels are clubbed together, they get converted into another form, eventually they get flattened, and these give you a complete output of how things work. You take the inputs, you have multiple hidden layers, and then you have an output layer. So taking your image right from its input, right, you are basically giving your computer an image saying, hey, here is what it is, process it. You're going to take it right from its image form until an output where you're trying to predict maybe what the image is, right? We are going to check out convolutional neural networks practically. So in those steps, steps, I'm going to highlight the mathematical aspect of things. I am going to take a look at and teach you of how things work in each of these layers as well, guys. And of course, when we are implementing all of these practically, you will have a complete knowledge of what we are talking about, right? But for now, you're supposed to know images get broken down into pixel, and that is how mathematically data is processed and furnished across the input, hidden layer and the output stages of the neural network. So again, here we make use of a concept called as filters, which we are going to check out in the next section. But for now, you have to know the advantage and the disadvantage that CNNs, are very good at, and of course the things that are bad at as well, right? Now, an important advantage that you have to know about CNNs is that whenever you're training a model to understand images, right, it is actually a very complex thing, as you can see from the demo we're going to be discussing. But to train it, you will not require a lot of parameters. A convolutional neural network is intelligent enough to understand what it is seeing in an image. So your job as a person who's trying to code a neural network is definitely reduced, but the output is still complex. It is an amazing output, but less effort on your side. That is the advantage here, guys. And then whenever you're talking about the disadvantage, right? See, one important disadvantage that you have to know is, even though you're doing a small amount of things and your network itself is using a small amount of parameters to give you an output, at the end of the day, the end design that's going to take you from your problem statement till the solution, right? That is still a little bit of a complex procedure. And whenever you're trying to talk about code maintainability, well, it still poses a slight challenge, guys. Right. Now, the next neural network that we're going to talk about is the radial basis function neural network. It's also called as the RBFNN or RBF neural network. So it means the same thing. So whenever we're talking about the RBF neural network, the radial basis function neural network, right? So it is an amazing neural network, which again, I am a very huge fan of, because here we try to use a priority based problem at hand and use this network to solve it, right? You have multiple inputs where each input gets tracked into an output, and eventually you have a hidden layer, and this layer talks to an output, as you can see from the image on your screen right now. So we take a classification problem at hand, and we try to classify our input at hand with the solution we are supposed to obtain based on how similar the input is to what our model sort of learnt in its training stage, right? So when it's training, of course, it's going to use the training data set. How similar is the input to the training data set? And then that is how we use a concept, again a mathematical concept called as Euclidean distance. Euclidean distance is this concept we're going to use to say, hey, okay, so if I have an apple or an orange, if I have a priority to say that I have to arrange the oranges first, do I have to arrange the oranges first? And if so, it will do it, right? But to get to that question, do I have to get to the answer of it, right? The concept of Euclidean distance is used. That's a very simple analogy to make sure you guys understand the RBF neural network, right? So, in fact, to give you a clarity of how things work itself, let me give you a very nice example. Now, let's say, there is your local power distribution hub, which provides electricity to your house, right? So there is a transformer or whatever it is, and there's multiple houses that one area's or one locality's power distribution hub gets connected to, right? It's not like each house has a single hub. No. So in this case, let's say there is a power outage in 3 places that you can see. One, as you can see in P1, if you remove the connection at P1, if there is an outage there, everyone at P2, P3 sort of lose their power, right? Even though they might be the same channel, even though they might be the different channel, if you have to prioritize saying, okay, if I remove P1, maybe the person at P2 will lose electricity. But if I do not fix P3, right? If I do not fix the electricity going from power plant P3 to houses B, C, D, well, 3 houses are losing electricity. But in the case of P2, there's only 1 house that's losing electricity, right? Again, let us take away all of these critical things, which is fire station, health services, hospitals and all that. Let's just consider these to be plain simple houses. So If you look at the problem in a logical way, you will realize that, hey, of course we need to fix the P3 link first because it has a more impact on more number of houses. 3 houses are waiting for electricity there, so firstly we're going to fix P3. Then after P3 you're going to say, okay, so now let us go on to fix P2 because there's only one house that's affected there, and then you're going to fix the backup line, which is P1, that says, hey, okay, so P3 is ready, the power is gone to the houses B, C and D. Now P2 is ready, the power has gone to house number A, and then you say, okay, let us have the backups lines ready. In this case it is P1, right? So this is how you have to prioritize things, right? You don't go on to do it in a random way. You see the impact, you see what is important and solve it based upon that, right? That is exactly what goes on in the working of the RBF neural network as well, guys. Right. So the next type of neural network that we're going to take a look at is the recurrent neural network. Now, recurrent neural network is also called as the RNN or RNNs, as I've told you. And this is an amazing neural network because with this, you can go on to do text classification, text processing, and there are so many different applications of RNNs that it is an amazing thing, guys. Of course, you can take a look at the image on your screen. It says recurrent. It means that something goes on again and again and again, right? So one advantage, one very important thing, even before we talk about the advantages about RNN, is that it has memory. It has the capability to save and hold the output of a layer. So using memory functions, using the concepts of forward propagation, you have the ability to teach the neuron what it is doing and save the output, right? Now, as we've been checking previously, the output of a neuron becomes the input of the next neuron, right? In that case, it has to hold some memory to say, hey, okay, this is the reason in this particular step of learning that this was the value that I have, right? So for that, especially that in the case of usage of text processing is very important, and recurrent neural networks are amazing with this because they are designed keeping text classification and processing in mind, guys. Now, to talk about the advantage and the disadvantage of recurrent neural networks, right? One advantage is that whenever you're trying to model and work with sequential data, right? Whatever it is, text data and all of these things, it does it amazingly well. It is purpose built for this. So if you have a requirement where you have sequential data and you want to process it, think not anymore. Just try to implement a solution with RNN, right? That is, my advice if you're trying to solve a practical problem. The disadvantage though is that training an RNN becomes a little bit of a tedious task because at the end of the day, the working makes it complex enough that first of all, it'll give you a beautiful looking output if things run fine. If it, is struggling to learn things, and if there's a little bit of a confusion about why, things are working the way it is or anything of that sort, to go back and to retrain it to understand what parameter, what memory function is missing things, why, upon more training, sometimes it so happens that more and more you train, your recurrent neural network's accuracy keeps coming down and down. So it is a very important thing that you will not understand about what parameter is having this kind of an effect, guys. So all of those things have to be kept in mind when you take a look at and of course implement a recurrent neural network. Right, guys. With this, I believe that you have to have an understanding of one of these neural networks to a good amount of depth. So we are going to take a look at understanding convolutional neural networks. Let us check out its working. Let us check out each of its layers. And of course, we're going to take a look at all of these things practically as well. Right. Now, as I've already told you, convolutional neural networks, or CNNs as I'm going to be calling it from this point of time, is very, very important for image processing. It is built for image processing, guys. So when you understand the concept of image processing, when you take a look at an image itself, right, as I've already told you, your computer, even though it is the most intelligent thing, it can understand zeros and ones, right? Even an image is a 0 and a 1 to its most functional level, but then usually images get a value which is again a little bit more than 0, a little bit more than 1, 255, 256, 1000, all of those things. We're going to discuss them. But the point is that if you're trying to bring it down to its most functional level and understand what your computer looks at when it understands an image is just numbers, right? So each of these numbers will have a value. It will talk about a shape, it will talk about the brightness, it will talk about the color. Again, I'm talking about the pixel side of things, right? So in the case of a CNN, the simple thing you're supposed to know is whenever you pass an input as an image, right, a JPEG image, a picture that you have clicked, as soon as you go on to give it as an input to your convolutional neural network, the output is going to be either another image, or it's going to give you the characteristics of the image that you have put. It can guess the features of an image. It can say, hey, I see all of these things in this image. This image is of a building, this image is of a person, all of these things. Even if you're looking at the most simple steps of classification, right, it is something that is definitely possible to do so in the case of using a convolutional neural network. So as I just mentioned, right, let us say you want to implement the concept of a binary classifier. Binary classifier. So binary talks about two things. Classifier talks about how you can classify these two things, right? You have a picture of a cat and a dog on your screen right now. So, you give the input image as that dog on the left, and your convolutional neural network can run through it, and it can train in a way where it can give you an output saying, hey, I have a 94% probability that the picture that you have shown me is that of a dog. On the right side, it's the same case. You can give it multiple pictures of cats and dogs, and the output it's going to say is, hey, I have a 91% probability that this picture is that of a cat. Now, if your neural network learns it wrong, or if your input is not that of a high quality or even a good amount of quantity that we discussed, right? Think about the section where we discussed machine learning versus deep learning. I told you that the data set has to be huge, right? So if your data set is all right, if your image is accurate, if your data is accurate, it will give you an output like this. It is going to find you and give you the probability, the percentage of detection that it thinks the image is whatever it is seeing, right? On the left, it says 95% I think it's a dog. On the right, it says, hey, I'm sort of 90% sure that this is a cat. But it also says, hey, I might be also thinking that this is a dog, right? It says this is 37% chance that this is also a dog. But of course, we consider the biggest number there where it accurately got it, saying, hey, it's 91% a cat, right? And of course, a lot of people will get curious, saying, okay, so what does it do if you give a picture of a cat and a tiger and all of that? Will it understand what a tiger looks like? Will it understand what a cat dressed up as a tiger looks like? Again, all of these are fun implementations, and I'm going to leave it to you guys after you understand, once we check out all the steps that go on in the learning of convolutional neural networks, right? So this is a basic binary classifier, right? So to again revisit the concept of how we are trying to bring the human aspect of things, human learning aspect of things here, think about the actual neuron and think about the artificial neuron that we are trying to create in our neural network. On the left, you have what goes on in the brain, right? So you have a cell nucleus, which sits in the aspect of a neuron, and that in our case is a node. It is one single node that we saw all those circles, right? It is one single node like that. Then you have a concept called as dendrites. Dendrites are used as points of entry, data entry points. In our case, inputs were x1 and x2, right? It is similar to that. Next, you have a concept called as the synapse. Synapse is how one neuron is connected to multiple different neurons. There is multiple new connections happening in your brain right now that you're learning a new concept in data science. These become the weights, because you don't just look at this and it just gets stored, right? It's not like you only see this slide to know what a convolutional neural network is. Next, when you go on to talk to a friend, you can also talk about multiple other things about convolutional neural network. So there has to be a layer which gets mapped with a new neuron, right? That's a synapse. Then you have the concept of an axon, where axon talks about the actual process of creating functions, the aspects of mapping, activation functions, learning, and all of that. In your brain, it's the duty of the axon to go on to do all of these things. In our case, we manually implement all of these because our computer is apparently not intelligent enough, right? And the last thing is you have something called as the terminal axon. Terminal axon again corresponds to your output. Each of these axons along with the nucleus dendrites, so it's one entity that we have to separate out in the case of an artificial neuron, right? I hope that concept is clear to you guys. Now, whenever we're talking about implementing a binary classifier, that is how you guys have learned it in school. in fact, of course, including me as well, we've learned it in school, right? So probably when we are very, very small, when we are infants, our parents used to show us, hey, look, there's a dog. Hey, look, that's a cat. So our brain continuously trained. Neural networks were formed in our head that says, hey, if I look at a cat, it is not only that I have to look at only that cat to know it's a cat, right? I can look at thousands of other cats and say, okay, that's a cat, that's not a cat, that's a dog, that's a parrot, or I don't know what that is, something like that, right? So that is how you would have trained, and that is the approach that we are taking here to again add that human aspect of thinking to our artificial neural network as well, guys. Now, to come to the depths of how a convolutional neural network works, first of all, you give it an image, right? Your input is an image. Now, as you can see, I have pictures of two very cute dogs here. It's one picture, right? Now, when I input this into a convolutional neural network, what happens is that this image gets broken down into pixels. Now, an image is consisting of pixels, right? When you take a look at the resolution of your monitor, it can say 1920 into 1080. It means horizontally it consists of 1080 pixels, horizontally it consists of 1920, that is 1920 pixels, and vertically it consists of 1080 or 1080 pixels, right? This changes. Your phone has a different amount of pixels, your TV, a 4K TV has different things, and 8K resolution TV has a lot more pixels compared to a 1080p TV and all of that, right? So at the end of the day, an image is basically a pixel which consists of certain data. Now, this value that gets broken down to, as you can see, 4, 2, 21, 22, 54, 36, all these numbers that you see, each number has a value on its own. And once an entire image gets mapped into these numbers, there are three different things that we pick up. As you can see, it is an array of 32 cross 32 cross 3. 32 cross 32 is basically how many pixels, right? It has 32 into 32 pixels is how the image gets, the image is basically in the form of its array structure into 3. This 3 is actually called as channel. Now, with the channel, when we say the channel is 1, either the image is black and white or it's in grayscale, where it's either colored or, so in this case, it's either nothing or it is black and white. But in the case of a channel being 3, we have 3 colored channel that goes on, guys. RGB, red, green, blue. So the values of mixings between red, green and blue eventually give you all the colors that you see, right? Of course, in this particular case, that is how we use it to train a convolutional neural network. So what happens is that once you give the input, right? So let's say in our case, we're trying to do a cat and a dog classifier. We give it to the input layer. We give an image. Now it sees the image and it goes into the convolutional layer first. In the convolutional layer, again, mathematically filters get applied and all of that. We're going to check it out. I'm going to show it to you with an example so you understand it better. After convolutional layer, there is the pooling layer that is next, and after which you have the dense rank layer, where again at the end of the day it gets squished, it gets pulled down into one filtered row, and then you have an output layer. Your input layer is you giving an image. The output layer is it is saying, is that a cat or not, is the question you're asking, and it's going to say, hey, this is the probability that it is a cat or it is not a cat, right? It is a very simple thing that you should know. But my point with this slide, again, we're going to check out all of these layers, is that know the order of the layer. First, we have the input layer. Next, we have a convolutional layer. Next, we have a pooling layer on the third thing. On the fourth thing, we have a dense layer, and then comes the output layer, right? That is the working of a convolutional neural network in its order, guys. So, we just checked out the various layers, right? So, here are the actual layers. In the convolution layer, what happens is that the image gets converted into an array. This array, I already showed it to you. And next comes the ReLU layer, or it's also called as a rectified linear unit. Here we try to do one of these concepts called as regularization, where we try to convert all these negative numbers to 0 and to bring it to a certain limit. I'm going to show it to you why we do this, but now you should know that this is what goes on. On the third layer, we have the pooling layer, where again, if you keep doing things to an image, it will drastically transform and become something else. It can get huge, right? So to make sure that your image is not huge and out of bounds, we reduce the input size with a concept called as filters, and we bring your output size very similar to be that of the input size as well. That is what we do in the layer of pooling. And then you have the fully connected layer, where we bring together multiple features and we have an output, or we have a process, we have a model that that says, hey, this is a cat, here's the probability of it being a cat or not, right? So let's visualize what each of these layers mean. So the first layer in the CNN is called as the convolution layer, right? So convolution layer is a layer where an image gets converted into an array. It is the first layer of a convolutional network. It takes the image, it understands the pixel values, and it gives out the array output. Right now, each of those numbers you see had a meaning there. If the number was 0, it means that part of the image was very dark. If the number was a huge number, it means there's a lot of light, there's a lot of color, or there's a lot of activity that's happening for that pixel, right? So that is a simple way to take a look at pixels in numbers, and that is what happens in this case as well. So with the convolution layer, our goal is to make sure that we are trying to extract features, we are trying to understand the mathematics, we are trying to understand why pixels are lit up there, what it is trying to convey, what shape is it trying to give us, what is the outline of the image, what is the edge, what is the curves, what is the bounds of the image. So all of this we can understand later if we break the image down into pixels and reduce its dimension, right? That is what we're doing in the convolution layer. So let me show you how it works. So first of all, we send it an image. As you can see, it's a little dark on the left, so there are smaller values here, and of course on the right it gets brighter, so bigger values are here. Then what happens is an image goes on to become a pixelated value. It gets created into an array that looks like this, and then we have something called as a feature detector or a filter that we apply onto it. Now a filter is basically a set of another smaller tiny set of an array that we multiply it with the original array to make sure that we know what it is seeing, right? A filter transforms your input in a way where it teaches the neural network about what it is seeing. Like, is there an edge? Is that a border? Is it dark there? Is it light there? Now I can take a look at it and tell you, hey, this is light and this is dark. But for the network to figure out, we have to multiply it with a feature detector, or what's also called as a filter, and then it gets to it. So once we multiply all of these things, this matrix with this particular filter, here is the output matrix that we get from the convolution layer. So here we're trying to say, hey, I understood certain features from this particular image, and of course you can see that our input is very much bigger in size compared to our output, right? So we are trying to reduce its dimension. So to get to here, what did we do? We took the input was broken down into arrays were multiplied with filters, and once you multiply the entire array with a filter, it's going to give you a smaller set where it understands the features now, right? So that is the convolutional layer, right? Next, we have the rectified linear unit layer, where what so happens is that now you might have seen values there which were negative in nature as well, right? So to bring all of these negative numbers to 0, we use the concept of what's called as a half rectifier. Look at the graph on your screen right now. Now, whatever is the negative input that you give, right? It can be -1, -0.1, -1 million, -1 billion. It doesn't matter. It becomes 0 eventually. Whatever is the positive values, of course, it's going to remain positive itself. Whatever is negative just gets squished down and becomes 0, right? So f of y, your output becomes 0 no matter what. If your input is less than 0, and your f of y remains y. Your positive numbers remain the same whenever y is greater than or equal to 0. Even if it is 0, it is going to remain as 0 itself, guys. So the range of the rectified linear unit function that we use is basically 0 to infinity. No negative numbers in talk whenever we consider the use of rectified linear unit, right? So we're trying to regularize, we're trying to remove these occurrence of negative numbers. Again, you will understand why we have to remove negative numbers, as they have a tumbling or a rolling effect down the line, because a negative number in a real scenario does not make sense, right? Your array value that you saw, the pixel value, if it is 0, it means it is completely dark. If it is -5, there is no meaning to it, right? It is not like a light is being removed from that pixel. It can either be dark black or it can have some value there, right? That is why we require the layer of ReLU. So here again, we added all the, from the previous layer, we got the filters, we multiplied the filter with the input, we have a value. Once you go on to apply the, ReLU layer, as you can see that we have one negative value here, which is -2. So what happens when we have any sort of negative values? It gets replaced with 0. What happens to all the positive values? They remain the same, right? So this is the ReLU layer. Next, we take a look at the pooling layer, where we are trying to reduce the size of the image input with multiple filters. Now, we commonly multiplied in the convolution layer with one filter across all the dimensions to give us more detail about the image. But here we are trying to reduce the size of the image itself and to bring down the number of parameters we're trying to use to assess and understand what the image looks like. Now you might have a question saying, okay, so why do we even require the pooling layer, right? See, pooling layer is very, very important to make sure that your model, whenever it's learning something, it does not go into overfitting. Overfitting is a concept where your model looks so deep into your data that it will rather get confused looking at noise rather than useful information. We want to avoid all of these things. That is why we reduce it in the size. We bring down the number of parameters and say, hey, this is what is required, right? So you might have a question saying, okay, so you used a 2x2 filter, can I use any size? Of course, you can use 3x3, 4x4, 5x5, anything that you require. But the most common way of, or the first prototype aspect of looking at things is to usually use a 2x2 filter there, right? Now, to talk about this layer, I have a simple animation here. First of all, our convolution layer is done. Our ReLU layer is done in a way where all the negative numbers are now vanished. We multiplied -2 and we had a 0 here. So our data is ready for it. So now what we're going to do is we're going to multiply this with 2x2 filter, and we have a parameter called as stride. Stride, of course, can be a new terminology to you. So with stride, what we're trying to do is when you have the image and when you have a filter that is being moved across an image, think about it like a torch, moving on each pixel, right? You're going to understand what I mean right now. For example, if stride is 1, I want the image to overlap 1 pixel to the right every time it moves. See, now I apply a filter here, and this filter talks about, it's 2x2 filter, where I have applied filter only on the first, this row and column that you can see on your screen. So upon applying a filter, multiplying it, all of that, I just get one single output here. Now, what happens is when I move it to the right? If stride is 1, it is saying, hey, if I take this box, think of it like a torch. If I move the torch just one array value to the right side, the overlapping comes at 2225, right? So this is stride equal to 1. If stride equal to 2, you can actually go on to move it another point to the right, where instead of it being 22, 0, 25, 87, it's going to be 0, 10, 87, 139, right? So it happens like this. We have stride equal to 1, so one layer on the right gets overlapped. You get one value as a result of the multiplication output. And again, now you have to overlap the next layer, which is 087. As soon as you do it, you have one output. But for the next one, you have nothing. You have only 10 and 139 there, right? So you assume default values to the right. This is where overfitting becomes a problem. It takes in nonsense values here, and it eventually gives you a very, very different or a random output, which is of no use, right? So as you can see from the output of this particular layer, this is the entire output. What you see on the white here on the bottom right? 25, 87, 139, and 139 again. So this becomes the actual output of this particular layer, which is again used in a very simple concept called as flattening the layer. So flattening the layer, all we're trying to do is after pooling, we try to take the feature map and convert it into an array. So we have numbers 25, 87, 139, 139 in the form of an entity, right? A data storage entity. We're going to take that, convert it, and flatten it out into, as you can see, we're just basically flipping it and flattening it out to get us again the same numbers arranged in a different order, right? After all of these things, the convolutional layer, the ReLU layer, then came the pooling layer, we have the fully connected layer. In the case of a fully connected layer, what happens is that we are bringing together all of the features to give us a particular model output. Whatever happened until now, from us giving it an input to it giving us an output, everything is brought together here and created a network, guys. This is the fully connected network. One important thing that you're supposed to know is this is the final step in the process of a convolutional neural network, right? So once you have flattened all of this has arrived. Each of these goes as an input, then you have the hidden layers which get trained, and then you can see the output layer which has a prediction saying, hey, it's a dog or it's a cat. Now for all the input that we saw, you remember the image of two dogs that we saw? Well, based on all the data, our model will learn. It gets passed to the input layers, then it connects to a multiple hidden layer network where it trains, it learns, it understands, data moves in both direction, forward propagation, backward propagation, and all of that. And at the end, the last layer, it says, hey, I predict that the image you have shown me is that of a dog, right? So this is how we get a CNN to work, guys. Now that you understand the theoretical aspect of all of these things, I want to show you guys the practical of it. I want to make sure that you guys understand this, and I show you practically how fun it is to work with neural networks, right? So let me quickly open up. So right, guys, now we are here at Google Colab as we've been using all these past modules. It's an online Jupyter notebook hosted on the Google Cloud platform. The first thing I have to do is connect to a runtime, right? Once you're connected to a runtime, Google Cloud platform allocates a certain amount of resources to you, so you can go on to work with it, right? So once it says connected, we have to do one step which we have not done until now, is to make use of the power of graphical processing units. Google Colab allocates a certain amount of GPUs for free. So using that, we have to change the runtime from the actual CPU. So click on runtime, click on change runtime type, and click it as GPU and hit save. So we're going to be using the power of graphical processing units, because at the end of the day, your GPU can handle image processing a lot of times faster. It can learn, understand it better using the power that goes into making a GPU, right? Now think about all you gamers who are there. You know what a CPU is good for. A CPU does everything nice, but if you have to play the latest games in 4K, not native support in the CPU. CPU is meant for other things, not image processing, graphical processing. So you have another entity called as a GPU, or a graphics card, that you put in your computer or your laptop, right? That is what handles all of the things. Eventually, all the output that gets given by the CPU to be shown on your screen is what it manages that, right? So again, here we're going to be using the same concept too. GPU, with working with the GPU, your CNN is faster, more efficient, and trains well as well, guys. So let us go on to perform image classification with convolutional neural networks. The first step I'm going to do is we're going to be taking a look at the cat and the dog classifier here. So with this command wget, all I'm trying to do is I have the training data set and the testing data set stored in a Dropbox format. So it's stored in an online cloud storage. I'm trying to implement it and bring it to my to the working environment here. Now if I click on the left side here, files, it should have downloaded all of these, right? So I asked it to download 2 zip files. Again, one data set, it is already split into testing and training. As you can see, 2 data set elements are here, testing set and the training set. Now these are images of cats and dogs and all of that, and again, all of these are labeled data sets. Again, a dog is a dog. For our reference, we can understand it. As you can see, one file was 173 MB, which was the training set. Then the testing set would also be something similar in size, 217 MB in size, right? So this downloaded 2 zip files for us. Now what I'm going to do is I'm going to unzip the contents of those zip files to make sure I can actually see what the image are like. Look at it, you can see it says dogs / so we have thousands of images of cats and thousands of images of dogs. So all we're trying to do is we're going to take a zip format, unzip it, and give it to our Google Colab, saying, hey, here are the individual images which you have to give to the model to learn, right? So since there are a lot of images, this is definitely going to take a little bit of time. It's asking me if I have to replace all the testing training sets with the storage. I am going to say let me just click on this. I have to say A, saying that, hey, replace everything with, create a new entity there and give me the output. So now it is basically going to create folders. In a folder, it's going to add cat. Another folder, it's going to create dogs. It's going to separate it based on testing data, training data, and all of that. Perfect. I hope that step was clear. Let me zoom in a little more on the next set of code. So the next set of code is I want to print a simple set of an image to show you what a cat looks like, right? So I have picked up one random cat image here, and all we're trying to do is we're trying to use the imread, the image read function, and we're trying to use matplotlib to plot an image for us. And as soon as I hit play, it is going to print the cat, which is from the file cat.4001, right? So this is a cute picture of a cat. You are trained, I am trained, both of us know that this is a cat. Our computer at this moment of time is not intelligent enough to know this is a cat. I have printed this for your reference. Similarly, let us print a sample image of a dog. This is such a cute dog, right? We know this as soon as we look at it, right? Now we cannot say this is a cat. right? Now we are well trained enough, I hope so, to look at it and say this is a dog. Now that we've taken a look at one or two sample images, next we're going to import all the libraries that goes into understanding the convolutional neural network, right? So we use TensorFlow, which is very popular, as I've discussed at the end of the last module. We have Keras, we use Matplotlib wherever we want to plot images and all of that, right? So our model is going to be a sequential model, since the data itself is sequential data. We're going to be using DenseRAC, we're going to be using two-dimensional convolutionals, we're going to be flattening it, we're going to be using max pooling for the pooling layer, we're going to have activation function. So we're trying to just bring in all of those and import all of it, so at the end of the day, later down the line, we can use it instead of having to manually import everything at that stage, right? So one code block, 5-6 line to import everything we need, and we are done. Now, just for the sake of showing you guys that we're going to be using the latest version of TensorFlow, it's 2.4.1. So this code works very well with the latest version of TensorFlow. So I've just printed out the TensorFlow version for your reference, guys. The next thing we actually come to is the aspect of where we are, designing the actual model. To design the actual model, you have to initialize all the things that you have given, right? So you have multiple images here. You have to sometimes resize it. You have to tell your model, hey, this is what is at hand, right? Now I'm telling my model, saying, hey, look, the image width and the image height, the height and width of every image is 150 cross 150 pixels. Here is where you can find the training data set. Here is where you can find the testing data set. I have 100 samples that you can use for training. I have 100 samples you can use for testing. And whenever you're learning anything, right, since this is an iterative form of learning where the network feed forwards, compares with the output, comes back with backpropagation, learns again, minimizes the loss, right? So I'm telling it, hey, 20 times I want you to do this experiment, this iterative experiment. That is what an epoch means. And an epoch basically means the time count, how many times a thing should be done. In this case, I wanted to learn 20 times. So I'm just initializing a variable to say down the line, I'm just gonna, instead of manually putting down 20 there, I'm gonna say, hey, use the value of epoch. Epoch consists of 20, so it knows it has to do 20 times, right? Next, I have the batch size equal to 20. With batch size equal to 20, what we're trying to do is we're trying to say you have 100 images, but split it down into sub batches and use 20 images at a time to learn and verify. As soon as I run this, all our variables are set. So when we discuss the theory aspect of things, I already told you what an image consists of, right? Pixel data in terms of three things. It's a 3 cross 3 cross 3, or let's say 32 cross 32 cross 3, where 32 cross 32 becomes the size of the image, and the last thing is the channel, which represents the color RGB, one number for each channel, right? So sometimes it so happens that whenever you're trying to represent an image, in the case of this array representation, you can have first to be all the row data, then you have the column data and the channel data. This is called as row first representation. If you have channel first representation, your channel itself becomes the first. So in our case, it can be 3 into 150 into 150 if it is channel first. If it's row first, it becomes 150 into 150, and then comes the channel at the last into 3. Right? Perfect. So all we're trying to do is we're checking the shape of what inputs we have, and we're trying to say that, hey, even if it's 150 into 150 into 3 or 3 into 150 into 150, you please know what to pick up. So we're giving it both the situations to understand. If it is that, take this to be the input shape. Else, if it is another one, then here's a different input shape that you have to understand. Right. The next thing is where we actually go on to train the model to generate an image for us. Now see, you might ask a question saying, why should we generate an image since we already are passing it images, right? Now, if I just give it that image as it is, it can take a look at it and say it's a dog or a cat. It can train on that. A machine learning model is good enough to do it. But what if you want to change the image in a way where you have to, let's say you have an image, you want to reshape it, you want to zoom into the image, you want to flip the image in a different direction, you want to rescale it, resize it. If you do all of these transformations to an existing image, can it still understand later, right? Can it still say that it's a dog or it's a cat? So to make sure our model accuracy is high, we go on to reshape, change, shear, we just tear the image left and right, and we, in a very different way, we try to think about like a crazy mirror when you go into these houses, right? It just distorts your body shape and it shows you yourself in a different way. That is what we're trying to do to our images here. So even with that case, it needs the capability to say it's a dog or a cat. So this is a simple 4-line code of how you can do that, right? So we're trying to flip it horizontally, we're trying to zoom it, we're trying to shear it, and we're trying to rescale it. Now, all of these values, why we require rescale from 1 to 255 is that sometimes the values that we obtain will be very high numbers. We have to bring it down into a range. We have to bring it down into a range between 1 and 255. That is why we go on to do that. And in the case of the color aspect of things, right, so even RGB values will have a value between 0 to 255 after the first line executes, but here we have to bring it to a range of 0 to 1. So later down the line in processing it becomes simple, right? So we train the image data generator, it creates all of these new image for us and gives it for us. So let me quickly go on to run this, and it says, hey, I found 8005 images belonging to two classes. Our two classes is cats and dogs. It eventually rescales all of it and gives us the output, right? So if we go on to see what the representation of the image data generator looks like, what are we doing with the image data generator? We are trying to generate an image, we're trying to reshape it, we're trying to resize it, we're trying to horizontally scale it, vertically scale it, all of that, right? So as you can see, this can be a part of a very big image where there is a table in the background or whatever it is. We are trying to rescale it. Then you try to shear an image, right? So this dog that we are trying to see here is a little stretched in its up and down aspect, right? Now even this cat, so even this image, and of course even this one, right? It is squished on the left and the right side. So this is a simple representation of we trying to generate images in a different form for it to understand, guys. Right. The next thing we're going to do is actually take a look at the layers in the convolution neural network. Again, you already know the layers. It's a convolution layer, ReLU layer, a rectified linear unit. You have the pooling layer and the fully connected dense layer, right? So here is where I say, hey, I want this to be my input layer. I want 64 neurons in total, which use a 3x3 filter. And then in the pooling, right, this is the convolution layer. Next, we have the pooling layer where I say, hey, I want to use rectified linear unit and bring the data down into that. So again, 2x2 filter is applied there, and our final layer, which is going to be the dense layer, which consists of our output layers. We're going to try to say, hey, take all of these things, create a fully connected layer for me, but create it in a one-dimensional array, right? So 64 neurons are what we're going to be using for that layer as well. Again, this talks about all the hidden layers too. So the convolutional layer, we have the activation function based on the rectified linear unit layer. Then you have the fully connected layer, and at the end of it, we have the output layer, right? So we're going to be using an activation function here called as the sigmoid activation function, which again gives us the output. So as soon as I go on to run this, it is almost like I've told it, hey, this is the model structure. This is what my model should look like. So it actually goes on to gives us the input shape of each of these layers, the output shape, how many number of parameters were there, right? See, look, the amount of trainable parameters it found were 22 lakh trainable parameters, and of course it goes the same to talk about how the total number of parameters are there, because we are only using the training data set to learn here, right? After you have created the basic structure of all of these layers, we have to go on to compile the model. We have to create a loss function. We need to have an optimizer. Optimizer is basically making sure that whenever back propagation happens, your values are being compared, right? At the end, our goal variable should keep going up and our loss should keep coming down. To calculate that loss, how do we do it? You find out what the actual output is supposed to be, compare it with what the input is, minus that, find a difference, right? That is how you know what is the loss function. Bring the loss down and use the metrics of accuracy to give us what it would look like, right? That is what simple, guys. Compiling an entire model to say, hey, this is the optimizer I want to use, this is the loss function I want to use, here is the structure. Again, look at it. It's what, all in all 10-12 lines of code for a very, very complex convolutional neural network. Simple, right? Then comes the actual place. Look, train generator, steps per epoch, all of these things is all the variables that we used at the first step of model initialization. As soon as I go on to run this, simple, it's going to start training. I told it to train 20 times, right? I told it to do 20 epochs. So now it is going to take a certain amount of time to make sure that our accuracy rate keeps going up with every epoch and the loss keeps coming down. Look at your screen right now as I speak, right? The loss is coming down. It started at somewhere around 18 or something, and now it's at 11. With this particular epoch, loss was at 11, accuracy of detection was 0.52, right? So the next one, the next epoch where it is going to train, again it's going to use 20 sub batches of data, and look, the loss function is again exponentially down for this particular epoch, right? Accuracy is slightly going up from 0.52 to 0.59, guys. Now similarly, this has to go on for 20 times with every thing now that you see on your screen right now. Just look at how time keeps going on to be less and less. Sometimes it becomes more as well, but at the end of the day, look at how the loss just keeps coming down and down and down, and the accuracy just keeps going up and up for all these 20 cases, guys. Let me zoom out a little so you guys can see better. So guys, as you can see, we are done halfway through. 10 epochs are done, and you look at the loss values, right? It is just keeping, it is coming down and down, but in one step, certain times, if it is, the loss can also go up based on how the weights were changed and the back propagation step happened, right? See, it was 0.59, but in the 9th epoch, it went to 0.61 again, and now it relearned something, so it's bringing down the loss again. That's the beauty of neural networks, guys. Now let us wait for the next 10 epochs to finish so we can analyze what is our final value and our accuracy rate. So guys, this took about a solid 5 or 10 minutes to get done, and as you can see, with every single epoch from 1 to 20, epoch 1 out of 20, 2 of 20, 3 of 20, the loss at the first step was very high because it is, of course, the first step you cannot calculate a loss unless you know what the output is, right? So you can ignore loss at the first step. As you can see, the loss keeps coming down from 0.7 until 0.5. That was the best of what we could train the model for 20 epochs. If I do it for 100, 200, 300, it might train better. Of course, there's no guarantee of that. I have to try it out. And then if you look at the accuracy, the score went up and up. From 0.52, we are all the way up to a 70% accuracy of detection, right? So you get a lot of metrics that you can check out as well. You get the value of accuracy, the value of loss, and all of these things. This is the actual process, guys. When I say, hey, train 20 times to create a model and understand, that is what I was doing. The next step we're going to take a look at is to find out how accurate the model itself was when it went on to learn, right? So here is a simple graph that talks about model accuracy and model loss as well. Let me zoom in a little. Yes, so model accuracy talks about what the testing data set is supposed to be like and what the actual training happened, right? So the blue line talks about accuracy with how many number of epochs, right? Every one epoch it trained. So this is how it could analyze and train, and this is how it compares to the testing data set as well. As you can see, it is almost in line, perpendicular, parallel to the data set, which is showing that it is learning in a way with every epoch, that it is bringing it closer and closer and closer to bridge the gap that exists between the testing and the training data set. That is what we want to see as well. Of course, in some epochs, the loss function, as I told you, it can go up again and come down. Of course, again, that is a common thing. And look at this. This is exactly what my point was. Your model loss, when we're talking about it, right? Your loss keeps coming down and down, but sometimes with many epochs, as you keep going, in some epochs, again, the loss can be very high for the testing data set, and eventually it just levels out. So we want the loss to be as minimal as possible, right? That is exactly what we're trying to show. And of course, the last step is where we are actually doing the magic. We're trying to say, hey, here is an image, tell me what it is. Either it's a cat or a dog, right? Now, as soon as I go on to run this, we're trying to predict if the result is 1, it means it's a dog. If the result is something else, it means it's a cat, right? Now, this is the image that I passed into it. And this is the image it's printing for me. Look at the prediction. If I give it this image as an input, right, for the first layer in the convolutional neural network, if this is the input I give, this is the output. It says, hey, it's a cat. How amazing is this, right? You can just change around any image here and ask your model to find out, guys. Now take a look at this. If I open the training data set and if I open the folder inside it, for the cat pictures, again, I have a lot of cat pictures here. Yeah, as you can see, look at the amount of cat pictures I have here, right? So I'll keep going on and on and on. It used all these to train what a cat looks like, and similarly for a dog as well. Look, I'm going on. It's still it's amazing how many amounts of pictures we have here of cats and dogs. And all of those were just cats. Next, we have all of these for dogs as well. So you can take any one of these, ask it saying, okay, so what image is this? Your neural network model is going to give you an output saying it's either a cat or a dog, guys. That is the most fascinating concept of convolutional neural network. So guys, I hope with this you are completely clear. So guys, I hope with this you are completely clear with the concept of neural networks. This is as close as you can bring a computer to think like a human being. So, since this is a very important concept in the case of data science, I thought that we can split deep learning and neural network over two entire modules and you guys have a complete knowledge about this. Again, we can implement a recurrent neural network in a very simple fashion for text classification as well. But since we consider the case of image classification, we took the example of using convolutional neural networks. Why? Because it is the most popular. It is purpose built to read images, understand images and work with them, right? So we saw of how image gets processed in every single layer and worked with that, guys. So I hope all of these things that were covered in this module were clear to all of you all. So alright guys, so all of these modules that we checked out, I am sure packed you with an amazing amount of information and detail about the domain, right? So now to quickly summarize all the things that we have actually looked through in all of these individual modules, it becomes very vital that you know all the important concepts that we checked out and learned, so that in case if you are revisiting these, it will definitely add a good amount of value to your knowledge to know what you have learned, in which order that we put out this structured video for you to make sure that you get the best way, the best track to becoming experts in data science, right? So guys, we began module 1 by taking an introduction to data science, right? We understood the most important foundational concepts that exist in the world of data science. We checked out what data science is. We had an introduction to understand, whatever it is that you need to know about this domain right now. And with this, we also made sure we checked out why this domain itself was required. Once you got a clarity about why the domain is in need today and that you yourself have aligned with the domain, we took a look at the architecture of how data science itself has spanned out, right? You got to understand so much detail about how it works, all the components that are involved in the world of data science. And one important thing that we covered right in the first module is to make sure to talk about the career aspects of data science, right? We spoke about a lot of things about the career in data science there. We made sure to talk about the current ongoing pandemic trends as well, post-pandemic trends, salaries. A lot of important things were discussed here. Upon introduction, we moved to a very important core concept of data science, which is statistics, right? So statistics is very important. We checked out what statistics is, why is it required, how can we use it, how does it align with data science, what are the various ways we can collect data, what are the various ways we can use data. And we also checked out the various types of statistical analysis that we can go on to perform. We took ample amount of examples for each of these statistical methodologies, and of course we checked out amazing stories whenever we spoke about all of these metrics of accuracy, the central tendency metrics and all of these things, right? So I made sure to give you guys a nice story kind of an approach whenever we spoke about all of these complex mathematical concepts to simplify it down so that you guys can remember. I'm sure if you watched module 2, you remember the diabetes story, the COVID story, the dinosaur story and all of those, right? So beautiful. Now after having an amazing module 2 session where we took a lot of understanding and took away a lot of knowledge about statistics, module number 3 came right in time to teach us about programming, right? So with module number 3, we spoke a lot about the most important programming language there is for data science right now, which is Python. We understood what Python is. We had a good amount of understanding in terms of introduction. We learned why we require Python. We took a look at all the important skills that you need to possess and you need to work on if you do not have those skills right now whenever you're getting started with Python itself, right? The important prerequisites. After which, of course, we had to align Python with data science. Python is used for so many different things, right? So we took a look at all the popular data science libraries, which is very important for all of us to know and understand. And we took a look at the two most important libraries for data science, which is NumPy and Pandas, right? So we walked through the theoretical concepts, we used the example, and of course we checked out all the basic aspects of programming and the working of NumPy and Pandas libraries as well, using a hands-on session where we were programming and working with it, and I walked you through all of these different things, right? So module 3 was a fantastic module to give you guys a clear picture about Python for data science. And then once you got an understanding of how to handle all these basic data, module number 4 came into the picture to show us all about machine learning, right? This is the most trending application that we have for data science right now. So we took a lot of understanding in terms of what is machine learning, what are the types of machine learning that exist, why is it that we try to implement everything in terms of machine learning whenever we go on to solve a problem today, right? So what is the actual process of machine learning? What is the working of it? And then remember, from module 3 we took all our Python knowledge to bring it and use it with machine learning here. And we did not stop right there. We made sure to take a look at all the top machine learning algorithms, and then we did not stop there, right? We made sure to take a look at all the top machine learning algorithms that is required for you guys in terms of today's knowledge, and of course in terms of data science as well. We went through all of those and we discussed all of these algorithms practically in Python as well, right? So this was a power packed module which gave you an ample amount of knowledge in terms of machine learning. And after module 4 came another very important mathematical concept, which is probability, right? See, probability, as I've been telling you all throughout this entire session, is a very important concept. This is how we checked out the way machine learning works with the help of statistics and probability. We took an introduction to understand what probability itself, the concept of factorial, all the types of data that we handle in probability. Why is randomness so much important for us, right? Now this is a domain where if data is random, everyone is happy, right? The people who are programming and the people who are solving problems. So we took a look at that. We worked with a lot of random data. We took a look at very important probability functions. We got an introduction to all of that, and we checked out things practically as well. So this was a very important module for you guys to add on to statistics and to make sure you now understood how algorithms also work in the case of machine learning, and of course going ahead as well, right? And then until now we were using all these ready-made data sets which were ready to be processed and all of that. But for you guys to know about how these data sets itself come in to be created, how they are stored, how they are worked with, we took a look at module 6 next. Module 6 we spoke a lot about database technologies, an introduction to databases, why do we require these databases in the first place, all the types of databases that are very, very popular right now. And of course, right, so whenever database is the name to be spoken with, people use the language SQL or SQL as it's called. So we took an introduction to that, we understood a bit of it, and of course we had a very, very important comparison between SQL and NoSQL as well, right? So this is an important thing that you had to know before moving on to the 7th module, because until you know how the data comes into the picture, it is very difficult to perform data analysis, right? Which is why after module 6 we make sure we took a look at exploratory data analysis, or EDA as it's called. This is one of the most trending concepts that we have in the entire domain of data science itself. We took an introduction to understand what it is, why we require it, where it is used, the popular applications, the advantages, the types of exploratory data analysis, and of course we had a comprehensive walkthrough where we implemented all of these again in Python, right? See, theoretical knowledge, ample amount of examples, practical walkthrough, and many things that we went through with these particular modules. And it didn't stop there, because as a data scientist you must have knowledge about data visualization, right? Data visualization is one of these key skills that is required for you. You have to have this ability to tell stories with all of your data, like how I explained a couple of concepts by telling you stories, right? That was very important. We took an understanding about what data visualization is, why it is so important, especially in the field of data science, right? After which again we spoke everything in terms of practical manner. We took a look at all the top libraries that are there in Python, Matplotlib, Seaborn, Plotly, and all of them. We understood very, very, very important visualizations in this particular domain, and of course again we implemented everything that we learned in the theoretical aspects practically, which is the most important way of how you guys should proceed when you're learning as well. Learn the theoretical concepts concepts, use examples to remember them better, and of course at the end of it, use practical implementation, write the code to mess around, understand the concepts better, right? Because once we cleared module number 8, we came to a fantastic domain in the concept of data science, which is deep learning, right? This is where we made sure we can teach our machines, train our machines to think like us, to think like human beings, right? So we took an introduction to what this entire concept of deep learning is, why we require it, vital examples and applications. There are certain important applications that are governing the world around us, everywhere we speak of in the domain of deep learning and data science. So we checked out how they are helping us in our everyday life, critical applications, and one important comparison we made here was to understand the differences that exist between deep learning and machine learning as well, right? After we were concrete with the differences that exist between machine learning and deep learning, we made sure to take a look at some of the most important use cases out there, and of course the top libraries which you have to have the knowledge about in case if you're looking at a specialization, or if you're very keen on becoming a master in deep learning as well. And using the concepts of module 9, we delved even deeper in module number 10 to take a look at neural networks. Neural networks, artificial intelligence, deep learning, machine learning, all of these concepts are the pinnacle of data science. These are the strong pillars that make data science such a strong domain, right? So we made sure we took an introduction to neural network, understand what it is, understand the mathematical working behind it, the architecture of neural networks, the various types of neural networks. We discussed right from the most simple neural network all the way to the most comprehensive, complex neural networks out there, right? After which we took up one example from all the different types of it. We took the convolutional neural network example right from its first step of image processing all the way till the end where we arrive at a solution. We made sure to walk through the mathematical aspect of it, the programming aspect of it, discussed every single layer, and we spoke about why each of these layers are even required and what they have to do to make sure our neural network learns to behave a little bit like a human being, right? So we checked out all of that, and we wrapped it up very nicely by taking a practical walkthrough to take a practical implementation of a binary classifier, and we worked with all of that, guys. So I hope all of these 10 modules add an immense amount of knowledge to your existing knowledge base. Again, you are more than welcome to check out this tutorial any number of times that you want, but my suggestion is that whenever you do go on to watch each of these modules, keep a pen and a paper handy so that you take a note of all of the important things that I have said during the tutorial, right? In many places I've explicitly mentioned that you guys should have a pen and paper. That is because you'll be performing mathematical calculations, you'll be taking down important points, or even a case where that it's a concept which will be very important maybe for your interviews as well, right? So keeping all of that in mind, I suggest you guys take that approach. Now, after all of these, it becomes very, very, very important that you guys know how to further enhance your knowledge, to build upon what you have learned, to look towards outside your comfort zone, to make sure you're learning new things rapidly, implementing new things, and of course, working towards becoming an expert in data science, right? The first thing that you guys should always do is to make sure you do not be overwhelmed by all the content that is present, right? Now, if you go on to type learn data science in Google, you will be given millions and millions of results, blogs, videos, tutorials, whatever it is. It becomes very important that you have a structured path, a structured way that you guys can take to learn all of these concepts and to make sure that you remember it and not be overwhelmed, not be confused and all of that, right? So again, all of these were implemented in this tutorial itself. We took a very, very structured path as I just explained in the summary. But again, my important suggestion is whenever you begin learning, tune into sessions like this. Make sure you're taking a look at the tutorials that we're putting up, all the videos that you're putting up. Come join us in our live sessions. We have multiple experts here, all subject matter experts from multiple different domains come together at Great Learning, and we teach here. So make sure you're checking the YouTube channel out, and a lot more things, because since you guys ask a lot for the free content that we provide, I spoke to you about Great Learning Academy throughout the session as well. Great Learning Academy is a definite place that you guys should be in. I'm going to walk you through Great Learning Academy in a second here. Now, the next place that you definitely have to check out and subscribe to is the Great Learning YouTube channel. It adds an immense amount of value. All of these content that you see on your screen, Great Learning Academy, Great Learning YouTube channel, Great Learning blogs, ladies and gentlemen, all of these are free, and we are putting all of these together in a very structured manner, in a very thinking a lot of things to make sure that you guys can get started and learn with this domain, right? So making sure that we provide the most high quality learning content is what we believe in, and we hope you guys are using the same to learn as well. So right guys, as I've mentioned, Great Learning Academy is a fantastic place for you guys to check out, right? So we get 700,000 plus learners joining in from 140 plus countries across the world, ladies and gentlemen. You are given with thousands and thousands of hours worth of free learning content, and we have 3 million plus people who get to check out and learn from here as well. We have multiple courses, 200 plus courses. We keep adding courses of course, it's available in multiple different languages as well for the people who are asking us for the courses in Hindi, right? So you can see multiple, for example, Python for machine learning. We have a course here, which of course you can enroll into for free, learn for free, and get a certificate of completion absolutely free of cost, ladies and gentlemen. It's in English. We have courses in Hindi. We have multiple different domains. Since this is data science, you can take a look at data science. But again, right, we have beginner courses, we have intermediate courses, we have advanced courses, everything to cater to no matter where you are in your career right now. You're in school, you're in college, you're about to graduate, you are coming from a non-technical domain, or you're a person who has 1 to 3 years of experience, or someone who's very experienced as well, right? We promise you that you have something that you can take away and learn a new thing, an important concept which will help you in your career here at Great Learning, guys. Of course, there's a lot of different things to talk about. We have a complete job interview preparation section, which is again absolutely free for you guys to tune in. You can work on your technical interviews, soft skills, aptitude preparation, a lot of different things, right? So you can reach Great Learning Academy from multiple places. Once the website, the next thing is the Great Learning app, which is available from the Apple App Store and of course the Google Play Store. But then guys, if you guys are very, very serious about your career, if you want to become thorough experts, right, it always adds a value to make sure that you guys are taking a look at the specializations and of course the post-graduation certification offerings we have here at Great Learning. Right now, if you can come to the greatlearning.in website, right, it will still work the same. The greatlearning.in website, click on explore programs and take a look at data science, guys. In the case of data science, we have multiple programs, right? So these programs are, again, look, I can just keep going on and on. So no matter what it is that you require for in terms of data science learning, right, we have it. These courses are done in collaboration with some of the most prestigious and fantastic universities, and even Ivy League schools out there. So you want master's programs, MTech programs, MS programs, we have all of them, guys. For example, this is a post-graduation program in data science and analytics that you can check out, done in collaboration with the University of Texas at Austin. This is considered to be the India's #1 course for data science and business analytics in multiple regards. There's multiple reasons for that. You will receive a certificate from the University of Texas at Austin and of course Great Lakes Executive Learning as well. You can check out the details about this particular course here. Then we have another course which is put together, stitched together, were a comprehensive course of around 11 months of learning, right? So next we have another course, post-graduation program in data science and engineering for people who have less than 3 years of experience. This is again a 9 months program, which is again online learning. You get to find all the details about this particular course here and a lot more, ladies and gentlemen. It doesn't end there. We have multiple post-graduation programs. Whenever you are talking about having a master's of science degree in the data science program. This is done in collaboration with Northwestern School of Professional Studies, right? So you get a certificate from very important faculties, right? So you get to learn from some of the amazing faculties, as you can see on your screen right now. All of these guys are thorough experts in this particular domain, so them sharing their knowledge with you is going to add a lot of impact to your learning. And of course, again, as you keep going and going, we have an MTech program which is made with Karnataka's #1 university, which is PS Universities. Again, this is this is a course you should be looking at definitely if you have somewhere around 2+ years of experience as well. We have another course in big data analytics, the MTech course. This is done in collaboration with SRM University, right? So again, this is a full-time classroom course that you guys can take a look at. There's multiple online offerings, weekend classrooms, and guys, the model of hybrid learning is something that we here prefer at Great Learning, and this is what you guys have been telling us as well, the way you want to learn, the way you are comfortable in learning, right? So we have something here that will definitely take you from being a beginner all the way to becoming an expert. You'll be handheld, guys. If I have to talk about the advantages of each of these courses, I can go on and on, but to make sure I add value to your time, I highly suggest you guys check out this page, explore it in detail, see if it aligns with whatever you require. If you are looking to become an expert, I highly suggest you check this out, right? So you get all the details, you can apply, you can find the the brochure details, you can find about the cost of these certification as well, right? So there's multiple programs that you guys can check out, right? So again, all of these specializations and post graduations is going to add an immense amount of value, so I highly suggest you guys check it out. So guys, with this, you've come to the end of this data science full course video. With this, I hope I have added a lot of value to your time and to your learning. I highly suggest you guys follow the recommendations and of course all the things that I've mentioned throughout all of these modules. Take the structured approach, take it slow, and since I've broken it down into very simple bite-sized pieces for all of you all, make sure you're not skipping any concepts even though you might know about it. It becomes very important that sometimes later down the line in the next couple of modules, when we tie back to the previous ones, you have to have knowledge about that as well, right? So even if you're a person with ample amount of knowledge in the domain itself, I highly suggest you check out all of these modules. It adds a lot of meaning to your domain, and we at Great Learning are very excited to see your feedback, to see your inputs, to see your comments, and of course feedback, suggestions, all of that on this particular video, ladies and gentlemen. I hope you guys had fun learning. I'll see you on the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200+ courses with 1000+ hours of free content on all of the trending high demand domains, absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.